In this demonstration, you'll learn how to perform a TCP and UDP-based port scan against a target system. Now I'm logged into my Kali Linux system. Let's take a look here at how to launch a terminal session. So up top on the floating toolbar, we have a terminal button, and that launches me into my terminal session. Now the first command that we're going to use Nmap as the tool to perform a port scan. And there's different types of port scans and different ways that you can perform that port scan. So my first example, I'm going to do an Nmap dash lowercase s, Linux is case sensitive, lowercase s, then a capital T. The capital T stands for a TCP connect scan. So this scan type will do a full three-way handshake with each of the ports. And then I'm going to put a space in, and then you type in the IP address of the system that you want to do the port scan on. Now in this example, I'm just going to do a port scan on the IP address of 10.0.0.1, and I'm going to hit enter. Now this will take a minute, potentially, maybe 30 seconds to perform the port scan. Now notice that I haven't supplied what port numbers I want to scan, so Nmap does use a default list of port scans, or ports that it scans. So it's finished, and it checked the most common ports. I'm going to scroll up a little bit here. So it says starting Nmap 7.91 on this date and time. This is the report for a port scan on 10.0.0.1, and then it's going to have a list of ports. Now it shows that 983 ports were filtered out. So because no reply came back, it's not shown that in the results. But notice that I am seeing in the state column here, I am seeing there are a number of ports that it found open on that target system. And just to highlight a few of them, notice the very first one, it shows port number 21 using the TCP protocol is open, and that port is most likely an FTP service, right? So it kind of lets you know what the service is. TCP port 53 is a DNS port. Port 80 TCP is open, and that is a website using HTTP. Now, another example of a port, I'm going to jump way down bottom here. Port 1433 TCP is Microsoft SQL Server. So by doing this port scan, I know that this target system has an FTP server running, it has a website, it has a SQL server, and I'm going to pick one more here, and it's port 3389. When you look at port 3389, this is the Microsoft Windows-based terminal server. This is remote desktop running. So as I'm kind of building my profile of this target system, I'm kind of documenting that this system is running an FTP service, DNS server, a website, SQL server, and it's running remote desktop. And then eventually what I'll do is I'll try to find vulnerabilities for those items, right? But I'm not ready for that yet. I still want to perform more scans. So the next thing that I want to show you here is, let me clear the screen so you can see it better, is I did a TCP connect scan. It does a full three-way handshake with each of those ports. But you can also do a half-open scan. So it's Nmap dash lowercase s, which means I want to do a scan, then a capital character to imply the type of scan. So this time I'm putting a capital S there, which means I want to do a SYN scan. It's a half-open scan. It means I'll send a SYN message to the port, it'll reply, but I won't do the third phase of that connection, okay? And again, we talked about this in the previous video. The reason to do a SYN scan or half-open scan is you are sending less traffic, right? And so although I'm not doing a full three-way handshake with the port, I'm trying to avoid detection. And I'm going to use the same IP address, the same target system, and let's see what the results look like. Oh, so it says I need root privileges to do that. So I'm going to do sudo nmap-ss 10.0.0.1 and supply my password. And again, this will take 30 seconds. But what I want you to see here is, although it's a different type of scan, the results are going to be the same, right? So underneath the scenes, it's doing things a little bit different. It's only doing sending SYN packets. It's not doing a full three-way handshake, but in the end, it's the same result, right? So port 21 is open, port 80 is open, port 1433, the Microsoft SQL Server, 3389. So from a results point of view, it is very, very similar. So that's how I can perform a TCP Connect scan and a half open scan. Let me clear my screen. The next scan type that I want to show you, I'll do the -ST. I'll do the TCP Connect scan. So I showed you how you can scan a single IP address. But what's important is you can also scan an entire network, right? So I can do .0/ and then supply the CIDR notation for the subnet mask. So in this case, it's going to go and do a scan on the 10.0.0 network, right? So this means it's going to scan 254 addresses, right? So the benefit is you can use Nmap to do a full scan of the network. Now, it will take some time. So what I'll do, when I hit enter here, I'll pause the video and it'll take probably 2 or 3 minutes, and then I'll resume the video again. So I hit enter, and it's going to do that TCP Connect scan. Okay, so that only took a few seconds, and really it's because in my test lab environment here, I don't really have a lot of systems. I think actually there's only 2 systems running, which is the target system, the Windows Server, which is 10.0.0.1, and the other one is the Kali Linux machine. So it actually didn't take long. But when you take a look at the results here, it shows, okay, Nmap scan report for 10.0.0.1. So even though I supplied a network range, it's coming in back and it's saying, hey, here's your results for our first system we found, which is 10.0.0.1. Notice that the results are the same. So it's showing you all the ports that are open on that 10.0.0.1 system. And then when I scroll down a bit, after it shows all those open ports, then it goes and shows you the next computer it found or next device. So it's saying Nmap scan report for 10.0.0.19. Now the hook is there's actually no ports open on this system. So it's saying all 1,000 ports that were scanned are actually closed. But what's important here is we do know that the host is up and running. So it did do a ping sweep. So Nmap is doing a ping sweep to find the systems, and then it does a port scan on those systems. So that's how we can go and do a port scan of an entire network segment if we wanted to. Let me clear the screen there. And the next thing that I want to show you is important as well. If I go and do an Nmap-ST, lowercase st, capital T, 10.0.0.1, back to this example. So I showed you how we can do a port scan on a single system, or it could be the whole network by doing a .0/ and then whatever your subnet mask is, right? So I'll do /24. So that'll do that whole network segment. So you can do that, but what's important is I didn't really specify a specific port number that I wanted to scan. So if you wanted to, you could specify specific port numbers with a -p. So let's say I want to scan for port 3389. And then you still specify the target IP address, or it could be the target network, right? The 10.0.0.0/24. So here I'm actually saying just scan port 3389. What this is useful for, and I talked to, in my networking courses, I talked to the network folks about this. Port scanning is not just used by penetration testers. It can be used by networking people to find out what services are running on systems on the network, or it could be used by security professionals, like a scenario where management comes up to me and they say, hey, Glenn, there's a huge security vulnerability with remote desktop right now. How many systems do we have running remote desktop on our network? So what you could do is you could use Nmap to find out that answer. So I could do Nmap-ST-P for port 3389 is the port that remote desktop uses. And let's say I did want to do the whole network. Since I know it won't actually take long, I'll do the /24. So I'm going to scan my whole network for devices that are running remote desktop. And the benefit here is that, from a pen tester's point of view, you may know of a vulnerability that will get you into the system running remote desktop. So that's why you're doing a port scan for specifically port 3389. But from a security professional point of view, as somebody that's trying to protect systems, you may want to identify what systems are running that port as well, so that you can then go in and shut those systems down or disable the port or whatever it is that you need to do, patch the systems to fix the vulnerability. So I do a little scan here for port 3389. It's come up with the results. Notice again, and we already know this, that 10.0.0.1 does have port 3389 open. Notice in this example, I'm not getting a list of all the ports because you told Nmap, I just want you to scan port 3389 across the network. And then here it's saying, okay, port system 10.0.0.19 is also a system that's up and running, but it does not have that port open. See the closed state there. So that's very useful as well. Now, if you wanted to, you could kind of build off that. So I'll use my up arrow to go to my previous command, and you could say, okay, I want to know what systems are running 3389, 80, 21. So you could pick a few different ports, maybe the SQL one as well, 1433. Notice that I can comma separate the ports that I want to scan without having a space. So you just comma separate them all, and then you have a space, and then it's the IP address that you want to scan. So I'm going to scan for those 4 port numbers across our network. It'll take a little bit longer. Oh, that wasn't too long, only a few more seconds. So it comes up with the results here. It says, okay, system 10.0.0.1 has port 21 open, has port 80 open, 1433 is open, and 3389. But this other computer of 10.0.0.19 has all those ports closed, right? So from a penetration testing point of view, and from a hacker's point of view, when they're doing their port scans, this 10.0.0.1 system becomes priority, right? They want to, this system has the ports open, so let's try and see if we can exploit that system. Now I have one more port scan that I want to show you. And it's an important one because when I scan, so Nmap-ST, when I use the TCP Connect scan against, let me do it again actually, 10.0.0. I'll just do the one system. When I do the TCP Connect scan and I hit enter here, we saw that what I have as an end result is I know that the ports are open. So port 21, port 80, port 3389 are open. But what's important is that right now we're doing our network reconnaissance. We're trying to collect information about the systems. So I know port 21 is open, port 80 is open, port 1433, port 3389. To the right, they tell you what type of service it is, whether it's an FTP or a Microsoft SQL server. But if I don't know what that is, I would just go to Google and search, TCP port 1433, and very quickly you'd find out that that's a port used by Microsoft SQL Server. So the point is that there's different versions of software that's used to open this port. So there's different versions of SQL Server, right? There's different versions of web server software. There's different versions of FTP server software. And my goal here is to collect information so that I can turn around and try to find vulnerabilities on the services that are opening these ports. But I need to know the version of the software because version 2 will have different vulnerabilities than version 1, let's say. So this next command is really cool. I'm going to do an nmap dash. I want to do a lowercase s, which means I'm going to do a scan, and I'm going to do a capital V, which is a version scan. And I'm going to go and do 10.0.0.1, and I'm going to hit enter. And what's going to happen is it's going to do a port scan, but it's going to come back and tell me the version of the software that's running on each of those ports. And that becomes extremely useful information as I now start researching, are there any vulnerabilities in the version of the software that was used by this system? Because once I know the vulnerabilities, then I can figure out how to exploit those vulnerabilities. So we'll give that a second here. Notice that it is taking a little bit longer. So because I'm digging for more detailed data, it does take the scan a little bit longer. All right, so it only took a few minutes longer. Let's scroll up here and see what we have. Okay, so we're doing an Nmap -SV of 10.0.0.1. I could have did the whole network segment, I should stress that. So I could have did 10.0.0.0/24. I chose to just do the one system in this example. Notice there's port 21 that's open, and it's an FTP service. So you get the same information, but notice that we now have this version column. And the version is trying to tell you what version of the software. So in this first example, it just comes up and says, oh, that's a Microsoft FTP server. So although it didn't tell me what version, it did tell me it's not a Linux system, it's a Microsoft FTP service. So I can go and try to research exploits against the Microsoft FTP service. But look at port 80 here. 80, I got a bit more detail. It is HTTP. But notice that it says, oh, this is Microsoft IIS version 10.0. So there I've got an actual version number. So now I can start researching vulnerabilities in Microsoft IIS 10.0, which will also lead me how to exploit those vulnerabilities, right? So that's very useful. Also, if I come down bottom here, so I do have Microsoft SQL Server, is the 1433. And then we also have our Microsoft Terminal services. Again, I didn't get version-specific numbers in those cases, but I did for like the IIS web server. And also it looks like here we do have it for the RPC service over HTTP. It looks like version 1 as well. So very useful is to perform this version scan to try to find out what version of the software is running on that port. Okay, one final demo is how to perform a UDP-based scan. So all of these scans that I've done are all TCP-based. So let's do an Nmap -SU for UDP and 10.0.0.1. Oh, so again, it comes up and says, hey, you need to have root privileges to do that. So I'm going to do a switch user. So our sudo nmap -su 10.0.0. And my password. So this will do a UDP-based port scan. And I'm trying to think, there's a couple ports that are open that are UDP-based. All right, so it only took probably about 30 to 45 seconds, but I can see that we're doing a scan of 10.0.0.1. The host is up and running, so it did a ping on it first. And then down below, we actually see there's only one port. It is running a DNS service, so it does see port 53 UDP is open. In this demonstration, you'll learn how to perform network sniffing with Wireshark. Wireshark is a tool that you can use to capture network traffic, including traffic on a wired network, a wireless network, and even traffic with IoT devices. You simply need to make sure that you put the system using Wireshark in the pathway of the traffic. For example, you could configure port mirroring on a switch, which sends a copy of all data passing through the switch to the port that your Wireshark system is running on. Or you could perform a man-in-the-middle attack or an ARP poison attack to place your Wireshark system in the pathway of the traffic coming from the target system or the IoT device. Now, in this example, what I'm going to do is I'm going to launch Wireshark and then go into a terminal to generate some FTP traffic. And what I want to do is use Wireshark to capture that FTP traffic. Now, in this example, FTP just represents the application, right? So if I want to monitor what type of information an application is sending across the network, I can use Wireshark to kind of discover that. So first thing I'm going to do is go to my Kali menu, and I'm going to go down here to Sniffing and Spoofing, and there's Wireshark. Wireshark is a very popular packet sniffer or network sniffer that you can download for free from wireshark.org, and they have versions that run on Windows platforms or Linux platforms. Now, when you launch Wireshark, you can see here the first thing I have to do is choose which network card I want to listen to traffic on. So I'm going to choose this Ethernet card, and I'm going to double click on it, and that'll start recording traffic. So now that it's recording traffic, I'm going to generate traffic from my application. Or again, you could be doing this with wireless networks. You could be doing this with IoT devices. Again, as long as that Wireshark system is in the pathway of the traffic. So I go into a terminal where I'm going to use the FTP program. So I'm going to do FTP 10.0.0.1, and I hit enter. It says connected to the FTP service. Give me the username. Username is administrator. Now you can see in the background, Wireshark is collecting packets as these packets are delivered across the network. So administrator is the username. The FTP service comes back and says, oh, we need a password for that username. So I type in the password. Now I'm not going to tell you what the password is. We're going to see if we can capture that information with Wireshark. It says, great, you're logged in. Now you're ready to use the FTP service. So to use the FTP service, I want to list the files that exist on the service. And what I can see here is it looks like there is one file on that FTP service called clientlist.txt. So what I want to do is download that file. So I can use the get command to download the file. So get clientlist.txt. And that downloads the file. Now, keep in mind, it downloaded the file to whatever folder went into this FTP session, which was my student folder, okay? Not that I really need that, because really our purpose here of this demo is to check out the Wireshark traffic. So now I'm going to quit my FTP session. So the point is, somebody has used FTP, and you were able to capture that traffic with Wireshark. So when I come here in the background in Wireshark, I'm just going to hit the stop button. And if I scroll up, you can see there's quite a few packets. So the Wireshark screen is divided into three parts. You've got your packet list at the top here. Each of these rows, so there's packet number 1, packet number 2. You can see the numbers there, 4, 5, 6, 7, 8, and so on. So those are our different packets that were captured. When you highlight a particular packet, so let's say I want to highlight, packet number 5. When you highlight packet number 5, this middle pane here is your packet details. And what you can do is you can expand out different pieces of information. So for instance, if I wanted to know what the layer 2 information is for this packet, and layer 2 is your Ethernet information, like your MAC addresses, what I could do is I could expand out the layer 2 header, and there's your source MAC address in brackets. That's the MAC address of the network card of the system that sent this packet. And then here is the MAC address, the destination MAC address of the system that received this packet, right? So that's our layer 2 header, that Ethernet section. Up above that, I should start at the top here. In our details, you've got your frame details. And the frame details is just the date and time, when this packet was captured. So I know on August 1st at 8:52, this packet was captured. So that's your general frame information, we call it. Then you have your Ethernet header, which gives you information like your source and destination MAC address. Then you have your IP header, right? So this is the layer 3 protocol, which is the IP protocol. And that'll contain information like the source IP address and destination IP address. So just to show you, if I expand out the Internet Protocol, we're using version 4. Notice in that summary line there, they give us the source IP address of this packet is 10.0.0.19, and the destination is 10.0.0.1. So that's our server. In this case, the FTP service running at 10.0.0.1. So you can expand that out to view details about the actual IP portion of that packet, right? And there's the source and destination IP address. If I collapse that down, then after the layer 3 header, then we've got our layer 4 header. So the layer 4 protocol is TCP that's being used here, not UDP. So it's the transmission control protocol. I can see the port number. So the source port number of the program is 35,216. So that's the port number used by the client application. That's destined to port 21, which is the FTP service, right? And again, you can expand that out to see more details. So there's your source port field, there's your destination port field, right? So to summarize this middle section, this is a very important section. You've got your frame information, which is its date and time and size of the frame. But then you got your layer 2 header, your layer 3 header, and your layer 4 header. And you may, after the layer 4 header, you may get application data. So in our case, when we look at our FTP information, once we find the FTP packets, we will have some FTP data there. Okay. Now let's, and then down below that is the hexadecimal and ASCII text representation of your details. So just to give you an example, if I go to the layer 3 header, the Internet Protocol version 4 header, and I come down here, watch this, I'm going to select the source IP address. Wireshark does is it highlights the relevant portion in the hex pane down bottom. So you can see the 0A000013. So that is the hexadecimal representation of the source address. If I highlight the destination address, the IP address, notice it's the next 4 hex codes, right? So each of these pieces of information are represented in the hexadecimal pane. Now, the hexadecimal pane, because I look at that and I don't really understand what I'm looking at, what Wireshark has done is they've created this detail pane. So this is the pane that you can look at to help understand what's actually going on without needing to understand the hex codes. Perfect. So those are our 3 panes. Now, what you'll do is you'll just follow your packet. So when I'm analyzing network traffic, what I'll do is I'll start at the top and I try to make sense of what's going on. So I can see the protocol is TCP, and I can see here, you can go and look at the details here if you wanted to of every packet as you highlight it. But what they do is they give you an info column that kind of shows you the most relevant information. So what they're showing here is that this is a TCP packet and 35216 going to, that's an arrow pointing to 21. So this means that the source IP address of 10.0.0.19 is sending data to 10.0.0.1, which is our FTP server. And so this is a client sending data to our FTP server, and they're showing you the ports. The client's using port 35216 headed to the server port of port 21. So in my head, when I'm looking at this, I'm thinking, oh, that's an FTP port, right? Not necessarily that it has to be FTP. It's just the default port number for FTP is 21. So I'm going to guess that that's an FTP port that this client system of 10.0.0.19 is communicating with. They also show the SYN there, right? SYN is the first phase of the 3-way handshake. So before these 2 systems can exchange data, they have to establish a connection, which is done with a 3-way handshake. So there's the SYN message. Look at that. Coming back from the server to the client is, so port 21 sending data to 35216, is the SYNAC. That's the second phase of a 3-way handshake, which is used to establish a connection. And then finally, the client sends to the server an ACK message. So at that point, the client has a connection to the FTP service. And look at this. And again, notice that I'm just staying and reading the info column, right? And it kind of makes sense in my head because I'm picturing the communication. Okay, so the client machine SYN message to the FTP service. It's replying. So they do the full 3-way handshake. And then there's a banner coming back from the FTP server, 10.0.0.1, is sending to the client a response that says code 220 Microsoft FTP service, right? That means the FTP service is ready for communication. So when you think about what we did is after I got that FTP service ready message, then I had to log in. So look at this. So request user administrator. So this is the client logging into the system by typing the username of administrator. Then the server comes back with, and I know it's traffic from the server because it's 10.0.0.1 going to the client system of .19. So the server is coming back with a response that says, hey, I need a password for that account. And then, and this is kind of where it gets good, is then we can see the client machine 10.0.0.19 is sending to the server 10.0.0.1 using the FTP protocol, right? The password. So pass space, and there's the password I typed in. Now you might wonder, what's the word pass doing there? Underneath the scenes, when you're using an application, so I was using the FTP program, underneath the scenes, there's actual commands that are executing. So the actual FTP command of pass was executed underneath the scenes to send the password up. So the password is capital $PA$$W0RD. Okay. It checked that, and then the server came back with, you're logged in. Perfect. So if I scroll down, I'm just kind of jumping to the relevant stuff. There was a request for a listing. This was me typing the ls command in, right? Saying, hey, show me a list of files. And then as a response, what should happen is we should get some FTP data. So there's some FTP data. Now this is where it gets good. Let me come back into the middle pane for a second. So I've got some FTP data. So this is coming from the server to the client. This is after I use the ls command. So I think this is the file listing coming back. And again, when you see a packet of interest, you can highlight it, and then you can look at, so although up here in the summary line, I know the source IP address and destination IP address, you can get that information in these headers if you wanted to. So I'm in the IP header, so there's 10.0.0.1 is the source, and 10.0.0.19 is the client, which we already know because it's up here. It saves you from having to look at the details. Perfect. So nothing of super interest in the TCP header. We know the source and destination port. Now notice that the source port has changed. It's not 21 anymore, it's 20. And that's because we're actually delivering data. So when an FTP server delivers data, it uses what we call the data port, which is port 20. The control port is 21. Control ports for FTP is what the commands go across, right? So because I said, give me a listing of files, the FTP service went and switched to port 20 and is delivering the files. But this is where it gets interesting, is below that TCP header, I've got my FTP data. And if I scroll down, line-based text data, if I expand that, what you'll see is each row of information that the FTP server responded in its data. So in this example, I only had one file on my FTP server, and I can see the file is called clientlist.txt. And this is what's important here, is that I'm monitoring network traffic, and I was already able to see the username and password somebody used to log into the FTP service, because FTP doesn't encrypt the communication by default. So when I'm analyzing the traffic from this application or from this device, I'm looking at this as a pen tester thinking, okay, we need to be using encrypted communication, right? So that's a huge flaw right now. So I am able to see the file name that's on the server is clientlist.txt, right? But then what's going to happen is, so when you think about, the logic here is, so the server sent me the listing of the files, which is just one file, clientlist.txt, and then I downloaded that file with the get command. So somewhere here should be me retrieving that file. There it is there. Now I use the get command to download the file, but underneath the scenes, the proper command in FTP is retrieve. So this is the client machine saying to the server, I want to retrieve clientlist.txt. And then we should see a response from the server, which is the FTP data. So the FTP data from the server 10.0.0.1 up to 10.0.0.19. And again, you could look at the headers like the IP header, the TCP header, but what I want to look at here is what we call the FTP data in this case. Now, keep in mind it's called FTP data because I'm using FTP as a program, but really what I'm looking at is the application data, the data from the software that's being delivered. And when I scroll down here underneath the line-based text, there's 2 lines. So, and I didn't open the file app to show you the contents of the file, but notice that Wireshark was able to capture the contents of the file. So these are the 2 lines that are in client list.txt. Now, what's interesting is I love this line-based text area, but you don't have to use it. Notice that down bottom in the ASCII section, you can see the information, right? And that was true up here as well when we looked at the listing. Where was it? Request list and then FTP data. Okay. So down bottom here, you can see client list.txt. So if you wanted to, you could look at the ASCII text down bottom, but again, it's not as easy to read. So Wireshark does is they interpret that information and show it to you in a better format within the middle pane or detail pane here. So I can do line-based text data, and that's much cleaner, right? Especially when you have multiple lines of information coming back. So we were able to see when I captured the traffic from this application, which in this example just happened to be FTP, we were able to see the logon traffic. And because there's no encryption being used, we were able to see usernames and passwords transfer across the network. We were also able to see sensitive data like this client list that's being exchanged within the application. Now, again, my example is FTP, but it could be any networking application that communicates with other systems or servers on the network, or with IoT devices as well. In this demonstration, you'll learn how to perform banner grabbing with Nmap. Banner grabbing is being able to determine the version of software that's running on a particular port of a target system. Let's take a look at a couple ways that we could do banner grabbing. The first thing that I want to do here is let's launch a terminal in Kali Linux. Once I launch a terminal, the first thing I want to do is I just want to show you how we would do banner grabbing in the past. How you do banner grabbing is you would telnet into the IP address of the system, but put a space and then the port number that you want to connect to. So in this example, I'm going to telnet into the IP address of 10.0.0.1, which happens to be a server that's running the FTP service, HTTP service, so it's a website. It's got remote desktop installed. It's also got SMTP running, that kind of idea. So I'm going to telnet into the IP address of that system, put space and then the port number. So what this will do is the telnet program will connect to port 80 on that system. And notice that I am connected to 10.0.0.1 over port 80. So this would be the older way of doing this, the less automated way. And what I'm doing is I'm manually connecting to each port. Once I do that, I would do a quit. So I've connected to the port, and so that's successful. And that's one thing that I'm making a note of as I perform my pen test is, oh, okay, port 80 is open on that system. But then when I typed in quit, notice that I do get, this is what we call banner information. Banner information is version information about that service. So I can see here it's a Microsoft HTTP API 2.0. So you would kind of record that information, say, okay, this is the type of service that is running on port 80. And then what you would do is do a telnet into your next port. So telnet space, actually, let me clear the screen there so it appears at the top, easier for you to see. So I'm going to do a telnet 10.0.0.1 into port 21. So same idea, and then I type quit. And the idea here is you can see, that's a Microsoft FTP service, right? I don't have a specific version number, but I do know it's a Microsoft FTP server versus an FTP server running on a different platform. So that's the idea of doing banner grabbing in the past. Years ago, we would telnet into each port individually, and when the system responds, it responds typically with banner information, which tells you the version of the software that's running. Now, that would take a very long time to do when you're performing a pen test. When you think, I just did 2 ports on one system, there's a lot more ports I could test, and there's a lot more systems I want to test. So Nmap gives us the capability, the network mapper is what Nmap stands for, and it's our port scanning tool. But what's cool is Nmap has a switch that we can use to return the version of the software, which does a banner grab. And that switch is -S V for version. So Nmap-SV. And then what you can do is you can add in the version intensity option. And here, this could be a number from 0 to 9. So I could do 0, I could do 5, I could do 9. And it's basically a value that represents how deep you want to do the version analysis, right? 0 being the lowest, 9 being the highest. So I'm going to do intensity is 9. And then what I'm going to do is I'm just going to go, and I'm not going to specify -P as the ports. I'm just going to specify the IP address of the system. Right? So Nmap-SV, I want to do a version scan with the intensity of 9 against the IP address of 10.0.0.1. And I'm going to hit enter. Now this will take a little bit longer than a regular port scan because it is going and A, it's scanning a bunch of ports, but B, it's trying to figure out the version of the software. So think of it as it's telnetting into thousands of ports. So it is going to take a little bit of time, not too long. It may take a minute or so. All right, so that took about 2 minutes. And we have our results here. You can see I have quite a few results. So just to go over the results here. So Nmap-SV, capital V, which means it's a version scan with high intensity against 10.0.0.1. And so you can see that it's come back, and what's kind of interesting is it shows our IP addresses there. It did do a DNS lookup, so it sees that this system is called server a.quick24x7.loc. Then we can see down below a list of ports that I found open. Now, if we were to do a regular port scan with a -ST, it would come back and say these ports are open. But what's different here with a version scan is you can see the version of the software. So I can see that this is a Microsoft FTP server. I can see that this is the web server is a Microsoft IIS 10.0. So the point is, from a penetration testing point of view, now that I know the version of the software that's running on that port, now I can do some research on what vulnerabilities exist with Microsoft IIS version 10.0, right? And that's kind of the important point here is as I scroll down, you can see the version there. The Microsoft RPC over HTTP version 1.0 is another version. There's Microsoft SQL Server there. So unfortunately, it didn't report the actual version of SQL Server, but I do know that 1433 is a Microsoft SQL Server. So I can spend some time doing some research on vulnerabilities. Now, it didn't tell me what version of SQL Server, but sometimes what you might be able to do is kind of use information like version from some of the other software. Now, not in the example of SQL Server, but let's go up here to the Microsoft FTP service. So they didn't tell me what version of the FTP service, but what I could do is research IIS 10.0 to find out what version of FTP comes with IIS version 10.0. So we do have a little bit of work to do, but what's nice is you now have more detail about what's running on those ports than you did in the past. Now, the last thing I want to show you here, I'm going to clear the screen, and there's another way to do a banner grab with Nmap. You can do an Nmap, you can do a TCP connect scan, so -ST, and then we can specify the -- script parameter. And what this is that Nmap has a number of scripts that you can execute when performing a scan. So in this case, I want to run the banner script. And then you specify the IP address of the system. So 10.0.0.1. Now, to speed things up a little bit, I think what I'll do is I'll specify the ports that I want to scan. So instead of scanning all ports, I'll do a -P, and I'll just search for some common ports, like 21 is the FTP port, 25 is the SMTP port, port 80, port 1433, port 3389. Went blank there on my RDP port. So yeah, what I'll do to speed up the scan is I'll specifically target these 5 ports and then hit enter. So in this point with this example is there is a script parameter, and there's a number of scripts that come with Nmap that you can execute as you're performing your scans. So for instance, there is vulnerability scripts where you can not only do a port scan against the system, but also check it for vulnerabilities. Notice that the scan results came back a little bit quicker this time. And a big reason is that we're only doing 5 ports. Now the output is a little bit different because I'm using the banner script. Notice that it shows that, okay, port 21 is open, right? And there's the regular output that you get is that, oh, that's an FTP service. But the banner script executed, and now we know that it's a Microsoft FTP service, right? So it looks like the banner script didn't get any results from these other ones. So to do a banner grab using Nmap, you can either do a version scan with the -SV, or you could use the banner script with Nmap. In this demonstration, you'll learn how to scrape information from a website using Instant Data Scraper. Instant Data Scraper is a third-party add-in that you can install on the Chrome browser that will allow you to easily scrape information off a web page. The first step is you have to install the add-in. So to install the add-in, what you do is you go to Google and you search Instant Data Scraper. So I've already searched Instant Data Scraper here. Once you search Instant Data Scraper, you'll notice that towards the top of your results, in my case, it's the very first result, I'll have the Instant Data Scraper from the Chrome Web Store. So you can see here the Chrome Web Store. So I'm going to choose that link. Once I choose the link, you'll notice that it gives me information about this extension or this add-in. So it says the add-in's called Instant Data Scraper. Kind of gives me information as far as the ratings go. So it's got a 4.9 star rating. 800,000 users have installed this. Notice the icon here for the Instant Data Scraper. It's kind of an optical disc with a, looks like, a red color above a gray color, right? Over to the right, I do see we've got the Add to Chrome button. So I'm going to add this extension to Chrome. Pops up with a quick little confirmation message. Are you sure you want to add the Instant Data Scraper? So I'm going to add that extension, and that'll install this to the Chrome browser. Gives me a confirmation message that Instant Data Scraper has been added to Chrome. Perfect. So I'll close that down. And then what you'll do is when you're navigating a target website, you'll go to the extensions button up top right here, and you can go and activate this add-in at any point in time just by choosing it there. Right? Now, if I want this add-in to display all of the time, I can hit the little push pin there, right? So instead of hitting the extensions button, I'll show you what I mean. If I come over here, we don't have the extensions or the Instant Data Scraper extensions button here on the toolbar, but if I want it, I can hit the extensions, hit the push pin, and notice now that that icon with the red and the gray is on the toolbar the whole time. Perfect. So then what you'll do is you'll navigate to the target site that you want to scrape data off of. Now in this example, what I'm going to do is I'm going to use Amazon, right, as my target site. And what I did is I did a quick little search on my books. So I can see here that I've got 1, 2, 3, 4, 5. So there's quite a few here, books themselves. And you can see the data is consistent. We've got the title of the book itself, You can see the author of the book. You can see the date that the book was published. You can see the ratings there for the book. The price is there for the book as well. Expected delivery time, that kind of idea. So what I want to do is I want to haul this information off the web page and dump it out to either a CSV file or an Excel spreadsheet. And that way I can analyze the information at a later time, right? And again, I'm just using the Amazon website as the example, but when you're performing a pen test for an organization, what you'll do is you'll target their web pages. So you'll check out their websites, the public website, and extract information. So you could be extracting information like contact information. So maybe you'll hit the About Us page or the Employees page, and there's a number of contacts, names, job positions, phone numbers, email addresses, that kind of information. And what you want to do is you want to extract that out into a CSV file or an Excel spreadsheet so that you can then use that information later on potentially in an attack. So maybe you're going to do a social engineer attack and you need that contact information, right? So again, I'm just going to use the Amazon site and the books as the example, but this is the data that I want to extract out. So what I'm going to do is I'm going to hit the little Instant Data Scraper button, and what it's going to do is it's going to use AI to detect the data on the page. And let me just maximize this window here, and just to kind of see if I've got the right information. So it looks like I've got a URL, looks like another URL for the image. So it looks like the URL for the actual book itself, an image, looks like another URL, and then this looks like the title of the book. So this column is the title column. Now notice that the name of this column is A size medium. That's a terrible name. So I'm thinking, you know what? I'm going to change the name of this column. And this is going to be the title column. So when I go and extract this out to a CSV file or an Excel spreadsheet, I'll have a title column, right? And then when I scroll over, just want to double check that I've got everything that's relevant that I care about. There's some stuff maybe that I don't want. So I haven't really kind of looked at which of these URLs. So I've got multiple columns for URLs. I haven't looked at which one is the actual column that I do want, but let's say this is a column that I don't need. I can hit the X there and I can close that column, right? So that way, when I go and export this out to a CSV file, I'm not getting that information. Same thing here. This looks like the link to let us know how many new and used are there. So I don't want that. I don't want the word by. Maybe I'll close that column. So I'm getting rid of the information that I don't really need. Here we've got our author information. So maybe I'll go and rename this column to author. It looks like another column. Oh, so it looks like a column where they have multiple authors. So it looks like the word and. So I'll go with, looks like the data is kind of messed up here. So I'll keep both of these columns because I'm going to have to massage that a little bit. It looks like the word by is here, but the actual author is in this column. So you can see it's not 100% perfect, but what's nice is it saved me a lot of work where I've extracted a lot of information from that website, right? Here I can see the published date. So maybe I'll go and I think that's the published date. So here I'll go and change the name of that. So again, you can continue on through and just scroll to the right, delete columns you don't need, and then rename columns that you do want, right? So you can see there's quite a few columns here. Looks like we do have the price column as well. So that's perfect. So a lot of those columns I would probably end up deleting. Now, if you don't want to decide right now, like I said, the URLs, there's multiple columns that involve URLs. So you really want to take a look at it. And so I do want the URL for the book. So you want to take the time to look at it, right? And this may not be the greatest tool to spend time investigating. So my point here is there's nothing wrong with extracting it all and then bringing it into Excel and using the ease of use tool of Excel or features of Excel to be able to delete the columns and even massage the data with formulas and stuff like that, right? So once I've got the information I want, what I can do is I can export it out to a CSV file if you wanted to, or you can export it out to Excel, right? So I'll do an export to CSV and I'll do an export to Excel. So I did an export to both. The other thing that I wanted to point out is that if you found that the instant data scraper, when I kind of shrink this window down, you can see that it's highlighted the table itself in the background, right? So it's telling you, hey, this is what I've seen as data that I'm going to extract out. Sometimes, depending on how the page has been developed, it may get that wrong. So what you could do is hit try another table, and it's gone and highlighted something on the page that it sees as a table. Might be something in the margin, but you can see a sample there of what it is you'd export, right? So let's say that I had launched the tool and it had selected this area first, this data. I'm looking at that thinking, no, that's not the data I want. So you could say, try another table, right? Now it looks like it highlighted the whole thing. So I try again. So eventually it should loop around. There it is in the margin area. Try another table, and it found the right results. So you may have to, depending on what it detects, you may have to hit the try another table to move it around and select the appropriate data on that page that you do want to export. In this demonstration, we'll take a look at how to perform host discovery with Nmap. Now, I'm already logged into my Kali Linux system. Let's go up and launch a terminal. Once in the terminal, the first command that I want to show you with Nmap is we can do an nmap dash lowercase s, which means scan, and then capital L, which stands for what we call a list scan. And what the list scan will do is it doesn't actually scan the target systems. It's just used to find out from DNS what systems might exist on the network. So I can do a 10.0.0.0/24 to do a list scan of the entire 10.0.0.0 network. Now, when I take a look at the results here, again, it's very quick because we're not actually scanning these systems. But notice what happens when I look at the output. I'm just going to scroll to the top here. It says starting Nmap, this date and time, Nmap scan report for the 10.0.0.0 network, Nmap scan report for, and notice that it knows that there's a system called server a.quick24x7.loc, and it has the IP address of 10.0.0.1. Notice that we know there's a system out there called Win10a that has an IP address of 10.0.0.2. And it looks like it didn't find a DNS record for 10.0.0.3. Same thing for 4, 5, and 6. Looks like it's also a system called Win10a.quick24x7.loc. So the point here is what I'm doing is I'm listing out systems by doing a DNS query against all the IPs. So it does a reverse query and looks for the IP within DNS and returns the name. So I can see there are a few other systems down bottom here. It looks like there's an accounting server at 10.0.0.31 and 10.0.0.32. So it looks like there's two accounting servers, and it looks like there's a marketing website at 10.0.0.41. Now keep in mind, these systems, we don't know if they're actually up and running. All that's been performed here with the list scan is it scanned through all the IPs and queried DNS for those IPs. So it did a reverse DNS query, and it found records matching. So that's basically all I know. But so I don't know if those systems are actually live systems. Are they old DNS records that never got removed? We're not quite sure just yet. But the point is, with the list scan, it is a quick way to just query DNS and find out what systems exist in DNS. And I can start documenting these, right? So I would start building a network diagram that shows accounting server 1 is 10.0.0.31, accounting server 2 is 10.0.0.32. And then what you can do is you can move on to do port scans on those target systems if you wanted to, right? So in this example, it was just to find out what systems exist in DNS itself, right? The next command that I want to show you, it is a type of scan, but it's a ping sweep, and we don't actually do a port scan. So you can use, I'm just going to clear the screen here, and we can do nmap-sn, lowercase n, and then 10.0.0.0/24. So it'll basically treat the last octet as host IDs. And what this will do is this will do a ping. So it doesn't do a port scan on each address. It just tells me if those addresses are up and running. So kind of the next step after doing DNS queries, here it says, okay, Nmap scan report for server A.quick24/7 is 10.0.0.1, and it says that the host is up and running. Then we've got an Nmap scan report for 10.0.0.19, host is up and running as well. So it looks like of all those addresses, there's only two systems up and running, 10.0.0.1 and 10.0.0.19. And you can see that kind of summarized down bottom. 256 IP addresses were checked and 2 hosts are up and running. So the point being here, by doing a ping sweep and not actually doing a port scan on targets, is I'm saving time because now I'm thinking, okay, there's only 2 systems that are up and running or answering to my ping sweep. So now what I'll do is I'll focus my port scan on just those 2 systems, right? So that's the idea of performing a ping sweep. Now, the other thing that I wanted to point out about Nmap is when you do a regular TCP scan, so nmap-st space 10.0.0.0/24, this is just going to do a TCP connect scan against all the systems in the 10.0.0.0 network. Now, keep in mind here that it actually doesn't do a port scan on every system, and I'll show you why. So here's my Nmap st 10.0.0.0/24, and notice that it's showing me a scan report for 10.0.0.1. The host is up and running, and these are the ports that are open. My point is, when you do a TCP connect scan or a SYN scan, it does do host discovery as well. So notice that it is saying the host is up, but in addition, it's doing a port scan. And basically what's happening here is to save time, Nmap isn't doing a port scan against systems that don't reply to the ping sweep. So when you do regular port scans, it's doing the ping sweep first, finding out what systems are up. This system is up, so now Nmap will go and do a port scan on that system. So it's saving time by not performing port scans against systems that aren't up and running, which is nice. And then notice down bottom here, there's the 10.0.0.19. Host is up and running, but there's no ports open. All the ports that it tested are closed. So what's interesting here is doing a regular port scan, it does do host discovery in addition to scanning common ports. Now, if you don't want that, because what happens here is there may be some systems that are up and running that are not answering those host discovery ping sweeps, right? So what you can do is you can do an nmap-st. So let's say I'm going to do a TCP connect scan, and I'm going to do a dash capital P lowercase n. And what I'll do here is just to save time, I'm going to list a couple IP addresses. What this is doing is this is telling the system not to do host discovery. So I've added the -pn, and let me scroll up top here. It says host discovery has been disabled. So what that means is the nmap command will do a TCP port scan on every target address, no matter what, whether it's up and running, okay? Which means it's going to take longer. It'll take much longer, and they say that, right? As a result of doing a host discovery disabled with the -pn, all addresses are going to be marked as up, and the scan times will be slower, right? So when I take a look at this, now remember, we know in my scenario, 10.0.0.1 and 10.0.0.19 are the only 2 systems up, right? So here's 10.0.0.1, says host is up, and there's the ports that are open on that system. So no different in my results than doing a regular -st. But what you will notice is because I supplied it 2 IP addresses just to save time, it goes and it does the test on 10.0.0.2. Notice that it's reporting that host is up, but it's not. That host doesn't exist right now. It's not powered on. But that's because host discovery has been disabled. So Nmap will report every host as being up, and it tries to do a port scan against every host. So here it tells me, okay, we scanned 1,000 ports on that system, 10.0.0.2, and they were filtered out or blocked. So in this demonstration, you saw how to perform host discovery with Nmap. In this demonstration, you will see how to use a pre-built script to perform information gathering. The Discover framework is a script that is used to discover information during both passive reconnaissance and active reconnaissance. The Discover script is used to automate a number of different reconnaissance searches in one script, such as domain reconnaissance and person reconnaissance. You can also do scanning as part of your discovery, which basically automates a number of Nmap calls. This is what we're going to look at in this demonstration. The first thing we need to do is download the Discover script from GitHub. So let's go and start a terminal session. Once we start a terminal session, we can use the git clone https://github.com/bleabird/discover.git. So once you enter this in, you'll hit the enter keystroke and it'll go and download our Discover scripts from the GitHub library. Now in this example, I've already gone and downloaded the Discover script. So if I do an ls command to take a look at my current folder here, you'll notice that I do have a Discover folder already. So after you go and execute the git clone command, it'll download the Discover tool into a Discover folder. And then all you're going to do is navigate to that folder with the cd command. So I cd discover. Once I'm in the folder, I'll just do an ls command to take a look at the contents of the folder. And what I want you to notice is that there's a number of scripts, sh scripts, so bash shell scripts here. So the script that we're going to execute is discover.sh, but notice that there's a number of other scripts. So there's a domain.sh, there's an ipcountry.sh, there's a listener.sh. So basically what you do is you run the discover.sh script and you're going to be presented with a menu system. And as you choose the different types of reconnaissance that you want to perform, it's basically going to execute one of these other scripts in the background. So notice, for instance, there's this nse.sh script, right? So that's the Nmap scripting engine calls that are going to be made. So to run Discover, we do a sudo /discover.sh. And like I said, in our password, what you're going to see is a menu system. So if I scroll up a little bit, you can see here's our Discover, the author of the tool, and then down bottom they have different categories. So there's reconnaissance, which I would see is kind of more passive reconnaissance. So there's domain and person searches. So if you did domain search, for instance, it would prompt you for the DNS domain that you want to search on, and it would go and collect all kinds of information. So a bunch of scripts in the background collects information on the domain that you specified, and then presents a report to you as well. Same thing with the scanning category, right? So we can go and scan systems by IP addresses or using the CIDR notation, which is what I'm going to do. The other thing down bottom here is you can see that you can actually do some web discovery, right, through tools like Nikto if you wanted to. So what we're going to do here is each menu option has a number beside it. We're going to do a scan of IP addresses using CIDR notation, which is option number 4. So I choose 4 and hit enter. It says, great, are you looking to do an external scan or an internal scan? We're going to do an internal scan, so we do option number 2. It says, what do you want to call this scan? I've already run the scan a few times, so what I'm going to do is I'm going to call this internal network, and I'll put 3, a unique number. So when you're performing your reconnaissance, you may want to go and base this name off the customer name or the client that you're doing the pen test for. So it could be company XYZ _ internal network, for instance. So I'll just call it internal network 3, and then I'll hit enter. It says, great, give us the CIDR notation of the network that you want to perform the scan on. So I'm going to do 192.168.2.0/24 is the IP range on my test network here. So I'll hit enter. It says, do you have any addresses that you want to exclude? So I'm going to choose no. Notice in circular brackets there that we have a y/n, so they're telling you what your options are. The capital N is the default, so if I hit enter, it would choose it, but I like to kind of be specific and type what I want. Do I want to perform a full TCP port scan? I'm going to go with a no. Do I want to do version detection, OS version? Because of time constraints, so it does take a little bit longer, I'm going to go with a no and hit enter. It says, do you want to set a scan delay? So maybe to help prevent detection by intrusion detection system, you can add a delay between systems, scanning of systems. So in this example, I'm just going to hit enter for just a regular scan. And do you want to run matching Metasploit auxiliaries? I'm going to go with a no. I just want to do the Nmap scan. So it starts, so basically what this script is doing, the discover script, is it's going to make a number of calls to Nmap, and it's going to do a port scan on the 192.168.2.0 network. But not only that, as part of the automation, it'll start with a regular Nmap scan, basically run the Nmap scripts, right? Which will check for things like vulnerabilities on those systems, right? So it's doing more than a port scan, which is kind of cool. So what I'm going to do here is I'm just going to pause the video and let this execute. This will probably take 4 or 5 minutes. And then when it's all done, what we'll do is we'll take a look at the output. Okay, so the script finished executing. It probably went for 3 or 4 minutes. What I'm going to do is I'm going to scroll up here to the top of the script output, somewhere up here. So all the way to the top, there's quite a bit there. Perfect. Okay, so here's the beginning of the scan after I chose my option, do a CIDR scan, which is basically going to scan all the IP addresses. And you can see here that it started right off the bat. It started basically discovered systems on the network. So in this case, it found a system with the IP address 192.168.2.33, and you're getting a list of open ports on that system, which is kind of nice. Down bottom, you're getting the MAC address of that system. And then also, it'll try to guess the operating system that the system is running. So here it's guessing that it's running a Windows XP /2008, and 87% chance of that guess being successful, right? So it does that for each of the IPs. There's 192.168.2.1, ports that are open on that system. And then if I keep going, 2.135, and so on. So it basically discovers the live systems, does a port scan on them, identifies the operating system on each of those systems as well. And then what you could do is you could kind of document that. Actually, I got a report I'm going to show you. But so point being is, so far it's just an Nmap scan. But after it does a regular Nmap port scan, then what's going to happen down below here, scrolling down, in my output, it says OS detection performed. Please report any incorrect results to Nmap. So Nmap, there was 256 IP addresses that were scanned, and 14 hosts were found up. So you get a little bit of a summary there. And it did find some TCP and UDP ports. So this is a little bit of a summary after the Nmap scan completes. Then it goes and it runs the different Nmap scripts. And these scripts will go and help discover vulnerabilities within systems. So it checks, it runs a FTP vulnerability script, an SSH vulnerability script, a Telnet vulnerability script. So it just kind of lets you know we're running all those. And then it goes and runs a few additional scripts as well. And then it tells you, okay, the scan is complete, and there is a report that you can look at. In the report, I'm going to go and take a look at that report with the sudo -i. I'm going to use the cat command and put in root / and I'll specify the path to the report. So data / internal network 3, and it's report.txt. So the cat command will be used to display that report content. So let's take a look at the report. There is more information in the report. So that's the bottom of the output. So I'm going to have to scroll up again in the report output here. Let's go way to the top. There's going to be some of the same information, but what I like is some of the summary information as well. So here I am typing the cat command in. So this is the beginning of the report. So it says when the report was run, the IP address of the system that did the scan. So the IP address of my Kali Linux system here is 192.168.2.166. This is kind of nice. It says that it discovered 13 systems are host. And what I love is it also lists the IP addresses, right? So instead of having to scroll through all the Nmap output, it just lists them all here. So now I have a list of all the IP addresses that are live on this network. And then they also give you a summary of what ports were open across all those IP addresses. So I can see these are the TCP ports that are open. Another example of something that's kind of cool in the report that I like is they have a section called high value targets by port numbers. So port 21, which is FTP, here is a system of interest that we may want to look into. Port 22 is 295 and so on, right? Port 80, notice there's a number of systems running port 80. So that's interesting. 3389, which is RDP. So there's 4 systems that are running RDP for remote desktop. So we potentially could leverage that when it comes time to try to exploit the systems. Then they're showing us and again, this is in the report file, they're showing us the port scan results, right? So 2.33 has these ports open, and this is the MAC address of that system. So I do like the output in the report better. It's a little bit cleaner. You don't get as much info. So here's the ports open on 2.1. This is what I love. They're showing you the MAC address, but notice also here they show you device type. It looks like that's a wireless access point. And they're right. That's my router, which is awesome. So I keep scrolling down through this. So they do that for each of the systems. You can see the ports and the MAC addresses of those systems. So I'll scroll past all that stuff. And then eventually, so that's just the results of the Nmap scan in the report. But then here's the results of the Nmap vulnerability scripts executing. So they're saying, okay, we went and ran like an FTP bounce vulnerability check, and it looks like 2.7 is an IP address of a device that could be vulnerable to FTP bounce. And they give you some information here. They did a banner grab. So notice that you actually get the device. That's a Lexmark printer. And anonymous FTP login is allowed on that device. That's not a good thing. So that's kind of what the vulnerability scripts are doing, is they're making connections to the different ports and then trying to find out if that service is vulnerable. And in this case, one of the vulnerabilities it found is it does allow anonymous FTP login. So they do that for a lot of the different services. So there's SSH, so 22. 23 is Telnet, right? They make a Telnet connection. Looks like the Telnet script didn't get very far, which is a good thing. And I scroll down through. So they do that with a number of different services. Again, this is in addition to a port scan. They run some of those Nmap scripting engine scripts. So if I scroll down through all that, then down bottom here, they show, that's more. Here's RDP. This is one that's interesting. So they do find port 3389, so 2.2. Notice that they're able to retrieve like computer name information from each of the systems for RDP. So 2.2, 2.5 is also open for remote desktop. 2.33 is open for remote desktop. And so is 243. Looks like it's open for remote desktop. So a number of systems there are running remote desktop. And this is also what I like about this Discover script, is it shows you a number of systems may be vulnerable to, and what I love here is the vulnerability, the MS08-067. So what's cool is I've got a vulnerability that I can now search in Metasploit. So the next step would be, once I know what vulnerabilities potentially a system may have, I can go and try and exploit those vulnerabilities with Metasploit. So you can actually search for MS08-067 in Metasploit to find out if they have an exploit for this vulnerability. So we can see here the MS10-061 as well. Looks like we may have some systems that are vulnerable to an exploit. So that's very useful. So you're making note of those IP addresses and the vulnerability as well. Perfect. That's a big thing. Not only having a port scan performed, but also understanding, what vulnerabilities might exist on each of those target systems. So in this demonstration, you saw how to use the Discover script, which is a tool that you can download from GitHub that basically helps with automation of reconnaissance.
In this video, we're going to look at using the Wayback Machine to review Internet archives, which can be very helpful for penetration testing. So let's start by first accessing the Wayback Machine. The Wayback Machine is a website so we'll be accessing it via an internet browser. To do this, we're going to open up a browser, and in the top URL bar, we're going to enter archive.org/web and hit enter. And this brings us to the Wayback Machine. Effectively, the Wayback Machine is an archive of the internet at various points in time. The Wayback Machine hosts snapshots of websites at various points in time and stores them so that we can go back and see how those websites have evolved over time. There are a variety of ways that this can be useful for penetration testing. First, we can use the Wayback Machine to see historical data about a website, which could help us to identify any changes that happened that might have introduced new vulnerabilities into the website. Similarly, we could use the various snapshots to compare to each other to identify any potential vulnerable changes. Another way that the Wayback Machine can be useful is by finding out sensitive information that may have been present on a website at one point in time but has since been removed. Sometimes, web developers accidentally reveal sensitive information like passwords, but will subsequently remove that sensitive information once they've realized it has been posted. However, if that information has been captured in a snapshot by the Wayback Machine, we could still recover that data using the Wayback Machine. The Wayback Machine can also be useful as a way of validating that certain vulnerabilities have indeed been removed. If we can go back to a specific vulnerable version of a website and verify that the vulnerability was present, and then go to the current version and verify that the vulnerability is no longer present, we can see that the website has been made more secure and validate that the vulnerability has indeed been fixed. So let's take a look at an example website now in the Wayback Machine and see what kind of information we get out of it. And for this example, let's take a look at the Google homepage. So we go to the URL search bar in the middle of the screen on the Wayback Machine and enter the URL we want to examine. In this case, I'm going to do https://google.com. And we are presented with a variety of data. The first thing that we see is a histogram of all the various captures that have happened for this URL every year. If we scroll down, we can see on a monthly basis what kind of snapshots have happened each day in a given month. So for example, if I hover over July 23rd, 2024, I can see that there were 1,391 snapshots taken, and each snapshot has an associated timestamp upon which it was taken. So let's start by scrolling back to the very first snapshot. If we look in the histogram, we can see that for Google.com, the first capture was in 1998. So if I click on that box, and I scroll down in the month, November 11th, at this time is the first snapshot. So if I click on that time, this shows me the state of the website as it was at that point in time. From here, I can scroll through the snapshots by going to the upper right corner and clicking on the blue right arrow. And this loads me into the next snapshot that was taken. And in this way, I can sequentially step through the snapshots of a website and see how it evolves over time. Now let's go back to the first screen that we saw, presenting us with the variety of data on Google.com. If I go to the top toolbar and click on the Captures button, it will take me back to the summary screen. So on this screen, we can also get more information about the website. Currently, we're on the Calendar tab. We could navigate to the Changes tab, and here we get a summary of the changes which have happened between snapshots. This is a particularly useful tool for penetration testing. So here, we will select two different snapshots and compare them. So for example, let's pick this snapshot on July 1st, 2024, and compare it to this snapshot on January 23rd, 2024. Once we have selected two snapshots, we scroll back to the top and click on the Compare button, and this would provide us with a side-by-side view where highlighted changes are in blue and yellow. Unfortunately, this feature is not currently working for the Wayback Machine, so as of right now, we just end up with an error. And unfortunately, this is a fairly common occurrence with the Wayback Machine, and this is one of the limitations of the tool, is that it is not always 100% reliable. So on any given day, you may find that due to the traffic load or various other loads or activities happening in the web page, certain parts of the Wayback Machine may or may not work. To that end, if something isn't working on one day, Try it again the next day and you may find that the tool you needed is now working. But when this function is working, we can use this as a very useful tool to compare the web pages. Next, we can move to the Summary tab, and this gives us various metadata about the snapshots that were taken. So scrolling down, we can get various different types counts for all of the objects that were snapshotted. As an example, here are the counts for JPEG images in our captures, with 35,958,618 captures for JPEG images and 8,812,761 unique URLs associated with JPEG images. And we have various filters available to us to further refine this summary. Now, returning to the main homepage of the Internet Archive Wayback Machine, we can see that there are a few other ways to interact with this service aside from a web browser. So under the Tools tab on the left-hand side of the screen, we see that we have a Wayback Machine Availability API, some extensions for Chrome, Firefox, Safari, Microsoft Edge, and apps for both iOS and Android. So these are various ways that we can use the Internet Archive aside from a web browser. Specifically, let's look at the Wayback Machine API. This API provides us with a programmatic way of testing to see whether or not a website has been archived and is accessible on the Wayback Machine. There is also the Memento API portion, which provides functionality for querying snapshots in the Wayback Machine. And then there's the CDX server, which is an API that allows for more complex interactions with the data and the snapshots within the Wayback Machine. So there are programmatic ways to access this data as well as via the browser. This Wayback Machine is a great tool if you are performing penetration testing on a web application that is publicly hosted and archived by the Wayback Machine. It can be a great way to start your reconnaissance and enumeration journey. In this video, we're going to perform link analysis using the Maltego tool. So to get started, let's go over downloading and installing Maltego. First, we need to go to the Maltego website. So in my URL bar in a browser, I'm going to go to maltego.com. And this brings me to the Maltego website. From here, in the top bar, I'm going to hover over Product and then click on Download Maltego. Then we need to select the platform that we're going to be installing Maltego on. In this case, I'm going to be doing the demo on Windows, so I'm going to be using a Windows executable. But if you're on Linux or Mac, they have distributions for that as well. If I scroll down, I select a file type, and in this case, I'm going to choose .exe plus Java x64, and then click on Download Maltego. This will start a download for the installable executable. Once the download has completed, we can open the executable, and this will bring up the installation process. So for the Maltego setup, it tells us that the Java Runtime Environment 17 is the preferred prerequisite for Maltego. Setup is now going to attempt to install Java 17. I click OK, and it brings me to the install wizard. Here I'm going to click Next. Then I'm going to leave all of the defaults and click Next. And then I'm going to click Install. Now the installation process has started. And this wizard has finished, so we click Finish. Now we're into the actual Maltego setup. So on the welcome page for this, I click Next. I'm going to leave the default of installing for anyone using this computer and click Next. I'm going to leave the default destination folder and click Next. And then I'm going to click Install. Now Maltego is installed, so I'm going to click Finish. And at this point, we're ready to start using Maltego. When we first open Maltego, we will have to read through and accept the license agreement, which I've already done previously. Once you have done that, click Accept and click Next. And then it will install the entities necessary, so we click Next. You can choose whether or not to help improve Maltego by automatically sending error reports, and then we click Next. In this case, for the web browser, we're going to leave the default system web browser and click Next. We have choices for privacy mode. We can have normal privacy mode, or we can have stealth privacy mode, and it provides a description for both modes and what they do here. In this case, we're going to leave it on normal privacy mode. And now Maltego is configured and ready to use. So we're going to click Finish. And now we are on the main screen of the Maltego application. Now currently, we're using Maltego casefile. In this case, we actually want to be on Maltego Community Edition. So to switch Maltego types, we can go to the top left corner and click on the Maltego icon. and then click on License Manager. And in the License Manager pop-up, we can click on Switch Maltego Product Type. And in this list, we can scroll down to select Maltego CE, and you'll need to register for an account first before you can use this. But once you have registered for an account, you can click Login, and then run through the setup one more time. Once you're logged in, make sure that you select Install Transforms from Standard Transforms CE. And on the next screen, it will install the data sources, and then we can click Finish. And now, on the top of your screen, you should see Maltego Community Edition, and this is the edition that we're going to use. So now Maltego is set up and ready to run. But before we actually run the link analysis, let's do a brief overview of what link analysis is. Link analysis is a part of mathematics known as graph theory. Generally, it's used to investigate relationships between various entities. Oftentimes, this is done graphically as an easy way to represent the links between the various entities. So one example of link analysis could be investigating the relationship between a person entity and a messages entity, examining what kind of messages were sent by the person entity. And Maltego provides us with a powerful way of visually graphing these link analyses. So let's go ahead and start with creating our Maltego graph. The first thing we're going to do is go to the top left corner and click on the Maltego icon and click on New. And this opens up a new graph page. So in the middle of the screen, we have an empty blank graph. Let's start by adding an entity to our graph. In this case, let's add a domain entity. So on the left-hand side, in the Entity Palette window, we can select Domain, and we can drag and drop that icon into our graph. And now we have a domain entity in our graph, and we can see it has the URL of maltego.com. Now, we need to use this entity to create new entities, and we do that via a transform. The transform will take our domain entity as input, and we can do that by right-clicking on the domain entity, and we can see a full list of the transforms that are available to us. So let's start by finding the email addresses that are associated with this domain. At the top of this Run Transforms window, we have a search bar. So if I type in email, we can see all the transforms that are associated with email addresses. And let's select the first one, which is to email address from whoisinfo. And now the transform is running. And this runs pretty quickly, so we can see that the transform has found one address associated with maltego.com, and that's abuse@godaddy.com. So in this way, we're building up our graph and performing link analysis around this domain entity. We can continue by finding any phone numbers that are associated with maltego.com. Once again, I'm going to right-click on the domain entity, and in this case, I'm going to search for phone. And we're going to select the first entry again, which is 2 phone numbers from whoisinfo. And that transform runs. And now we can see it's found 2 different phone numbers in our graph. And if we want to separate this a little bit, we can click and drag any entity to make the graph look how we want it to. So let's keep building out this graph. Now let's look for DNS names. So I right-click on the domain entity once again, and now in the search bar, I'm going to search for DNS. And in this case, I'm going to scroll down and click on To DNS Name, Find Common DNS Names. And here we see an example of where the transform didn't actually return any information. Using that transform, it wasn't able to find any information around the common DNS names. And down below, in the terminal under Output Transform Output, we can see that in the second to last line, if we scroll to the end, it returned with 0 entities. So this is how we can perform link analysis on a domain entity. And there are a huge number of different entities that we could select to run various transforms on in order to create graphs. And these can all be found in the left-hand window under Entity Palette. Further, we can right-click on any entity that was created via our transform and run transforms on those entities as well. This can be a powerful tool for visualizing the web application or whatever entity it is you are running a penetration test on. Once again, it can be great for your reconnaissance stage and information gathering. In this video, we're going to go over how to perform passive reconnaissance using Recon-ng. Recon-ng is a reconnaissance framework that's aimed at performing open source web-based reconnaissance. There are a variety of ways to use Recon-ng, and you can install it on multiple platforms. Kali Linux comes pre-installed with Recon-ng, or you can run it on various Linux distributions like Ubuntu. In this case, we're going to be using it in a Docker container. So let's go over getting started with Recon-ng and how to get it set up in a Docker container. First, we need to open a PowerShell window, and that's where we're going to be doing all of these commands. Now, we need to clone the repository from the source. To do that, we can use the command git clone, and then the URL to the repository. In this case, that's github.com/landmaster53/recon-ng.git. And you'll need to make sure that you have Git installed on your system in order for this command to work. So when we hit enter, we clone the repository, and now we need to change directory into the newly cloned repository with the command cd recon-ng. Now that we're into the Recon-ng folder, we can do an ls to examine what the contents are. And in here, we can see that the file contains a Docker file, and that's what we're going to use to build our Docker image. In order to build this, you'll also need to make sure that you have Docker installed on your system. Once you do, you can run the command docker build --rm -t recon-ng dot. And this is going to build the Docker container that we're going to use. Now, the Docker container has been built, so we can run it. And to do that, we're going to use this command. The command is docker run -rm -it-p 5000:5000 -v $! pwd curly brace /recon-ng -v $! home curly brace /recon-ng /root/.recon-ng recon-ng. Now there's a lot going on in this command, so let's break it down and see what it's actually doing. This command creates a Docker container that will remove itself when exiting, makes the container interactive, binds the container to the local port of 5000, mounts necessary volumes, and then points to the image to use. Now we are running in the Docker container Recon-ng, and now we can start going over how to use Recon-ng and some of the features of Recon-ng. To start, on the command line, we can run the command help. And this outputs a list of commands that we can use along with descriptions of what the commands will do for us. This can be very useful if you ever forget or need a reference to a specific command, and is a good starting place to learn the tool. At the bottom of the list, we see the command workspaces, with the description manages workspaces. Workspaces are useful for keeping your investigations organized and all in one place, as well as separated from other investigations. So let's go ahead and create a workspace now with the command workspaces create, and then provide it with the name that you want your workspace to be. In this case, I'm going to call it demo_workspace. Now we've created a workspace, and we can see on the console, instead of recon-ng default, we have recon-ng demo_workspace, telling us that we're in the demo workspace. We can also type in the word workspaces and hit tab twice to get a list of options that are available to us after the keyword workspaces. So we can see we have create, which we've already used, list, load, and remove. Let's use workspaces list, and it shows us the two workspaces that we have, default and demo workspace. We could use workspaces load to return to the default workspace. And once again in the console, we can see that instead of demo workspace, we're back in the default. Let's use that command once more to get back into our demo workspace. And now let's use our next command, which we're going to use marketplace. Marketplace, as the description says above, is a way to interface with the module marketplace. And let's start by seeing what commands we can use with marketplace. So once again, I'm going to type in marketplace in the console and hit tab twice. And I can see the options that I have available to me after the marketplace command. I have info, install, refresh, remove, and search. Let's start by running the command marketplace search and seeing what we get. We can see that the output is a long list of all the modules that we have available to us, as well as the version, the status of their installation for our workspace, when they were last updated, whether or not they have dependencies that are required, and whether or not they require keys. We can be a little bit more specific with our marketplace search command as well. So we could use marketplace search and then profiles. And this will give us all of the modules around profiles. We can get information on a specific module out of this list using the command marketplace info, and then passing one of the profiles like name chk. And this gives us a little bit more detailed information than the table does on the specific module. So let's look at using a specific module. In this case, let's use the hacker target module. To do that, we're going to use marketplace install hacker target. This module uses the hacker target API along with a hostname search to gather subdomains for a given domain. If we do a marketplace search again, and we scroll through the table, we can find the recon/domains/hosts/hacker target module and see that its status is installed. Now that we've installed the module, we need to load the module into our workspace. To do that, we can type modules load hacker target. And now we've loaded into the module within our workspace. So once again on the console, we can see it's changed to Recon-ng demo workspace hacker target. Whenever we are within a module, we can run the help command again to get help specifically related to that module. So running help has shown us the specific commands we can use within this module. Let's start by looking at the show command. If I type in show and then use the double tab again, we can see that we have various options around the command show. So now let's use some of these commands. First, we can run the command info to get info about the loaded module, and we can see various information. If you've previously worked with Metasploit, some of this might look familiar. For example, the options of setting a source and a value look very similar to how you set options with a Metasploit module. In this case, we want to set our source to be whatever web application we are trying to perform reconnaissance on. So in this case, let's do a subdomain search on the domain for Recon-ng. To do that, we're going to use the command options set source, followed by the URL that we want to investigate. In this case, landmaster53.com. Now that our source has been set, we can use the command input to see what kind of input the module has. And we can see the module input is landmaster53.com. And now we can run this module using the command run. And upon running, we have found 2 hosts associated with the domain. This has now populated information within our workspace and within our module. So now we can use the command show hosts to see all of the hosts that we found in a nicely formatted table, where it shows us the host, the IP address, and other information that it was able to find out. So this is one way that we can use Recon-ng to perform reconnaissance on a web application. In this video, we're going to go over some various operations you can do when performing reconnaissance using the Shodan platform. Shodan is an internet search engine very similar to other search engines that you might be familiar with. However, it is more specifically targeted at looking for internet-connected devices, and it can get information about these devices like IP addresses, open ports, and what services are running on those systems. Some examples of internet-connected devices that you might look for include webcams, routers, servers, or industrial control systems. So to get started with Shodan, you need to first open up your internet browser and navigate to the Shodan website. To do that, we go to the URL seen at the top of the screen in my URL bar, which is www.shodan.io. And on the home page, we have a search bar, which is where we can interface with the search engine. So let's type in shodan.io into the search bar and see what it comes up with. And we see a report on shodan.io. So it gives us an IP address of 141.226.5.15. It gives us a location. It tells us that this is running on Windows NT using Server 2003, and it's on port 55,130. So this gives us some information about Shodan.io. If we want to, we could also do a lookup the other way using the IP address. So if I copy this IP address that it gave us and put that into the search bar, we can see that it comes up with some information about the IP address. So this is how we can do an IP lookup and see what's associated with that IP. So once again, we have information like open ports 23, 264, 443. It gives us information about host names, domains, the location, the organization, the internet service provider, and the ASN. Below the open ports, it gives us more information about what's running on each of those ports. So on port 23, that's where we have the Windows NT Node Server 2003. On port 264, there's a checkpoint firewall. And on port 443, which is HTTPS, we have TCP with an SSL certificate information associated with that as well. Now there are some other things that we can do on this web page as well. If we click on the Explore button at the top, this provides us with categories that we can use to explore various resources within Shodan. Some categories it's suggested for us are industrial control systems, databases, network infrastructure, and video games. And there are various other things that we can do with Shodan, all of which are listed below. But for now, let's look at the video games category and see what comes up under Explore. And under video games, we have a few different suggestions with games like Minecraft, Counter-Strike, and Starbound. So let's see what we get when we explore Minecraft. And it's important to note that at this point, you'll need to be logged in with a Shodan account in order to use this feature. And if I click on Explore Minecraft, we can see that we start to get information related to the Minecraft video game. So we can see that there's a Minecraft server here running on 96.35.45.104, and it tells us the number of online players and maximum players. So we have information about the various servers that are running on Minecraft. And on the left, we have more overview of the results with 272,669 results, as well as the specific locations where these result numbers are coming from. Scrolling down, we can get more information about the versions of Minecraft that are running on each server, and the organizations that are hosting them. Next, let's take a look at some of the other features available to us on the Shodan website. In the top bar, I'm going to click on More, and we have a variety of Shodan products listed to us. Shodan Search is what we've been using so far, which is described as the main search engine that makes the information collected by Shodan available through a website. But there are other products as well. There is Shodan Monitor, which can keep track of your devices that are accessible from the internet. There is Shodan Maps, which will show you the devices on a map. There's Shodan Images, which collects images from various services. There's the Shodan Help Center, which can help with common use cases for Shodan. There's Shodan Trends, to see the historical data that Shodan has collected. And then we have some developer services. Shodan does expose a developer API that you can use to work with Shodan programmatically, as well as some other APIs like InternetDB and GeoNet. There's also CVE-DB API, which gives you information about vulnerabilities programmatically, and Shodan Chrono, which is used to give progress bars on the web for various scripts and containers. If running an enterprise account, there's Shodan Enterprise. And then we have research projects like Shodan Exploits, Internet Exposure Observatory, and Shodan 2000. Let's start with Shodan Exploits. If we click on Visit Website, we can use Shodan Exploits to see if there are any exploits available for a given website. This can be very useful if you're trying to secure your website or your web application, because you can use this to quickly find out any vulnerabilities or exploits you might be subjected to and quickly fix them. So once again, let's type in shodan.io into Shodan Exploits. And here we can see the results we get from the exploits search. There are 4 results, and they each come with titles and descriptions of what they are. So we can see on memcached 1.5.5, there is insufficient control of network message volume, denial of service. And then scrolling down, there is a stack buffer overflow path traversal issue with Claymore dual ETH. There's directory traversal with Twonky Media, and backdoor access with Dahua generation. So this can be a very useful way of performing reconnaissance and information gathering for your web application penetration test. Going back to the various products available by Shodan, there's also the Internet Exposure Observatory, which can be used to see how secure a given country is. And Shodan 2000 is a fun tool that lets you explore the internet in style with an 80s retro theme to it. So all of these tools are available. Some of them are free, some of them require a paid account. There is also a command line interface available for Shodan that you can use to interact with Shodan via a terminal. And many developer resources are available if you click on the Developer tab at the top of the screen. Generally, to leverage these products as a developer, you need to have a subscription active for Shodan, but once you do, it has a lot of resources to help walk you through setting up and using their various APIs and platforms programmatically. And if we scroll down, this is where we can install the command line interface that we mentioned earlier, and it gives us a list of all the available libraries for interacting with the Shodan API. So this is a little bit of how we can use Shodan to help perform our reconnaissance and information gathering. In this video, we're going to use the Spiderfoot open source intelligence automation tool to perform open source reconnaissance. Our first step is going to be installing the Spiderfoot tool. In this case, we're going to be installing it on Windows, but Spiderfoot is a Python-based package, so the procedure will be very similar regardless of what platform you install on. To get started, let's open up a terminal, and we are going to need to have Python and Git both installed on our system before we can run these commands. Once we have those installed, we first need to clone the repository for Spiderfoot by using the command git clone, followed by the URL to the repository, which is github.com/smicallef/spiderfoot.git. Next, let's change directory into the Spiderfoot folder that we've just cloned by using the command cd spiderfoot. And we can do an ls inside this folder to see what the contents are. And within this folder, we see that there is a requirements.txt file. This is what we're going to be using to install Spiderfoot. So within this directory, we're going to run the command pip install -r requirements.txt. Once this command completes, we're ready to start using Spiderfoot. We can run Spiderfoot either through a web browser, using the UI mode, or through a command line interface. In this case, let's use the web UI mode. To do that, we use the command python sf.py -l 127.0.0.1 :5001. Now we have a web server running at the address 127.0.0.1, which is our local host, on port 5001. So if we open up a web browser and navigate to that address, it brings us to the web UI version of Spiderfoot. Now we can start interacting with and using the tool. To run a scan on a web application using the Spiderfoot web UI, we go to the top of the screen and click on New Scan. And this brings us up with a new scan configuration page. First, we need to give the scan a name. In this case, we'll call it Demo Scan. Next, we need to provide it with a scan target. On the right, we have some information about what the scan target can be. Spiderfoot tells us that the scan target could be one of the following: a domain name, an IPv4 or IPv6 address, a host name/subdomain, a subnet, a Bitcoin address, an email address, a phone number, a human name, a username, or a network ASN. In this case, let's make the scan target spiderfoot.net. Next, we have a variety of different options about how we want to run the scan. We could do it by use case, by required data, or by module. Under the By Use Case tab, we have a variety of use case options to pick from, with the default being All, where we get anything and everything about the target. If we go to the By Required Data tab, we can see that we can select or unselect various data that we want to retrieve in the scan. And if we go to the By Module tab, we can select or unselect specific modules that we want to run. In this case, let's use a By Required Data scan, and we're going to select specific data that we want to achieve. So first, we're going to click on the Deselect All button, and now we're going to select specific pieces of data that we want to retrieve here. Let's get affiliate IP address and affiliate domain whois. And for this scan, that's all we really want to get. If you were running a real reconnaissance penetration test, you may want to get much more data than this. However, this will be sufficient for demonstration purposes. If we scroll down to the bottom of the screen, we can click on Run Scan Now. And now our scan has started. Once your scan has finished, or in this case, manually been stopped because oftentimes they can take quite a long time to run, you will have results available to you from the scan. So on our demo scan page, we now have a completed scan, and we can go down and see a histogram of the summary of all of the scan results. If we click on the Browse tab, we can see all of the different elements in more detail from the summary screen, and if we go to IP address under Type, we can see the IP address that has been retrieved for spiderfoot.net. We can also get a graph of all of the different web connections that we have starting from spiderfoot.net, going out to the various subdomains and IP addresses. We can get a review of the scan information and scan settings that we used. And there's a log information as well so that we can review what happened during the scan. If we go to the top and click on the Scans tab, we can see a history of all the scans that we have previously run. This is also where you can go to manually control your scans, for example, to stop your scan or delete your scans, or rerun any scans that you want to run again. So this is how we can use Spiderfoot to perform reconnaissance during our penetration tests. In this video, we're going to look at some of the ways that we can perform passive reconnaissance using tools like Whois and Registration Data Access Protocol. We can use these tools to look up things like IP address and domain information. The first way we're going to do this is via a web browser. And when you open up your browser, if you navigate to the URL seen at the top of my screen, which is lookup.icann.org, then you'll be brought to this homepage. This homepage is where we can perform IP address and domain information lookups. Now in this case, this lookup is using RDAP, or Registration Data Access Protocol, which is a replacement for the Whois tool. However, they both work very similarly and they will give you similar results. So let's see how we can use this website to perform these lookups. In the middle of the screen, we have a search bar. Here we can enter either a domain name or an IP address and look it up. So let's try looking up this website itself. I'm going to put in icann.org into the search bar and then click Lookup. And now, on the page, we have information about the domain. It gives us the internationalized domain name, the registry domain ID, the domain status, the name servers that are associated with the domain, when the registry would expire, when it was last updated, and when it was created. Sometimes there is contact information. However, in some cases, it's redacted for privacy reasons. We have information about the registrant for the domain, the registrar information, which gives us some contact emails. We have DNSSEC information, and the authoritative servers that are used by the registry. If we scroll back up to domain information, we can look under the name servers and find this IP address, 199.4.138.53. Let's copy that IP address, and now in the lookup bar, instead of icann.org, let's put in that IP address, and click Lookup. So now we're doing a lookup by IP address instead of domain name. Here we get data such as IP network information, which tells us the status, the address range, the IP version, the name, type, parent handle, and Whois server, as well as the registration and last change dates. We have contact information, once again, for the registrant, and the name is ICANN. So in this case, we've done a lookup using RDAP, which is very similar to Whois, on ICANN, using both the domain name and the IP address to get information. Now let's look at a way we can do this using a command line tool. There are a variety of Whois command line tools available depending on what platform you're working on. In this case, we're going to be working on a Windows system, but you can install this on Linux systems, and things like Kali Linux come with it pre-installed. To work with Whois on the command line on a Windows system, navigate to the URL learn.microsoft.com/en-us/sysinternals/downloads/Whois. Then, on the page, click on Download Whois. This will download a zip file, which you can then extract into a folder. Once you have that folder extracted, you can open up a PowerShell window or terminal of your choice inside of that folder, and then run an ls. Running ls shows us that we have an end-user license agreement, as well as 3 different executables. This whois.exe executable is what we're going to use to run our Whois lookups. Once we have this tool downloaded, we can start working with Whois on the command line. So, to run Whois, we can do /whois.exe, and then provide it with either a domain name or an IP address once again. So let's provide it with icann.org again. And scrolling up, we can see that we got very similar information to when we used the web browser. However, doing it on the command line gives us a little bit more flexibility to start doing this programmatically. So we can see that in the output of the whois.exe, it tells us connecting to org.whoisservers.net, and then we get a variety of information about the domain that we've looked up. So we can see the Whois server, the registrar URL, the updated date creation date, the registry expiry, the registrar, the domain status, various IDs and names if they aren't redacted. We can see the registrant organization is ICANN, or Internet Corporation for Assigned Names and Numbers. There is more information about the registrant, as well as the admin. We have the name servers again, and DNSSEC information. So now we've looked up a domain via the domain name using the whois command line. Let's do the same thing, but with an IP address. So once again, I'm going to type in /whois.exe, and then I'm going to give it an IP address. And in this case, I'm going to give it the same IP address of the name server for ICANN.org that we used previously, which is 199.4.138.53. And if I scroll up, we get very similar information in the output. So this is how we can use the command line to once again use the whois tool to look up IP information using a domain name or domain information using an IP address. And if we want to clean up the command a little bit, we can pass the flag -no-banner to this command before the IP address and hit enter. And it gives us a slightly cleaner output at the start. This can be useful if you're trying to incorporate this into a scripting environment. This can be a very useful tool for getting preliminary information when doing your reconnaissance for a penetration test. In this video, we're going to look at how to use both the nslookup and dig commands to query DNS information. Let's start with nslookup. nslookup is a tool that we can use to display and diagnose domain name system or DNS information. In this case, we're going to be using it within a Windows PowerShell terminal, and generally PowerShell comes pre-installed with nslookup as an available tool. To use the command, we type in nslookup and then hit enter. This starts us in an interactive terminal session within the nslookup tool. So within this interactive session, we have a variety of commands available to us. One of the most useful commands is the help command, so let's start there. When we type in help, we get an output of information telling us what commands are available, along with a description of how to use those commands. One of the most useful commands is the very first one in the list, which is name. And that will print info about the host/domain name using the default server. So in this case, if we want to use this command, we would just replace name with the URL or IP address that we want to get information about. As an example, let's type in nslookup.io. And we have found some DNS information for that domain. The name we used was nslookup.io, and we have some IPv6 and IPv4 addresses that have been found for it. Now, instead of looking up via a domain name, let's try an IP address, such as 8.8.8.8. And we can see that this is the Google DNS server with the name dns.google. If we scroll back up to the help output, we can see that we have a variety of options we can set along with this command. We aren't going to go through all of these options, but let's take a look at one of them. For example, type equals X. This allows us to set the query type, and in this case, we can set the query type to be any, or whatever other option you might need for your use case. But in this case, we're going to use any. So within our interactive session, we can type set type equals any, and now we have set our query type. So let's run nslookup.io again in the interactive session and see how it looks different now. And we can see that this time we have internet address equals, and on the bottom line, unknown type 46. So this different output is a result of the query type that we set before in our interactive session. So this is how we can use nslookup to perform DNS lookups and get other information about domains, which is a very useful way to add to your reconnaissance and information gathering stage of a penetration test. Let's take a look at dig now as a command. So to exit the interactive session for nslookup, I'm going to type in quit, and this takes us back to the terminal. To use the dig command, we are not going to be able to use PowerShell. We can see that if we type in dig, the name is not recognized as a valid command. So we'll need to have WSL, or Windows Subsystem for Linux, to use dig on our computer. To do that, let's install WSL first with the command wsl-install. And this will install an Ubuntu-like system on our Windows instance. If you're already working on Linux, you won't need this step and you'll be able to install dig directly within a normal terminal. Once the installation completes, you'll be prompted to put in a username for your Unix system. In this case, let's use demo. And then put in a password for your user. And now we are into a Linux terminal that we're ready to use. To install dig in this terminal, we can start with sudo apt update. And now we can install dig with sudo apt install dnsutils. Now we can use the dig command within our WSL terminal. If we type in dig and hit enter, we can see that it is now a valid command. So let's start with the help command for dig by typing in dig-h. And the output shows us how we can go about using dig. So under the usage section of the output, we start with the command dig, and then we can pass it a variety of options. And for each of the options listed, the description is down below. So for example, domain in the usage is listed in the where section and is described as domain is in the domain name system. So let's start with dig nslookup.io. And we have our information back from the dig command. If we look under the answer section of the output, we can see that dig has found the same IP addresses that we found using nslookup. And then we have meta information about the command itself. So at the bottom, we can see how long the query time took, the server that was used, when the query took place, and the message size. And we also have metadata above for the command. And once again, we can also do a reverse DNS lookup using the IP address with the command dig-x 8.8.8.8. And in the answer section, we once again see that this IP address is associated with the Google DNS server. So this is how we can use dig to also perform DNS lookup information and help out with the reconnaissance stage of our penetration test. In terms of the differences between nslookup and dig, nslookup tends to be a little bit simpler and provides us with the interactive mode to do multiple queries in a row without needing to reissue the same command over and over. However, it tends to be more limited than dig and has also been deprecated in favor of dig. Dig is a more comprehensive, more full-fledged tool that is more flexible and versatile overall. As we can see in the output here, it provides us with more detailed output when compared to nslookup and is overall more powerful. However, they both accomplish similar jobs, and in most cases, you'll be able to use whichever tool you're more familiar with. In this video, we're going to use the Census platform to perform open source intelligence reconnaissance. Census is a platform that aims to give more visibility into internet-connected devices and services. The idea behind Census is to allow the search of various assets on the internet, like servers, websites, or IoT devices, with the aim of finding potential vulnerabilities, misconfigurations, or security risks within those devices. It performs this search via active scanning on the internet and creating a database of all of these devices and services. Some of the use cases that we can use Census for include identifying and tracking various assets, detecting vulnerabilities within those assets, monitoring for threats, and performing research and analysis. Census is very similar to other platforms like Shodan, but tends to have more of a focus on the research side of cybersecurity. To get started with Census, open up a web browser and navigate to the URL seen at the top of my screen, which is search.census.io. When you get to this screen, you will see a search bar in the middle of the page, and on the left, we have various options we can configure. So at the far left of the search bar, we can click on the Hosts button and see a drop-down list where we can select two different datasets, either hosts or certificates. We'll start by doing hosts. Next, we can click on the gear icon, and this allows us to set the settings for our search. We can choose the sort order, how many results we want per page, and whether to include virtual hosts. For this search, we're going to leave everything as the default. There's also some metadata information below the search bar about the Census platform, giving us numbers about the services, number of IPv4 hosts, IPv6 hosts, and number of virtual hosts. Underneath that, we also have some resources, like getting started, if we want to upgrade to a premium account, some community features, as well as trying beta features. Now let's get started with searching via Census. Census actually has its own search language that you can use to write queries in the platform. However, the search language is fairly intuitive, and you don't need to know any programming languages to use Census Search. For our first example, we're going to do a full text search using the query hello in the search bar. And what this will do is do a search for any hosts where the parsed data has the word hello contained within it. Once I click search, I can start to see some results. So this gives me the results for my query. I can click on one of the results, like the first one, and it gives me more information about that host. Within this host, we can get information like the IP address, the reverse DNS, forward DNS, any routing, the services that are running. We can see that there's a remote desktop protocol port open for network administration and remote access. And then we have more detailed information if it's available. So we can go through and find information about the TLS handshake, certificate, and fingerprint. And if we want to know more information about any of these sections, we can click on the View All Data button for each of their respective sections. And this takes us to a much more detailed page around the port and protocol that it identified. Going back to the main screen, we can see that we have other tabs aside from this main summary tab. We also have tabs for history, who is data, and then we can click on the Explore tab. In the Explore tab, we can start to work with a graph-like system where we can click and hold on a node and start to pivot through the information. So if we click and hold on this first node, we can click on something like Explore Domains. And no results were found for that. So now let's click on View. And this takes us back to the same summary screen. Going back to the Explore screen, we can also click on Explore Certificates. We can do the same thing on any node in our graph. So if I click and hold on the green node and click Explore Hosts, I can see that the arrow and connections are starting to build up between these two nodes. And if I scroll down, I can see the available pivots that I have and more detailed information about what those pivots do. So based on these results within Census, we can start to get a lot of information about any potential host we want to examine. We can also see at the top of the screen, the search bar is actually the IP address now, instead of hello, which was our original search, because we've delved deeper into a specific host. So we could also search for IP addresses in the search bar. Now let's get a little bit more complicated with the Census search language. We could do a field value pair search, where we do something like services.http.response.html title as our field. And we can see as I'm typing, it prompts us with potential suggestions for what we might want to search for. In this case, I do see response, so I'm going to click on that. And then I can go deeper, and I can click on HTML title. And then this is the field that I want, so I'm going to end it with a colon. Now we want to search for a value. Let's try index of / and search for this. And once again, we see a similar results screen. In this case, we're searching for all of the hosts that have an HTTP service where the HTML title tells us that a directory is being exposed. And just like before, we can delve into these hosts. We could also use an exact match operator search, where we do something like services.http.response.body_hashes equals, and then we pass it something like a hash sum value that we want to check. Once we have our hash sum value, we can search for that and see results where the response body hashes match our specified hash sum. The query bar also supports Boolean logic, so we could type something like TeslaMate in round brackets, and then use the Boolean operator and give it a location. So location.country equals United States. And we want to wrap United States in quotes, and then hit enter. And now we're doing a search for hosts that are only in the United States with references to the string TeslaMate in those hosts. And there are a variety of other ways you can work with the Census query language to build more and more complicated queries for your reconnaissance and information gathering stage. So this can be a very useful tool in a penetration tester's tool belt. In this video, we're going to look at how we can use the Hunter email outreach platform for enumeration and reconnaissance during a penetration test. To get started, open up a web browser and navigate to the URL seen at the top of my screen, which is hunter.io. On the main screen of the page, you'll need to create an account to start using the platform. So click on Get Started for free, and then go through the process of signing up for an account. Once you have successfully created an account, you will be brought to this main dashboard. On this dashboard, we can start using the Hunter platform. What you will see is, in the main part of the page, a search bar that we can use to describe companies that we're looking for, and on the left, we have filters we can apply to our search. And on the top bar, we have a variety of different tabs that we can navigate to, with the default tab being this Discover tab. To get started, let's click on the Show Me an Example button. And what this has done is it has applied a search for companies using Canada as a location. So what we see is a list of companies that match that filter. So if we click on Shopify.com, we can see that there are 546 email addresses associated with Shopify.com, and it brings up a tab with information about the company, more details on the company below that, and then we have an email addresses tab within the drawer. Under that emails tab, we have a list of emails associated with the domain Shopify.com and the company Shopify. So a use case for this would be if we were running a penetration testing campaign to evaluate the overall cybersecurity knowledge of a company base, and we wanted to do something like a test phishing attack on an organization, we could use this email address to create a list of people we want to test. If we navigate to the Technologies tab, it gives us a list of the technologies that are used on Shopify.com, which can be useful for our penetration tests to try and find vulnerabilities within specific pieces of software or packages that we could use in our penetration test. And then if we click on Signals tab, this gives us a list of updates that have been found for this company. So we can see that on August 10th, 2024, a new email address was found. And we can scroll through this list to see what kind of updates have happened around this company. Now, let's return to the main screen. First, we can clear out our filters either by clicking on the X underneath headquarters location or by clicking Clear All. Now we're brought back to the same main screen we started on. Let's try a search of our own, and we can use the ghost text in the search bar as an example. So let's try out small companies in Austin, Texas. And now we can see a list of small companies in Austin, Texas, along with the email addresses that would be associated with those companies. And we can see the list of people for these companies tends to be around 1 to 10, and we can see what type of company they are and their location. So in this way, we can start to gather information about whatever company it is we're looking for, as long as that information is present in Hunter.io's search database. Now let's explore some of the other tabs along the top of this page. If we click on the Search tab, this brings us up to a domain search. If we click on the question mark beside the domain search title, it gives us more information about what the domain search is doing. And generally, this search is going to find all the email addresses for whatever domain name you search for. And the key here is that these email addresses will appear publicly somewhere on the web, and Hunter will find those for you. And cost information around this domain is listed below. So if I type in Shopify.com again to the domain search, we can see it has popped up with some suggestions that we might be looking for. And the first one is the one that we saw earlier with 546 results. And so if I click on that, we can see that same list that we saw earlier with the email addresses. And from here now, we can start to apply filters on this email address list, like either personal or generic, the department that the email address is associated with, or show only results that have phone number, position, or full name. And like before, if we want to clear out our search, we can go into the search bar and click on the X button, and it brings us back to the main domain search. We can also see that it maintains a history of our recent searches. So if we want to reapply a search or reperform a search, we can do that easily here. Moving on to the next tab, we can click on the Finder tab. And here we can use the Email Finder. Once again, if we click on the question mark beside the Email Finder title, it gives us a description about what this is doing. So this gives us a way to find email addresses using a name and domain name combination. So we could try test@test.com. And it tells us that this domain is used by a disposable email address provider. But if we click on something else in the list, like test.gg, it can tell us we couldn't extract a first name and a last name from the provided full name. We could leave that blank, and it will tell us we're missing the first name parameter. If we type in John Doe, it tells us we didn't find an email address for John Doe. So we can use this tool to verify whether or not a given email address exists. Returning to the question mark, we can also see that it will return us with a confidence score of how confident the platform is that this is a verified real address. Moving on to the Verifier tab. Once again, we can enter an email address here, and if we click on the question mark, we can see that the email verification tool gives us a way to check whether or not an email address is deliverable without actually needing to send an email to that address. This can be very useful if you're trying to avoid detection during your penetration test. So if we type in test@shopify.com, we can see it gives us some information, but this is an accept-all domain, so they can't determine whether the email is valid or not. But we do have a confidence score of 73% associated with that information about Shopify.com accepting all email addresses. Now let's move on to the Bulks tab. And this is where we can do a lot of these previous tasks that we've looked at, but we can do them in bulk. So we can perform bulk domain searches, email finders, and email verifiers. If I click on domain search, we could launch a bulk domain search from here by clicking on the new bulk button. And then we can go through and fill out all of the necessary fields to perform a bulk domain search. And this will do the same thing that we saw domain search do, but on a larger scale. And finally, let's look at the Campaigns tab. On the Campaigns dashboard, we can click on the New Campaign button. And what this will allow us to do is launch something like a phishing campaign against a list of email addresses. So within this page, we can select the content that we want to have within our email campaign, such as the from sender, the subject, the body of the email. We can choose to have follow-ups, insert unsubscribe links in the emails, and track the email opens, all of which can be useful when determining the cybersecurity awareness of an organization. As we move through these campaign settings, we'll be able to set audiences, various settings, and review, and then launch the campaign from here and see the various statistics and metrics about our campaign within the campaign window. So we will be able to click on engagement, reporting, and get all kinds of information about this when we launch an actual campaign. So this is how we can use the Hunter platform for our reconnaissance, information gathering, and other penetration testing activities. In this video, we're going to look at how we can use the DNS dumpster tool to perform security assessments and help us in our penetration testing. To get started, we first need to open up a web browser and navigate to the URL seen at the top of my screen, which is dnsdumpster.com. When you navigate to the URL, you'll be brought to this main page with a search bar in the center of the page. This tool is used by penetration testers to build up a map of an organization's attack surface during a penetration test. You can also use it if you are a network defender to proactively secure your network. DNS Dumpster helps perform all of these activities by helping you with domain discovery, revealing the subdomains associated with a domain, and performing DNS record retrieval. So let's get started and see what this tool provides for us. The first thing we can do is do a DNS record lookup on a domain. For example, we could type in dnsdumpster.com into this search bar and click search, and we get results for dnsdumpster.com. So we can scroll down and see what kind of results we have retrieved. First, we have hosting information, or IP block owners, which gives us information about the hosting services, and then we have the geo IP, or location, of the actual hosting. And that tells us that this is primarily hosted in the United States. Continuing down, we can see it has found multiple DNS servers for us, and for each DNS server we get the name, IP address, and common name, as well as location. If there were any MX records, this is where we'd find something like a domain email, and then there's a TXT records section. MX records can be useful if you're trying to build up a mailing list for your penetration test, and use something like the Hunter IO tool. And TXT records can be useful for finding a variety of information, including things like security policies, comments left over by developers, network descriptions, and more. So oftentimes during your penetration and network mapping, these two sections are going to be very useful for your reconnaissance and reporting. And then we have a host records section, which gives us more detailed information about the host itself. If we want to download copies of this information, we can download .xlsx copies of this, or we can click on View Graph, and this brings up a graphical representation of what we have discovered. So we can work through this graph, starting at dnsdumpster.com, and we can see how it branches out. So we have an empty branch leading to the MX records because none were found. We have a branch leading to the name servers, where the DNS servers were found, and we have another branch leading up to our hosting server. This can be very useful when enumerating an attack surface on a network or an organization. This graph can be exported as a PNG as well, so it's useful for reporting purposes. And you can maneuver and manipulate this graph to suit your needs by clicking and dragging on various nodes. So if I wanted DNS Dumpster to be on the left and everything related to it to be right of it, I can do that by clicking and dragging. Returning back to our main results screen, we can see that underneath of those buttons, DNS Dumpster has created its own domain map for us, and it's similar to what we just saw on the graph, but a little bit less interactive. If we scroll back up to the top of our results, we can also see these buttons on the top right for DNS servers, MX records, TXT records, host records, and domain map. Clicking on these will bring us to the respective section in the search result. So if you have something that has a very large amount of results and you need help parsing through it, it can be useful to navigate to the direct section using these buttons. If we scroll all the way to the top of the screen, we can see we have a few other tabs available to us. We can click on the Home tab, which brings us back to the original search bar page we started at, or we can click on the Defend tab, and this gives us information about open source intelligence for network defenders. And this is a good resource to go over if you're getting familiar with performing this kind of network intelligence and defending a network. So in addition to being a helpful tool for discovering and mapping networks, this is also a useful tool for learning about network security in general. Going back to the top right, we can also click on the Learn tab. And once again, this is a good resource for getting started with network mapping and performing penetration tests, as well as defending a network. And then we have a Scanners button. Clicking on the Scanners button will take us to the associated organization HackerTarget, who hosts and maintains the DNS Dumpster tool. And they provide a range of various scanners as well as documentation about how to use them. And if we scroll down to the bottom, we can see that DNS Dumpster is associated with hackertarget.com. If we return back to the main homepage, we can scroll down on this page and get a little bit more information about how to use this tool, what DNS Dumpster can do, and how it works. So DNS Dumpster can be a very useful tool when looking at performing network mapping and defending networks. In this video, we're going to perform open source reconnaissance using the AWASP Reconnaissance tool. To do this, we're going to be running on a Windows system and running the AWASP tool inside of a Docker container. However, there are other ways that AWASP supports running, including building from source or using a pre-built binary. So depending on your preference, you can work with AWASP in different ways. To get started, open up a PowerShell terminal on a system with Docker installed and run the command docker build-t AWASP, followed by the link to the AWASP GitHub repository, which is github.com/owasp-awasp/awasp.git, and then hit enter. This will build our Docker container for us. Once we have the Docker container built, we can start to run the Docker image. So an example command that we could run is docker run AWASP and then enum -- list. And this will run our Docker container and output a list of all the data sources that AWASP is using. So here in the output, we can see a list of all the data sources, the type of those data sources, and whether or not those data sources are available. So as an example of some common ones that we might be familiar with, we can see that we have Shodan, which is an API type data source, but it's not available for us. We also have the wayback data source, which is an archive type, and that is available in our installation. So this is a good way of seeing all the data sources available to you, and which data sources are available in a mass but maybe not installed in your instance. So now that we know how to install and start running a mass, let's look at more specifically how we can start to use the tool. The tool has various commands available to us, and the first one we're going to look at is the intel command. To use the intel command, we'll start with docker run a mass, intel, followed by -h. And the -h tells us we want to see the help output for this command. So the output under this command gives us the usage for the intel command, along with all of the different flags we could pass to that command. The intel command is designed to collect open source intelligence on a target. So as an example, we could use it to collect intel on a specific word like OWASP. So let's run this intel command on OWASP.org, and we're going to use the -d flag to pass OWASP.org as a value, which will be our domain name, and then we're going to do a whois lookup on it. We can see we can do that if we scroll down and use the -whois flag, which will give us all provided domains running through a reverse whois. So to do this, we can use the command docker run a mass intel -d owasp.org -whois. And now a mass is performing its open source reconnaissance on owasp.org using a reverse whois. And it's doing this using the data sources we saw previously in the enum -- list. And as the command starts to run, we can see it populating various domains with blockster.com and modeltime.com. Now let's return to the enum command we used previously. Once again, let's start by using the -h command to get a help output for that command. So I'm going to run docker run a mass enum -h. And similar to the help command we saw under the intel command, we see an output of all of the different flags and usage options for the enum command. So let's use the enum command to passively search for any subdomains that are present with owasp.org. To do this, I'm going to use the -passive flag, which we see here. And this isn't really necessary because passive is the default setting, but it doesn't hurt in this case to be explicit. And then I'm going to use the same -d flag to pass a domain value, in this case owasp.org. So to do this, I use the command docker run a mass enum -passive -d owasp.org. And this will use the data sources to search for subdomains on owasp.org. And what we see is a long output of the subdomains that have been found using this amass enum. So this is how we can use amass as a tool to perform open source reconnaissance and intel during a penetration test. The amass GitHub page also hosts more resources. For example, if you want to install amass in a different way than we've shown here, this is where you can go to do that. So you can open up a web browser and navigate to the URL seen at the top of my screen, which is github.com/owasp-amass/amass. And on this page, you can scroll down to the installation section and see different ways that you can install the amass tool. We can also go to this installation guide linked underneath the installation header and see more detailed information about how we can go about doing all of these installations. On this page, we could also go to the left-hand bar and click on things like scripting to get information about using the scripting engine. They have an extensive tutorial on using the tool, as well as a general user guide. So these are useful resources for learning about the amass tool. In this video, we're going to go over how we can use the Nmap scripting engine. To get started, we first need to download Nmap. To do that, you can navigate to the URL seen at the top of my screen, which is nmap.org/download.html. And then, in the middle box on the screen, you can click on the distribution that you want to get Nmap for. In this case, we're going to click on Windows, and that takes us to the Windows section, where we can download the self-installer. So we click on nmap-7.95-setup.exe, And once our download completes, we'll click on Open File. Next, we'll run through the installation procedure. And now that Nmap has been installed, we can open up a PowerShell terminal and use Nmap via the Nmap command. If we type Nmap into the terminal, we can see that it outputs various usages for Nmap along with the flags and options we can pass to those usages. If we scroll down in this, we can see that there is a section called Script Scan. Script Scan is where we can use the Nmap scripting engine. So we have a variety of options that we can use within the Script Scan capabilities. And these are some of the script flags that we're going to be working with today. So to work with the Nmap scripting engine, we're going to be using this --script command, and we're also going to be using this -sv command for service and version detection, which will help us probe open ports to determine service version and info. And what we're going to start with is a vulnerability scan to look through the vulnerability database and see if those vulnerabilities are present on a system. And we're going to use localhost for this, so I'm going to run nmap-sv --script vuln localhost, or 127.0.0.1. And now we're using the Nmap scripting engine to run a vulnerability scan on the local system. Now that our vulnerability scan has completed, we can look at the results. First, because we used the -sv flag, we did a port scan to see what kind of services and ports are open on the host, and that's what we get here in the first part of the results, which gives us a list of ports, whether they're open, closed, or what state they're in, the service that typically runs on those ports, and any versions that were able to be found on those ports. If we scroll down to the bottom, we can see where the Nmap scripting engine results came in under the host script results section. And here we can see a list of 3 vulnerabilities that were potentially found on the system. And we found SMB vuln MS10-061, Samba vuln CVE 2012-1182, SMB vuln MS10-054. Now, in this case, these are not indicating that these vulnerabilities are present on the system necessarily, but rather indicating which vulnerability checks were done and what the results were. So in the case of the first 2, where we have results like failed to receive bytes, this is telling us that the vulnerability scanner tried to check for these vulnerabilities, but couldn't establish a connection to the SMB service. Most likely, this is because the SMB service is not running on this host, so we're unlikely to be affected by these vulnerabilities. In the last case, the result is false, which is telling us that in all likelihood, this host is not susceptible to this vulnerability. So these are how we can interpret the results from the host script. Now in this case, we use the built-in vuln scripts, but we can also use external scripts from other resources to run more robust scans or different functionalities. So let's add some external scripts into our environment. First, we're going to navigate to the location where we want to install the scripts. Because we installed this on Windows, we are going to put our scripts into C program files x86 nmap scripts. So in your terminal, use the command cd followed by the path to the scripts folder, and then we can use git to clone the repository of the scripts that we want to pull in. In this case, we're going to use the vulners repository, so we'll use the command git clone https://github.com/vulnerscom/nmap-vulners.git. Now we can use this nmap vulner script that we've just pulled in. This is also going to be a vulnerability scanner, but the difference between the built-in vuln script and the vulners script that we just pulled in is that they will use different vulnerability databases to try and find vulnerabilities on a system. Vuln will use an internal database built into Nmap, whereas vulners will use its own external vulners database. So to use the script, we're going to use a very similar command that we used previously. We're going to start with nmap-sv-script, and then we're going to pass it the folder for nmap vulners that we just cloned. and then the target, which will still be localhost or 127.0.0.1. Now we're running a vulnerability scan again, but using the new scripts that we just pulled in. And once again, the first part of the results are the same, with the -sv output, and at the bottom, we don't have any output, meaning that no vulnerabilities were found by the Nmap vulners database. There are a huge number of scripts available within the Nmap scripting engine. And if we do an ls inside of this folder that we navigated into, we can see an output of some of the scripts that we have available to us. So by doing ls, I can see that right here is the vulners script that we just pulled in, and I can scroll up through this list of scripts to see all of the ones that are available to me. And there's a huge number of scripts that we can pull through. One thing to notice is that there's no direct vuln script to map back to the command that we used originally. And that's because vuln isn't a specific script, but rather a keyword that sets a predefined category to which scripts belong. So in this case, vuln means all scripts that are associated with the vulnerability scanning or vulnerability discovery portions of Nmap. So when we use the vuln command, we actually ran a number of different scripts to check for vulnerabilities. So this is how we can use the Nmap scripting engine to try and perform reconnaissance on a system. In this video, we're going to look at gathering information using the Harvester tool. The Harvester tool can be run on a variety of different platforms. For example, it comes pre-installed with Kali Linux. You can run it in a Python virtual env or a Docker container. You can build it from source, or in our case, we're going to be running it and installing it on an Ubuntu Linux system. And in this case, we're going to be using WSL because we're working on a Windows system. So to get started, open up a Windows PowerShell terminal on a system with WSL installed and run the command Ubuntu. Now we're working inside of an Ubuntu system in WSL. Now, the first thing we need to do is clone the Harvester repository. We can do that with the command git clone, followed by the URL to the repository, which in this case is github.com/laramies/theharvester.git. Next, we'll change directory into the newly cloned repository with the command cd the harvester. Next, we need to make sure that we have Python installed on our system, and we can do that with the command sudo apt install python 3. And in this case, Python is already installed, and for most Linux distributions this is going to be the case. Next, we need to make sure that we have all of the requirements needed by the Harvester to run in Python. To do that, we can use the command sudo apt install python 3-pip. Once that's installed, we can use the command pip3 install -r requirements.txt to install all of the necessary packages for the Harvester tool. Once this completes, we should have all the necessary modules and packages installed to run the tool. Now that we have all of the requirements installed, we can start to use the Harvester tool. To do that, we use the command python 3 /theharvester.py. And because we didn't pass it any options, it outputs the usages that we could have done with it. So below the header, we see a usage description for the harvester.py along with all of the different flags that we could pass to it. The first flag is the -h flag, which will give us help output for using the tool. So let's try that first. If we use the same python 3 the harvester.py command and pass it the -h flag, we can see that it outputs a help output for us. It gives us a brief description of what the Harvester tool does, and the Harvester is used to gather open source intelligence or OSINT on a company or domain. Once again, we have the usage above that, and below it we have options showing us all the flags and descriptions of what those flags do that we could pass to the command. So the first one is the one we just used, -h or --help, and that shows this help message and exits. And then we have a variety of other options. Let's start with the -d, -l, and -b commands. The -d command is where we pass a domain that we want to search. So this would be the company name or domain name to search. Then the -l command is our limit, limiting the number of search results, and the default is 500. Then the -b command specifies the source that we want to try and do this search from. So we have a variety of different options listed in the description, and we're going to be using Bing as our source. So we start with the same base command of python3 the harvester.py, then we pass it -d, and we'll search kali.org. Then we pass it -l, and we're going to limit our search results to 200. And then we pass it -b and specify Bing as our source. And in this case, we have no information found. Now, there could be two reasons for this. One, there could be no resources found in the Bing data source, or it could be that we didn't specify an API keys.yaml. We can see that it created a default API keys.yaml, but you may need to create your own API keys in order to properly interact with a source. However, this is how we can go about doing a domain search and gathering information using the harvester. We could try a different source by changing -b Bing to -b census. And in this case, we can see explicitly that we're missing API keys for census. So we know that this is not going to work because we need API keys for these tools. Let's try another source of DNS dumpster. And here we can see that we actually do have some results. So scrolling up, we found through DNS dumpster no IPs, no emails, but we did find 62 hosts. And then we get a list of all the hosts that we found. So this can be a very useful tool for searching through and digging into domain information on a penetration testing target. To finish off, let's quickly look back at the help command and see some of the other options that we can use with this tool. So we've seen how to use the -h, -d, -l, and -b flags, but we do have some other options. For example, the -s flag would use Shodan to query discovered hosts. So we can go even further. For example, after we found this list of hosts, pass the -s flag and use Shodan to get more information. We could use the -p flag to specify proxies for requests. If we want to start with a specific result number, for example, when querying with Shodan, we could start with the result number X, meaning we don't have to query every single result. If we have a -l of 200 and a -s of 150, then we could start at 150. We could take screenshots using the --screenshot command. If we want to search for virtual hosts, we can do that with the -v command. We can specify specific DNS servers to use for lookups with the -e flag. Takeovers can be found with the -t flag. We can resolve DNSs with -r. We can do DNS lookups with -n. And we can perform DNS brute forces on domains with -c. And if we want to save our output to a specific file, we can do that with the -f flag. In this video, we're going to look at how we can use wiggle.net to collect information about wireless networks and hotspots and get other reconnaissance information for our penetration tests. To get started, open up a web browser and navigate to the URL seen at the top of my screen, which is wiggle.net. Wiggle.net is a website specifically designed to gather and map information about wireless networks. It does this using geolocation data. When you first navigate to the website, you'll land on the main interface, which will show us a map allowing us to move around and explore wireless networks in different areas. The map also has a search bar in the top left that we can use to search for specific locations, addresses, or coordinates to go to specific spots on a map. By default, the map looks like it's over San Francisco. And if we zoom in, each of these individual dots represents some sort of node in the database that we could get information about. If we look on the right side of the map, we have a drawer that allows us to apply various filters to the map to make it more tuned to our use case. We have options here like latitude and longitude, SSID and BSSID, date ranges that we could specify. We could specify possible free nets, possible commercial nets, no labels, only discovered by me and only discovered by others. We can modify the coloring, which is applied based on the density of networks. And then once we have specified our filters, we can click on Filter. Or if we want to return to the defaults, we can click on Set Default. We can also change the standard view from something like standard to grayscale, night vision, or whatever we prefer. For this, we're going to leave it in the standard view. Zooming out, we can start to see how the density filter works based on the coloring. We can see there's a much denser area in the center of the screen, but on the northern peninsulas, we have a much less dense area. So we can get a very quick sense at a glance of how many networks are present in a given area based on this density information. If we want to see a bigger version of this map without the extra information around the sides, we can click on the View button in the top left-hand corner and then click on Map. This brings up a full screen version of what we were just looking at. If we scroll all the way in as far as we can go, we can start to see the names of the actual network nodes. Now, if we want to do a more specific search, we can return to the top left button that says View and click on Basic Search. Here, we can search for networks more specifically. So at the top, we have the option of searching for Wi-Fi, cell, or Bluetooth networks. Because we're interested in hotspots, let's do a Wi-Fi search, and we'll leave the default latitudes and longitudes. We'll leave the default last updated and BSS ID, and we'll leave a blank network name, but we're going to select only freenets. And then we can click on Query. And this will execute a query for all freenets or hotspots that we find with our given filters. And now we have a list of all the freenets that were found by Wiggle. So we can click on an example one, like medium light, and it shows us where on the map that network is, along with some other information about the network. Within the map, we can also switch between map view and satellite view, depending on how you want to look at it. We could switch to cell networks and perform similar queries here, and in this case, let's leave the defaults. And now we can see all of the cell networks that are running in the area. And we can also do the same for the Bluetooth networks. When I click Query, we'll see the Bluetooth networks that are present in the given area as well, along with more detailed information about each network. If we want to do more detailed searches, we can go to the View button in the top left-hand corner and click on Advanced Search. Here, we have a similar functionality, but with a lot more granular control over what we're searching. We can see that we can give average locations in terms of address or coordinates, as well as network characteristics. This is under the General Search tab. If we go to the Wi-Fi/Cell Detail tab, we can see that we can give more detailed information here as well. And similarly, on the Bluetooth Search tab, we can once again give more detailed information. If we go to the top bar and click on the Uploads tab, we can see that Wiggle database is actually populated by observations and scans from users. So there are ways to contribute to Wiggle by uploading scan files to their database. And this is how Wiggle populates a lot of its information. If we click on the Info tab, we can see that we can get various information about all of the platforms that Wiggle works on, as well as FAQs, their forums, and their social media presences. We can click on the Stats tab to see the general statistics about how much information is inside of Wiggle, such as the number of unique Wi-Fi networks in the database, which is 1,389,992,888 at the current time. And we can also go to the Tools tab, which will give us options for downloads if we want to download data. We could click on the API tab to see how we can work with this tool programmatically. There is a CSV upload section that allows you to upload data in a CSV format, and you can manage your account here. Clicking on the globe icon in the top left brings us back to the main screen that we started on. So Wiggle can be an excellent tool for performing reconnaissance if you're dealing with Wi-Fi, cellular, Bluetooth, or hotspot networks. In this video, we're going to look at how we can use the Insider Network Analyzer to perform reconnaissance activities for a penetration test. Our first step is going to be to download Insider. To do that, we can go to the URL seen at the top of my screen in a web browser. The URL is metageek.com/INSSIDER. On the main screen, we're going to click on the Download Insider button, and this should automatically start the download for your Insider application. Once the download has completed, click on Open File. At this stage, you'll need to have created an Insider account in order to continue with the installation process. Once you create an account and click Login, you'll be redirected to this main page of the application. Here, you'll see a list of all the networks that the application was able to identify. For each network found, you'll find the SSID, the signal strength, radios, clients, channels, whether or not the network is secure, the modes, the max rate, and when the network was last seen. The main purpose of this application is as a network analyzer for performance. So oftentimes, the use case for this application is to optimize and improve a network's speed and performance. However, this same information can be helpful for the information gathering phase of a penetration test. By performing this network discovery that the application has automatically done, we can see all of the wireless networks that are within range, and that can help us identify any potential targets we might want to test. Also, gathering this SSID information or MAC addresses of access points can help you in determining how you might want to go about testing those networks. Additionally, we can use this channel analysis, which we can see there is only one 2.4 gigahertz channel that this network is running on, to see which channels are actually being used, and that can help us identify any way that we could interfere with the network or vulnerabilities that might be present based on the channel being used. This can also be a way of seeing which networks are overlapping in terms of the channels that they are using. When we look at the signal strength of a given network, we can determine how far the coverage area or reach of a given network is, which can be useful for understanding where you might want to put something like a rogue access point or perform man-in-the-middle attacks. This can also help us get an idea of where the physical location of the access points of a given network are, which can be useful in our penetration tests. If we double-click on any network that we found, we can get more information specifically about the given access point. Here, we can see the security that's applied to the network, in this case WPA2 personal, and this can give us an idea of what kind of encryption type is used by a given network. In this way, we could identify if a network is using a weaker encryption type or has poor security configurations that we might be able to take advantage of. It can also tell us if the network is open, in which case we will be able to freely connect to that network. If we return to the main screen, we see that there is a filter to apply for hidden networks. This allows us to hide hidden networks, but by default, hidden networks will be found by Insider as well. So if a network is hiding its SSID, this application may still find it. On the left-hand side of the screen, we have a few different tabs we can navigate to. By default, we start on the See All Networks tab, but we can also go to See All Clients, and we can see that there is an experimental feature where Insider can discover devices on your local network using various IP tools. So once you have connected to a given network, this tool can also be useful for finding what other tools or devices may be connected on your network as well. We can also click on the See All Channels tab and see what channels are being utilized, what percentage of utilization is on each given channel, and which network has the highest signal on a given channel. We are also able to navigate to the Network Snapshots page, where we can take snapshots of a network to track how the network changes over time. And we can expand and collapse this tab as we wish. If we go to the top left corner and click on File, we can see that we can discover LAN clients, and we can export summary. This summary export can be very useful for the reporting phase of your information gathering. So when it comes time to put together everything that you found, this tool has a nice way of packaging that together for you. We can customize whether we see 2.4 GHz only, 5 GHz only, or both in the View section of our toolbar, as well as customizing the time frame that we see in terms of the last 2 minutes, 5 minutes, or 10 minutes. And there's also a dark mode. And then if we click on the Help button, we have some information on resources about using this tool. So this is how we can go about using Insider as an information gathering tool around networks, even though that's not its express use case. So this also goes to show that penetration tests can make use of tools that aren't necessarily specifically built with penetration testing in mind. We can get creative and use other applications to help get this kind of information for us. In this video, we're going to look at how we can use Wireshark to perform reconnaissance activities. To get started, we first need to download Wireshark. To do that, open up a web browser and navigate to the URL seen at the top of my screen, which is wireshark.org. When you navigate to this site, on the main page, click on the Download button. Next, we need to select the release that applies to our platform. In this case, We're going to be running this on a Windows system, but there are distributions available for Mac OS as well as source code. For now, I'm going to select the Windows x64 installer, and this will download an executable. When the executable download completes, click on Open File and start the installation process. In the installation wizard, we first click Next. Then we need to read through the license and click Noted. And then we click on Next. And then we'll leave all the defaults in terms of choosing the components and click on Next. We're not going to create any shortcuts, but you can if you want to. And we'll leave the default Associate Trace File Extensions with Wireshark checked. We'll leave the default installation directory and click Next. We currently have npcap installed, but if you need to install npcap, you can select Install npcap and click Next. If you want to capture USB traffic, you can click on Install USB pcap, but in this case, we're not going to be doing that, so I'm going to leave it unchecked, and then click Install. This will start the installation process for Wireshark. Once the installation is completed, we can click Next, and we'll click Finish. Now, when we launch Wireshark, we should see a screen like this. On this main screen, we can see a variety of different network interfaces that we could select to try and start to capture network traffic on, which is the primary use case for Wireshark because this is a network analyzer that we use to perform packet captures and packet inspections on a network. Beside each network interface, we can also see the level of traffic that is currently happening on that interface. So we're going to double-click on Ethernet to start capturing traffic on this network. Now we're capturing packets on this network. Once we feel that we've captured enough packets, we can go to the top left and click on the Stop Capturing Packets button. Now the packet capture has stopped. If we decide we want to start again, we can click to the left of that on the Start Capturing Packets button, and it will give us the option to save captured packets before starting a new capture, otherwise they'll be lost. Now, let's look at what kind of information we've gotten out of this packet capture. Each row represents a packet that was sent across the network. So let's pick an arbitrary row, for example, 129. We can see in the summary window, which is the main screen, the time at which this packet was sent, the source IP address where the packet originated from, the destination IP address that the packet was sent to, what type of protocol was used, the length of the packet, and more information. So this was an ACK going from an arbitrary source port of 28,276 to 443, which is HTTPS. When we click on this row, we can see two windows populate at the bottom of our screen. On the left, we have the human-readable version of the packet, and on the right, we have the hex representation of the packet. We're going to focus on the left side of this screen, and we can expand each of these by clicking on the arrow to the left of each row. So if we want more information on the frame, we can expand that and see all the information about the frame. Then we could expand the Ethernet 2 line and see all of the information there in terms of the destination and source. Then we could expand the Internet Protocol version 4, which is oftentimes where we actually want to start because very often we're interested in things like the source address, the destination address, the total length, the protocol, some of the checksums, and other related information. And then we can go into the transmission control protocol, which once again is really where we get into the meat of the information that we're often looking at for packets. So this tells us the source port and destination port, along with the flags that were set, and other useful information for inspecting a packet. We can right-click on any given row. So if I right-click on row 129, we can see that we can perform various options on the given packet. We could add comments to the packet. For example, if we are saving this packet analysis for reuse later, we may want to add a comment saying, "This is a suspicious packet," or "Look at this packet more in detail." We could also apply and prepare filters based on this packet. We can follow the TCP stream because this is just one part of the overall TCP handshake that we're looking at, so this can be very useful as well. Something that we notice here is that when doing a packet capture, we fill up a lot of information very quickly. So oftentimes when you're looking at packet captures, the amount of data can be somewhat overwhelming. Wireshark can help us here too by allowing us to apply filters. So if we click on the filter bar where it says apply a display filter, we can start to parse down our data from this packet capture. For example, we could filter on a specific IP address, for example 52.108.9.12, by typing into the filter bar IP. And we can see that as we type into this bar, it pops up with suggestions on what we might want to look for. And in this case, I'm going to click on the first suggestion, which populates with IP.adder == 192.0.2.1, and I'm going to change that to the IP address that we want to look for, and hit enter. Now, we only see packets where the IP address is 52.108.9.12. So this is a very useful way to look at only information you're interested in. For example, if you know that your specific target has a given IP address, then this is going to be a very useful filter for you. If we want to save this packet capture for later, we can click on File, Save As, and then we can give our file a name and choose the save type. By default, the save type will be Wireshark PCAP-ng, and oftentimes this will be a suitable format, but you may prefer just a straight .pcap, in which case you could select Wireshark/tcpdump. This will allow you to save, share, and load packet capture files. So this is how we can use Wireshark to analyze the traffic going across a network and get information.
In this demo, I'll use scripting to validate vulnerability discovery and analysis results. We'll be using Nmap for reconnaissance, scanning, and enumeration, and then validate our results with a Python script. In this simulation, we're testing services on our local host, treating it as if we've just discovered a new environment. So let's look at scanning with Nmap. Imagine you're performing a penetration test on an environment you've just come across. Your goal is to understand what's running and identify potential vulnerabilities. We'll start with Nmap to discover open ports and then enumerate the services running on these ports. Let's use Nmap to perform a full port scan. The command that we'll run is nmap -p- space localhost. This starts Nmap, and here's what this does. The -p- is a flag that tells Nmap to scan all 65,535 ports on the target. In this case, localhost. We do this to ensure that we're not missing any potentially open ports. After running this scan, we can see that we've found a number of services on some ports. So for example, we have FTP on port 21, HTTP on port 80, we have MySQL on port 3306. Once we have a list of these open ports, we need more details. So we'll use a second nmap command to perform some service version detection. We can do nmap space -s, lowercase s, uppercase v, space -p, 21, 80, 2222, and 3306 local host. So let's break this command down. -sv is the service version detection flag. It tells Nmap to attempt to determine the version of the services running on the specified ports. The -p flag, followed by the list of ports, restricts the scan to just those ports. This command will give us insights like whether a service on port 80 is an Apache web server, or if the service on port 21 is a particular version of an FTP server. These details are crucial for identifying vulnerabilities. Now that we have our list of open ports, let's hit enter. It runs nmap based on the command that we've just passed it, which should give us back our services. Here we can see that it's returned our services. In case of port 21, we have pure FTPD. In case of port 80, we have Apache HTTPD. In case of port 2222, we have OpenSSH. So now that we have our list of open ports and the basic service details from Nmap, we can move into what's called the enumeration phase. And here we dig deeper into each service to gather more information that could be useful in later stages of our assessment. For example, let's say we found SSH running on port 2222. In the enumeration phase, we'll try to identify the exact version of the SSH service. And this could reveal whether it's outdated and vulnerable to specific attacks. Similarly, if we have MySQL running on port 3306, we might try to connect and see if there are any default configurations or weak security settings. While we won't run any additional commands for this demo, think of enumeration as the process of exploring the information discovered in the scan and then using it to build a more complete picture of the target environment. This phase is crucial for identifying potential entry points or misconfigurations that could be exploited. With our Nmap results in hand, we'll move on to validation. We'll use a Python script to automate the process, confirming which ports are open and trying to identify the services running on them. The script checks ports like 80 for HTTP, where it sends a simple HTTP request and gets a response. It also grabs the banner from FTP on port 21 and SSH on port 2222. The idea is to automate these checks to ensure our initial findings are accurate. So let's have a look at our Python script. Here we can see that our target IP is localhost, and our ports are 8021, 2222, and 3306. So let's run our command to run our Python script. And we can say sudo python 3, and the name of our script is validate scan.py. And now we can see that our script has run, and we've gotten some responses. In this case, port 80 is open. The expected service is HTTP. This confirms that this service is running as expected on port 80, and the 302 found response indicates a redirect, which could be a sign that the web server is configured to redirect traffic elsewhere, perhaps to a login page or another resource. And this could be something we can investigate further to see where this redirection leads. Port 21 is open, expected service is FTP. It's identified the service on port 21, and we can see that the FTP service is running, and it provides a banner message from pure FTPD. And this message also indicates that TLS is supported, which could be relevant if we're looking at how secure the FTP service is. It's good information for assessing whether the service is configured securely or if it might be susceptible to attacks. Port 2222 is open. The expected service is SSH. The identified service is OpenSSH Ubuntu 4. And this service is indeed running, and we've identified the version. This is critical information, as knowing the exact version allows us to check if this version has any known vulnerabilities or if it's up to date. Outdated SSH versions can sometimes be a target for exploits, so we would document this as a potential risk. Port 3306 is open, and the expected service is MySQL. We've identified that the service is interesting because the script was expecting to find a MySQL service, which is the default on the MySQL port. However, it didn't get a banner message or a clear response identifying as MySQL. And this could mean that the MySQL service is running with restricted access, or it's not providing banner information for security reasons. We'd need to investigate this further, trying to connect with proper credentials or looking for configuration files. Overall, this output gives us a good starting point for understanding the services running on this target environment. The HTTP and FTP services provide useful information right away, while the SSH and MySQL results highlight areas for further exploration. This process showcases the importance of using scripts to automate and validate findings, ensuring our data is accurate and actionable for further analysis or reporting.
In this demonstration, you'll learn how to use Metasploit to discover vulnerabilities and exploit a system using those discovered vulnerabilities. The first thing that I want to do is I want to create a Metasploit database. So I'm going to do sudo space MSFDB and init, which means initialize the database. Type in my password. It says that the database has already been created, so I'm good to go. So the other thing that I should stress here is that you don't need to use Metasploit with a database. Some of the features of Metasploit do require the database. So for instance, if you're going to use the Nmap features of Metasploit, then the database must be initialized. So in this case, the database has been initialized, and I need that because I am going to use some of the Nmap features. But if I wasn't, I would, you don't necessarily need to create that database is my point. So next thing I want to do is I want to go into Metasploit. So I type in MSF console. It says that it's starting the Metasploit framework. And now I'm in a Metasploit prompt. And you can see there's a large number of exploits available on the system. So 2,134 exploits, and I'm sitting at the Metasploit prompt. And the first thing that I want to do is I'm going to use the Nmap features that are built into Metasploit to basically scan the network and discover ports that are open on a system and hopefully discover versions of software so that I can then search for vulnerabilities on that software. Now to save time here, what I'm going to do is I'm going to do a dash lowercase s for scan, capital V for version scan. Version scan will tell me what version of software is running on the port. And then I'm going to specify the IP address of one of the live systems on my network, which is 10.0.0.103. And just to save time here, I'm going to go and specify a few ports that I'm going to scan. So I want to scan port 21, port 80, and 3389, which is the remote desktop port. So in this example, I'm not going to scan the whole network just to save some time. I'm only going to scan the one system, but you could scan the whole network by putting in the IP address of 10.0.0.0/24 if I wanted to. And the ports, you could exclude the -P switch and it'll do a scan of all the default ports. In this case, just for time purposes, I'm going to specify 3 ports. And really, port 21 is the port that I want to perform the attack on. So I hit enter. The Nmap scan will take a few minutes because it is doing a version scan, which means not only is it going to identify the ports that open, but it is going to try and discover what version of software is running on the system. And it's completed. So again, because I'm only doing the 3 ports, it was pretty quick. So we can see here that port 21 is open on this 103 system. It's an FTP service, but because I did the -SV with Nmap, it's come back and said, oh, that's a VS-FTPD 2.3.4. So notice that I do have version information. That's important because what I want to do is I want to search for vulnerabilities or exploits against that version. And then notice that the web server as well is got a version number associated with it. So it's an Apache Web Server 2.2.8. So in this demonstration, I'm going to exploit the FTP service, but we could also look for exploits against that Apache 2.2.8. So now that I have a version number, now what we're going to do is we're going to use the search command, and we're going to search for exploits for VS-FTPD 2.3.4. And again, where I got that information is from performing that version scan with Nmap. And then I'm going to hit enter. And it comes back and says, okay, we got one exploit for you. It's known as exploit 0, and it's the exploit on a Unix system. Notice up top here, it did guess that the target is a Unix system. Underneath Unix, it's FTP VSTP 234 backdoor, right? And its ranking is this is an excellent exploit. So the next step in Metasploit is you want to choose to use that exploit. And the reason why the use command is here is because you may find that when you search for an exploit, there actually are multiple exploits and they'd have different index numbers here. So in my case, I only have one exploit here. So it's index number 0. But if there's 5 of them, it'd be 0, 1, 2, 3, and each one of them would have a different name. So I want to use, and you could either type in 0, say I want to use exploit 0, or you could type in the full path, FTP/VS-FTP. I use tab there to auto-complete that, and then I hit enter. Once I go and hit enter, then down below there, you can see the prompt has changed, and I'm actually on the exploit itself. So what you can do is you can use the show options command to display the settings for this exploit. And here are some of the different settings. So our host, which means the remote host. So before I run this exploit, I need to set the our host value. It currently has no value, and it is a required setting, which means it must be filled in. So I need to fill that in. But a lot of times when you're using Metasploit, a lot of the options will be filled in with default values. So our port, for instance, is the remote port, and it's port 21, which is already configured. So it's required and it's already set, so I don't need to set that. You could change its value if you wanted to, but I don't need to. So I need to set the our host value. So I'm going to go and do a set our host to, and then we're going to specify the IP address of the FTP service that we want to exploit. So 10.0.0. In my case, it's 103. I'm going to use show options again, just to make sure that it set that value, and it did. Looks good. Once we have all the required options that are listed up top, once we have all of those set, and in this example, there's only 2, the remote host and the remote port, the next step is you want to set your payload. The payload is what's going to execute when the system is exploited. So you can get a list of payloads with the show payloads command. So we can see we have one payload. It's payload with index number 0, and the name of this payload is payload command Unix interact. So basically it's going to give me a command shell to that target system. You can select the payload either by using the index number or by using the name of the payload. In this example, I'm going to set the payload by using the index number. So I'm going to use 0 and then hit enter. And then it gives me feedback, says the payload has been set to command Unix interact. Now that I have the payload selected, and I've got all my options set, now I can go and run that exploit. And how you run the exploit is you can use the exploit command, or you can use the run command. Either one will work. Now I should give you the heads up that I do find this is a little bit buggy, in the sense sometimes the exploit works right away, sometimes I'll have to run the command multiple times. So I type in the exploit command, and you can see here it's asking for please specify a password. So this is not going to be successful. So I usually bounce between use an exploit or use and run. And this time this will be successful because you can see the port used by the backdoor bind listener is already open. It found a shell, and now I've got session 2 open with that target system. So I do have a cursor there. I'm on the FTP server, and now I can use any number of FTP related commands. So for instance, I can use my ls command to list the contents of that FTP server. And keep in mind, I haven't authenticated to this FTP server, and I'm able to access the contents. So I can use any of my FTP related commands. In navigating through the file structure of this FTP server, I can download and upload files, that kind of idea. So in this demonstration, you saw how to use Metasploit to discover a vulnerability and exploit that vulnerability. In this demonstration, you'll learn how to use Netcat to create a communication channel between two systems. Netcat is a common tool used to create a communication channel between two different systems. To use Netcat, you can use the nc command in Linux or install Nmap on Windows, and that will give you the ncat command, which is a Windows version of Netcat. Let's get started by, on my Windows server here, my first step is going to be to set up a listener on this target system. In this example, I'll set up the listener on the server. The listener opens a port on the system to allow the attacker to gain access at a later time. This is common for maintaining access after the hacker has compromised the system. Let's get started with a couple commands. So I'm going to click on the Start button, and I'm just going to go to my command prompt here. And what I'll do is I'll run that with admin capabilities. In our Windows command prompt, because I've already installed Nmap, and Nmap includes the ncat command, which is the Nmap version of Netcat, I can use the ncat command at any point in time. So the first thing I want to do is show you that ncat has a -h switch that you can use to get help on the command, which will give you a list of all the different switches that can be used. So we can see here, this is ncat 7.95, and it shows the usage is ncat, and then specify your different options, and they give a list of all the different options here. I'll highlight a few of those options in a second. After you specify your options, then you specify the host name or IP address, and then a space, and then the port number that you're trying to use ncat or netcat to connect to. Now, some common options that are here, you can throw in a -4 where options is, which specifies that you want to use IP version 4 versus -6 would use IP version 6. Some other common options that I'm going to use in my example is -E, which means we want to execute a command. So what I'm going to do is I'm going to set it up so that if somebody connects to the system, a command prompt executes. And that'll give me command prompt access from a remote system. Some other switches that are useful here, there's the -H. We also have down below here, we have the -L. -L is how you set up what we call a listener. It means that you're configuring ncat to listen on a port number. So I'll use -L. We also have -N, which means don't resolve host names via DNS. So a lot of times if we are using host names, we may want to cut down on name resolution traffic by doing a -N. We can also use -V for verbose logging, so it outputs as much information as possible. So that's another switch. You'll notice that there are other options as well, so to specify that you want to use SSL to encrypt the communication, that kind of idea. So lots of options there on the netcat command. So the next thing I'm going to do is I'm going to use netcat on this system to set up a listener. So I'm going to do netcat or ncat space -n. Then after -n, remember -n is for no DNS lookups for name resolution. -v for verbose logging. Now I am going to set up this system as what we call a listener, which means this is going to be the target system. I'm going to go, after I set up the listener to listen on a specific port number, I'm going to go to another computer and I'm going to connect to this listener. After I do a -l for I want to be in listening mode, then I do a -p to specify the port number. And what I'm going to do is I'm going to go with, I want to listen on port 50,001. So a lot of our common services like web servers listen on port 80, FTP servers 21, secure websites, so HTTPS will listen on port 443. In this example, I'm configuring my own port number that I want to use, which is 50,001. So in order for somebody or me at a later time to be able to connect to this listener, I have to connect to port 50,001. Now, the other thing that I want to do is I want to execute a command. So I use -e, and I'm going to do cmd.exe, right? Which means that when somebody connects to this port, cmd.exe will execute. So I'm going to hit enter here. And we can see here that we get some output. It says that ncat version 7.95 is being used. And notice that it says that ncat is listening on port 50,001. And then I have a cursor blinking there without a prompt. So this is basically netcat running. It's currently waiting for me to connect from another system. Now, after we set up the listener, if we expect to be able to connect into this system at a later time, we're going to have to open the port on the firewall to allow somebody to be able to connect to that port. Again, which is probably myself at a later time. So to open a port on the firewall, we click on the Start button, and we're going to type in the command firewall. And we're going to go into the Windows Defender firewall. Once in the Windows Defender firewall, we're going to come down here to Advanced Settings. In our Advanced Settings, we're going to choose to create an inbound rule. An inbound rule means we want to allow or block inbound communication. So I right-click on Inbound Rules, and I choose New Rule. And I'm going to build a rule based off the port number of 50,001. You specify what protocol, whether it be TCP or UDP. So netcat is using TCP, and we're going to go with our port number of 50,001. Then it says, do you want to allow the connection or block the connection? I want to allow the connection. And then for what network profiles, right? Network profile contains settings, and there's 3 different profiles: domain, private, and public. So I do want this rule to be available for all network profiles. So I choose next. What do you want to call it? We're going to call it port 50,001. And then choose finish. And notice here that we do have our port 50,001 rule. It also has a green check mark beside it, which means it's enabled. If I want to disable that rule, which means communication would not be allowed through that port, I can just right-click and choose that disable command. Notice the green check mark is gone. I do want it enabled, so I got to right-click and enable it. So now traffic should be able to pass through that firewall. Notice netcat is still listening. So now I'm going to switch over to my other system and see if I can connect into port 50,001. Okay, I'm on my other system. Now my other system is a Windows 10 system. It does have Nmap installed as well, which means it does have ncat available at the command prompt. So I'm going to click on the Start button and type cmd. So notice that I'm in my Windows command prompt. The other thing I want you to notice here is notice the prompt. I'm at c:/users/student. Now, just as an example, what I'm going to do is I'm going to type the command hostname. And notice that it says my host name is Skillsoft Win10A. Perfect. That's important because what I want to do is after we make the connection to port 50001, you'll notice my prompt will change, which means I'm on the other system in a command prompt. And what I'll do is I'll verify that with the host name command. So to make a connection using netcat to the other system, use the ncat command. I'll use -n for no DNS name resolution, -v for verbose logging, and then you specify the IP address of the target system that's running in a listening state. In this example, that server has the IP address at 10.0.0.1. Then I'm going to put a space, and you specify what port number it's listening on. So it's 50,001. So from a Pentest Plus certification point of view, know how to set up netcat with a listener. So notice in this example, I don't have a -l, which means I'm not setting this system up as a listener. I am connecting to a system that's already in a listening state on port 50,001. So I'm going to hit enter here. Now watch my prompt. When I hit enter, I was successful, so it shows me the version 7.9 connecting to system 10.0.0.1:50,001. So that's the IP address and then the port number. And notice that my prompt has changed, right? I am now sitting at C:\\, not C:\users/student. So something changed there. And what it is I'm actually on the other computer right now. I remotely connected into it, and it's giving me a command prompt. So if I do the host name command, notice that it says my host name is server A. So I was successful. So I'm currently on server A system. So if I wanted to, I could look at the list of user accounts with the net user command. These are the users that exist on that system. And the other thing I could do as well is I could do net user hacker with my password /add. I can create a user account on that system. So notice that the user hacker wasn't in the original list, but if I do a net user, now I've got an account called hacker on the left side in that first column. Perfect. So that account wasn't there 2 minutes ago. Now I can do net local group. I want to modify the administrators group, and I want to add the hacker account to that group. It says command completed successfully. So what I did here is I remotely connected into the system on a port that I put in a listening state myself. So that was my back door. And once you're connected in, my point here is I can use any commands on that system to change that system. So in this case, I just created another backdoor, which is my own user account that I could gain access to the system at a later time. And that user account is in the administrators group. So in this demonstration, you saw how to use netcat to put a system into a listening state so that you could remotely connect into it at a later time. In this demonstration, you'll learn how to perform a network scan using Nmap. So I'm already logged into my Kali Linux system, and what I'm going to do is I'm going to launch a terminal up top here on the toolbar to launch a terminal session so I can start using the Nmap command. Now, Nmap stands for Network Mapper, and it's a very common tool that we use to scan networks, identify systems on networks, identify ports that are open on those systems, and also scan for vulnerabilities on the system as well, including identifying version information of the software that runs on that system. So let's start with a ping sweep. So the first thing I want to do is identify what systems are up and running on the network. And there's a couple commands that I could use here. I can use nmap -sp and then the network IP range. So 10.0.0.0 / I'm going to go with it /24. So it's only going to scan 254 addresses, right? So I'm going to hit enter here, and this will take a few seconds. We can see here it's completed already, and it's identified that we do have a system called server a.quick247.local, which has the IP address of 10.0.0.1. It also looks like we do have a system up and running at 10.0.0.7 as well. So there's a few systems up and running. It says that it scanned 256 IP addresses. So 256, and it's identified that 2 systems are up and running. Perfect. Now, so that's the idea of using Nmap to do what we call a ping sweep. And basically all you're doing is identifying what IP addresses are being used on this network and what IP addresses are up and running. Now, the SP switch that I use there, I've been using that for many years with Nmap. The dash lowercase s, means scan, but then the capital P is the type of scan you're doing, which in this case is a ping sweep. So it's easy to remember, dash SP for I want to do a ping sweep or scan ping. But what's interesting is that a lot of the new certification exams, and even the Nmap help, doesn't show that dash SP anymore as a switch that you can use. And obviously it still works because I just used it. So I do want to mention the other way that you could do a ping sweep with Nmap, because this is the command that would be on your certification exams. So it's nmap-sn, and then same thing, we're going to use 10.0.0.0/24. And it's going to go and do a ping sweep on the network. And notice that the output is the exact same, right? So again, for your certification exam, remember to do a ping sweep, we can do a -sn. So that's our first thing, is performing a ping sweep. And what I'm getting as a result from the ping sweep is I now have some IP addresses that I want to go and do a port scan against. Now, for this demonstration, what I'll do is I'll use this 10.0.0.1 system because that is my server that's running a couple different services. So I'll use that as the example. So now I want to go and do a port scan against that system and find out what ports are open on the system. So to do that, we can use an nmap dash lowercase s, meaning I want to do a scan. And remember, we saw that you could do a capital P, which is a ping scan or a ping sweep. But this time, what I'm going to do is I'm going to do what they call a TCP connect scan. So I put a capital T there. With a TCP connect scan, it means that the Nmap program will do a full three-way handshake with each of the tested ports, right? And Nmap has a default set of ports that it'll test the common ports. I think there's about 1,000 of them that it will test. We can specify what ports we want to scan if we wanted to look for a specific service, but for this example, I'm just going to have it scan the common ports. And then you plug in the IP address. In this case, I want to focus on that 10.0.0.1 system that I know is up and running. So I hit enter, and again, this will take a minute or two, I guess not that long. So this did a full three-way handshake with each of the common ports, and it lists out what ports are open. So it sees that port 21, TCP port 21 is open, and notice that it says, okay, it's an FTP service. 53 is DNS, right? So it notices that's open. I'm going to highlight just a few examples here of common ports. Notice port 80, which is the website, is open. And then down below that, we can see here 1433 is open. There's a number of Microsoft networking ports there as well, like the RPC port is port 135, but we also have 1433, which is Microsoft SQL Server. So by seeing that 1433 there, I know that this system is running SQL Server. So I could start researching how to exploit a Microsoft SQL Server, for instance. Another port that's interesting is I can see here we have port 3389 open, which is the remote desktop feature, the Microsoft Terminal services. So I know that this system has remote desktop enabled. So I could also research how to exploit remote desktop. So that's with a TCP connect scan. And we would document these ports as being open ports. Now, before I move on, though, I want to show you could also do a port scan. There's a number of ways, and there's more switches than what I'm showing you here, but I do want to mention the dash lowercase s and then capital S. So this is not a TCP connect scan. This is what we call a SYN scan. And with a SYN scan, you're only doing like a half, we call it a half open scan. It doesn't do, Nmap won't do a full three-way handshake with the service. And the reason to do that is because it generates less traffic. Generating less traffic means you have less chance of getting detected as you're trying to kind of scan the network and discover services that are open on the network itself. So I'm going to hit enter here, but what's going to happen is it's going to give me a little message that says, sorry, you don't have the privilege to do that. So to do the SYN scan, we have to throw the sudo command in front of it, and then nmap-ss 10.0.0.1. And then I hit enter. It asks for my password. So I give the password. And then what you'll see is the output will be the same. So I can see port 21 is open, 53, 80, right? All those ports are open. So the results are the same. It's just underneath the scenes, how the scan is happening is different, right? So again, the SYN scan doesn't do a full three-way handshake. Another important command for you to be aware of, and I'll go back to the TCP connect scan. So again, I'm still doing port scanning, but I'm just taking a look at a couple options here. So nmap-s capital T, which means I want to do a TCP connect scan. But what you can do, and this is on your certification exam, you can change the timing of the packets. So Nmap, when it's doing a port scan, it's sending traffic to each port that it's testing. Okay, so with a TCP connect scan, it's doing the full three-way handshake with each port. What you can do is you can slow down the timing between the request for each port if you wanted to, or you could go and increase the timing. And a reason to do this is if I can go and slow down the timing, so, check port 80, and then maybe a little bit later, check 81. So it's not happening, the traffic's not being generated all at once. And again, the goal is to try to avoid detection. So you can control the timing by using a -t and then a number from 0 to 5. 0 meaning it'll go and space those packets out more. And then as you increase the number, it'll go and send the request out closer together. So very common is like a -t4 or a -t5 to basically say, no, send each request out immediately. We don't need to kind of space the request out to avoid detection. So if I wanted to avoid detection, I would go with a -t0. But if I'm not worried about being detected, I would do a -t4 or t5, right? So we do a -t4 and then the IP address. Now again, when I hit enter here, what I want you to notice is we're not really going to see anything different as far as results go. But again, the -t switch is used to control how things are done underneath the scenes, right? Notice that in this example, I've got port 21 is an FTP service, but I don't really know what version of FTP software. So it is very common, let me clear my screen here. It is very common to want to know what version of software is running at each of those ports, and also to know what operating system is running. So with Nmap, we can do a -s, which means I want to do a scan. The type of scan goes in capital letters. So in this case, I'm going to do a capital V for version scan. And then what I'm going to do is I'm going to throw in a -O for OS detection. And then the IP address, which is 10.0.0.1. So this will do a version detection on each port, trying to tell me what version of software is running, and -O will tell me the operating system. This will take a little bit longer. Okay, it says that it needs more privileges, and so I need root privilege. So I got to throw the sudo command in front of it, and then have it execute. This will take a little bit longer because it's actually performing a number of tests underneath the scenes against those ports to try to figure out what version of software is running on each of those ports. Okay, so it's completed the version scan. Now the output doesn't look great here because my font's a little bit larger. So we can see here that it did start the Nmap scan. Down below that, it lets us know that, okay, it found one host up and running. I'm only scanning one host right now. And by the way, you can do all these scans against the entire network if you wanted to. So instead of putting 10.0.0.1, you could do 10.0.0.0/8 or /24 in my case, right? Down below that, I can see here, TCP port 21 is open. It's an FTP service. But notice that this time we have a version column. where it's trying to let me know what the version is. Now, I don't have a specific version number here, but I can see that it's a Microsoft FTP service. And then down below that, you can see port 80 is a website using HTTP, and that's Microsoft IIS HTTP daemon 10.0. So I actually have a version number for that one. And then same thing down bottom here with port 443, which is the secure HTTP port. Notice that's version 10 as well. We can see here 1433 is Microsoft SQL Server. Again, it would be great if I had a version number there. I don't, but at least I know it's a Microsoft SQL Server, right? And then down below that, because I did the -O, it actually is trying to do the operating system scan. So OS scan results may be unreliable. It lets me know. And here it takes a guess that you're running Windows Server 2016 or Windows 10 or Windows 12. And I believe that 10.0.0.1 system is a Server 2016 system. So it kind of makes a guess at that, lets you know the percentage. So it did an aggressive OS guess, and it's 92% sure that it's a Windows Server 2016. So what that means is, now that I know the operating system, now that I know some of the version of the software, now I could start looking for exploits against those specific versions, which is interesting. A couple other commands I want to show you because, again, these are important for the switches are important for your certification exam. The next command I'm going to show you is Nmap. So we just did -sv. What I'm going to do this time is just show you that you could do -version intensity, and spell that right, intensity. And so same kind of idea, underneath the scenes, when it's trying to figure out the version of the software that's running, it can send a number of different types of packets, and how the system replies is how it figures out what the version is, because Nmap knows that different systems with different software version reply different ways. So what's important is that, again, you can increase the intensity here and have it perform a lot of testing or minimal testing. And again, the reason why you care about this is because if you do minimal testing, then chances are you may avoid detection. But if you do, a lot of testing, then chances are you could be detected by an intrusion detection system or something like that. So you can change the intensity with numbers from 0 to 9, for instance, right? So 9 is a very intense version scan. And again, the hopes is that you'll get very accurate results there. I'm not going to hit enter there just because it'll take a little bit of time for it to execute, but that is a command that you definitely want to know as a penetration tester and also when preparing for your certification exam. One last switch I want to mention is that with Nmap, you can do a -A and then the IP address, 10.0.0.1. If you use the -A, it does a number of different types of scans all in one. So the first thing it does is it enables OS detection, right? So even though I'm not using -O, -A, think of A for all, do all scanning, right? So it'll do OS detection. It'll also do the version detection. So it's like doing a -O and a -SV. It'll also go and run the vulnerability scripts. So Nmap has the capabilities to run vulnerability scripts to identify vulnerabilities on the system. So it'll do script scanning as well, and it'll do a trace route to that target. So what I'm going to do is I'm going to hit enter here. Now this will take some time to execute. And what I want you to notice here, I do have one more thing I want to talk about. And that is, while this is executing, it's obviously working, it's doing something, but I have no idea what it's doing. So one of the things that you can add to all of your Nmap commands is a -v, which stands for verbose logging, like show information on the screen. So I'm going to do a Control-C to stop the scan. And what I'm going to do is hit my up arrow key, and I'm going to add a -v in front for verbose logging. So I'm still going to do the all scan, where it goes and does OS detection, version detection, script scanning, and trace route. But notice that with that -v, I'm going to have output appear on the screen right away, right? So it kind of lets me know what's going on in the background. as it's performing all the different types of scans. Whereas if you don't put the -v, basically all you see is the results, which is good a lot of times because that's maybe all you want. And then you can kind of screen capture those results and paste those in your penetration testing report if you wanted to. But if you want to verify that it's actually doing something when the screen is kind of held up there, then that -v is a good switch. And again, you can use that on any of the commands that I used here so that you get some sort of feedback on the screen of what's happening, right? Which is kind of cool. So in this demonstration, you saw how to perform network scans using Nmap. In this demonstration, you'll learn how to use Impacket, which is a set of Python scripts and libraries that are used to craft network packets and perform networking and exploitation tasks during your penetration test. You can get your hands on Impacket from GitHub and then start using the built-in scripts right away. Now, the first command that we want to use with Impacket, I already have it downloaded and installed, so I'll just go into a terminal session. Once in the terminal session, you can call upon the different Impacket scripts by doing Impacket dash and then the actual script name. In this case, the first example I'm going to use is the SMB client. Now, SMB stands for Server Message Blocks, and it's the underlying file sharing protocol in the Windows environment. So what this command or script will do is it'll allow me to connect and enumerate through shares on a Windows machine. With most of these scripts, what you'll do is you'll call upon the script name, so Impacket dash SMB client, then you'll specify your Active Directory information. So quick24x7.loc is my Active Directory domain. So most of these scripts are going to be used to interrogate an AD environment. After you have your domain name in there, you're going to do a /, and then you'll specify an account that you're going to authenticate with. So you're going to use this after you've already performed some enumeration of user accounts on the system and cracked some passwords. So in this example, I already know an administrator account called administrator. Then I put a colon and I specify the password for that account. Notice that I'm putting the password in single quotes. After you specify your Active Directory domain name, the user account information, then you'll specify the system that you're trying to connect to interrogate the shares from using this SMB client script. So I use @ and in this case, I am going to direct the command at a system with the IP address of 10.0.0.1, which is my actual domain controller, but it could be other servers or systems within your network environment. So I'm going to hit enter here. And right away, you notice that it takes me into a different prompt. So I have that # as my prompt. So at this point, I can use the different commands within the SMB client tool itself. So if I'm not quite sure what the commands are, they let you know right on the screen, type help to get a list of commands. So I can type help. And you'll notice there's a number of commands here, just to highlight a few of them. We do have a login command to log in with a specific username. There's a log off command. I'm going to use the shares command to show you a list of shares that exist on the system. And if you want to connect to a share, once you see a list of them, you can use the use command to connect to that share. You can also use the pwd command to print your working directory, the ls command to show a list of files that exist within a share. And then they also have commands for you to do file manipulation, right? So there's a remove command, there's a remove directory. There is a put command and a get command, which are used to upload and download files from the share, which is very useful. There's a cat command to display the contents of files if you wanted to. And I like this one as well. There's a who command for you to see who currently has a session with the server. So I'm going to click down below here. And the first command that I'm going to use is shares. And this will list all the different shares that exist on this system. And notice that I can see the administrative shares, which are typically hidden, right? So admin $, I can see the C $, the IPC $ share. So I can see all those shares. Notice that there's a data share there. So if I want to connect to that share, I use the use command. So use data. And then I do an ls, and it'll list out the contents of that share. So notice that there is a file there called report.txt within the share. So that's kind of cool. The other thing that I can do here, which is really neat, is I can use the who command to see who's connected to the server. So this is very useful when collecting information. So I can see that there's a user that's authenticated to the system, the server called administrator, which has the IP address of 10.0.0.7. So what I'm doing here is I'm seeing some IP addresses of other computers on the network, and I'm seeing user account names as well. So I'm collecting that information. So it looks like there's a T Smith account that's connected to 10.0.0.1 that's sitting on a machine that has the IP address of 10.0.0.6. So that's very useful. Now I'm going to type exit here to get out of the SMB client. Then I'm going to clear my screen. So that's just one of the commands that exist with inside Impacket. There are other commands, and just to kind of show you a few other ones, I can use Impacket-lookup SID, and then same thing, I specify my Active Directory domain with my user account and password. And again, you would have gotten this through different phases of the pen test. And then the server, the IP that I want to execute the command against. So I want to look up the SIDs. The SIDs are the unique identifiers associated with each user account that either exist in the Active Directory domain or the SAM database of the system. In the system we're talking about is whatever you put IP address you put there. So 10.0.0.1, I want to retrieve a list of user accounts and their SIDs from 10.0.0.1. So very useful. So when I take a look at this output, what I'm seeing is I'm getting a list of all of the different SIDs. Here's the unique identifiers over here on the left. And also what's really cool is you're actually getting usernames and group names. So I'm collecting a lot of pretty important information about this target environment. So here I can see there's a user account called administrator. You can see the groups. There's the domain admins group. And if I keep scrolling down, I can see some other Active Directory user accounts. So there's an Alan, there's a Marcia account, and again, you have the SIDs associated with those accounts. So now that you have those usernames, you could plug those into a, let's say, a users.txt file, and then use that text file in all your password cracking tools. So the next command that I want to show you, so that's looking up the SIDs, which gives you the usernames and the SIDs themselves. Let me clear the screen there. The next command I want to show you is Impacket-secrets dump. So it's plural. And again, notice the format is the same. You specify your Active Directory domain, the username and password of an admin account to authenticate, and then the IP address of the system that you want to connect to and retrieve what they're calling here the secrets. The secrets are the hashes. So I want to retrieve the password hashes from the system with the IP address of 10.0.0.1. Now again, this happens to be a domain controller in this example, but it could be a member server or a Windows client machine on your network. So I hit enter, and it is retrieving the password hashes from those user accounts on that system. Very, very cool. So what I can do here, there's our administrator account. Now I already know the password for the administrator account, but there's the hash, the password hash for that administrator account. So what you could do is you could grab this information, copy it out to a text file, and then use your password cracking tool, whether it be John or Hashcat, and crack those password hashes, right? So notice that I do have Alan's account with the password, Marcia's account with the password hash. So I could go and copy and paste those and then send them into my password cracking tool. Very useful. Next command that I want to show you is an important one, and it is how we can exploit a system and gain access to a remote system using Impacket. So with Impacket, there is what they call PSExec. So we can use PSExec to remotely connect to a system, or WMI exec. With WMI exec, it uses the WMI technology that's built into Windows environments and exploits that WMI technology. WMI stands for Windows Management Instrumentation, and it's a library of code that exists on every Windows system that allows you to retrieve information about a system, all the hardware and software about a system. So what this inpacket-WMI exec is doing is it's exploiting that library. So I'm going to do a quick 24/7. So the format is the same. We specify the domain, the user account you want to authenticate as. So again, you would have had to retrieve this information in a previous step. And then you specify the IP address of the system that you want to run either the PS exec or the WMI exec against, right? So when I hit enter, I should get remote access to the system. And notice right away my prompt has changed, right? So up top here, I've got a Kali Linux prompt with the pound sign, but notice now I've got a Windows C:\/ prompt. So basically I'm on that system and I can use all the commands from that system. So for instance, I could do a who am I, which is a Windows command. It says, oh, you're logged in as quick24/7 \administrator. I could do a host name, which reports back my computer name. So again, notice that it says server A. So I am remotely connected to server A, and I could use all the commands of that target system. I could do a dir and access the file system if I wanted to. So this is the hard drive of that system. And I can manipulate those files. I can navigate through the file system, essentially doing what I want with this system. I have, full remote admin capabilities of that system. So in this demonstration, you saw how to use inpacket to collect information and exploit a system. In this demonstration, you'll learn how to use Map exec, which is a post-exploitation tool that can use different protocols such as SMB, LDAP, WinRM, SSH, and MS-SQL to collect information about a group of systems. Now let's get started with the first thing I want to do is use Map exec to use the SMB protocol to discover computers on the network. So I do Map exec, then you specify the protocol. So here I'm going to use SMB, but you could be using WinRM or LDAP or MS-SQL. Then you specify the IP address of the system or network that you want to discover or collect information on. So I'm just going to go and do the 10.0.0.0 network itself. So I hit enter, and what you're seeing here is that Map exec has discovered two systems, 10.0.0.6 and 10.0.0.1 are the two systems. 10.0.0.6 has a computer name of Skillsoft Win10A, whereas 10.0.0.1 has a computer name of Server A. It's also kind of retrieved the computer information. In this case, the Skillsoft Win10A system is a Windows 10 client, whereas the Server A is a Windows Server 2022. Perfect. In this case, those are the only two systems that I have on this network. So one of the things that you may want to do is to speed up the execution of the commands. Instead of constantly supplying the IP range of the entire network, what I can do is I can create a text file that contains the list of IPs that are valid on this network. So that's what I'm going to do. I'm going to use nano space, and I'm going to specify targets.txt. I'm going to create a targets.txt file that has two IP addresses, 10.0.0.1 and 10.0.0.6, which are the two IPs. Now down bottom, it says to do a Control X to exit. So I do a Control X. Down bottom, it says you want to save your changes. I'm going to do Y for yes. And it says what file name. Notice that it's going to write to that file name, targets.txt, at the bottom there. So I just hit enter. And if I do an ls, I should have a targets.txt file. And just to kind of verify that that file is working, let's run that map exec command again. So I'll do a clear screen, map exec This time I'm going to do smb of targets.txt. You know, it's completed the command a little bit quicker than the last time. So those are my two target systems. Perfect. I got 10.0.0.1 server A, 10.0.0.6, which is the Win10 client. Notice that you can also see as well in the bottom of the screen or the bottom of the output that it looks like we're in a domain called quick24by7.loc. So I've got a lot of information just from this one quick command. I know 2 computer names, 2 IP addresses, right? And I know the domain name, which is quick24by7.loc. So that's a lot of info. Had I have had 50 computers on this network, this command would have collected those 50 computers and their IP. So that's perfect. Now, the next thing I want to do is I want to see if I can figure out the password for some of the user accounts that may exist inside this domain environment. So what I'm going to do is I'm going to perform a dictionary attack. And to perform that dictionary attack using SMB, what I'm going to do is create 2 text files, a user list file and a pass list file. So I'm going to use nano again, and I'm going to create a file called users.txt, and I'm going to put in some user accounts. And these would be common user accounts that are typically used, like root and admin, but also these may be user accounts that you collected through your reconnaissance, right? So a lot of times when you're looking at email addresses that maybe you collected from online sources, a lot of times those email addresses, the first part of it anyways, is the logon name, right? So you may want to input that information in here. I'm just going to go with a few. And our username that is valid on this network is administrator. So notice that I have put that in as the last entry. So my goal here is when I run the dictionary attack, we're going to see that it's going to try Glenn Clark and a bunch of passwords. It's going to try root and admin, but eventually it'll try the administrator account and it will be successful. So I do a Control X to exit out. It says, do you want to save the changes at the bottom of the screen there? So I do Y for yes, and then hit enter to accept to write to that file. So that's my user list file. Now I'm going to create my pass list file. So I'm going to do nano space, and I'll call it passlist.txt, and hit enter. And then what we're going to do is just plug in some common passwords that might be used. So pass 1 2 3 4, password 1 2 3, and then the actual password for my admin account. I'm going to plug that in here. So obviously I'm intentionally putting in the correct usernames and passwords into these files. In real world, what you would do is have a user list file, and then you would use a common dictionary file like the rocku.txt, which contains thousands and thousands of passwords. So I'm going to save this. And if I do an ls, I've got my targets list, I got my users list, and my pass list, right? So now what we're going to do, I'm going to clear the screen. We're going to use crack-map exec using the SMB protocol against the targets.txt, so those 2 IP addresses. And then I'm going to specify -u, and here I could type in a single username that I want to try to authenticate against those targets as, or you can also type in a file like users.txt. So what's going to happen is crack-map exec will try every username that's in that users.txt file against every password that's in the passlist.txt file. So I'm going to hit enter. And it goes through and it tries all of the usernames and passwords in those 2 files. So if I come to the top of the output here, the first username that's in the users file is Glenn Clark, and it tried the password of host from the password list. Then it tried kids, then it tried pass and pass 1 2 3 4, and it's letting you know that logon failure, right? So it was not successful in logging in with the Glenn Clark account. And then it should hit the next username that was in the user list file of root, and it tried host kids. So again, it's just reading the password list file and trying every one of the passwords with that root account. And then it did that for admin, and then eventually administrator. So it tried hosts, wasn't successful, kids, wasn't successful, pass 1 2 3 4, and eventually, and you can see the pond here, you can see that it was successful in authenticating to the Active Directory domain as administrator with that password. So now I document that password. So that is the credentials that I can now continue doing my discovery and use those credentials to retrieve, more usernames if I wanted to retrieve password hashes and just start collecting information about these systems and about this network. So I make a note of that username and password, administrator, with capital P A $$W0RD. I'm going to clear my screen. And then what we'll do is we'll use some of the other commands with crackmap exec to discover additional information. So crackmap exec using SMB. So I always have our protocol there. I'm going to use the same targets. So since we have 2 computers that we know of on the network, I always want to use those. Now I'm going to do -u, and I'm not going to specify the text file because now I know a valid username is administrator and -p is going to be capital P A $$W0RD. So here what I'm doing is I'm telling crackmap exec, I want you to execute this next command as this specific username and this specific password and try to authenticate with that account, which I suspect is an admin account. And then I can do a --users at the end here. So this --users is saying I want to retrieve a list of user accounts from each of those target systems. And let's see what we're able to collect. So it looks like if I scroll up here, so again, we know our 10.0.0.6 is the Win10A, 10.0.0.1 is server A, lets us know those OSs. Down bottom here, we do have a list of, so it did authenticate against each of those systems with that account, and then it was able to retrieve a list of user accounts from the Active Directory domain environment. So we do have our Allen account, we do have our Marcia account. Looks like there's an account called SQL Service, and this is all within the Active Directory domain. Looks like there's a T Smith account, and there's also a hacker account that I created in a previous demo when I exploited the system and created a backdoor account, right? But the point being is, this is a list of different accounts that exist within your Active Directory domain environment. So again, now what we do is we kind of record that information. Other commands that we can execute, if I go and I'll use my up arrow key to go to my previous command. Instead of just collecting a list of user accounts, maybe I want a list of shares from those target systems. And using the SMB protocol, it gives me a list of shares. So it looks like the Win10A machine has our administrative shares, admin $C $IPC And then it looks like the server A system has shares, admin $, but there's an app share. Looks like there's a data share, and so on. So we can collect a list of shares. So we've got a list of user accounts, we got a list of shares. So our next command that I want to perform is we do know that the 10.0.0.6 system is a Windows 10 client, which has a SAM database. So what we want to do is see if we can retrieve a list of accounts from that SAM database and hopefully get the password hashes as well. So we can do crackmap exec SMB, and in this time, instead of using the targets.txt file, I'm going to plug in the IP address of 10.0.0.6 -u. The username I want to use to connect is administrator -p. The password is going to be our password for that admin account. And then I'm going to do --sam. So it's going to connect to 10.0.0.6 and try to retrieve the SAM database from that system. And notice that it is dumping the SAM hashes here. Now I don't have many user accounts. I only have 2 user accounts. There's the administrator account, and notice we do have the password hashes. So you can grab this, the second one here is the NTLM. So I can copy and paste that password. Oops, got to make sure I get everything from the 3. So for instance, you would copy and paste that, or copy that password hash. And same thing down bottom here. It looks like the guest account is there, but there is a student account as well, right? So I can grab that NTLM hash for the student account and copy it and paste it into a text file if I wanted to. The other cool thing that's neat here is, let me copy the administrator hash. So I'm going to copy that selection. The other cool thing that I just want to show you with Crackmap exec is when you're performing these commands and you don't know the password, but you were able to collect, let's say, the hash value, you can paste the hash value in. And then execute using that hash value. So the cool thing is you could pass the hash value in instead of the password. And that's typical of all of these different Crackmap exec commands that you execute. In this demonstration, you saw how to use Crackmap exec to perform post-exploitation tasks. In this demonstration, we'll take a look at how to use Wireshark to perform network analysis. Wireshark is an example of a network sniffer that can be used to capture network traffic and analyze that network traffic. You can download Wireshark from wireshark.org. I've already got Wireshark installed, so I'm going to launch it by double-clicking on the Wireshark icon. Once Wireshark is launched, you can see down bottom here that it does show our different network adapters, and you can choose which network adapter you want to capture traffic off. Here's my Ethernet adapter. You can see there is some network activity there, so that is the adapter I want to use. You can also hover your mouse over it, and you can see a little tooltip pop up that shows the IP address of that interface. So that's 10.0.0.1, which is the interface that I want to capture traffic off. So I'm going to double click on the Ethernet interface, and it starts capturing network traffic. Now what I'm going to do is I'm going to switch over to a client system and generate some network traffic, and then we'll come back and analyze that traffic. So I'm on my network client. What I'm going to do is go to a command prompt here. So I click on the start button and type CMD to go into a Windows 10 command prompt. Once in this Windows 10 command prompt, what I'm going to do is generate some network traffic. And in this example, I'm going to create some FTP traffic for us to analyze. So I'm going to do FTP space and then the IP address of the FTP server. The FTP server sees that authentication is required, so it prompts me for a username and password. So I type in the username of administrator, and it says that a password is required. So I type the password in. Then it says that I'm logged in. Perfect. If I want to view a list of files that exist on the FTP server, I can use the ls command. And I can see here there is one file called clientlist.txt. So if I want to download that file, what I can do is use my get command in FTP, and I can do get clientlist.txt. You can see that the transfer is complete. It says that it downloaded 99 bytes within a certain amount of time there. Looks like 3 seconds. Perfect. Now I'm ready to quit my FTP session. And notice that I'm back at my command prompt in Windows. Now, when I use the get command, it basically downloaded the file in the folder that you were in when you entered into the FTP session. So I was in the folder C:\users\student. If I do a dir there, I should now see there's my client list.txt. Perfect. So let's switch back to our monitoring system and let's analyze the packets and see if we can see things like the FTP username and password and the contents of the client list file. Okay, we're back on our monitoring system. The first thing I want to do is stop capturing network traffic, so I hit the stop button up top here. Now that I've stopped capturing network traffic, you can see our different packet numbers. So I've got like 460 packets that have been captured. So up top here, this is your packet list frame. You can scroll up and down and scroll through the packet. So I'm going to go to the top portion and start at packet number 1. So the idea here is that when you select a packet, like packet number 1 is highlighted, it then shows you the packet details down in our details pane here, and it shows the hexadecimal contents and the ASCII contents in the hex pane and the ASCII pane. So those are your 3 different areas. So what I'm going to do here is I'm going to scroll down and look for our FTP traffic. Now the FTP traffic is going to be TCP traffic at port 21, destined for port 21. So I'm actually looking for TCP packets here. So I'm scrolling down and here's a TCP packet. Now, when I look at this packet, I can see in the info column gives you kind of critical information that you can use to kind of quickly identify what the purpose of the packet is. Here they're showing this 50651 with an arrow going to 21. Those are port numbers. So this is the client system sending traffic to port 21 on a server system. Now, I don't know that 100% yet, but just so you know, that's what the 21 is. That's your FTP traffic. Now, in this example, when I look at this FTP traffic, port 21, you can see that it's got the SYN in brackets. And then down below that, we have our SYN-ACK, and then we have our ACK. So this is the three-way handshake, the TCP three-way handshake of a client machine connecting to the FTP service. So that's a very critical packet. Now, when you take a look over here on the left, you can see the source IP address of the client, and you can see the destination IP address as well. So I can see here the source IP address of the client is 10.0.0.6 with traffic headed to the server at 10.0.0.1. You can see here in the next phase of the three-way handshake, the server is sending to the client the SYN-ACK packet. And then finally, the acknowledgement, which is the third phase of a TCP three-way handshake, is coming from the client going to the server. Notice after the three packets that are the three-way handshake, we then have an FTP packet. And this is basically the server coming back with the FTP banner saying it's a Microsoft FTP service. Then what's going to happen is down below here, we should see, there's a lot of different packets here. We should see when I highlight the protocol column for FTPs. So as I scroll down, even though there's a bunch of DNS packets there, I'm ignoring those because that's not the type of conversation that I'm trying to analyze right now. But I can see here that we do have another FTP packet, a few packets down. So it looks like packet number 190 is the client is sending to the server a user space administrator. So this is the client logging in. So I can see the username that somebody's logged in as. Then the server comes back with a password required message. And then eventually I should see the actual password. So if I scroll down to my next FTP packet, right, we can see the password is pass space, capital P-A $W0RD. So that's somebody typing their password in. Now the user is logged in. That's a status message coming from the server going to the client, right? After that, then we should see an FTP packet where we're retrieving a list of files. So here is the client, 10.0.0.6, sending to the server an NLST, that's the ls command, right? Asking for a list of files. And then we should see some FTP data, which is going to be the list of files itself. So there's our FTP data. So from the server coming back to the client. Now, when you look at the FTP data, what's important is you can look down bottom here in the detail of the packet, and I'll look at this top section here in a second, but notice that we do have some line-based data, right? If I expand that out, it's basically coming back and saying, oh, you've got a client list.txt file. Now, one thing I want you to notice is that when I select a piece of information here in our detail pane, notice that it highlights that information in the hex pane, and it highlights it in the ASCII pane, which is kind of nice. Now, I don't understand all that hex data, so that's why Wireshark has this detail pane, so that you can just look at the packet details. When you select a packet, you just analyze the traffic by looking at these packet details. You don't have to convert that hexadecimal data to ASCII data. Perfect. So here I can see that a user asked for a list of files. and they got a list from the server, client list.txt. Now, somewhere here, if I keep scrolling through our packet capture, so there's FTP data, we should see the command of get being fired off, which is the retrieve command underneath the scenes. So there it is there. So there's FTP data, a request for, I want to retrieve client list.txt. So that's the client at 10.0.0.6 sending a command over to the server that says, I want to retrieve client list.txt. And then we should see a response come back with FTP data, which is the client list. So again, if I highlight the FTP data, if I select that packet, so the server is sending to the client, and I look at that line-based text data, there's the contents of the text file, which is kind of crazy. But because we're using FTP here, and FTP is an unsecure protocol, it's not encrypting the communication, so anybody that can tap into that communication can see the data. Now, before we go any further, let's take a look at when you're highlighting a packet. So I now have packet 273 here. I can see the source IP address, the destination IP address. I can see the protocol, which helps me kind of understand the conversation a bit. And then the info column that gives me a little bit of detail. But a lot of your packet details are here in the details section. So just to give you a summary of some of the pieces of information we have here, if I expand out the frame section, in the frame section, you'll get information like the size of the frame, so how big it is, how many bytes, right? And also you'll get date and time information on when that frame was captured. Then if I collapse that, in the Ethernet section, you'll get your source and destination MAC addresses. So in brackets there's the source MAC address and the destination MAC address of the network cards that are communicating. So that's very interesting. And then if I collapse that and I expand out the next header, this is the IP version 4 header, where you can see all the fields that exist within the IP4 header, including the source IP address and destination IP address, right? So when I look at it, here I've got the source address is 10.0.0.1, destination address is 10.0.0.6. So the source and destination address are fields within the IP header, but what Wireshark does is that's pretty critical information. So Wireshark shows it as its own separate columns in the summary pane up top there. So that's very interesting. I can also see things like the time to live field. So the IP protocol uses a time to live field to prevent packets from running around on the network forever. Basically, every time the packet passes through a router, it decrements the time to live by 1. And once the time to live is set to 0, then the packet is removed from the network. The point here is that when you're analyzing network traffic, you learn default values used by different platforms. So for instance, the time to live value is set to 128 on Windows systems by default. Most Linux systems will set the time to live to 64 as a default. So my point is when I'm analyzing the traffic here, I'm also building a profile of the person that generated this traffic. So I'm looking at this saying, okay, whoever this person is, they're running a Windows system. Now, keep in mind, they could spoof that information, so they could customize the packet and set their own time to live to try to hide that kind of detail. But that's just one example of a default value that's set in your different fields. And a lot of times we use that as security professionals to help build profiles of hackers and kind of try to make some sort of guesstimate as to, what they're using as a system. So that's in our IP header. You have your source and destination IP address. And then we have because we're using TCP here as a protocol instead of UDP, if you expand out the TCP header, you'll see your source and destination ports. So this is where you'll see your source port or destination port of 21 for FTP, 20 for FTP data, which is what I'm looking at here. But also if it's a website, it'll be 80 or 443 and so on. The destination port here is the browser. right? So the FTP server is sending data to the web browser that the client is using, and that web browser has randomly selected a port number of 50,653. Now, one last thing that I want to do here is I want to show you how we can filter this output. So when you're looking at network traffic, there's going to be a lot of packets that are captured. So up top here, we do have a filter, a display filter that you can put in place. And there's a number of ways that you can filter traffic. So for instance, you can filter by the IP address. So I can write a condition here that says ip.address ADDR equals $=10.0.0.1. And I can hit enter. And what it's doing here is it's filtering out all of the packets so that you're only seeing packets that involve 10.0.0.1 as being the source IP address or the destination address. Now, in my example, that's all I have. But if I was capturing traffic on a live network, you may have packets from all kinds of different systems. So when you're trying to analyze traffic for a given system, this could be a very useful filter. And notice that the filter is showing a green bar in the background. That means the syntax is correct. So if I was to backspace over that, notice that it turns to red. It's showing that my syntax is not correct or is incomplete. You can also remove the filter if you go over here to the right and hit the red X or the X that's over there, and that will remove your filter. Now so a lot of times when I'm analyzing traffic, I'll filter by the IP address of the system I'm trying to monitor. Or the other thing is a lot of times I know what type of traffic I'm looking for. So for instance, if I'm looking for just FTP traffic, I could type the protocol of FTP here and then hit enter. And what you'll notice is that it filters out. I mean, I had a lot of DNS traffic that was captured, and notice that now when I scroll up and down, I don't have any of that DNS traffic. It's all FTP traffic that I now have. So there's the FTP banner coming back. Here's me logging in with the username of administrator. There's the server prompting me for a password. There's me typing a password. There's the server come back and say, great, you're logged in. There's me asking for a list of files and so on, right? What I am missing here though, which is unfortunate, is I'm missing the FTP data. So for instance, when I'm asking for the list of files, we're actually getting the transfer complete, but I'm not actually getting the list of the actual data that was delivered from the server, because that's in a different protocol. That's in the FTP data protocol, not the FTP protocol. So what I can do here is in your filter syntax, you can use and or statements. So I could do 2 ampersands for an and. That's not what I want to use. I want to see packets that are using FTP or, so 2 pipe symbols is your or syntax, or FTP, and notice that they're showing me options as I type. Perfect. So here I'm putting a filter in place that says, show me any packets that are FTP or FTP data. And notice now I have some FTP, but I also have some FTP data, which is great because that means I'm seeing the client list, and in this case, I'm seeing the contents of the actual file itself. So that's very useful. So you can filter not only by, things like the IP address, but you can also filter by protocols. And there's lots of different fields. Basically, any of these different fields that exist, you can filter by that. Now, I'm going to get rid of that filter. The other thing that I wanted to show you here, if I can find it, is my 3-way handshake. Let's find my 3-way handshake. Here it is here. Okay, so this is my 3-way handshake with port 21. What you can do in Wireshark is you can right-click on a packet and you can say, I want to follow the entire stream of data. So instead of me scrolling up and down and trying to find the next packet, again, because I am getting a big mixture of traffic, so you can see in the background there, I've got some DNS packets on the screen. Instead of scrolling around, you could either put a filter in place, which is very useful, or you could say, I want to follow this TCP stream, which means I want to follow this conversation. And when you do that, it opens up a window and it shows you the core phases of that conversation. So there's that FTP banner. There's me logging in with a user administrator. There's the server come back saying you need a password. There's me typing the password. There's the server come back saying you're logged in. There's me asking for the list of files, right? And there's the transfer complete, but notice that I don't actually see the actual data that was delivered, right? So this is very useful, right? But it's also useful to be able to filter the list of packets, and I can close that filter that was applied, filter the list of packets by protocol or IP address. So in this video, you learned how to analyze network traffic with Wireshark. In this demonstration, you'll learn how to create malicious payload with MSFvenom. In this example, we're going to use MSFvenom to create malicious software that when the user runs that software, it makes a reverse connection back to our penetration testing system, giving us full control of the victim system. The first step is we want to make note of what our IP address is on our Kali Linux system. So I'm going to do an ifconfig, and notice that the IP address is 10.0.0.7. So I make a note of that. Now I'm going to clear the screen. And the next thing we want to do is to create the malicious software. And the command to do that is we're going to use MSFvenom space, we're going to use a -p to specify the payload. And the payload is the attack that we're performing. And in this case, we want to use a meterpreter payload that makes a reverse connection to the Kali Linux system. So that exploit is going to be Windows/meterpreter/reverse_TCP. Then we specify the local host setting, which is going to be the value or the IP address of your Kali Linux system. So in my case, it's 10.0.0.7. Then we specify the local port, and this is going to be the port that we want the malicious software to connect to on that Kali Linux system. So I'm going to specify a port of 5555. Then we specify our architecture with a -a, and I'm going to go with x86. Then we specify our platform with --platform. And the platform is going to be, this is going to be a program that we're generating that runs on the Windows platform. Then we're going to specify our encoder. So there's different types of encoders that could be used to create the malicious software. In this example, I'm going to use the x86/Shikata_GA_NAI. And you can view the help to see some different encoders that are supported by MSFvenom. Then we specify a -f, which is the file type that we want to create with MSFvenom. So this malicious software is going to be an exe file, is what I want to generate. Then we specify a -i, which is how many iterations we want to encode the malicious software. And the concept here is that the more encoding iterations you do, the less likely your virus protection software will detect the malware. So I'm going to go with 15 iterations. And then we're going to specify a greater than sign so that we write the output of MSFvenom to a file called, and I'm going to call it course10_malware.exe. And then we hit enter. So it generates the executable. If I do an ls command, I should see our course10 malware executable is here. So this malware, when somebody runs it, will make a reverse connection to our system. Perfect. Now, before we send that malware out to somebody, the next thing that we want to do is we want to set up our Kali Linux system to be a listener. A listener is waiting for somebody to connect to us. So to create a listener, we use MSF console. And that's going to start our Metasploit framework. Once in the Metasploit prompt, then we use the exploit multi-handler. So I press enter there. Once I use the exploit, then I'm going to set the payload to Windows Meterpreter /reverse_TCP. Then I'll set the host or local host address to the IP address of the Kali Linux system. So 10.0.0.7. And then I'll run my exploit. So I forgot to change the port number there. So I'm going to do a Control-C here and stop that. If you use your show options command, once you're on the exploit, you can see a list of the options. And notice that on the left-hand side here, I've got my local host address is set. The local port is set to port 444. But remember, when I created the malicious software, I set the port to 5555. So I need to set that. So I'm going to do a set L port to space 1, 2, 3, 4, 4 fives. Hit enter. I'll do my show options just to make sure that it's set it properly. So I have my local host address set to 10.0.0.7. I have the local port that I'm going to listen on set to 5555. Perfect. Now I'll run the exploit. So you'll notice that it says started a reverse TCP handler on 10.0.0.7:5555. That's the port number. So at this point, I don't have a command prompt where I can type anything because this prompt is sitting there idle, waiting for a victim to run that program, which will make a connection to this listener. So what I'm going to do next is I'm going to switch over to the Windows client where the user is tricked into running the program. So I'm at the Windows client. Now, what would happen normally is you would trick the user into running the program either through an email message, like a social engineer attack, or what you would do is put the program on a USB stick, and then you would do a USB drop where you spread a bunch of USB sticks around the organization, hoping somebody throws the USB stick inside a system and runs the program out of curiosity. So either way, once you trick the person into running the program, so here's the program, I'm going to double click on it and run that program. So I do get a message here on the Smart Screen feature, can't communicate out to the internet, that's fine. I'm going to choose to run. And now what I'm going to do is switch over to the hacker's system. So I've switched back to the attacker's system, or in this case, the pen tester, and you can see here that we no longer just have the idle prompt of started reverse TCP handler. You'll notice that we do have a connection to 10.0.0.6, so that must be the IP address of the Windows 10 client, and we have a meterpreter session. Now with this meterpreter session, we can perform a number of different meterpreter commands, they're called. And you can get a list of the different meterpreter commands by doing a question mark. So if I do question mark and hit enter, here is a list of all of the different meterpreter commands. And just to highlight a few of these, if I scroll to the top, so we do have things like, if I scroll down, file system commands. So there are commands for you to look at the contents of files on the target system, delete files, create files, download and upload files, make directories, that kind of idea. So all kinds of commands on that. We do have some networking commands as well. So things like your ipconfig and netstat commands are there. We do have some system commands. So things like, this is interesting, clear EV, which clears the event log. So if you want to kind of remove any kind of auditing that's happened after you've made a bunch of changes to the system, you could try the clear EV. There's a sysinfo command, which is what I'm going to use, and that'll retrieve information about the system that is connected to your pen test system. We also have commands to work with things like keystroke logging, so I can record the keystrokes of the user, try to capture their passwords. There's a screenshot command to grab a screenshot of the user interface. There's webcam commands, which allow you to do things like, record an audio file from the microphone of the webcam, or take a snapshot of the user with the webcam. All kinds of things like that. So what I'm going to do is I'm going to try a few of these commands out here. I'm going to do a sys info first to obtain information about the system. Notice that the computer that's connected to us at this time is Skillsoft Win10A, and it's a Windows 10 machine with a 64-bit architecture. Perfect. So we know the system information. And then we could do a number of other things. So for instance, I could use the shell command, which will jump me into a Windows command prompt of that system. So if I do the shell command, and now notice that my prompt has changed, I'm in C:\excluded is the folder. So if I do a dir, right, I can see a listing of the files that exist on that system. I could go and create files, copy files, like use all my typical Windows commands if I wanted to. Right? If you want to get out of your shell, you type exit, and that'll put me back in the Meterpreter session where I can use any of those Meterpreter commands. So in this demonstration, you saw how to use MSFvenom to create malicious software. In this demonstration, you'll learn how to use Hydra to crack passwords on a Windows system. Hydra is a password cracking tool that can encapsulate the password attack into different types of traffic, such as FTP, HTTP, HTTPS traffic, MS-SQL, and remote desktop or RDP traffic, to name a few of the different protocols. Now, to get started with our attack here, the first thing I want to do is create a user list file and then a password list file, which are going to be the usernames that I want Hydra to attempt to log into or try and crack the passwords of, and then in the password list file. So I'm going to launch a text editor here. So I click on my Kali Linux button, and I have a text editor button. And what I'm going to do first here is create the user list file. And typically what we do is we create a list of common usernames. So root, admin, administrator. I'll go with those 3 usernames. And then what I'm going to do here is I'm going to save this file. So I'm going to do a file save as. And I'm just going to save this to my home directory here. And I'm going to give it the name course10 user list.txt. And then I'll hit save. Now I'm going to do the same thing, but I'm going to create a password list file. So I'm going to list out some common passwords. So I'll list out hosts, kids, pass 1, 2, 3, 4, maybe the word password, maybe Tor, and then finally the actual password for my admin account, which is capital P A $W0RD. So I'm going to save that. So I do a file save as, and this will be called course10 underscore pass list.txt. Perfect. So I have my user list file and I have my password list file. So the whole idea of Hydra here is what we're going to do is we're going to supply Hydra the IP address of the system that we want to perform the password attack against. And we're also going to specify the protocol. In this example, I'm going to use RDP. Then what we're going to do is specify the user list file that we want Hydra to read from in the password list file. And what will happen is for every one of these usernames, so for root as the first username, Hydra will use or attempt to use login with every one of these different passwords. So in this case, it should fail, and then it should go and try the next username, and that'll fail. And eventually, my username and password for my lab environment here is administrator with the password of that 6th password. Okay, so that should be the password that is successful, or the credentials that are successful there. So to use Hydra, we're going to go into a terminal session. And once in the terminal session, we're going to use the Hydra command. Now, if you want to see a list of the different switches for Hydra, you can use Hydra-H, and that'll show the help for Hydra. And it shows you a list of all the different switches here. So it's Hydra space. You can do -l, where you specify the login name to attempt. So if you know there is a specific user account on that target system, like administrator is typically there on most Windows systems. So I could do -l administrator, and it means that it'll try to log in with the administrator account. It won't read a file. for the usernames. If you want to read a file for the usernames, you have to use a -L instead of a lowercase l, and then you specify the file name. Same thing for the password. If you want to hard code the password to attempt to use, a -p and specify the password. So for instance, if you wanted to do a password spraying attack where you specify maybe a login file with a bunch of different usernames, but you're going to try the same password because you know there's a certain password that's very common. Whereas if you use -P, you specify the file, which is the password list file. And there's a ton of other settings in here. Some of the other settings that we're going to use here, I'm going to use the -V for verbose logging. What that'll do is that'll show you each of the different usernames and passwords that Hydra attempts on the screen, which is kind of nice. So you can see it, what has been attempted. So I am going to use that -V switch, and I am going to use a -L to specify my user list file and a -P to specify my password list file. So I'm going to clear the screen. And to use Hydra, we're going to do Hydra space -L, and then the name of the file, which is my login username file, is course10_userlist.txt. Then -P, and is my password list file, so it's going to be course10_passlist.txt. -V for verbose logging. And then finally, we specify the IP address of the system that you want Hydra to attack. So in this case, I do want it to use the RDP protocol. So I'm going to do an RDP://10.0.0.1. And then I'll hit enter. And you can see that it's trying each of the different usernames and passwords over RDP. So it tried root with a password of host, tried root with a password of kids, tried root with a password of pass1234, and so on. Eventually, it's not successful with root, so it tries admin with each of those passwords, and then it tries administrator. And down bottom here, we can see that it was successful, and it highlights it in green there. We were successful in logging in as administrator with a password of $PA$$W0RD. Now I should note that in this example, I created the user list and the password list file. It's typically not common to create the password list file unless you know, for some reason or you have a heads up of some of the common passwords used within an organization that you're trying to perform the pen test on. Typically what's going to happen from a password list file, what you're going to use is one of the dictionary files that come with Kali Linux. So if you navigate to the user share word list folder on Kali Linux, you'll see that there's a rocku.txt file, which contains, it's a dictionary list file of all kinds of common words and potential passwords. And it's monstrous. It's a huge file. It's got hundreds of thousands of entries in it. That's what you'll use as your passwords list file. So what you'll do is you'll just go and create maybe a user list file of some common usernames, or maybe as part of the pen test during your discovery, you found some different usernames that were used within the user environment. Maybe that's email addresses or something like that. So you plug that into a user list file and then use a dictionary file like the rocku.txt file that's provided with Kali Linux. So in this demonstration, you saw how to use Hydra to crack Windows passwords. In this video, you'll learn how to use Responder to perform a poisoning attack. Responder is a tool that will respond to name resolution requests as clients request to connect to different systems on the network. Windows systems use Link Local Multicast Name Resolution, or LLMNR for short. For example, with LLMNR, if a client tries to resolve a host name, say server B, that is not known to DNS, then the client will talk to other systems on the network using LLMNR, essentially asking the machine, do you know how I can connect to server B? When using Responder as a tool, Responder replies with, yes, I know where server B is, give me your password hash, and I'll pass it on for you. Once the client hands over the username and password hash, Responder records it for later use. When a pen tester or attacker uses Responder to capture the username and password hashes, they can then send the password hash to a password cracking tool to figure out the user's password. Let's take a look at how to use Responder. So the first thing that I'm going to do is I'm going to create, or in my case, I'm going to open up a password list file that I had used in a previous demonstration. Now, how I created that is I went to the Kali Linux menu, and then I chose Text Editor. Once in the text editor, you can go and create your password list file, or in my case, what I'm going to do is I'm going to do a file open, and I'm going to open up the course 10 pass list file. And notice that it's just a list of different passwords. So host, kids, pass1234, the word password, tour, and then my actual administrative password, which is capital PA $$W0RD. So the first thing you're going to do is create this file and then save it. So I have it saved to my home directory. So I'm going to close that. Now in this example, I've created a password list file that I want to use to try and crack the password hashes once I've collected a password hash. But keep in mind, in real life, you would use a dictionary list file like the rocku.txt file that comes with Kali Linux. Now that I've got the pass list file, the next thing I want to do is I want to go into a terminal session and I want to use Responder. We use the Responder command. We use a -I to specify the interface that you want to monitor request on. And then I'm going to specify my interface, which is ETH0. And I'm going to do a -v for verbose logging. And I'm going to hit enter. It lets me know that I have to run this as root. So I'm going to do a sudo responder -I ETH0-v. Supply my admin password, and then now Responder is listening for events. So what I'm going to do at this point is I'm going to go to another system, a client system, and I'm going to try to connect to a server on the network. And what should happen is Responder should pick up on the password hash as that client tries to connect to that system. Okay, so I'm on the client system. What I'm going to do here is I'm going to click on the start button, and I'm going to type in // server B and hit enter. Now, in this example, there is no server B system, but notice that I'm prompted for authentication here, which is kind of strange because why would a system that doesn't exist ask me to authenticate? And what's happening here is Responder has responded to, hey, I'm server B, pass me your credentials, and I'll send those over, right? So what I'm going to do is I'm going to go and type in a username and password here. So I'm going to go with a username of administrator, and I'll go with our password. And then I'll hit OK. Okay. Now, again, I could prompt me again, access denied. So the point is the system doesn't exist, so I'm not going to be able to connect to it. But that was enough for Responder to do its thing, right? So Responder challenged the person for the credentials. I typed the information in, and now when I go back to Responder, I should see that password hash. So let's go back to the Responder system. So when I switch back to my Responder system, notice that we do have some activity here. So I did only supply the username and password once, but what's interesting is even before that, what happened is that my client system sent over its current credentials. So on that client system, I'm logged in as student, and there's the password hash for the student account, right? So if you're in an Active Directory environment, you could then go and crack that password, and you would have the password for a potential Active Directory account, right? So we can see the password hashes have been passed in. And there's the administrator one. So this is where I tried to authenticate with the administrator account to the system. So what I'm going to do is I'm going to highlight that username, which is administrator, and the password hash for that administrator account. And I'm going to go and I'm going to copy that information. And what I'm going to do is I'm going to put that into a brand new file. So I'll launch my text editor here. And I'll go to Edit and Paste. And I'm going to save this. So I'm going to do a File Save As. And I'm going to save this as course10 underscore hashes, or hash.txt. Course10 underscore hash. Now choose Save. I'll close that down. And that's it for this. I'm going to do a Control-C to end my responder session. Now I'm still in my prompt here. I'm going to do it to clear the screen. Now what I want to do is, if I do an ls command, I can see I've got a couple files here. I do have our course 10 password list file, which is the password list file that I'm going to use to try to crack the password hash. Again, in real life, you would use a dictionary file like the ROCU text file, but I don't want it to take that long to do. So I just created a small file with a few passwords that I know, or a few words that I know are not the password, but then I've got the actual password in there just for demonstration purposes. And then we actually have our password hash in the course 10 hash. So let's take a look at these files. So I'm going to do a cat / course 10 underscore user list. So there are, sorry, I want the password list, not the user list. So I'm going to do a cat course 10 underscore pass list.txt. There we go. That's what I want. So just to kind of take one last look at those files, there's a list of passwords that I want any password cracking tool to use. Again, you would typically use a dictionary file like the ROCU.txt. The other thing here is I have the hash, the password hash of a user account that was collected by responder. So now what I want to do is try to crack that password hash. So to crack the password hash, I'm going to use John, and I'm going to specify the word list file. So -w equals, and our word list file is going to be course 10 underscore pass list. This is where you would supply in a dictionary list file like the ROCU text file. And then I specify the password hash that I want to crack, which is the course 10 underscore hash.txt. So I hit enter. Notice that, again, it was very quick because I only have a few passwords in the password list file, and one of those is the correct password. But notice that it came back and it says that it figured out the word password is the password for the administrator account. Or I should say, it's not the word password, it's capital P A $W0RD for the administrator account. So we are able to, once obtaining the password hash, we are able to crack that password hash and figure out what the password is for that account. So this is a very common technique to be able to hack into accounts within an Active Directory environment, is use Responder to collect those password hashes. In this demonstration, you saw how to use Responder to perform a poisoning attack.
In this video, I'll demonstrate how to dump and crack NTLM hashes using CrackMap exec. So in order to dump and crack hashes, you need access to the hashes. Then the actual cracking of the hash, if it is vulnerable, is usually accomplished using some cracking tool, such as Hashcat, John the Ripper, Hydra, Medusa, etc., some of which we are getting to during this course. We'll start with the assumption here that we have access to a compromised account. In order to enumerate the hashes, we need to breach one computer to start with. From there, if we can escalate our privileges, sometimes finding other high-value accounts, we can then move laterally through the network or intranet. The first step with CrackMap exec is to choose the protocol. This will be system-dependent, based on the computer or network that you're pentesting on. So let's have a look and see what CrackMap exec gives us. So CrackMap exec-h. So this is the help. It'll give some information. What we're concerned about here are the available protocols. So the available protocols here are RDP, Remote Desktop Protocol, WinRM, LDAP, Lightweight Directory Access Protocol, SSH, MS SQL, so this is Microsoft SQL Server, SMB, and FTP. In this case, I'd like to demonstrate the SMB option. But I don't want to run it against the computer on the network which doesn't have SMB. It's not something we're going to run against every system. A quick confirmation is always advised first. So for this purpose, I use Nmap. So I want to make sure that the traffic will be accepted, the traffic that CrackMap exec sends, so the packets or functions that it tries to replicate, that they'll be received by destination computer. So in this case, we'll do sudo nmap -s uppercase UT -p uppercase U :137, comma T uppercase T 139, comma uppercase T 445. So these are the 3 ports, 2 TCP ports and 1 UDP port. That's why we're using Nmap with -SUT for UDP and TCP. So these are the ports associated with SMB. And at the moment, the computer that we're testing against on my network, which will be different wherever you're running this from, is 192.168.2.182. Now, if I wanted to test the entire network, all the computers on my network in the certain range, in the 192.168.2 range, so I could do .0/24, and that will look throughout the 255 possibilities to see which ones might be running or most likely running SMB because of the port. But at the moment, I'm certain it's on port 182, because that's how I've set it up this time. And what I'm looking for is exactly what I'm seeing here. The results of the scan shows the port and the protocol 139/TCP. It shows that it's open. 445, which is the important one, is also open. And 137, the UDP port, is also open. So these 3 ports being open indicate that it's 99% sure that SMB is running. Now, our first CrackMap exec command, CrackMap exec SMB -u user, in this case, is the name of the user account on that computer, -p, and in single quotes, password 123. I've set it up with a terrible password, which helps in demonstrating some of these commands so that we can show what it looks like when a bad password is used and it is vulnerable. So in this case, we're looking for the command --shares along with CrackMap exec against SMB, against the computer on the network 192.168.2.182. So here it shows the enumerated shares based on this user, but it doesn't show exactly what we want. It doesn't show that it is vulnerable, at least not in this sense. CrackMap exec, we'll run it again, SMB-u administrator. So I've also set up an administrator account on that computer, -p, with the same password, which is a terrible idea in practice, but obviously a helpful idea when demonstrating these pen testing tools. 192.168.2.182. So the same computer. And here, now we see what we're looking for. So there's a line. It has the computer name, /administrator, password 123. And then highlighted in orange and in parentheses, it has pwned, PWN3D exclamation mark. So we know we have access, and we know this account has given us administrative access to this computer. Obviously, it's an administrator, but a misconfigured user account could end up with the same results. So the first step is always to run shares. That'll give us some information about what's being shared. And if the account is vulnerable, it'll show that it's owned. Now we'll run CrackMap exec SMB-u administrator -p, and then we'll put in the password, and --sessions. So the second step is to run the sessions command, 192.168.2.182 against the same computer on my network. So it doesn't show any extra information with the enumerated sessions, but it does show I still have access. So at this point, it hasn't given us a whole lot. Now I'd like to rerun this command, the session commands, but I'm going to change the user from administrator to user to see if I get any extra information, and run it against the user account and not the administrator account. So I haven't gotten any information on enumerated sessions. So there's nothing open. So these are the active sessions we're looking for, and we don't see anything yet. So one of the things that we can do is that if we have a high value account, something with administrative or some type of elevated privileges, we can actually run some remote commands. So another thing we can do is run crackmap exec with smb-u, and I'll stick with administrator because this will give us some information, some extra information, because the administrator account has more access. So we'll use get-service. So this is the command we're going to run, and we'll run it against our 192.168.2.182. And this is what we'd like to see. This script contains malicious content and has been blocked by your antivirus software. So this is very good. This is what we want to see. So when the antivirus software is running, it blocks us from access. Now, if we'd like to see what full owning of the computer is, we can turn off the antivirus software, which I don't recommend ever doing. But at this point, we see that there is some mitigations against these scripts. Another thing we can do is, if there's antivirus software running, we can use crackmap exec SMB, and we'll put in the same administrative user, administrator -p, password 123, and -uppercase M, and we'll use enum_AV products. So this is a built-in script we can use to run it against the same computer. And this tells us that it does have antivirus software, it's running Windows Defender, and that it is running, and it tells us what it's running from and gives us a bit of information. So we know that there is antivirus running. It's good to see, because if we don't see this information, if it doesn't show any virus, then there's another vulnerability which we should document. So at this point, because we know we have full access, let's try to dump some hashes. So crackmap exec smb-u administrator -p, password 123, _SAM. So we're trying to dump the SAM hashes, 192.168.2.182. And it does give us the hashes. So we have the administrator hashes, guest, default account, WDAG utility account, and user. So the user and the administrator are the ones that I've shown in this video. And you can look at the hashes. So it's interesting that the hashes are identical. So when it shows identical hashes throughout our results, if you see this, there's a very good chance, or almost a 100% chance, that the same password is used for administrator and user, which is not a good sign. So it's another thing you can look at here. And if you're using hash cracking tools like Hashcat, you can even use these hashes and attempt to crack them for if they're using poor passwords. Now I'll show you one more command, crackmap exec. And this time I'm going to use LDAP. So I'm not going to use SMB. I'm going to try LDAP against that same system. So the lightweight directory access protocol, put in the same information, -u administrator, -p password 123, _Kerberosting. Well, let's see if it's vulnerable to Kerberosting. So we'll try and dump the Kerberos hashes, 192.168.2.182. And we're not getting anything. So there's probably not a service running that is using Kerberos authentication, or at least not an LDAP service. So we don't get anything. And you can do the same, and you could check to see if it's running Microsoft SQL Server. You can use the MS SQL command under crackmap exec. But if you don't get this far, if you don't have an administrative account, or it doesn't have a vulnerable account, you won't get the message showing that it has been owned, and you won't be able to dump the hashes, which is a good sign. If you're pen testing, you want to make sure that you can't get in this far, that you can't dump this information from external sources. If there's a non-administrative account, which lets you get in and dump all this information, including the administrative hashes, then its access privileges are probably set too high. And that concludes this demonstration of cracking NTLM hashes using crackmap exec. In this video, I'll demonstrate how to intercept Windows credentials using Responder. Now, Responder is a man-in-the-middle attack tool. It attempts to intercept requests and impersonate computers and services on a network, such as SMB, Microsoft SQL Server, HTTP, LDAP, mail using SMTP or IMAP, DNS, and ARP spoofing. Responder is a network infrastructure penetration testing tool. The first thing to do before we run Responder is to make sure we know our local computer's IP address. So I'll run IP ADDR on this Kali Linux box, and I see that we have our IP address 192.168.2.177 on my local network. Now let's look at some responder options. So responder, and then -h as its argument. So there's some example usage at the top. We have responder, -I, ETH0, so we have to specify the interface. And if we scroll all the way up, we'll see that when I ran IP ADDR, it's on ETH0 or Ethernet 0. So we know what interface, what network interface to run it on. And then we have some different options, such as -B for basic or HTTP authentication using NTLM. So this is typical Windows authentication. We can intercept DHCP requests, DHCP DNS, WPAD for web proxy auto discovery, which is a powerful attack we should protect against. By default, this value is false. And the -F for forced WPAD authentication, and -P for proxy authentication. The first mode we should begin with is the Analyze mode. This option allows you to see NBT, NS, browser, and LLMNR requests without responding. So it will impersonate, but it's not going to attack. So this is the basic option. So it'll analyze network traffic, analyze any requests that come into it, and even appear to be a valid NTLM authentication point for HTTP authentication or anything that connects to it. It will impersonate the initial request, but that's all. So it's not going to be active on the network. It's not going to disrupt anything unless somebody specifically connects to it on this computer. It's not going to disrupt our network. And it's a good mode for testing or initial discovery. So I'll run responder, -I, ETH0, so we specify the interface, and then -A. And like many of these commands, for pen testing, because of the network access it needs, we want to run them as sudo. So we run them as root user. So it tells me it's in responder mode. So it's not going to poison any requests, but it will sit in the middle and it will respond in a more passive mode. So any attempts to connect will fail. The initial connections will appear to be valid. Like if an RDP request or HTTP request hits a server, it will look like a real authentication prompt, but then it dies there. So you can see already it's picking up MDNS requests that are coming through on the network. Now I'm going to open up another terminal window on this same computer. I'm going to look at what it looks like on the network using Nmap. So I'll do Nmap -SUT for UDP, TCP. So just a very basic Nmap requests, 192.168.2.177. And you can see a lot has returned. So Nmap shows that it looks like there are services running for FTP, SSH, SMTP, domain, HTTP, Kerberos, POP3, MSRPC, so a whole bunch of others. So this is identifying as a very active server on the network with a lot of services running. So this is what responder is impersonating. Now I can attempt to make connections using any of these ports or any of these services, and they'll look valid from the outside, but any attempts will just return failure. So that's what it does in analyze mode. So it's just looking for traffic coming into it on any of these ports. So when I switch back, you can see there's more activity since we last left it. Now I'm going to stop the analyzer mode. Now we can run responder in responder mode or active mode. This can be disruptive on the network. So you don't want to do so without consent and without users or clients knowing pen testing is happening on the network. It will poison requests such as DHCP or web proxy auto discovery or WPAD. So you need to get sign off before you run any of these tools on a client's network. So we can run sudo responder -I, ETH0, -W, F, -V, lowercase v, for verbose. See what this looks like on the network, and we'll go back to our other window, and we'll run Nmap again. So again, we have all the services showing, but this time it's going to be running in a WPAD poisoning mode. So it still shows all of the same things, but any WPAD requests or any web proxy auto discovery requests that come in will be poisoned. So you can see there's a lot more activity going on. So this is coming from another server. So I just did a Control-C to stop it. So you can see this WinDev 2407 eval. So this is another computer running on my network, running in a virtual machine that I have here. So this is a Windows machine, and that's a lot of the requests coming through are that Windows machine trying to authenticate itself. So there is a lot of activity. Verbose might have not been the best option in this window. So I'm going to kill this window and open up a new one. Now again, I'll run sudo responder -i eth0, and I'll run it in analyzer mode again. And let's look at what the responses look like. If I switch back to another computer, type in the IP address 192.168.2.177 where responder is running, you'll see that I get a sign-in. So this is a typical NTLM authentication. If I put something in, it just returns and it looks like I've successfully connected. But nothing happened, so it's a blank page. So you can see this access credentials, enter your credentials to connect to 192.168.2.177. If I put in some credentials and I hit OK, it just fails. So it looks like it's not working. I close out of it. Let's go back to Kali Linux. And you can see this NTLM v2 request that was made that I tried to connect to from the other computer captured the hash of what was connecting. So then we can take this hash offline, use some other cracking tools to attempt to discover the underlying passwords corresponding to that hash. And if I scroll up, you can see the web browser request I made, the initial request. So over the course of that exercise, there's been a number of requests come through from this other computer, this Windows computer, and you can see the username, the hash. So we've already captured some information, even running in passive mode, because someone tried to connect to it directly. So you can imagine running in responder mode, that it's going to be capturing all kinds of credentials and hashes and getting into the middle of legitimate traffic on the network. So putting these hashes into tools like Hashcat, we can attempt to crack them and discover the underlying passwords, which we'll cover in other videos. So mitigations to this type of network attack are usually setting up internal authoritative DNSs and internal top-level domains or TLDs. You want to block external access to wpad.dat files. So this is web proxy auto discovery configuration files. And you should identify WPAD network traffic and monitor for activity. So anything anomalous or anything running services on computers that aren't supposed to be running, it's possible to detect it and prevent it from poisoning your network. And any kind of automatic proxy configuration on workstations and browsers, you want to disable auto detect. And then regular penetration testing on network infrastructure. So periodically employing tools like Responder to verify configurations, especially after changes to network configurations, is important, as well as regular security awareness training, so users aren't entering credentials into unknown computers. And that concludes this demonstration of intercepting credentials using Responder. In this video, I'll demonstrate how to crack passwords using Hashcat. Cracking a hash, what Hashcat does, is about finding a string of characters which, if hashed using the same method as the target hash, will give you the same result. Passwords are usually stored in hashed format, as they should be. When a username and password are entered into a login form, the password is hashed and compared to the stored hashed value. If they match, then the user entered the correct password. We're going to look at cracking passwords using known passwords from a password list. So Kali Linux comes with some word lists, and these are stored in /usr/share/word lists. So we'll look at this with ls, and you can see there's a number of files. So these all contain passwords. So if I look at one of them, we'll use head/usr/share/wordlist/ let's look at Wi-Fi. So this comes from a certain application, and it shows the top 10 passwords in this file. So it's some very basic passwords, simple passwords that people use. And let's look at the contents of the folder with ls-la usr/share/word lists. You see, some of them are just symbolic links to other files, other passwords. So if I just copy the folder and I do an ls on that file, you can see the file size is not very big. So there aren't too many passwords in some of these, but we do have one big password file, rocku.txt.gz. So it's a zipped file, and it's quite large. It's 53 megabytes in size. So if we look at the contents, using ls-lah for human-readable USR share word lists, yeah, you can see that this rocku.txt.gz is 51 megabytes of passwords in zipped format. So it's quite a large file, a lot of passwords in there. So it's a common one that'll be used when cracking passwords using a known list. So it's a convenient one for you to use with your own testing. Another thing you should use when using Hashcat is the Hashcat examples. So go to https://hashcat.net/wiki/doku.php !ID equals example_hashes. So this page contains all of the generic hash types supported by Hashcat. So if you enter the hash mode 0, it'll expect an MD5 hash, which we'll try to crack. There's an important comment here. If you get a line length exception, so if you see this as an error in Hashcat, it's because the mode you selected doesn't match what you're trying to compare it against. So if the mode doesn't match in the file you're using, then it will give you that error. So let's start off with a simple example to see this working. So we'll use hash mode 0 or MD5, and we can create this right from the Linux command line or right from the Kali command line by using a command called MD5 sum. So we have to pass it something, and we do this with echo. So I'll use echo-n. So we want to suppress a new line of echo. This is important. Put ABC123. So it's going to echo ABC123, but with the -n, we suppress the new line. Because if you don't, then when we pipe this in to MD5 sum, it would add the new line character, and it will take the MD5 sum, including that character, which will throw off our results. So if we look at the result here, you can see this ABC123 hash with MD5 sum gives us this long hexadecimal value, this long number, E99, etc. But at the end, there's some space and then a hyphen. So what we want to do is remove that from the result. So if we pipe this into cut, so using our Linux commands, -d with the space surrounded by single quotes, -f, so field number 1, field 1, and then the double arrow, double greater than sign, MD5 hash.txt. Now, if we look at the result of that file using cat MD5 hash.txt, we just get the hash. So now we can run hashcat -m0 for MD5 -a0, then MD5 hash.txt, and then we give it a word list. So let's USR share word lists / let's use the wifi1.txt. We only need a small one for this. And if it finds a result, it'll show it in these results. So status exhausted. So it went through all the results and couldn't find a match. So that word list probably was too small. It didn't have our result. Let's try it with a bigger one. And let's use our rocku. And this time it shows cracked. So it was able to find the result. And if we scroll up, we can see that it found the hash colon and then our result, ABC123. So that was the string that we had hashed with MD5, ABC123, and it was able to find it. You can see it found it quite quickly. It took 3 seconds, so it shows the start and stop time. It took 3 seconds to find that using that password list. It's very simple passwords. It is lightning quick to find it, even with a hashed password. Now let's look at an example with a real-world hash. So in my case, I've run the pen testing tool called Responder in another video, and that's stored in, its results are stored in USR share responder logs. You can see there are a number of session files or log files according to what I've run. And I'm going to take one of these NTLM-v2 files, this HTTP NTLM-v2. So I'll pick one of these and copy the results. So I'll do cp/usr/share/responder logs. And I'll copy that to the current folder. And now I'll run hashcat -m. Now we need a mode for this. It's not going to be SHA-1 or MD5. It's going to be an NTLM-v2. So I'll go over to the Hashcat documentation. And here, NTLM v2 is in this list, and the mode is 5600. And now we specify the hash file name, the http-NTLM v2, and then the word list /usr/share/word lists rocku.txt.gz. And you can see this went very quickly. And the results of this, so the hash result, so it takes the hash with Kali and it finds the password Kali. So this is a hash. So this was captured from the default Kali Linux password, which is just Kali, Kali. And it cracked it almost immediately. One thing we didn't look at were the contents of the file. So if we look at this hash file, so you can see it has Kali and then it has some colons and then it has the hash information. So with all this hash information extracted, it found a result that would match to this hash. So if you take the NTLM v2 hash of the word Kali, it will give this result here. So it will encode that information within the hashes here. Now, if you have a more complex password, then it's much harder to crack. And in terms of mitigating these types of attack, you can see with very simple passwords or short passwords, even on a virtual machine, not a very powerful system I'm running here, it finds them almost immediately, which shows that strong or long passwords, complex passwords, will help mitigate this and require a lot more computing power. And it's also important never to reuse passwords, because if an attacker has a list of hashed passwords already, it could use some of those passwords and the corresponding hashes to help discover passwords that have already been used elsewhere. And another thing, if you're implementing a hashing system for passwords, you always want to make sure that the hashes have corresponding salts. So these are additional text used alongside the passwords to generate the hash values. This simple method makes cracking like this exponentially harder, especially if the user uses strong or long passwords. And that concludes this demonstration of cracking passwords using Hashcat. In this video, I'll demonstrate how to crack SSH private key passwords using John the Ripper. So you should always secure your SSH keys, your SSH private key with a password. And that password should be secure. It should be strong, complex, and it should be a long password. A simple password is easy to crack. Now, we'll demonstrate this. We'll start by creating a public private key pair using SSH-keygen. Let's give it a type, so -t RSA, then -b 4096, and then hit enter. So we want to save the key. We don't want to save it in the home SSH folder, the default folder for SSH keys. We want to store it right here. So I can just type in the name. So I'm going to call it test_RSA and enter a password phrase. In this case, I'm going to use something very simple, so we can demonstrate it being cracked. So now if I look in the current folder, I have my public private key pair. I have test RSA, which is the private key, and test RSA.pub, the public key. Now, if we look at the contents of test RSA using cat, we can see that there's this SSH private key. Now, in order to use John the Ripper or the John command, we need it in the supported format. So there's a command called ssh2john, and we can give it the test RSA greater than, so we're going to put this output from ssh2john into test_RSA.hash. Now, if we look at test_RSA.hash using the cat command, you can see it's in a slightly different format, but it's a format compatible with John the Ripper. Now we can run our John command. So we want John test_RSA.hash and then /word list. So we need to give it a word list equals /usr/share/word lists/ let's use wifi.txt for this first example. So it does take a little bit of time to run, and it shows that it will run using 4 OpenMP threads. So it's a multi-threaded or multi-process application, and you probably can't hear it over the microphone, but I can hear my computer's fan spinning up. So it's actually doing a fair bit of work to try and crack this key. And then the stronger the password, the more complex it is, the harder this will be for a computer. And you'll need more and more powerful computers to crack more and more complex hashes, which will take more and more time. So if you have a long password, something 14 characters or greater, or even 20 characters or longer, if you're storing the password for your SSH keys in a password manager and using something complex, this could take hundreds of years on the most powerful computers in the world. That's why password complexity and length is so important. So the process is still working away even after 10 minutes, and it hasn't found the password yet. So it's quite an intensive process, and it may take some time, even with simple passwords. We have a way of forcing it. So I hit Q. You can see it's been running for 8.5 minutes, and it still haven't found a result. So let's trick the result. So I'm going to create a file to echo, and I'll give it the string abc123, and I'll put that into a file called abc123.txt. Now I'll run John on test_rsa.hash. And my word list, so _word list equals abc123.txt. And you can see that it found it almost immediately. As you can see, brute forcing is not always trivial, even if there's a fair bit of complexity in your hashed password. Now, the usual advice in these situations is never expose your private keys, always put a password on them, and make sure it's a strong password. And that concludes this demonstration of cracking SSH passwords using John the Ripper. In this video, I'll demonstrate how to use Hydra to brute force login pages. We'll start with a test case on the basic use of Hydra. So Hydra is a brute force or password cracking tool that uses brute force. And here I have Hydra-T1. T is the number of tasks or threads, so we can run multiple tasks in parallel if we need to, depending on our processor and how powerful our computer is. In my case, I'm only going to use one for this simple example. For the login or the username, we give it -L and then the name of the user. In this case, I'm going to try administrator. -P for password, password123 is going to be the password, and RDP is the protocol we're going to use. Hydra supports a number of different protocols, including HTTP to post forms to a web page, which we'll get to in the next example. But I'd like to test the basic mechanics here to make sure Hydra is working as expected. So I have a computer at 192.168.2.77 that should be successful for this request, and it is. So 1 of 1 target, successfully completed, 1 valid password found. So I knew the password, and it's not really the best use case, but if you want to confirm that Hydra is working correctly and the mechanics of your command are what you'd expect, it's good to try a result that you know you're going to get a success for before you get started. We can make this a little more complex. I'll start with Hydra again, -T1, -V, uppercase V for verbose mode, so we'll get a bit more output, -F to tell it to exit when first login password is found. So this is important when you're pen testing. If you want to stop when you find one username password successful, then you specify -F. And now we'll do -L administrator again. And this time, -uppercase P. So lowercase p, we specify a single name or single password. Uppercase P, we specify a file to try. And in this case, I'll use /usr /share/wordlists/rocku.txt.gz, the password list file that comes in with Kali Linux in its built-in word list. 192.168.2.77, and I can specify the protocol at the end, RDP. In verbose mode, it's actually showing it going through all the passwords it's trying, and it's doing so quite slowly. And you can see after 11 attempts, the server starts kicking me out. In this case, the server is configured to stop accepting attempts after 11. Or maybe it stopped at the 10th and the 11th just failed. So when it made the attempt, it kicked it out and it reattempted it until it reached an error threshold and then stopped. This is the basic function of Hydra. It's good to run it in verbose mode when you want to see what it's doing, if you're not sure what it's trying. Obviously, for a practical brute force or an effectively practical brute force, something that has a chance of working, we can't use this verbose mode to attempt it in such a slow fashion. And the same with the number of tasks or the number of threads, the T command. You'll want to do this in a multi-threaded fashion to get through a large number of passwords very quickly. Clear the window, and we'll get into an actual web example. I'll open up my browser. I'll put in 192.168.2.244, where my example page is running on the network. And now this example is running under Metasploitable, and the example I'm going to use is in a tool called Mutilidae. So Mutilidae is a deliberately vulnerable PHP script of OWASP top 10. So this is specifically for pen testing or learning or practicing pen testing. In this case, I'll go to the login page, and I'd like to perform a login. For Hydra, what we'd like to do is simulate this name and password form. There are a few ways we can accomplish this. So we'd like to look at the request. It should be a post request. And if I go into the browser settings, into more tools and web developer tools, open up the network tab. I'll select reload to reload the page. And you can see all the requests that are made by the page to load it. Keep this open and put in a name and a password. So I'm just going to put in admin, hit login, and I get authentication error, bad username or password, and not logged in. So this information about the failure is important, and I'll get to that in a moment. So the method here in the network console is post index.php (page equals login.php). And this is the request I would like to look at. So this post of the request, I want to look at what parameters are being passed, what form data, username, admin, password admin, and login, PHP submit button, login. I could look at the raw details. So this payload is username equals admin, ampersand password equals admin, ampersand login, hyphen PHP, hyphen submit, hyphen button equals login. Switch back over to my terminal window and come up with my Hydra command. Hydra hyphen F, so we can fail out immediately if this works. Now, it's not important for this case because I'm only going to pass it a single username and password. I'll do -L admin, -P admin. We know this one failed because that's what I just put into the form on the web page. Then the target IP address, 192.168.2.244, the method HTTP -post-form. If this were a secure form running somewhere else with a TLS certificate or SSL certificate, we could put HTTPS, but in this case, it's just plain text, HTTP post form, and then in double quotes, the path. Path here, we can get from the network information, so it's going to be in the headers, and if we look at the post, we have http:// and the IP address, 192.168.2.244, and then the path of the URL after that. So we want everything after the domain or the IP address of the request. So we'll copy value, go back to our terminal window, and paste it in. So we have /mutilidae /index.php (page equals login.php). So that's the path. That's the first parameter of our request. Then we specify a colon and then the request body. In this case, we go to the request, we look at the raw request, copy the text, go back to the terminal window, and paste it in. Now we have username equals admin, password equals admin, and login PHP submit button equals login. So I'd like to edit this part. So username equals, and we're going to specify a variable for substitution. And we do this by using the caret, user in uppercase, and the caret. So anything in the L parameters, then it will replace all the users with those login names. So it can do a variable substitution in this request. And the same thing with the password. So if we have a password file and use the -uppercase P command with a file of passwords and a file of usernames, then we can do the Hydra will do the substitution for us. Then I'll remove the password that's hard-coded and put !pass, and then make sure my ampersand is there. So I have username equals user surrounded by carets. Then ampersand password equals !pass, ampersand login -php -submit -button equals login. And then close my double quotes. Actually, before I do that, very important, another colon, and then the criteria for a failed password. But what I'd like to use is something on the page, something that's returned by the server that tells me that it didn't work. And in this case, I'm going to use not logged in. So if the response sees the text not logged in, it's going to fail. Hit enter, and it failed. It tested the target, and it said 0 valid password found. Well, that's what we expected, because if I go back to the web browser, when I tried that username and password combination, it didn't work. I'm going to change it now and use the username and password that I know works. So admin is fine, and then password admin PASS. So admin pass in this case, terrible password, but that's what we're using for this demo. And logged in admin. So this worked. So in this case, it logged it in, and I'm logged into the page. So I'll go back to my command line, arrow up to get the request back, and go to the P parameter, so -P, and I'll change this argument to admin pass. I'll run it again. And in this case, it was successful. 1 valid password found, and the login admin pass worked. Now I'll demonstrate the command by passing a password file. I'll create the password file using nano admin pw.txt. I'll type in some passwords, ABC123, some very simple passwords, 123456, password 123, admin pass, which is the correct one, what we just used, and then pass admin. I'll exit out, save this, arrow up to bring up my command again, so Hydra -F -L admin I'll change the P to uppercase P, so -uppercase P, and then specify admin pw.txt. In this case, it will test all of the passwords in that list, and we can verify that with a verbose, so -uppercase V, our same IP address, and the rest of the request doesn't change. And now it will substitute all of the passwords for the passwords in the file. And I'll execute. You can see it did it so very quickly. So it tried admin with all the passwords, which all failed. But when it reached admin pass, it succeeded. So I'll clear this window, and we'll bring up the command again. So we have our command again. Now, one part that's very important when running this command is what we specify in the string at the end. So the substitution and the parameters we pass into the string. So there's 3 parts to it. The first part is the path. The second part is the request body. And the last part is the failure criteria, or the failure text, or whatever the failure is needed to happen, so we can detect what's a successful request and what's a failed request. And that concludes this demonstration of brute force login pages using Hydra. In this video, I'll demonstrate how to use BloodHound to perform Active Directory attacks. BloodHound is a single-page JavaScript web application used to identify internal network vulnerabilities in Active Directory, such as misconfigurations or weaknesses due to privilege escalations through lateral movement. BloodHound has data collection tools, one called SharpHound and another one bloodhound.py, and possibly some others. An analysis for data collected for BloodHound is done through a graph-based interface with nodes between connected entities in order to discover attack paths. BloodHound isn't the tool to carry out the attacks, The attacks will be carried out by other tools, with basic PowerShell commands in some cases, or post-exploit tools like Evil-WinRM Community Edition is what I'll use for this video, and the quickest way to get up and running with it is through its Docker image. This isn't a video about Docker, so I'll skip the Docker install. You can verify Docker is installed and ready to go in your system by running sudo docker run hello-world. You should get hello from Docker. This message shows that your installation appears to be working correctly. If you don't get this message, go to the Docker website, follow the instructions, get it installed, and get back to this point. And now we can get the Docker image. So I'll use curl -uppercase-L https://ghst.ly/get bhce, and this will get the Docker compose file. So we want to use a greater than symbol and put this into docker-compose.yml. And we'll type cat docker-compose.yml, and that looks like a typical Docker file. So now we can run Docker to pull this image. So sudo docker compose pull. It may take a few minutes depending on your connection speed to get all the files it needs. And then once it completes, you can type sudo docker compose up. Now it's important here to follow what's going on in the output, because the first time you run Docker, it's going to generate an initial password, and you want to grab that initial password from this output. So on my screen, I have one of the log messages that say initial password set to, and I want to make sure I stay on that part of the screen and grab the message. I'm going to copy this. And now the log continues going, but I want to switch over to my browser, open up a new browser tab, and type localhost:8080. Now, where it says email address, we're just going to type admin. The default user is admin. Paste the password in from the log messages, login, and we're going to need to paste it again. So it's just a one-time password. So we paste it in because it expires. Now I'll grab my actual password from off screen and paste that in. I click reset password, and then it should take me into BloodHound. Now, initially it tells me there's no data available. I can use the data collection tools like SharpHound or Azure Hound or BloodHound.py. And then afterwards, once I've collected the data, we go to File Ingest, and we upload the files we like to use. If you don't have data you can use, or you don't have AD running on your local network, or it's not managed by AD, you're not going to get a whole lot of information out of it. So what I recommend is going to the GitHub page from Spectre Ops, the makers of BloodHound, and go to their example data. And then there's the AD example data and the Azure example data. So I've downloaded these, and I'm going to load the AD example data.zip. And then I'll take the AD example data.zip and drag it onto the screen and hit upload. Now, it may take a few minutes to ingest, but the file ingest page has a status, so it says it's ingesting. And when it completes, it'll update the status message, and then we'll be ready to explore the data. Now, I've waited a few moments. I'll refresh the page just to see the status. And at the moment, it tells me it's analyzing. And then it gives us a message complete, so we're ready to go. So we'll switch over to Explore, and we can search for something. Let's search for a name. I'll search for Alice. So we have Alice at phantom.corp. And there's a single node. So if we select the node, it gives us information about that object, about what it is. And we can scroll down until we get to this section here where we have sessions, the membership or group membership, outbound object control, and inbound object control. So Alice is connected to many other nodes on the network. The outbound object control shows there's been some big improvements in BloodHound over the past few years to display some pretty big and complex information. So I'm going to switch over to a simpler user. I'm going to look for Bob at phantom.corp. I'll select Bob, and then his local graph is much smaller. So we have Bob here on the network, and each one of these edges between the nodes you can actually select what they own, right owner, generic writer. And when you select one of the edges, one of the labels on the edges, it'll give us some information. Let me scroll over and find something with a bit of information. So you can see as I click the different edges, the labels on the edges, it changes the information in the right-hand panel. So it shows some general information about what the edge means, Windows abuse, what you might be able to do with it, some suggestions if you're using Linux abuse, OPSEC, and references. So some information about where this information comes from. So this comes in handy when you're trying to test it. When you're looking for vulnerabilities, you're looking for hops that don't make sense. So you can see the ownership of a particular user, what they're a member of, and how they're connected to other users and other entities. And quite often, if something's misconfigured, you'll find a path to a user or a group with elevated privileges. And sometimes it's hard just to do it visually. Now we can expedite this by using pathfinding, and we can look for how Bob is connected to domain admins. So we can look at domain admin at phantom.corp. So that's a possibility. So we look how Bob is a member of domain users, and domain users have access to phantom.corp. And then there's some connections between phantom.corp and other logons and what they contain. So the interesting thing is that you can go from Bob to domain user to Phantom Corp, which contains managed service accounts, which contains Hayden at phantom.corp, who is a member of domain admins. Permission on the parent. So if we go to select one of the edges and go to the abuse section, permission on the parent of a child object may enable compromise of the child object through inherited ACEs or linked GPOs. See the inbound edges on the parent object for details. We have domain phantom.corp contains the container managed service accounts at phantom.corp. So there's a path here to domain admins at phantom.corp, which may or may not be expected. But you can see we get a visual sense of how we can go from Bob all the way across to domain admins. If we're not sure there's a connection, we could always go into pathfinding and see if BloodHound can work it out for us. And sometimes it says path not found. So I can't go from one group, this denied RODC password replication group, to domain admins, and that might be what we want to see. And if there is a connection, there could be a configuration problem. It's something that leads to an exploit that allows for lateral movement through the network and the escalation of privileges. And that concludes this demonstration of performing Active Directory analysis using BloodHound. In this video, I'll demonstrate how to use Medusa to crack passwords. Medusa has a number of modules that you can look up by running Medusa-D. All of the available modules are listed here: CVS, FTP, HTTP, etc. We're going to use SSH. And to specify the module when you're running Medusa, you use the -M and then the module name without the .mod, so SSH. So if I run Medusa-M SSH, then -U, I can specify a username. Let's do an example I have here, MSFadmin, -P, MSFadmin, -H for the host, 192.168.2.244. So this is a service, a virtual machine I have running on my network that has this username and password, the default for this install. And when it returns success, first it shows the account check. So it's what it's checking, what it's attempting. And then if it succeeds, it shows account found, and it shows the success message. If I arrow up and replace the password with MSFadmin and remove a character, remove the N, it's going to fail. And in this case, the account check shows, but there is no account found, there's no success message. So that's how we differentiate between success and fail with Medusa. Suppose you want to test all of the SSH hosts on your network, or all the hosts running SSH as a service, but you don't know exactly where they are. So if we want to find those, we can run sudo nmap -p 22, the standard SSH port. Now, of course, if SSH is configured to run on a non-standard port, this wouldn't pick it up But if you're concerned about that, you could do a more comprehensive scan that'll take a bit more time, but it should be able to identify the SSH ports regardless of where they're running with the proper scan. But in this case, I'll just use port 22 and check 192.168.2.0/24. So that's everything on my local network, all 255 addresses in that space. Now for the output, I just want to grab the IP addresses. Now a good way to do this with Nmap is to use the -o command or -o uppercase G. And this stands for greppable. So it's searchable with regular expressions where you can match on the string you're looking for and output just say the IP address in this case. And then the final hyphen just says we want it in standard output. Here it gives me a list of probable candidates with some extra information. So it tells me if it thinks the host is up, and it looks at port 22. In some cases it says closed or open or filtered. We probably want to test at least the open and filtered ones, but let's test them all just in case. I want to grab just the IP addresses. So I'll arrow up and repeat the same command, but I'll pipe this into awk. And I'm going to look for any line, so /up with a $sign. So this is a regular expression in awk to look for any line that ends in up. And then in braces, print $2, close brace, close our single quote. And then we'll send that using the greater than symbol into a file called sshhosts.txt. Now, if I use cat on SSH hosts, it'll show all of the IP addresses that were captured. Now I'm going to use a word list for users, so a user list. So I'll type nano userlist.txt. And I've created this small user list to pass into Medusa with root, MSFadmin, Kali, and administrator. So 4 accounts that might be on my network on hosts that are running SSH. I'll close out of that and nano password list. Although I could use a more comprehensive password list like the built-in to Kali Roku password list, but I'm just going to create a small one for the sake of this example. And in my password list.txt, I have MSFadmin as a password, root as a password, Kali 1234567, and password 123. What Medusa will do is for every host, for every user on that host, it will try every password. So that means it's going to take the number of hosts multiplied by the number of user lists in the user list and the number in the password list, and that's how many attempts in total it could potentially try. To do this, we'll run Medusa -uppercase H. If we're specifying a file, we use uppercase letters for our arguments. So uppercase H, sshhosts.txt, -uppercase U, userlist.txt, and -uppercase P, password list.txt, and then -uppercase M for the module SSH. And Medusa will go through as quickly as it can, trying all of those combinations. Right from the start, it couldn't connect to 192.168.2.1, so SSH wasn't running on port 22 on that device, but now it's trying on .43. So all of these are remote attempts to crack the SSH password. If it doesn't get disconnected or temporarily blocked, or it could be timed out by the implementation or by the configuration. If it doesn't get any of these, like I've already see a problem here with trying to connect to 192.168.2.43. The system should never be configured to allow a large number of attempts or an effectively unlimited number of attempts with no delay between the tries. Here, at least there is a delay, but after this many attempts, after, at most a dozen attempts, it should be blocking for any more failed attempts. I consider that a misconfiguration problem. So when you're pen testing for a client, this needs to go into your recommendations. You can see when it reaches a host that it's unreachable or there's nothing running there, like on 192.168.2.59, it makes a few attempts to connect, and then it moves on. And finally, it reaches the 192.168.2.244, which I demonstrated at the beginning of the video. I'll stop this here. I'll do a Control-C to get out. And you can see when it reached the user MSFadmin, password MSFadmin, it had a success. So it will report this success message as it's going through. And the nice thing about this, when I do a Control-C and stop, I can resume my original scan. I can add -uppercase-Z, H6U, 4, H7, as it directs me to here in the result, and it will continue on where it left off. Very useful if you want to stop the process and resume it. So we'll stop there, and that'll conclude this demonstration of cracking passwords using Medusa. In this video, I'll demonstrate how to use Burp Suite to perform broken authentication attacks. To start Burp Suite, I go to the menu in Kali Linux, select Web Application Analysis, and Burp Suite. Just going to launch a temporary project in memory, use Burp Suite defaults, and start Burp. Then from the top bar, I'm going to select Proxy, Intercept On, and Open Browser. So this will launch the pre-configured Chrome browser that's connected to Burp Suite. And I'll type in 192.168.2.244, which is the web service running on my network that I'd like to intercept. Now, as soon as I enter something in the browser, it switches back to Burp Suite because it's intercepted the request. Now, I'd like to forward this, and that allows the browser to continue on. So it forwards the request or the response back to the browser after the request was made. So every time I click something, it'll go back to Burp Suite, show me the request, and ask me what I'd like to do. And for normal requests, things that we don't care about intercepting, things that we want to allow to continue, we just click forward, and that continues it on. Go back to the browser. You could always leave intercept off for the things you don't care about. Get to the page you want to intercept. And in this case, the login page, I'm using a software called Mutilidae. So this is an intentionally vulnerable web application running under Metasploitable. So these are good for learning pen testing tools, these intentionally vulnerable environments. The good thing is, in a lot of ways, default setups on most regular operating system installs are relatively secure to begin with. They're easy to update, and they get the latest patches and security updates. So it takes a bit of work to get a vulnerable machine, especially when you're trying to demonstrate a particular vulnerability. That's where tools like Mutilidae and Metasploitable come in handy. They're easy to download and get started with. At this point is where intercept becomes important. When I put in a name and a password, hit enter, that's where I want to be intercepting. So I'll turn intercept back on, go back to the browser, and try this login again. So I'll type admin and admin, and we get a failed response. But it's good to see what's being sent, so we can look at the request that's going to be sent, username equals admin and password equals admin, and so all the form information that's being sent by the browser is captured by Burp Suite. I'll hit forward and let the request go through, and I can look at the HTTP history. It will show the post and the result. And if I look in the result, I can see all of the page information that gets rendered by the browser. And in the browser, I haven't had a successful login, so it says not logged in. I'm going to put in the correct name and password this time. I'm still intercepting, so it should go back to Burp Suite. So it does. And if I look at the intercept, it has the information. I hit forward, and then forward again. So let it do its complete thing. I don't want to save it. So here it shows me I'm logged in as admin. And what I'd like to do is go back to my history and look at some of the information that's contained in the request. So the final GET request to reload the page after I've logged in shows a new cookie being set. So there's a username, admin, and a PHP sesh ID. This is not entirely uncommon. However, with cookies, you can edit them. So I could go into the cookie, change the UID to another number. So what I'll do is go back to the browser, hit refresh. Intercept stops the request, and it shows me the request that's going to be sent by the browser. So I'm holding on to it. And what I'm going to do before it sends it back to the server, I'm going to go in and change some of this information. I'm going to change the UID in the cookie from 1 to 3, and then forward. So it's going to continue the request, but with my modified interception. So when I forward it, go back to the browser, you can see logged in user is no longer admin, but it's set to John. So this is the user ID of ID 3. which means the authentication method is broken. We've bypassed the authentication, and this allows us to set any user as long as we know the user ID. And if I reload the page again, you can see now it still goes back to UID 1, but I can keep changing this. I can change it to something else. Let's go 2 this time. You can see logged in admin, Adrian. This type of vulnerability is common, and a tool like Burp Suite makes it easy to discover. And that concludes this demonstration of performing a broken authentication attack using Burp Suite.
In this demonstration, we'll take a look at how to perform credential attacks with Mimikatz, including a pass the hash attack. Let's start by getting into a Meterpreter session on our victim system. So the first thing that I'm going to do is I'm going to type in MSF console to load Metasploit. Once Metasploit loads, then I'm going to choose an exploit that I've used to gain access to a system already. So I'm going to use the exploit for Windows against the SMB service, and it's the MS17_010_eternal blue exploit. Now notice that it configures my payload there. It says that no payload has been configured, so it's going to default to Windows x64 Meterpreter reverse TCP. Now the reason why I mention that is you do want to make sure that the payload that's selected is in a 64-bit version versus the x86 version. And in this case, it is the 64-bit version of Meterpreter. So it means when I exploit the system, it's going to put me in a Meterpreter session, which is a great tool to use for post-exploitation, including performing password or credential attacks. Once I've gone and selected the exploit, now I want to go and set my options. So I'm going to go and set my rhost value to the victim's IP address. In this case, it's a Windows client machine, which runs at 10.0.0.10. Now that I've got all that set, I'm going to exploit the system. If it's successful, it'll show a win at the bottom of the screen. And there we go. So it was successful. Notice that my prompt has changed. I'm in a Meterpreter prompt. And at this point, I could use any of my Meterpreter commands. But what we want to do in this example is we want to focus on using Mimikatz to perform credential attacks. So I'm going to use the load command to load the Mimikatz module. Now, one thing I want to stress here is that the commands have changed, and they even give me a little yellow explanation point there, and they say, hey, this Mimikatz extension has been replaced by Kiwi. So really the command I should have used was load Kiwi, but most people know this as the Mimikatz module, so that's why I wanted to use it, knowing that it would still work. So it says at the bottom of that output that it was successful in loading the Mimikatz module or the Kiwi module. And at this point, there's a number of commands that we can use. And if you want to see a list of the commands, you can use the question mark. So just to highlight a few examples of commands, if I want to take a look at any credentials, so Mimikatz is a module that we can use to extract passwords from memory of the victim system. So the creds_MSV will extract out the NTLM hashes from memory. So any user accounts that have authenticated on that system with the credentials still sitting in memory, it'll go and show those credentials to me. The other thing is that there's a creds_Kerberos, which will retrieve any Kerberos credentials and display those. Again, that's from memory. But we also have a command here to do a SAM dump. So if I want to retrieve all the password hashes from the SAM database of that system, I can use the LSA_dump_SAM command. And there's other commands here. You can do a password change on an account if you wanted to. I can get a list of Wi-Fi networks that the system is configured to connect to. So all kinds of different things that I can do here. So just to kind of show you a few examples, the first thing that we're going to use is we're going to use the creds_MSV, which will show any of the password hashes that exist in memory. So this client machine, somebody has logged on, and they logged on as the administrator, and there's our NTLM hash, which is awesome. So what you're doing at this point is you're kind of making a note of, okay, we have a username called administrator. The domain in this case is just a local workstation logon, so it's the name of the workstation, Win7a, and NTLM would grab the password hash. So you kind of start collecting that information. Now what's really cool is if you use the creds_Kerberos command, it'll actually show that password in plain text, not just the password hash. So now I'm collecting information about, usernames and passwords that are still stored in memory on this target system. So I can see there's a username called administrator on Win7a with a password capital P A $$W0RD, which is awesome. Now, the other thing that we can do as well is we can dump the entire SAM database. So I can do an LSA_dump_SAM. And what happens here, if I scroll up in my output, is we can see all the user accounts and their password hashes. So again, what you'll do is you'll collect this information. So we already know the plain text password for the administrator account. So I don't think there's a lot of value in grabbing that password hash, although you still may want to grab the password hash. But notice that we do see other users on the system. So there's a user account, user1, and we have the password hash for that user account. We have user2, user3, and notice that the password hashes are different. So there are different passwords used on these accounts. So what you could do is you could collect that information. Now, also what you can do with Mimikatz is you can fire off custom commands. So there's a whole bunch of different commands that you can fire off. And with the Kiwi extension here now, to fire off a custom command with Mimikatz, it's Kiwi_command, and this was in the help there. And then in single quotes, you plug in the custom command. This will take a little bit of getting used to. The commands are in two parts. So the first part is the category of commands. So this is the secure LSA, and then we do : and you specify the action on what you want to do in the secure LSA category. And the action, there's an action called pass the hash. So I do : PTH space, and then you specify any parameters that it would need. So for instance, I can do the user that I want to authenticate in or as is user6. The domain, in this case, it's just the Win7a system. And then we can do an NTLM : and what we can do here is we can pass in the password hash of that user6. So I'm just going to copy that here. So I copy selection. I'm just going to paste it in with my command there. And then what you could also do is you could specify, not only do you want to authenticate to the system as user6 using, instead of trying to crack the password, I can just pass in the hash value is kind of the point here. But the other thing you can do as well is you can go and specify that you want to run a command. So I could do a /run, and I could do cmd.exe. Hit enter, and it comes up and gives me feedback here. It says, okay, you've authenticated as user6 on the Win7a system, and you're running the program cmd.exe, and they show the process ID here as well. So the point is, the pass the hash feature allows you to authenticate to a system without trying to figure out what the plain text password is. So you could use a password cracking tool and you could crack the password hash, but sometimes that could take quite a bit of time. So the idea here is that Mimikatz gives us the capability to authenticate to the system using the password hash if you use that /NTLM switch. So in this video, you saw how to perform credential attacks or password attacks using Mimikatz. In this demonstration, you'll learn how to use Rubeus to perform attacks against Active Directory. Let's start with a quick description of Kerberosing. Kerberosing is an attack that tries to get the password hash of an Active Directory account that has a service principal name associated with it. A service principal name, or SPN for short, is an attribute that associates an account with a service on the network. This SPN is then used in Kerberos authentication for clients to obtain a ticket to access that service. The attack here is that anyone can request a ticket from the service which contains the password hash of the service account being used. Once the attacker obtains the password hash, they can then crack the hash offline using a tool such as Hashcat and then impersonate that account. Rubeus is a tool that can request for a Kerberos service ticket which contains the password hash that will then crack offline with Hashcat, but you could also use John the Ripper as well. Let's start by using Rubeus to send a request for a ticket. So we use the Rubeus command. We specify our option on Rubeus. So in this case, we want to use it to perform Kerberosing. Now keep in mind that Rubeus can be used for different tasks or attacks against Active Directory, including obtaining what we call a silver ticket, which means getting a min-net level access to a service itself. So here we're going to do Rubeus Kerberos. Then we specify our domain. In this case, we're in the quick 24/7.loc domain. You specify the credentials of a user account on the network. So this is important because any user on the network can request a service ticket from Active Directory. So here all I need is just regular user credentials. I don't need a min-level access to send this request. So the credentials that I'm going to use, and when you specify your credentials, you do have to specify the domain again. So quick 24/7.loc/, and the user account that I'm going to use is T Smith. So I would have obtained this user's password in a previous attack. And then I'm going to specify the password for this account is capital PA $$$W0RD. That happens to be the password I'm using for all the accounts in my lab environment here. Now I am going to specify the no wrap option here. And what this is used for is when the Rubeus sends out that request for a ticket and we receive that ticket, the actual hash that's used to encrypt the ticket is going to display on the screen. And in order to be able to copy and paste that properly, we have to specify that we don't want a password hash to be wrapped. So I'm going to fire this off. And when I hit enter here, it shows that we do have one service account in Active Directory. It's an account called the SQL Service account. We can see the distinguished name of the account. So this is the full distinguished name. So it's CN equals SQL Service. It's in an OU called Service Accounts and in a domain called quick 24/7.loc. We can actually see the service principal name here as well. So this is the service account that's going to be used by Microsoft SQL Server. And then we have the password hash. So what you can do is you can select this password hash. So this is a Kerberos hash. And you can copy it. So I can highlight it and hit enter, and that'll copy it to the clipboard. And then what I can do is paste that into my next command, which is to use Hashcat. Okay, so what I've done here is I've switched over to my real computer because that computer has a GPU that Hashcat can use to crack the password hash. So to crack the Kerberos password hash, we're going to use Hashcat. And then in quotes, we're going to paste in the password hash. Perfect. I'm going to close the quote, and then I'm going to specify the dictionary file that I want to use for the password cracking. So in this case, it's example.dict. This is the sample dictionary file that comes with Hashcat. What I did is I modified it, and I actually put our password in there just for the demonstration. I did put it pretty far down in the file, so it'll still take a few minutes for it to be able to crack the password. So I hit enter, it executes our Hashcat program, and within a minute, it finished the password crack. So very quickly, again, for the demo, I put the actual password in there. So you can see up top here, if I scroll up, so it is using Hashcat, and it is using my GPU to perform the password cracking. Down below here, they show us the password hash, which we've supplied, but notice right after the password hash is a colon, and there's our password. So capital PA $$W0RD. Down below that, we can see the Hashcat program has cracked the password. shows you the start time and the end time. So again, it happened very quickly. And that's it. So now we have the password for that service account. And that service account, we can log in with that and access Active Directory, and it may have permissions to different Active Directory resources. In this case, it's the SQL Service account, so it'll have access to the SQL Server. You can then turn around and use this password with that user account, that SQL Service account, to then issue a request for a silver ticket to get a min-level access to the SQL Service if you wanted to as well. So all kinds of things we could do once we have the password for the service account, but we can now impersonate that service account. So in this demonstration, you saw how to use Rubeus and Hashcat to crack an Active Directory password. In this demonstration, you'll learn about Certify, a penetration testing tool that can be used to leverage weaknesses within Active Directory certificate services. So the first thing that I want to make a note of is that the newer version of Certify is now called Certify-AD. So if I do a Certify-AD command all by itself, it'll display the help for the command. Or you could use the Certify-AD-H to display the help if you wanted to. But typing the command all by itself without any parameters will display the help. And they show you the general syntax, so it's Certify-AD. Again, the older version was just called Certify, but now it's Certify-AD. And then they show you your command switches that you can use, and then the actual commands. So there's an account command you can use, there's an auth command for authentication, there's a CA command, there's a cert command, and so on. And then what they do is they give you a list here in the help of what the general purpose of each of those commands are. So the account command will manage user and machine accounts, whereas the auth command will authenticate using certificates. The CA command will manage CA and certificates, and so on. I want you to notice that there is a find command, because that's going to be our first command that we use, and the find command is used to enumerate through Active Directory certificate services. And also notice that we do have a request command as well, which is used to request a certificate. And those are two examples of commands that we're going to use here in this demonstration. So I'm just going to clear the screen. So that's how we display the help. So note that we did see that there was a find command that we want to use. So what you can do is you can do Certify-AD, use the find command. If I've never used that command before, I want to do a -H on that to get the help of the find command specifically. And you can do that with each of the commands. So when I look at the help for the Certify-AD find command, they give you a list of all the options with an explanation of what each of the parameters or what each of the options do. So that's important to kind of know as we get started here. So I'm going to clear that screen. So I do want to use the find command. So I'm going to use Certify-AD space find. Now when I use the find command, what I'm going to do is I'm going to authenticate with a user account. So tsmith at quick24/7.loc. The password for that account is capital PA $$W0RD. So that username and password you would have obtained in an earlier step within your penetration test, right? I do want to stress that this is just a regular user account. So one of the things with certificate services is that users can send search requests and discover information about certificate services and its vulnerabilities. So I'm going to specify the IP address of the domain controller, again, which you would have discovered earlier on in the penetration test. So the IP address of the domain controller is 10.0.0.1. So I hit enter. And basically what happens here is Certify goes and contacts Active Directory and discovers information about certificate services. So the vulnerabilities that it can leverage come from vulnerabilities within what we call certificate templates. A certificate template is a basis for different types of certificates that can exist. So for instance, a user certificate is generated from a certificate template called user. A server certificate, which you can use for server applications, let's say, it is generated from a server certificate template. So every certificate that's generated in certificate services is based off a template. So the template defines the types of certificates that can exist. And then the other thing is the certificate template contains the options or settings for that type of certificate. So my point here is a lot of the vulnerabilities come from these certificate templates. So it says that it's finding certificate templates. It found 34 certificate templates. It also found the certificate authority. So it found one certificate authority. The certificate authority, or the CA, is the entity that's going to issue out certificates within our PKI infrastructure here. Perfect. So it kind of gives you just a little bit of info on that. It says got CA configuration for server A. So server A is the actual CA. And then it specifies that it's basically outputted the information to a BloodHound file, or it also outputted to a text file that we could view. So I just want to view this. This is going to be a huge file, but just to show you, we're going to use cat space 2024. I'm just trying to think how I can, let me go to a previous command to save me from typing all those numbers out. And then I'll just update it somewhere here. There we go. So 2024-1219, and then it's 132-138. So it's based off the date and time. So when you're running this on your own system, you'll have a different file name. The great thing is they tell you the file name right there on the screen. So I just got to make sure I have no typos as I type that out. So I'm going to double check it here. 2024-1219. 132.138_certify.txt. Perfect. So like I said, this is going to be a huge file. And when I scroll up, not insanely huge, but I just want to scroll up, show you the contents of the file. Okay, so I'm at the top here. There's me issuing the cat command to display the contents of a text file. There's the name of the text file. So in the contents of the text file, they do show you information about certificate services. So this is important information that I need to collect and document. So the name of the CA is server A, and I'm going to need to know that in my next couple commands, or I'm going to have to supply that, I should say, in my next couple commands. The DNS name for this certificate authority, or CA, is servera.quick24x7.loc. They show some information about the certificate server there. Perfect. And then when I scroll down, they show some permissions. So the owner is administrators, access rights. These are the people that can enroll certificates, so authenticated users, read certificates, manage certificates. Authenticated users can manage certificates and manage the CA. Notice that authenticated users can, which is not normal. So I did basically unsecure the CA so that the demo would work. So what they're doing here now is they're going to show you some vulnerabilities. And this is what's great about this Certify tool, is that it's going to list out different vulnerabilities. The vulnerabilities are actually identified by an ESC number. So each number identifies a different type of vulnerability. So ESC7 means that authenticated users have dangerous permissions, or I shouldn't say specifically authenticated users. Somebody's been granted dangerous permissions and they're identifying what group it is. So if I'm assessing the security of the CA, I would make note of that vulnerability and I would want to lock things down a little bit, right? So I would go and find out, okay, why do authenticated users have the extended capabilities or permissions here? And can we remove those? And those permissions should be removed. ESC8 is the fact that the web enrollment tool is enabled. That's a website that allows people to request certificates. Now, remember we said that a certificate template is a definition for a type of certificate that can be created or issued by the CA. So now what they're going to do is they're going to list out, and this is why the output is so long here, they're going to list out each certificate template and information about each template. So the very first template is called Quick 24/7 User. Again, I'm making a note of that because that's something I'm going to supply in one of my future commands. Okay. And then down below, they'll give you information about that template. So server A, it is an enabled template, which is important. It's used for client authentication. So for clients to authenticate to the network and so on. And they go and show permissions on this template. And again, all the information about each template. So then they show the vulnerabilities. So this is the vulnerability that I want to exploit here is the ESC1 vulnerability. So they're saying, hey, this certificate template is vulnerable to ESC1, which is the fact that domain users and authenticated users can enroll or create a certificate off of that template. And what's important here is I can do that for an administrative type account. So the purpose of this demo is I'm going to request a certificate as Tom, as T. Smith, who's a regular user, and I'm going to request a certificate for the administrator. And then what I'm going to do is I'm going to try to obtain the password hash from that request so that I can then turn around and crack the password of the administrator account. That's our vulnerability here. So they do show each of the templates. I'm not going to go through every one of these templates, but basically that's what you're seeing here in the output. Now, my point is that output is very long. So what I can do is I can shorten that up a little bit by saying, let me use my up arrow key. So certify AD, I want to find information about our certificate services environment, but specifically, I want to find information about certificates that are vulnerable. And then I supply my username and password. And again, I'm just logging in as the T. Smith account and then hit enter. Now, my point here with this example is because I've added the -vulnerable switch, the output is going to be much shorter. So what I'll do here is I'll cat that out, which should be 12.19133.010_certify.txt. Okay, so let me display this text, this information out. And I want you to see here the output is quite a bit smaller. Like I had to scroll up for quite a bit of time there a few minutes ago because I was getting all kinds of information. Now I'm just saying, show me vulnerable information. You do get information about the CA, the certificate authority. So I do need to know what the name of the CA is and what the DNS name is. That'll be important for my next two commands. And then down below here, notice that they do show the vulnerabilities with the CA, and they show the certificate template, the Quick 24/7 user certificate template, and they show its vulnerabilities as well. So it's vulnerable to ESC1, which means that authenticated users can enroll a certificate and supply a subject name. Perfect. So that's the first thing. The find command was used to discover information about certificate services environment and also discover vulnerabilities with that environment. Very cool. So our next command is we're going to request as Tom, which is just a plain old user, we're going to request a certificate for the administrator. Okay, so our next command is certify-AD. This time, instead of the find command, we're going to request a certificate. And we're going to specify our user credentials. Again, I'm going to impersonate the Tom Smith account. So I supply Tom's credentials, which I would have obtained in a previous step within my pen test. And then we're going to go and supply the password. Then we need to specify the name of the CA. And remember, this information was in the find results. So the name of the CA is server A. And I do want to stress, notice that I'm putting the values of like logon names, passwords, server names in quotes. And a big reason for that is there could be special characters used like the $sign. So you want to make sure it's put in single quotes. That way it's treated as just a string value. I'm going to specify the target server is server a.quick24/7.loc. Again, that information was obtained from the find command. Then we specify the template name. So when we request a certificate, we got to specify what template that defines the type of certificate that's being requested. And it's going to be a user certificate based off of the quick 24/7 user template. I'm using this certificate template because it was vulnerable. And then I'm going to specify the UPN, the user principal name of the account that I'm requesting the certificate for. Notice that I'm supplying the account for the administrator email address. And then I specify the IP address of our domain controller of 10.0.0.1. Hit enter, and it says that sending a request for a certificate via RPC communication successfully requested the certificate in our second line there. Perfect. It says that it got the certificate with the UPN of administrator at quick24/7.loc. And then it saved the certificate and the private key for that account to a file called administrator.pfx. So if I do an ls command here, you can see we do have a file called administrator.pfx. Perfect. So that's the administrator's certificate, which contains the administrator's private key. So the last thing I want to do here is extract the authentication information from that certificate, which will contain the password hash for the account. And the goal here is that with CertiPy AD, I can get the password hash, and then you can crack the password hash with your password cracking tools. So my last command, CertiPy-AD. This time we're going to use the authentication command, so the auth. I'm going to specify the pfx file, which is administrator.pfx. And the domain controller's IP address is 10.0.0.1. Hit enter. So it says that it has saved the credential cache for the administrator in administrator.ccache. It's trying to retrieve the NT hash for the administrator. It got the hash for the administrator, and here's the hash value. So the point is we could then turn around and crack that with our password cracking tools, which will then give us the password for the administrator account on the network. So in this demonstration, you saw how to use CertiPy to identify vulnerabilities in Active Directory certificate services and exploit those vulnerabilities. In this demonstration, we'll take a look at how to perform safety checks using a program called Seatbelt. Seatbelt is a program from the GhostPak suite that can be used to perform a number of security checks on a system. For example, you can use it to check the antivirus software status. You can check to see if AppLocker is blocking any applications, and you can use it to view the audit policies on a system. You can also use it to view the auto-run settings on a system and enumerate browser history and bookmarks of that system. These are just a few examples of information about a system that can be extracted using Seatbelt, but keep in mind there's a ton of information that can be retrieved about a system when you use the Seatbelt program. The different types of information are presented in what we call groups. You can think of these groups as categories of information. For example, there's a Chromium group to view web browser data or a user group to view user information. Let's take a look at how to use the Seatbelt program. So the first thing we want to do is we're going to use the Seatbelt program all by itself. When I do that, what's going to happen is it's going to display the help for Seatbelt. And within this help, there's a ton of information. So I'll scroll up to the top here. First thing is you'll see the Seatbelt logo. It kind of shows a seatbelt, the left side kind of connecting to the right side of a seatbelt. And then down below that, they show you a list of available commands where the plus sign means that the command can be executed against a remote system. So just to highlight a few things that we can collect here, you can get information on antivirus software, on the app locker. You can view the ARP table of a system if you wanted to. You can review the audit policies, the auto run section of the system registry. So it can retrieve that and report that to you. The history and the bookmarks that are set up within the browser itself, the DNS cache, information on your .NET versions that are running on the system, So Seatbelt uses WMI to collect a lot of this information about a target system. Your FileZilla history and configuration files, all kinds of different pieces of information, different IE tabs that are open, your favorites, your URLs, last shutdown time, any group policy objects, local GPOs that are being applied to the system, information about the local users and the local groups and what users are inside those groups. You can also retrieve information on things like PowerShell. So your PowerShell commandlets that have been executed in the PowerShell history. You can get a list of printers and processes from that target system. All kinds of stuff here. We also have information about SCCM. So any SCCM settings that exist on the system. Information about services. UAC settings, also Wi-Fi profile settings, all kinds of different types of information, and then information about WSUS as far as WSUS settings go. So all kinds of information. Now what I like is down below that, the help shows you your different commands that you can use to retrieve data from different groupings. So for instance, if you want everything, you can use seatbelt-group equals all, and that'll run all commands. But if you just want to see the user data, then you would go and do seatbelt-group equals users, and they give you an idea what commands would execute if you go and retrieve the user group. So you'll get all the certificate information on the system. You'll get things like most recently run programs or most recently used programs from that system. You'll get the FileZilla information. You'll get the browser information as well. You'll get map drives, IE favorites and tabs, all kinds of information here, right? So that's all the different types of commands that execute if you just fire off the -group equals user. So they give you that breakdown for each of the different groupings. If you do a seatbelt-group equals system, then it'll go and fire off your antivirus commands. You'll get app blocker, the auto runs, you'll get your policy information about that system, all kinds of details, OS information, all kinds of details about the system. If you just want your browser information, right, then you can go with seatbelt-group equals Chromium. And it'll give you your history and your bookmarks and stuff like that. So that's kind of the idea of being able to read the help and also using the groupings. So I'm going to show some of these groupings here. And the first one, let me do a clear screen here. The first one is I'm going to do a seatbelt-group equals all. Now this will take a few minutes to execute because it does retrieve all the information about the system. So we'll just let that run. It'll take a few minutes, and then we'll kind of review some of the output. Okay, so it finished up. Now let's go to the very top. And what I want to do is just highlight some of the information that is displayed here. Okay, so here's me running the command, seatbelt-group equals all. There's our logo. First thing is they give us information about our antivirus software. So it looks like we're using Windows Defender on the system. Down below that, they give us additional information, if they can, about the antivirus software. So it looks like it couldn't retrieve any additional information. And you can see here a little bit of a WMI call that's being executed, but there's no data to retrieve. AppBlocker is the program in Windows that allows you to go and block applications from running. So we can see that AppBlocker is not being used on the system, which means that there is no blacklisting of programs, which is important from a pen tester point of view to be aware of. We can see the ARP table, any addresses that have been resolved recently. We can see per interface, so it looks like we've got some MAC addresses of different IP addresses there for both a 192.168.2 network and a 10 network. So those are live systems on the network, which is important, so I may document that. Underneath that, we have, so this is the auto run section. So they're showing you programs that are set up to run automatically. So it looks like there's only one program on the system that's set to auto run. Again, very important information when assessing the security of a system. We have information about the certificates that exist on the system. So number of different certificates there, certificate thumbprints. Here's where they have our browser history, right? And any bookmarks. So it looks like there's no bookmarks on the system. And then we have some browser history. So you can see here, navigating to, looks like the Hashcat site, that kind of idea. Perfect. So more browser history. Down below that, we have, this is interesting. So it's doing a directory listing of the file system. So it's showing you some different folders and files that exist. So you can kind of navigate through that and get a listing of the different files. So there's some of the programs that I've been using in some of the demos and stuff like that, right? So very interesting. So there's a file listing. There's your .NET versions that are running. All kinds of data or information here that's being retrieved. Environment variables and environment paths. So they'll go through different environment variables here. Those are the paths, but eventually I should see some environment variables. There. There's the environment variables and what their values are set to. So for instance, there's the OS environment variable and it's set to Windows_NT. So again, just an example of the type of information that's being retrieved here. All kinds. Most recently used, Explorer most recently used, so different files that are used on the system. Firefox and IE settings. Installed software on the system. Looks like Nmap has been installed on the system. Wireshark has been installed on the system. So as you can see, lots of information. As I scroll down through this stuff, we'll also see user information. So users and groups. So I'm just kind of scrolling by all the software stuff. Here's some interesting files that exist on the system. Interesting processes that are running. Internet settings. Last time the system was shut down. These are non-empty local groups. So these, and it shows the members. So the administrators group has these accounts inside of it. So that's important from a security assessment point of view. I can see here that there's a gcleric account in the administrators group. So next I would wonder, is that a valid account in that group? Should that account be in there? Great tool, gives us lots of information to review. So again, it shows all the different groups and who's members of those groups, and then shows our user accounts as well. So there's an administrator account, there's a guest account, there's an Alan account, there's a Marcia account, and so on. So all kinds of information collected. Now, the last thing I want to show you here is that if you didn't want to collect all the information, you could call upon a specific grouping. So for instance, I can do seatbelt space -group equals, and let's say I want the browser data only, I can call upon the Chromium and it just shows the browser data. So you're not getting as much output. And again, this could be written to a file as well, which is important. So you could output to a file for reporting purposes. So that's our Chromium information. If I want the user data, I can do seatbelt -group equals user, and that'll just give me the user data. Quite a bit more there for the user data, but we can see our users and we can obtain group information as well, which is all important information. So, and all those groupings are inside the help there, which is very useful. So use the help for seatbelt to guide you in your commands and what commands you want to execute. So in this demonstration, you saw how to perform safety checks on a system using seatbelt.
In this video, you'll learn how to exploit a system using PSExec. PSExec is a common tool used by Windows administrators to run a program on a remote system. For example, an administrator can use PSExec to launch a command prompt on a remote system and perform administrative tasks on that system. The remote nature of PSExec makes it an attractive method to exploit a system and gain full access to that system. PSExec could be used to perform lateral movement on the network as the attacker jumps from system to system. To get started, the first thing that I want to do as an attacker is obtain the administrator's password hash, and then see if I can use that password hash to laterally move from one system to another using PSExec. So to get started, I'm going to exploit the Windows client, which I know I can exploit because I've already exploited that in previous stages of the penetration test. So the first thing that I want to do is go to MSF console to launch Metasploit. Once Metasploit loads here, next thing that I want to do is I want to load the exploit that I want to run to exploit a Windows system. Now in this case, I'm going to exploit a Windows client. Like I said, a client that I know that I've had access to already. So I already know the exploit I want to use. I'm going to use exploit Windows SMB MS17 Eternal Blue. So that's a common exploit against the SMB service on an unpatched Windows system. Now the next thing I want to do is look at the options that need to be configured here. So I'm going to use the show options command. So I can see here that the rhost, which stands for the remote host, which is the IP address of the system that you want to perform the attack against, that parameter or option is required and it currently has no value. So I do have to set that one. The next setting is required as well, which is the port to perform the attack against. And notice that that's already filled in. So the only required setting that's currently not filled in is the rhost option. So I'm going to set the rhost to the IP address of the Windows client. So set rhost to 10.0.0.10. Perfect. Now that I've got everything set, now what I'm going to do is just run the exploit. So this will perform an attack against that system. If it's successful, it'll open up a Meterpreter session where I can then go and perform a bunch of post-exploitation tasks. So notice that I'm in a Meterpreter prompt. That's perfect. So I can type in sysinfo just to display the information about the system. So I can see that it's a Windows 7 client machine that I've exploited. The other cool thing that I want to do here, and very important, is to obtain the password hashes. So I'll use the hash dump command. And then what I can do is I can copy all these password hashes to a text file and then work on trying to crack the passwords for these different user accounts. So these are the user accounts on this Windows system, and it's being retrieved from the SAM database. Now, what I care about for this demonstration is the fact that there is an administrator account, and because most administrators will use the same password on all the administrator accounts, what I want to do is I'm going to copy this password hash here. And I'm going to use that. So I'm going to copy the selection. I'm going to use this in another attack against a different system without actually trying to crack the password. I'm going to pass that hash value into my PSExec exploit. So I'm going to leave that window open. And what I'm going to do is I'm going to jump to another prompt. So I'm in another prompt here, and I'm going to perform a different attack. So I'm going to go back into MSF console, which launches Metasploit. And once in Metasploit here, I can search if I wanted to for exploits against PSExec. And there's a number of different exploits. Now the one that I'm going to use is the exploit number 4, the exploit Windows SMB PSExec. And I'm going to use this to exploit the system and gain access to a different system. In this case, I'm going to use the PSExec exploit to gain access to a Windows server. So once I've gone and searched for PSExec exploits, now what I'm going to do is I'm going to use exploit Windows SMB, and I'm just typing in the PSExec. I'm just typing in the path to the exploit I want to use. That's displayed up top here in my search results. So again, that number 4 was exploit Windows SMB PSExec. Now, again, you want to do your show options just to see what options need to be set here. So notice that we have to set the rhost option, which is the remote host of the system that we want to perform the attack on. Perfect. So I'm going to do a set rhost to 10.0.0.1. And then I'm going to set my local host address to 10.0.0.7, which it was actually set to anyway, but that's okay. Now, two other options that I want to set here is notice that there is an opportunity to supply a username and a password. So this is the SMB, is the core protocol that Microsoft uses for file sharing. So I'm going to supply my Windows username of administrator, and instead of the password, I'm going to pass in that hash that I obtained through exploiting a totally different Windows system on the network and see if we can perform some lateral movement. So I'm going to set my SMB user to administrator, and then I'm going to set the SMB pass to the password hash. So I'm going to paste my password hash in here, which I thought was in my paste. Let me switch back to the other window. And let's grab that password hash right here. Copy selection. So what I'm doing here is I'm kind of betting on the fact that all of the Windows systems on this network are probably using the same password for the administrative account. That may not be true, but we'll find out. So I paste in the password hash as the password for this exploit. Now I'm going to do my show options one more time just to take a quick look. So the remote system is 10.0.0.1, which is a server that I have running, a Windows server. We have the SMB password. Notice that I didn't have to spend the time cracking the password. I'm passing in the password hash. And then the SMB username is administrator. Perfect. So now we're going to exploit this system. And if it's successful, again, I'll be thrown into a Meterpreter session, and it's successful. So I now have access to that 10.0.0.1 system. So if I do a sysinfo, I can see here that it's a machine called Server A. It's a Windows 2016 or above Windows server in the domain quick 24/7. And bottom line is I can go and execute any number of commands here. So if I use a question mark, I have all the different Meterpreter commands. I could do a hash dump on this system to retrieve the Windows account database if I wanted to. I could clear the event logs. I could go and create new user accounts on the system if I wanted to. So I can perform any number of commands on the system. So just as an example here, let me go into shell. That'll take me into the command prompt of the target system. And if I do a who am I can see that I'm logged in as the system account. So I could go and create a new user account. So net user hacker with my password /add. Oh, the account already exists, so I must have already done that. So let me, I don't know if my up arrow will work because I'm in a shell. So net user course 12 hacker. That account won't exist. Perfect. Okay, so it created the account called course12_hacker with the password of capital PA $$W0RD. So my point is I can go and perform anything, make any change. I can create some hidden user accounts on the system if I wanted to. I have full control of this system. So in this demonstration, you saw how to exploit a system using PSExec. In this demonstration, you'll learn how to use PowerShell in your attacks. Here's the scenario. We know of a vulnerability on a client system within the network. We're going to exploit that vulnerability to obtain the password for the administrator account. We then use that password to connect to a more valuable system on the network, like a server or a domain controller. At any time, we can jump into a PowerShell session and use our PowerShell knowledge to manipulate the target system. Let's get started by performing the exploit on the client system.
the first thing I'm going to do is I'm going to go into MSF console. When I type MSF console, it loads the Metasploit program, and now from here I'm going to select my exploit. So because I've already done a vulnerability scan on the system, I know that the system is vulnerable to an SMB attack, the MS17010 Eternal Blue exploit. Once I've gone and selected the exploit, then I want to set my target system, which is with the rhost value. So I'm going to set rhost to 10.0.0.10 and then run the exploit. Now I do find sometimes that the Metasploit product is a little buggy. If it doesn't work, what I'm going to do is I'm going to just run exploit a second time. So just a heads up if you find it doesn't work. Now in this case it did work. You can see I've got win at the bottom there. And notice that my prompt has changed. I'm now in a Meterpreter session. And within this Meterpreter session, I can perform a number of post-exploitation tasks, such as I want to go and try to retrieve some credentials from the system. But note that I could also go into a PowerShell prompt from here if I wanted to manipulate this system with PowerShell. Now in my demo, I'm not going to do that. What I want to do is let's see if we can grab some credentials and then use those credentials to move laterally across the network. So I'm going to load the Mimikatz module. And from here, I can use the question mark. Notice that at the bottom of my screen, it says success. So it was successful in loading the module. I'm going to do a question mark and it shows me all my Mimikatz commands. So from here, I want to go and retrieve some credentials. So I'm going to use the creds_msv command. And notice that I can see there's two credentials on the system, one for the administrator and one for user one. And it shows the password hashes there, which is great. I can go in and copy those password hashes and then use a password cracking tool if I wanted to crack the password hashes. But there's another command in Mimikatz that I can use here, creds_Kerberos. And this command will actually show you the passwords in plain text. So I can see the administrator has a password of capital PA $$W0RD, while the user one account has a password of host. So what I'm going to do is I'm going to make a note of that password for the administrator account, and now I'm going to see if I can exploit a server on the network using that administrator's password. Because a lot of times, administrators will use the same password on all their systems. So let's go and open a new prompt. And with this new prompt, what we're going to do is perform a different exploit against a domain controller. So first thing I'm going to do is go into MSF console again. That way I've got Metasploit running in this window. And this time I'm going to use a different exploit. I'm going to use psexec, which is used to execute commands against remote targets. So I'm going to use exploit Windows psexec. Use exploit Windows SMB psexec is the module. There we go, that looks better. Notice that it's loaded, or it's defaulting to the payload of Windows Meterpreter reverse TCP. I do want to use the 64-bit version of that module. So I'm going to set my payload to Windows x64 Meterpreter reverse TCP. Perfect. Now from here, I've got a couple options that I want to set. I can use my show options to view the settings or the options that need to be set. I do need to set the rhost, the remote host of the system that I want to perform the attack on. And in this case, it's going to be my domain controller, which has the IP address of 10.0.0.1. Then I also want to make sure that I set the username and password to use to make that remote connection. So I'm going to use the username of administrator and the password that we obtained from that other system, hoping that the password is the same for all the admin accounts across the network. Now that may not be the case, but we want to try it to see. So I'm going to set my first option, which is set our host to 10.0.0.1. Then I'm going to set my SMB user to administrator. I'm going to set the SMB pass to the password. And then I'm going to exploit the system. Notice that when I run the exploit, again, I'm in a Meterpreter session.
which I love because, again, there's a number of post-exploitation commands that I can use there. In this demonstration, what I want to show you is that from this Meterpreter session, if you wanted to, you could jump into PowerShell, or you could execute PowerShell commands. What you need to do is you need to load the PowerShell module. And that way, if you're somebody that's comfortable with PowerShell, you can then start using all your Windows PowerShell commands against that target system. So I'm going to use the load PowerShell command, and it loads the extension PowerShell, successful. Now I can use a question mark to see the PowerShell commands that I can execute. So a couple commands that are here. The very first one is the PowerShell _execute. The PowerShell _execute command will allow you to execute any PowerShell command against that target system. So that'll be the first example that I use, is I'll show you how to execute PowerShell commands using the PowerShell execute command. But then the other thing that we could do if we wanted to is we could do a PowerShell import to execute a PowerShell script file. So again, I'll show you how to do that. You can also remove a session if you wanted to, if you had a PowerShell session. The final command I want to show you as well, and this is how to go into an interactive PowerShell prompt. Okay, so let's start with just executing individual commands. To execute an individual command, I can use the PowerShell _execute Meterpreter command because I've loaded the PowerShell module. And then what you do is in single quotes, you put in your actual PowerShell command. So I'll fire off a few examples here, but bottom line is anything that's a PowerShell command, I can run now within the single quotes. So I'll do get service name SP star. So what I want to do here is I want to get a list of services running on the system. Because I don't want the big list, what I'm going to do is I'm going to filter it out and say, just show me services that start with the letters SP. So I hit enter, and it shows that there's two services that start with SP in the name. There's the spooler service and the software protection service. Notice that the spooler service is currently running. So what I could do if I wanted to is I could do a PowerShell _execute, and I could do a stop dash service. The name of the service that I want to stop is the spooler service. And notice that it says it executed that successfully. Now what I'll do is I'll use my get command again to look at the results. And notice that when I use the get command again, and I use my up arrow to go to my previous commands there, notice that the spooler service is now stopped. So what that's proven to you is that not only can I execute PowerShell commands, but I can manipulate the target system. I just stopped a service on that system. And again, using my knowledge of PowerShell commands. So bottom line is if there's any PowerShell commands, you could execute those here. Another example, if I wanted to browse through the file system, for instance, I could go and do a PowerShell execute and just a dir c:\\. So if I just want to start taking a look at files that exist on the hard drive of this target system. Now remember, this is a server, so it does have a bunch of server folders there. It looks like it's a WSUS server, that kind of idea. Perfect. Now a couple other commands. There's the PowerShell execute. This target system is a domain controller, so if I wanted to, I could get a list of the Active Directory user accounts. So I can use my get AD user, filter star, which means give me all user accounts, and then format the results in a table and just give me the name of the user accounts is what that does. So when I hit enter here, now I've retrieved a list of all the usernames. Now, I may also want the SAM account name. I think is the property, SAM account name. Yes. So the SAM account name is there as well, which is the logon name. So notice that the Tom Smith account, for instance, T Smith is the SAM account name. So that's the logon name, and G Clark as well. Perfect. So my point is, not only can I go and kind of just retrieve information about that system, but because that system is a domain controller, I can now work with Active Directory accounts, which is kind of crazy. And just one last little example with Active Directory is I could do a PowerShell execute and do a new AD user command, and I'll create a new user called Horse12 PowerShell hacker. So new AD user, Horse12 PowerShell hacker.
and it looks like it completed successfully. It doesn't like the characters that I used, it looks like, in the name. So it might be too long for a name, but let me just try PowerShell Hacker. Okay, that worked. Perfect. So my point here is any PowerShell commandlets that you're familiar with, once you load that PowerShell module, you can now execute individual commands with the PowerShell_execute command. But the cool thing is that's not all. What you can also do is you can go and execute scripts. So I'm going to do a PowerShell_import command. And with the PowerShell import command, you can reference a script file. So I've got a script file in my student directory called course12_script.ps1. Now this script is very simple. I think all it does is do a directory of the C drive. But the script could have any PowerShell commands in it. And the point is as a pen tester, you can prepare your script. Then when you exploit target system, load the PowerShell module, and then go and execute your script with the PowerShell_import. So notice that it did give me a dir, so it shows me what's contained on the hard drive of that system. That's only because that's the command I put into the script. And again, I could have put anything into the script itself, but I just wanted you to visually see that when I call the import command, it does execute the script. So you prepare the script and you can execute it. And what's cool about this is that script resides on my pen testing system, but yet it executes against the target because I've loaded that PowerShell module after exploiting that target system. That's very cool. Now, the last thing I wanted to show you here is we can go and open an interactive prompt if we wanted to by using the PowerShell_shell command. And notice that I'm out of the interpreter prompt now, and I'm in a PowerShell prompt. And from here, you can use any of your PowerShell commands. So again, I'll use that get service name sp star. But notice that I don't have to have the PowerShell_execute in front of everything because I'm in a PowerShell prompt, which is nice. Now I can start that service if I wanted to. So start service name spooler. No results in a PowerShell prompt means it was successful. So I'll use my up arrow to go to my, I guess I can't use my up arrow in this prompt. So I'll do the get service name sp star again. And you can see that the spooler service is now running. So again, I've manipulated the system, and in this case, I've started a service that I stopped earlier. And again, I could go and use that get AD user, filter star, and let's pipe that to format table and give me the name and the SAM account name. So you can go into an interactive prompt and then just type your different commands in to manipulate the system. So in this demonstration, you saw how to use PowerShell as part of your attack on target systems. In this demonstration, you'll learn how to use Evil-WinRM to remotely exploit a system. The Windows Remote Management Service, also known as WinRM, is a feature of Windows that allows administrators to remotely connect to a system and change its configuration settings. It saves the administrator from having to be physically at a computer to change its configuration. Evil-WinRM is a tool used by penetration testers that is used to exploit that service to gain access to a target system and extract info from the system or make malicious changes to that target system. Let's first look for target systems that have the WinRM service running. What we can do is we can use Nmap to scan for port 5985. So I'm going to do Nmap-st-p for port, and it's going to be the 5985 port. And then we can specify which systems we want to scan. In this case, I'm just going to scan the actual system that is my target system, 10.0.0.1. But keep in mind, you could do the whole network by specifying the subnet ID if you wanted to. It's just that's going to take a lot more time. So in my case, I'm just going to pick the system that I know does have that service running.
So I hit enter, it does the port scan, and it does show that port 5985 is open on the target system. Perfect. So now I know 10.0.0.1 is a valid target. Again, in real world, I would have scanned the entire network. It would have took a few minutes, but then you'd have a list of systems that have that port open. The next thing that I'm going to do is I'm going to use the Evil-WinRM command all by itself. And what that will do is that'll give you a list of switches. So if you want to see the help on the command itself, just type the command by itself. So Evil-WinRM, it comes up with the help on that command and shows me a list of the different switches that are supported. And we'll take a look at some of these switches as I continue on through the demo. So for instance, -I is how we can specify the IP address of the target system, whereas -u is how you specify a username, and -p is how you specify the password. So next thing I want to do is use the Evil-WinRM command to make a connection to the target system. So I'm going to do an Evil-WinRM space -I 10.0.0.1 is the IP address of the target system, -u, and then the username I want to authenticate as, and -p with the password. So this username and password you would have obtained through a credential attack earlier on. So I'm going to hit enter and see if it connects to the target system. And it does look like it was successful. Notice that my prompt has changed. I was in a Kali Linux prompt here, typing the Evil-WinRM command in. But notice that after the connection was established, looks like I'm in the PowerShell prompt of the target system. And at this point, I can start using any number of commands on that system, right? So for example, I'll use the whoami command. And with the whoami command, it reports back who I've authenticated as. So it looks like I'm logged in as quick24x7 is the domain name / the administrator account. If I wanted to, I could then go and fire off any Windows commands. For instance, I could use the net user command to display a list of user accounts that exist on that system. Notice there's a T Smith account, a G Clark account. It looks like there's an Allen account as well, and a Marcia account. So I can see the user accounts that do exist. And better than that, if I wanted to, I could start creating accounts, right? So I could do a net user. I'm going to specify course 12_hacker is the user account. And I'll specify the password, capital PA $W0RD1234/add. So it's created that account successfully. So my point is, now I've exploited the system and I'm thrown in a command prompt here, I can use any command prompt commands that I want. If I use the net user command again to view the list of accounts, I can see my course 12 hacker over in that third column there at the top. Perfect. So not only can I use Windows commands, but because I'm in a PowerShell prompt, I can also use PowerShell commands. So for instance, I can use the get AD user -filter star, and then I'm going to say format table, give me the name and the SAM account name. And notice that I've used a PowerShell command to retrieve the user account list as well. So my point is you can use any of the commands from that target system now that I'm in a command prompt. There are other specific Evil-WinRM commands that you can use as well. If I type in the word menu, it'll bring up the Evil-WinRM menu system. And notice that we do have a list of commands here. There's a DLL loader, there's a donut loader, there's an invoke binary, there's a bypass for MSI, there's a services command, an upload command, a download command, a menu command, and an exit command. So let's start at the very top here and just give you a quick description of each of these commands. So DLL loader is used to load a DLL into memory to make the functions that are in that DLL available to the attacker. Donut loader can be used to load code into memory and then execute that code. Invoke binary is used to run an executable file on the target from a path specified with the -e switch of the Evil-WinRM command itself. The bypass for MSI command is very interesting because it's used to disable the anti-malware service on the target system so that you can run malicious scripts or executables on that target system. The services command will list the services on the target system. The upload command is used to upload a file to the target system. The download command is used to download a file from the target system. And then the menu command is used to display this menu. And then finally, the exit command will get you out of the Evil-WinRM prompt, which you can see I'm at the bottom of the screen there in the red. Perfect. So let's take a look at downloading some confidential data from the target system to our Kali Linux system. So the idea here is what you could do is you could use your commands like ls to get a listing, or dir to get a listing of the different files that exist on the system. Now in this case, I happen to be in the documents folder of the administrator account on that system. And notice that there's a file there called customer_list.txt. So I'm thinking, okay, that looks really interesting. What I want to use is use the Evil-WinRM download command to download that file. So I'm going to use the download space and then the name of the file, customer_list.txt. And then I'm going to specify that I want to download it to the /home/student/downloads directory /customer_list.txt. So I specify the file that I want to download and where I want to download it to on my Kali Linux system. So I hit enter. It says that it downloaded the file successfully. It's a very small file, so you saw a bit of a progress bar there. Had it been a larger file, it would have taken quite a bit longer, right? But it's a very small text file. So now that it's downloaded, what I'm going to do is I'm going to exit out of my Evil-WinRM, and let's print out our working directory. Notice that I'm in the home student. I want to go to my home student downloads. So I'm going to do a cd/home/student/downloads. And I'm going to do an ls, and I can see there's a file there called customer_list.txt. Now, if I want to display the contents of that file, and keep in mind I'm on my pen testing system now with a copy of that file, I'm just going to use the cat command to display the contents, and notice that I can see, the information that's contained inside that sensitive file. So in this demonstration, you saw how to use Evil-WinRM to exploit a system and extract information from that system. In this demonstration, we'll take a look at how to perform a living off the LAN attack. Living off the LAN, or what's known as LOL bins within your Pentest Plus certification and exam objectives, living off the LAN means that once we exploit a system, what we're going to do is we're going to use commands that are available from that system to continue our attack. The benefit of living off the LAN, or using programs that come with your operating system to continue your attack, is malware protection software will typically go and identify and prevent you from running your malicious tools or your malicious scripts and stuff. So as an attacker, it's good to kind of have a set of operating system commands, or commands that come with the platform that you've exploited, to continue that attack. So let's get started. First thing I need to do is I'm going to exploit the system. And I'm going to exploit the system by our target system by going into MSF console, the Metasploit tool. And with Metasploit, what I'm going to do is I'm going to use the exploit against Windows SMB service. And it's the MS17 010 Eternal Blue exploit. Now with this exploit, what I'm going to do is set my rhost value to the victim system, or my target system, so 10.0.0.10, and then I'm just going to run the exploit. Looks good. It has exploited the system, and notice that I'm in the meterpreter prompt, and within this prompt, I can execute any number of meterpreter commands, which is awesome. Meterpreter has a number of post-exploitation commands that you can execute. So things like trying to retrieve the SAM account database, the password hashes, that kind of idea. Now that we've exploited the system, now what I want to do is go into the shell or a command prompt of that system. So if I type the shell command, which is a Metasploit command, it'll jump me into the command prompt of the platform that's been targeted. So in this case, I've exploited a Windows machine, and notice that I'm in the Windows folder there. So I'm within the Windows command prompt at this point, and now I can use any number of Windows commands. The first thing I want to check, though, is what my credentials are, because if you're going to live off the land, you're going to execute commands that come with the operating system, and if those commands are going to make changes to the system, you will need to have admin access. And in this example, notice that I am authenticated as the system, which is the operating system. And the system account has admin capabilities to that system, so I'm good to go. And now you can fire off any commands that you want. So a lot of times as a pen tester, once you've exploited a system, what you want to do is plant a backdoor. So the cool thing is you can use your net user command. And again, you could use any commands, but in this example, I just want to take a look at the user accounts that exist on the target system. And maybe what I want to do is I want to create a brand new account that I'll use to authenticate to the system at a later time. And the reason why that's important is because the system may get patched and my exploit may not work, down the road. So planting a backdoor account is very important. And knowing my Windows commands and how to view the list of user accounts and then also create user accounts is what I want to do here. So notice that I do have user accounts here, or it looks like the target system has user accounts of user 1, user 2, user 3, user 4, user 5, user 6. So what I'm thinking is, as an attacker or a pen tester, what I want to do is create an account that kind of stays hidden within that naming convention that's being used. So I'm thinking I'll build a user 7 account. So I do a net user. I'm going to call this account user 7, set the password for that account, and I'm going to add the account. So again, the lesson here is I know Windows commands. So as a pen tester, once I exploit the system, I can use those Windows commands. There's nothing wrong with executing these commands, and any malware protection software that's running on that system won't be triggered by these commands because they're just regular Windows commands. Now that I've added that user account, now what I want to do is put that user account into the administrators group. So user 7/add. So net local group, the name of the group is administrators. The name of the user I want to put in that administrators group is user 7/add. And notice that it comes back and it tells me that the command was completed successfully. So not only did I create a user account here, but I've now planted that user account in the administrators group. So if I authenticate to the system as user 7 at any point in time, I am an administrator of that system. We can do a number of other things as well. So just to kind of show you, I can use the Windows operating system commands to do like a ping sweep. Maybe I want to discover other systems on the target network. So I can do the ipconfig command to display my IP address. So it's 10.0.0.10, and my subnet mask is 255.0.0.0, which means I'm on the 10 network. So if I wanted to, I can use a Windows for loop. So I can do for%i in, and then what I'm going to do is I'm going to supply random numbers. I'm actually going to pick numbers I know that are being used on my network. So 1 is used on my network, 2 is not, 6 is, 7 is, and 10 is. But what I'm going to do is I'm going to go and execute a ping command of 10.0.0. And then I'm going to put %i. So basically what I want to do is I want to use the Windows ping command, but I'm going to embed that in a for loop so that it executes the ping command multiple times, each time using a different number. So the first time, %i will be 1, which means this will be 1. So the first time the ping command executes, it'll be 10.0.0.1, that's ping. Then the second time, it'll be ping space 10.0.0. %i will be the 2 second time. And then third time, %i will be 6, so it'll be 10.0.0.6. So the point is I'm using just a Windows for loop to do a ping sweep on this network. And now I'm not going to ping a whole bunch of addresses, just due to time constraints, but I'll do a couple here. So you can see it's trying to ping 10.0.0.1 and it was successful. Looks like 10.0.0.2 is unreachable, so that system's not up and running. So as a pen tester, I'm kind of making notes here of what systems are up and running and which systems are not. And I record those, and those could be potential victim systems as well. So the point is, I wanted to show you that, hey, you can do a little bit of scripting within this Windows command prompt, which is kind of cool. Now, the other thing that I want to do is, and again, these are all just commands that come with the operating system, is to show you that you can do all your file management stuff. Let's do cd / and then do a dir, and I can see, oh, there's a data directory. So I can browse through the file system of the target system. I do a dir inside of the data directory, and I can see, oh, there's a file called logins.txt. Well, let me type out the content of logins.txt, right? So I can see, oh, they've recorded some websites and what their passwords are for those websites. So again, as a pen tester, I'm collecting that information. In this demonstration, you learned about living off the LAN attacks, which involves using programs or commands that come with the target operating system.
In this video, we're going to look at how we can use the TruffleHog tool to explore source code in repositories and look for secrets and other valuable information that could be helpful to us when performing web application attacks or other penetration tests. TruffleHog is a tool specifically designed to allow you to scan your own repositories to look for any kind of secrets that could pose a security risk for your product, which can be extremely helpful when doing internal penetration tests. TruffleHog works by looking at the version history of a code repository, analyzing the resources and permissions associated with it, and then looking through all of this data to find these secrets. TruffleHog also provides integrations and hooks to prevent secrets from being put into your repository in the first place, as well as providing you with remediation around tracking your different key types and helping you get rid of anything that's present in your repository. So to get started, we first need to install TruffleHog. In this case, we're going to be doing the installation on a Windows system with Docker installed. And rather than installing the tool directly on our system, we're just going to be running it directly from a Docker container. But there are distributions available for you, whether you're on Linux, Windows, or Mac OS. So to get started with TruffleHog, we're going to run the command seen on the screen here, which is docker run -rm-it-v, and then in double quotes, $curly brace pwd closing curly brace :/pwd truffle security /trufflehog github --repo https://github.com/trufflesecurity/testkeys, and then hit enter. And now we can see the output from this command. And what this command has done is scanned the GitHub repository that we pointed it to, which in this case was the Truffle Security Test Keys repository, and returned to us any secrets which it found. And if we scroll down to where the green text starts, we can see the results of what it found. Each green checkmark denotes a new entry into the secrets that were found during the scan. So looking at the first green checkmark block, we can see that it found a verified result. The detector type was AWS or Amazon Web Services with a plain decoder. It gives us the raw result, and it tells us the resource type is an access key. We then have an account number associated with it, and then we have a true Boolean value beside isCanary, and we have more description below that with the message, this is an AWS Canary token generated at canarytokens.org. And then we have information about the ARN, as well as the commit number where this secret was found, any emails associated with it. It is a keys file. It was found on line 4, and then it gives us a direct link to that repository location. So we can click on that link, and it takes us directly to that file. And here we can see the AWS access key ID located in the testkeys/keys file. Returning to our terminal, we can scroll through and see that we get similar information in multiple different blocks, showing us all the different locations where secrets were found. At the end of the green text, we see that we have found an unverified result. An unverified result means that TruffleHog has not confirmed that this key can be used live for SSH or SSL. But it does still mean that a private key was found, and in the raw result we can see the private key itself. Once again, we have the information like commit number, email, where the file was found, and a direct link to that file. And then at the bottom, we have a summary output which can be useful for reporting purposes, telling us what the scan found. Some relevant bits of information to us would be the verified secrets field, telling us it found 3 verified secrets, and the unverified secrets field, telling us it found 1 unverified secret. Now this scan was done on a GitHub repo, but we can scan other things like Amazon S3 buckets, Docker images, GitLab, various continuous integration tools, and more. If we return to the command we originally used, which was trufflesecurity/trufflehog GitHub, which is using the GitHub command to the trufflehog tool, we could pass --help to that command to see more information about what we can provide to that subcommand. And in the output, we can see the information about the GitHub command now, which tells us this finds credentials in GitHub repositories. And then we have a long list of the flags that we can set when performing our scan. So this can be very useful when performing custom scans or tuning your scans to your use case. And for every subcommand, we can perform that same help flag to get more information. So for example, I could also get the help around Git, and this tells us that this command finds credentials in Git repositories, and it has its own associated flags. So this can be a good way of figuring out how to use a certain subcommand in trufflehog. So as we've seen, trufflehog can be a powerful tool for scanning through your repositories and seeing what kind of secrets you might have accidentally exposed, and give you a good way to remediate and remove those secrets from being exposed to the public. This can be a great tool when performing web application penetration tests, and in terms of getting up and running with trufflehog, the tool takes a minimal amount of time to get set up and start running actual scans on your repositories. In this video, we're going to look at how we can perform penetration tests on web applications using Burp Suite. To get started, you'll first need to download and install Burp Suite on your system. To do that, you can open up a web browser and navigate to the URL seen at the top of my screen, which is https://portswigger.net. On the main page, you can click on the Products tab and then download the corresponding edition of Burp Suite that you want to use. In this case, we're going to be working with the Burp Suite Community Edition. Once you have Burp Suite downloaded and installed, you can launch Burp Suite and you'll be met with this welcome screen. For this demonstration, we're going to create a temporary project in memory, and because we're using the Community Edition, this is the only option available to us. So on this main screen, we're going to click Next. Then we can set a custom configuration if we want to, but in this case, we're going to use the Burp defaults, and then click Start Burp. So now we have a Burp Suite project started, and we're ready to start working. To get started, we're going to click on the Proxy tab, and then on the Proxy tab, we're going to click on Open Browser, which will open up the Burp Suite browser for us. Returning back to the Burp Suite tool, we also want to make sure we click Intercept Off and turn that to Intercept On. Now we're ready to start intercepting requests that happen via the Burp Suite browser. If I return to the Burp Suite browser, we can see what kind of requests we get when we start navigating to the web application that we want to test. In this case, I have a vulnerable web application running on my local host at a port of 3000, and we can see what that looks like when I type in localhost:3000 into my URL bar in the Burp Suite browser. Now the first thing to notice is that the page actually isn't loading, and if we return to the Burp Suite application, we'll see why that is. Here we can see that because intercept is on, we've actually stopped the request from going through until we decide to forward that request on to its destination. And we can see that that request is an HTTP request going to localhost on port 3000. If we go down to the bottom, we can get more detailed information about the request. And on the right, we have an inspector that can give us the request attributes, request query parameters, request body parameters, request cookies, and request headers. For now, let's click the down arrow on the forward button and select Forward All. If we return to the Burp Suite browser, we can see that the page has now started to load. Going back to the Burp Suite application, we can see that we once again have the option to forward all of these requests that we've intercepted. So for now, to see the full page load, we can turn Intercept off and return to our browser and see that now the page has loaded because our intercept has stopped blocking the packets. And this is what the vulnerable web application that I'm using looks like, which is called OWASP Juice Shop. And OWASP provides this free vulnerable web application that you can set up on your own machine as well. Now let's get started with penetration testing on this web application using Burp Suite. The first attack we're going to perform is to intercept some credentials when a user registers in this web application. To do that, I'm going to click on the account button and then click on Login, and this takes us to a standard account registration page. At the bottom, I'm going to click Not Yet a Customer, and here we're going to fill out a user registration form. And we're going to go ahead and fill in some values here. So the email will be test@test.com. I'm going to put in a password for the account. And then I'm going to answer a security question of your eldest sibling's middle name with test. And now I can click Register. We're not going to save that password in the browser. And now it tells me that my registration is complete. If I go back to the Burp Suite application and I click on the HTTP History tab and I scroll down to the bottom, I can see all of the packets that I've intercepted so far. So here we can start to go through and see some interesting information. If I look at this post of API security answers, by clicking on it, I can see that I can inspect the request and response information for that particular HTTP post. Looking at the request, if I scroll down to the bottom, I can see that the user ID of 22 had an answer of test to the security question ID of 1. So one thing that we can see right away is that this web application is not encrypting anything by default, and we're able to see this information in plain text. If I click on the /API/users endpoint and examine that request, by scrolling down to the bottom, I can see the email that was used, along with the password that was input for that account. And I can see the security questions as well here. So I get all the information I need to hack and access this account just by watching the requests coming to and from this web application. So by watching the requests coming to and from this application, we can perform some penetration testing just by looking at these requests. Now, in addition to having harvested the credentials of an account, we've also seen how the application creates an account. So let's try and use that to our advantage. If we right-click on this post to API/users, we can click on Send to Repeater, and then click on the Repeater tab at the top of the application. This will allow us to modify the packet or the request and send a custom request to the API and see what kind of response we get. So in the request window, I'm going to scroll down to the body of the request and change some of the values. In this case, my email is now going to be test1@test.com. The password will be password2!! We'll leave the security questions the same, but we're also going to see if we can give ourselves a different role. So I'm going to pass a common field to the body, which is the role field, and I'm going to give it a value of admin. And then I'm going to click Send. And in the response, I can see a status of success. And it looks like I have been able to create an admin level account in this application. So in this way, we've exploited a vulnerability within the application that has allowed us to get elevated privileges for an account. This is one of the best ways that we can use Burp Suite to perform penetration tests, by taking requests and modifying them to see how the server responds to those modified requests. We can get a lot of information and manipulate applications to our need. This makes Burp Suite a very powerful tool in any application tester's tool belt. In this video, we're going to look at how we can set up and use the Z Attack Proxy or ZAP tool. To get started, we first need to download ZAP. To do that, open up a web browser and navigate to the URL seen at the top of my screen, which is www.zapproxy.org. On the main page, click on the download button in the top right, and then select the appropriate download for your platform. In this case, we're working on a Windows system, so I'm going to click Download beside the Windows 64 installer, but there's also distributions for Linux and Mac OS. Once the download has finished, I'm going to run the installer by clicking on the exe that we downloaded, and this will start the installation wizard for Z Attack Proxy. On the first page, click Next. Then, read through the license agreement, and if you accept it, click I accept the agreement. Next, select the type of installation that you want to perform. In this case, we're going to go with a standard installation. Then, review your settings and click Install. Now ZAP Attack Proxy has completed installation, so we can click on Finish. Then we can start the ZAP application, and this is what it will look like when you first boot it up. In this main window, where it says Welcome to ZAP, this is our workspace window. This is where we're going to see things like requests, responses, and scripts, as well as give us the ability to edit those things. On the left, we can see that we have a tree window, which will show us our directory trees that we're working in. And then at the bottom, we have an information window. This is where we're going to be seeing the details of the various tools and scripts that we run. Beneath that information window, we also have a footer, which has various alerts and other results from the tools that we're going to be running. Now, on this Windows system, I have a vulnerable web application running on port 3000 on my local host, and that's what we're going to be looking at through ZAP Attack Proxy in this demonstration. To get started, we're going to click on the Quick Start button, which should be the default that is open when you start the application. In this window, we want to click on the Automated Scan button. Here, we can type in the URL that we want to attack with ZAP Attack Proxy. So in this case, I'm going to type in localhost 3000. Then we'll leave the rest as defaults and click on Attack. And after some time, your scan will complete, and we can verify that by clicking through the tabs above the information window and see 100% on our spider and our active scan. So now that our scan has completed and our attack has completed, we can start to see the results. In our tree window on the left, we can expand the Sites tab and see all of the sites that have been enumerated by our scan. And this can give us some good information about the layout of the web application itself. Next, if we look down at the footer, we can see that the scan has noticed some alerts. So if we click on the Alerts button at the top of the information window, we can see the alerts that were potentially found. So we have two alerts. One is a high-risk alert telling us cloud metadata potentially exposed, and the other is an informational alert about user agent fuzzer. If we click on the Output tab, we can see all of the output that the tool has given us during the scan. And then, going back to the Spider tab, we can see all of the various requests that were sent to and from the application. And within these requests, we can navigate to the URLs tab, which shows us the URL that the request was sent to, what nodes were added as a result of the method, and the messages that were received by those requests. This gives us detailed information about the request timestamp, the method, the URL, the response code, and various other HTTP-related information. Moving on to the Active Scan tab, this is where the ZAP Attack Proxy tries to actually exploit the web application itself. And these are the requests or sent messages that were sent to the application in order to try to attempt that. If we return back to the original Quick Start menu, we can click on Manual Explorer as well. With Manual Explorer, we can launch a specific browser to explore the application that we've selected. And when I click on Launch Browser, I'm brought to the vulnerable web application that's running on my local system. And I can start navigating around the website as normal to either try to find my own vulnerabilities or verify anything that the active scan had found. If we go back to the Manual Explorer tab, we could also check on Enable HUD. With that checked, we're going to launch the browser again, and we can see that this gives us the heads-up display for ZAP Attack Proxy. It gives you the option for tutorial, or you can continue to your target. Here on the left and the right, we can see the various operations and information from the ZAP Attack Proxy HUD. So on the right side of the HUD, I could click on Start Spider, and then it tells me localhost 3000 is not in scope, so I'm going to add localhost 3000 to the scope and start spidering it. Now on the right, I can see that the spider is running, and it says 0%, and then when it completes, I'll have the same information I got from the spider when I did the automated scan. So this is how we can set up and start using the ZAP Attack Proxy to perform penetration tests on our web applications. In this video, we're going to look at how we can use the Postman tool to perform API testing and vulnerability exploration and exploitation. Postman is a very popular tool when it comes to testing APIs. It gives you the ability to send API requests, inspect the responses from the API, and look at any potential issues that might be present in the API. By being able to programmatically send and receive requests to an API, we can automate and inspect all of the functionality of that API, and additionally, we can start to manipulate that behavior of the API to see if there are any vulnerabilities present or weaknesses in its implementation. So let's get going and see how this works in Postman. The first thing we need to do is have an API that we want to test, and we're going to put the address to that API where it says enter URL or paste text. In this case, I have an API running on the local host at port 5000. So my URL to the API that we're going to be testing today is http://127.0.0.1:5000. This is the base URL that points to the API, and all of the different API routes are going to be appended onto this URL as we go. So let's append one of those API routes now, and we're going to start with the /login route. So to the end of the base URL, we type /login. And now we're going to be hitting the login endpoint for this API. Next, we need to set what kind of method we're going to be using for our API request. If we click the drop-down list next to post, we can see that we have many different options available to us in terms of HTTP methods. In this case, we're going to be leaving it as post to the login endpoint. Now, we technically have enough information to start sending a request. So we can see what this API will do if we send just this request with no body by clicking on the send button. And at the bottom window of the screen, we can see the output or the result from our request. And it tells us that there's a 500 internal server error. And we have a bad request in that we sent a request that the server could not understand. And then we have a key error telling us we're missing a username key. So this is telling me that I'm missing some key fields in this request. So we can start to build out this request now by clicking on the body tab and then clicking on form data, and we can pass specific keys. And we know that we need to pass a username key. So I'm going to put in username as the key value here. And I'll put in a value of admin. And then likely, I also need to have a password key. So I'm going to type in another key for password. And we don't know the password, so let's type in test. Now we've added form data to our request, passing along the keys that the endpoint is expecting. So once again, I'm going to click send, and now I can see at the bottom in the response window, I get a message saying login failed. And we kind of expected that because we didn't know the password value, we just put in an arbitrary value. But let's see if this API is vulnerable to SQL injection. With SQL injection, we can try to give malformed inputs to make the API behave in ways that it shouldn't. In particular, we could try using a --, which in most SQL implementations is used to end an SQL query, and we might be able to use that to bypass the password check on this login endpoint. To do that, I'm going to go to the value I passed as a username, and I'm going to craft it as the end of an SQL query. So it's likely that the username is quoted in the SQL query. So the first thing I want to do is end that quote by putting in a single apostrophe at the end of the admin value. So now I've simulated the username value being finished, and now I want to just end this query here. So I'm going to put in --. And so now instead of a query like select * from users where username equals admin and password equals any value, I'm trying to stop that query at select * from users where username equals admin. So I'm going to go up and click send again. And we can see at the bottom that the login has been successful. And not only that, we can see the user is admin, and it's told us that the username's password is password. So I've gotten information about the user, and I've proven that this API is vulnerable to SQL injection. Now, let's test the API to see if it's vulnerable to cross-site scripting. Cross-site scripting is similar to SQL injection, but instead of modifying the SQL query through malformed inputs and unsanitized inputs, with cross-site scripting, we're going to be trying to inject scripts directly into the API. So we're going to start by changing the endpoint that we're hitting on the base URL to /welcome. Now we're going to pass it a name field, and then we're going to pass it a script to pop up a JavaScript alert. And that looks like this. We pass a name equals, and then inside of that equals, we pass a script to pop up an alert saying XSS. We can get rid of the form data for this particular request by clicking on None in the body. And then we're going to change our post method to a get method. And then we're going to click Send. And we see that we get a header back with welcome and the script that we passed to it. And this is because this particular web page displays a name field based on the value passed to it. So now let's try that same thing in a browser. And we can see that if we put in that same URL that we just passed via Postman, we do get an alert saying cross-site scripting, or XSS. So now we've seen that this API is also vulnerable to cross-site scripting. Finally, let's check if this endpoint is misconfigured to allow access to endpoints without requiring authorization. So the endpoint is going to be /data. So I modify the endpoint to be localhost/data, and I'm going to leave the method as get, and I'm just going to send the request as is. And I can see that the API has responded with secret, this is sensitive data. And I haven't had to do any kind of authorization to access that. So we can also see that there are endpoints in this API that have been implemented incorrectly to not require authorization for access. So this is how we can use Postman to test and evaluate APIs for function and vulnerabilities, as well as to exploit them during a penetration test. In this video, we're going to look at how we can use the SQL map tool to exploit SQL injections. SQL map is a powerful open source tool that aims to automate the activity of performing SQL injection attacks. SQL injection is a very common vulnerability within web pages and APIs, so it's very useful during a penetration test to have an automated way of looking for these SQL injection vulnerabilities. To get started, we first need to download and install the SQL map tool. To do that, open up a web browser and navigate to the URL seen at the top of my screen, which is sqlmap.org. On the main screen, because we're working on a Windows system, we're going to click on the download.zip file. But there are distributions available for Linux as well, and you would click on download.tar.gz. Alternatively, you could also clone this directly from the repository. Once you've downloaded the zip folder, extract it to a directory of your choice, and then open up a PowerShell window or a terminal within that directory. And then, once you have your PowerShell window open within that directory, you could run the ls command to see what's available inside that folder. In this case, we're interested in the sqlmap.py file, which is the SQL map tool. We also need to make sure that we have Python installed on our system in order to be able to run this tool. We can run the tool by typing in python sqlmap.py. And it tells us that we are missing a mandatory option, and it gives us a usage example. Pressing enter to continue, I can retype that command and pass -h for basic help or -hh for advanced help. When I pass -h, I see a detailed output of all the different ways that I can use the SQL map command. So this can be a very useful reference when you're learning and getting used to the tool. So let's go ahead and start building an SQL map command. We have a vulnerable web application running on localhost at port 5000, and it has a /login endpoint that is vulnerable to SQL injection. So that's what we're going to be using to test with SQL map. So I'm going to start with the command python sqlmap.py, and then I'm going to pass it the -u flag. And if we scroll up, we can see the -u flag is used to pass the target URL. So in this case, it's going to be the location of my API endpoint, which is http://127.0.0.1:5000/login. Next, we're going to pass the --data equals flag. And if I scroll up under the request header in the help output, I can see the description for this is the data string to be sent through a post request. So I'm going to pass it username equals admin and password equals test. Then I'm going to pass it the -p flag. And if I scroll up into the injection section of the help, I can see the -p flag is followed by a test parameter, and this is where I can pass the testable parameters. And the testable parameter that I want to test is username. and then I'm going to pass it --dbs. Once again, if I scroll up, I can see under the enumeration section, --dbs enumerates DBMS databases. And then I'm going to hit enter. And now the tool is running, and we can see that it was not successful. And this is because we have a critical warning saying that we're not authorized. Try to provide right HTTP authentication type and valid credentials. So in this case, we haven't passed valid credentials to the API, and that's what it's found. So SQLmap hasn't been able to do what it needs to do. If I return to the command, and instead of test, I put in password, which is the correct password for the admin account, and I hit enter, we should see a different output. Now, we do see a different output, and we can see what SQLmap has done. First, it tested the connection to the target URL. Then it checked if the target is protected by WAF or IPS. Next, it tested if the target URL content is stable. It found that the target URL content is stable. And then we see the most interesting one, which is heuristic basic test shows that post parameter username might be injectable, and it found that we're possibly working with an SQLite database. Next, it started testing for SQL injection on the post parameter username, and it tells me that it looks like the backend DBMS is SQLite. Do I want to skip test payloads specific for other DBMSs? And skipping these test payloads will make things go much faster, so I'm going to type in Y and hit enter. Next, it asks me for the remaining tests. Do I want to include all tests for SQLite extending provided level 1 and risk 1 values? So I'm going to type in Y again and hit enter. And once again, we see a critical warning, warning us again that we're not authorized. Below that, we can see that SQLmap hit a 500 internal server error 4 times and a 401 authorized error 1 time. However, we now know that the username and password combination is correct. So we can actually tell SQMap to ignore that code by going back to our previous command and adding in a flag --ignore code equals 401. And then hitting enter. Now that we've ignored the 401 code, we see a lot more output because it's getting past that error. And at the bottom of the output, I see a prompt saying post parameter username is vulnerable. Do I want to keep testing the others, if any? At this point, I found a vulnerable injection point, so I'm going to type in N for no. And now SQLmap has gone ahead and enumerated the database for me. So below that prompt, I see SQLmap identified the following injection points with a total of 46 HTTPS requests. And then it gives me the output of parameter, username, the HTTP method was post, I have some type information, the title is an AND Boolean-based blind, where, or having clause, and then I have the payload that was actually successful for doing the SQL injection. And we can see it used username equals admin, apostrophe, and 7267 equals 7267, which is a truthy statement, meaning that this will always evaluate to true, and fvpj equals fpbj and password equals password. Below that, there was another payload that it sent, which also demonstrated the SQL injection, and then we have a third payload which also worked for SQL injection. It confirmed the backend DBMS is SQLite, and then we have a warning on SQLite it's not possible to enumerate databases. And then it gives us the output for any HTTP error codes that were detected during the run, and any data logged was logged to a text file for this run. So this is how we can use the SQLmap tool to automatically uncover SQL injection vulnerabilities in an API or a web page, which can be extremely useful during a penetration test. In this video, we're going to look at using the GoBuster tool to perform web application penetration testing. GoBuster is a command line tool and is used for performing brute force attacks on URLs, directories, files, and DNS subdomains. So we can use GoBuster and these brute force capabilities to enumerate web directories and files on web servers, enumerate subdomains of a domain, detect virtual hosts that are configured on a server, and more. GoBuster can be installed on a variety of different platforms like Linux and Windows, and in this case, we're going to be running it on a pre-built Docker container. So to get started, open up a Windows PowerShell terminal or a terminal on your platform, and you'll need to have Docker installed and running, and then use the command docker pull ghcr.io/oj/gobuster:\latest. And this will download a pre-built Docker image of the latest GoBuster version. Now that we have the Docker image installed, we're going to have to do some setup to get ready to run GoBuster. In another PowerShell window, I've served up a local server on my local host on port 8080, and this is what we're going to try to enumerate to see what kind of information we can get out of this server. Before GoBuster can perform brute forcing of this server, however, we need to create a word list for it to use in its brute force attack. There are many pre-made word lists out there that we could use, but in this case, we're going to create our own simple word list for testing. So I'm going to use this command in PowerShell to create a wordlist.txt for GoBuster, and it's going to contain the words admin, hidden, secret, login, and test. Now wordlist.txt has been created, we can try running the tool against my server. To do that, I'm going to use the command docker run --rm, and then the path to the image, which is ghcr.io/oj/gobuster:\latest, and this will run the GoBuster tool. So we can start with -h to see how the tool is run. And we can see that the output gives us a help output, at the top telling us a usage, and then we have the commands that are available to us under the available command section, and then we have all of the different flags that we could pass to the command. Let's start by using the dir command, which under the available command section we can see says uses directory/file enumeration mode. So let's start building that command now. To start, we're going to return to that same base command that we used, which was docker run --rm and the path to the Docker image, but we're going to modify this a little bit to put a -v in front of the path to the image, followed by the path to the folder with our word list, which is c/demo/gobuster, and we're following it up with :/mount. This is because by default, Docker containers are isolated from the host system. So in order to access the word list that we've created, we need to tell Docker to mount the local file system at that path in order to access that file. Once we've done that, we can add on to the end of the command dir, followed by the -u flag to point to the URL we want to enumerate, which in this case is going to be running on my local host at port 8080, but again, because we're using a Docker container, I'm going to actually need to use a specific IPv4 address to my local machine in order for Docker to access that. Next, we're going to pass the -w flag, which we use to tell GoBuster to use a word list at a specific location, in this case /mnt/wordlist.txt. And then we hit enter. And GoBuster gives us an output of the results of its enumeration from the brute force attack. We can see a summary of the parameters that were used to run the attack, such as the URL, the HTTP method, the number of threads used, the word list used, any negative status codes, the user agent, and timeout configuration. Then we can see that GoBuster started GoBuster in directory enumeration mode because we passed the dir command to it, and it found /hidden directory and a /secret directory. So we've successfully done our first directory enumeration. Let's try to start refining it a little bit more. If I run the same command, but I pass -v at the end of the command, I can get a more verbose output with a little bit more information. And in this output, I see not only the directories that were found, like /admin, /hidden, and /secret, I also see which ones were missed. So this gives me a little bit more information about what was checked entirely and not just what was found. The next thing that we notice is that GoBuster is only enumerating the directories or files at the root level of the web server. This is because GoBuster doesn't automatically search inside of any directories that it finds. However, we can start to go inside of those directories manually by once again going back to our command. And now we're going to modify the -u value because we know definitively that certain folders exist. So if we tag on to the end of the URL one of the found folders, such as /secret, we can see that the output is different because now we're scanning inside the /secret folder instead of the root folder. And in this case, all of our word lists have missed. So we know there are no folders inside the secret folder with any of the word list names that we have given. But this doesn't mean that the secret folder is empty. We could also try looking for specific files by passing a -x flag and then giving common file extensions like .html, .php, and .txt. and rerunning our command. And if we look at the output, for the majority of our words, they've missed, but we can see that for each word in our word list, GoBuster has appended the file extensions that we gave to search for those files inside of the secret folder. And we found a /password.txt file. So this is how we can use GoBuster to enumerate files and folders on a web application. This can be very useful during penetration testing when trying to gather information or find secret data that may have inadvertently been exposed. In this video, we're going to use the WFuzz tool to perform web content discovery. WFuzz is an open source web application vulnerability scanner, and it also performs brute forcing, and it's designed specifically for fuzzing web applications. Fuzzing is a term that refers to a technique of automated software testing that is used to detect coding errors and security vulnerabilities in web applications and other kinds of software. Generally, WFuzz is used for brute forcing directories and files in a web application, performing fuzzing on API requests to find get and post parameters, and looking for things like authentication bypasses. Some of the advantages of the WFuzz tool are that it has customizable payloads, it can filter through responses based on HTTP codes, response length, and other parameters, it has support for multiple HTTP methods, and it also has proxy and Tor support. To get started with the WFuzz tool, we first need to install it. WFuzz is a Python-based tool, so we're going to need to make sure that our system has Python installed before we start working with WFuzz. So on a system with Python installed, open up a PowerShell terminal or a Linux terminal or whatever terminal is on your system and run the command python 3-m pip install wfuzz. And this will install WFuzz if it's not already installed. In this case, WFuzz is already installed on my system and ready to go. If I type in the command wfuzz now, I can see that it outputs the usage options below that, telling me that the WFuzz tool is properly installed. We can also see how we can use WFuzz in this output, and we can get further information by typing in wfuzz-h. Here we have the help output for the WFuzz tool, telling us the usage and all of the different flags we can pass to the command, along with descriptions of what those flags do. Now let's run some commands against a local web server and see what we can do. I have a web server running on port 8080, and that's the web server that I'm going to run WFuzz against. Now, our first step before we get going with using the WFuzz tool is going to be creating a word list for the WFuzz tool to use. So to do that, I'm going to create a file in my directory called wordlist.txt, and we'll fill this up with some common words. Once I'm happy with my word list, I'll save this file. And now we can start building our WFuzz command. So I'm going to start with the command WFuzz. I'm going to pass the -c flag, which will make WFuzz format its output in a nice colored format. And then we're going to pass the -w flag and point to our word list. And that tells WFuzz what word list to use when performing its fuzzing. Then we want to hide any 404 responses, so we'll pass --hc404. And then we'll pass the address of my web application, followed by /fuzz, and hit enter. And WFuzz gives us some output from our command. So let's examine this output now and see what the fuzzing tool has done. This /fuzz that I put onto the end of my URL is representing the placeholder that is going to be replaced by all the words from my word list when the fuzzing tool is running. So when the tool is actually running, instead of /fuzz, it's going to be trying /admin, /hidden, /secret, and so on for all the words that we put in the word list. We can see that in total, WFuzz tried 8 different requests on the target, and then we have a column of output from the tool. Starting in the response column, we can see that we have 3 301 responses, meaning that we were redirected when the admin, hidden, and secret path were put in place of fuzz. So this means that the server was redirecting us, likely appending a / at the end of the URL, indicating that these are potentially valid folders on this server. And then we have a 200 success response, meaning that the base resource for the URL that we specified was found and is valid. We can also get information about the response body, knowing that it is 17 lines, 29 words, and 302 characters long. With the 301s, we didn't get any body, so we're not seeing any line, word, or character length. And then at the bottom, we have some metadata telling us the time it took, the number of requests that were processed, the number of filtered requests, and the requests per second. So now that we have some information about this server, let's run another command. We're fairly confident that the 301s mean that these are directories on the web application. So if I return to my previous command, and at the end of the URL, instead of /fuzz, I'm going to put /secret/fuzz. And rerun the command. And now we're trying to fuzz against the secret directory on this URL. And we have a response telling us 200, so this URL was valid, but none of our words enumerated any further directories or information for us with this command. However, this doesn't mean that this is an empty directory, it just means that there are no more subdirectories found for our word list. So now that we know this is a valid directory, let's try and enumerate some of the files inside of that directory. Once again, I'm going to use that same command that we just used against the secret directory, but I'm going to add a -z flag to my command, followed by a list of common file extensions that we might want to look for. And we do that by first specifying list, followed by the list of actual extensions. In this case, we're looking for .php, .html, and .txt. And we'll run the command again. But we run into an error, telling us that the fuzz words and number of payloads do not match. And this is because when we use the -z list option, we're actually fuzzing two positions. So wfuzz is going to expect two placeholders in the URL, one for the word and one for the extension. So at the end of our URL, we need to add fuzz2z to put the second fuzzing position in place. And now we can run the command again, and we can see that it runs properly. But no files were actually found inside of the directory. So this is how we can use the wfuzz tool to try and explore web applications and enumerate the various information that might be hosted on those applications. And we would continue performing our investigation on all of the folders that we find, looking for more folders, more subdirectories, and more files within those directories. In this video, we're going to look at using the wp-scan tool to identify WordPress vulnerabilities. wp-scan is a command line-based security scanner that's specifically aimed at evaluating WordPress websites. We can use this tool to help find vulnerabilities in the core files of WordPress, its themes, and its plugins. It does this by scanning for known vulnerabilities in WordPress versions, scanning the themes and plugins in WordPress versions, performing user enumeration on WordPress sites, performing password brute force attacks, and through security configuration audits. The tool also has API integration available and has its vulnerability database regularly updated. wp-scan is a Ruby-based tool, so on our platform, we're going to need to make sure we have Ruby installed before we can run the tool. In this case, we're going to be using a Linux shell on a Windows system, and to install Ruby and wp-scan, I'm going to use the following commands. First, I'm going to use sudo apt update. Then I'm going to run the command sudo apt install ruby-full. And now I'm going to run the command sudo gem install wp-scan. Now wp-scan should be installed and ready on our system. We can verify that by running the command wp-scan --version. And it tells us that the current version is 3.8.27. We could also run wp-scan -h, and this gives us the help output for the wp-scan tool. It gives us the usage along with a list of flags and their description that we can pass to the command line. Now, let's try using wp-scan to perform a basic scan against a WordPress instance. In this case, I have a WordPress instance running on localhost at port 8080, so that's going to be the target of our scan. To get started, we'll type in the command wp-scan. Then we're going to pass the flag --URL. And if we scroll to the top of the help output, we can see that the description for this flag of --URL is the URL of the blog to scan. And then it gives us some more information telling us the allowed protocols are HTTP and HTTPS, default protocol, if none provided, is HTTP, and that this option is mandatory unless update or help or HH or version is /r supplied. And the value we're going to pass to that flag is http:// localhost:8080. Then we're going to pass --disable-tls-checks. And if we scroll to that flag in the help output, we can see the description for this flag is that it disables SSL/TLS certificate verification and downgrade to TLS 1.0+, and hit enter. And WP-Scan has now scanned our WordPress instance. So let's scroll to the top of the output and go through it and see what it did. We can see that the first thing that the WP-Scan tool did is update its own database. So it's performing this scan with the most up-to-date database it can have. Then we can see the URL that we specified as its target and the date and time when it started. Then we have an interesting findings section, and this is where we're going to see all of the findings that the WP-Scan tool found. We can see that it was able to enumerate the headers on our WordPress site. XML RPC seems to be enabled, which during a penetration test could direct us towards some vulnerabilities we might try to exploit with the site. It found a README at localhost 8080/readme.html, and oftentimes we can use READMEs to get crucial information about a service. The external WP cron service seems to be enabled at this address, which means the service could be vulnerable to a DDoS attack. We found the version of WordPress that's running on the application, which is a good way for us to research what vulnerabilities are actually going to be applicable to this particular WordPress instance. And we would be particularly interested if this WordPress version was significantly out of date. Then it found the WordPress theme in use, which is also important because WordPress themes can have inherent vulnerabilities associated with them as well. It then tried to enumerate all the plugins via passive methods, and no plugins were found on this WordPress site. Then it enumerated config backups using both passive and aggressive methods, and no config backups were found. And then it tells us that no API token was given, so no vulnerability data has been output. But we can get a free API token with 25 daily requests by registering at this URL. And then we have some summary metadata about the scan. So let's try running that same scan, but this time providing it with an API token and seeing how the results differ. Once again, I'm starting with wp-scan --URL and my localhost :8080. And now I'm going to pass the flag --API-token, followed by the API token value, and hitting enter. And we can see that this time there's no warning about a missing API key, and we have a wp-scan db API OK. Our plan is free, and 2 requests were done during the scan with 23 requests remaining. So this means that I've used my 2 out of 25 requests for the day. Now let's try to perform a brute force attack on this website using wp-scan. Starting with our same base command of wp-scan --URL localhost 8080, I'm going to give it a username that I want to try to brute force, in this case admin, by passing the flag -U, admin, -P, followed by the path to my word list, which is wordlist.txt, and hitting enter. And we can see in the output, it tried to perform a password attack on XLM-RPC against one user, trying admin, but no valid passwords were found. So let's try another user. And this time we'll try the demo user. And here we can see it tried to perform the same password attack, and we have success with demo and demo. So it found a valid combination for username and password with a username of demo and a password of demo. So this is how we can perform brute force attacks on WordPress sites using wp-scan as well. If your penetration test involves specifically a WordPress application, then wp-scan can be a very valuable tool to have when performing that penetration test. In this video, we're going to explore the Pacu tool to see how we can use it to perform AWS attacks and post-exploitation techniques. Pacu is an open source AWS exploitation framework designed specifically at performing penetration tests and security assessments in AWS environments. It provides us with a variety of different tools and modules that we can use to identify, exploit, and test the security of a given AWS environment, and we would typically use it for enumerating AWS accounts, trying to perform privilege escalation, exploiting any found vulnerabilities, performing cloud security assessments, and more. Pacu is a Python-based tool, so we'll need to make sure we have Python installed on our machine before we start using the tool. On a system with Python installed, open up a PowerShell window or a terminal, and clone the Pacu repository. To do that, we're going to use the command git clone, followed by the URL, which in this case is https://github.com/rhinosecurity-labs/pacu.git. Once we've cloned the repository, we can change directory into it with the command cd pacu. Next, we need to install all of the dependencies for the tool. To do that, we're going to use the command python3-m pip install -r requirements.txt. Now that we have the dependencies installed, we're ready to start using the tool. To do that, we can use the command python3 cli.py, and this will launch the Pacu command line interface. Now we'll follow through the setup prompts. When asked what would you like to name this new session, we'll call it demo. And now our demo session has been created. Scrolling up, we can see that Pacu has given us some output in terms of the tool usage and the commands, along with associated descriptions for each command, showing us how we can use the tool. The first thing we need to do is set up some dummy keys. To do that, I can use the command set_keys, and this will add a set of AWS keys to the session and then set them as the default. Our key alias is going to be test. Then the access key ID is also going to be test. And the secret access key will once again be test. We'll leave the session token as none. And now we have our dummy keys set up. With our dummy keys set up, we're ready to start using some of the modules within Pacu. In this demonstration, I'm going to be pointing Pacu to a local stack instance running on a Docker container on my local machine, which emulates an AWS environment on my local system. To get started, let's look at some of the modules that are available to us. To do that, I can use the command list, or ls, to list all the modules. And if I scroll up through this list, I can see all of the modules and the category in which those modules belong. To use a module, we would pick one, for example, IAM__enum users, and then we'd use the command use, followed by our module name. And it tells us the usage for that command, and we did not pass all the arguments that we need. We would have to pass role name and account ID in order to have some valid arguments. We could try passing arbitrary values.
And in this case, we end up with an error because our security token is invalid. But this is how we could use some of the modules to exploit AWS instances. Now let's explore some of the other options within Pacu. We can always open up the help menu by typing in help. And this opens up the usage information that we had at the start. We could use the command list sessions to see all of the sessions that have been created in the Pacu database. And in this case, we can see that there are two demo sessions, demo and demo 2, and demo is active because that's the current demo session that we're in. If we want to within Pacu, we can also run AWS CLI commands directly by using AWS followed by the command. We can also get help on a specific module if we want to know more about how that module works and what it does. So let's see how to do that by once again running the command list. And now let's pick one of the modules under the exploit category, for example, Cognito attack, and find out more information about that. To do that, I can type in help, followed by the name of the module, in this case, Cognito__attack. And here we get all the information about the module. We can see who the module was written by, we can see any prerequisite modules that are associated with it, then we get the usage for the module. This tells us all of the different flags that we can pass to the module in order to configure it to run properly. Then we have a description that tells us this module attempts to retrieve IAM credentials from identity pools, create or log in a Cognito user with each user pool client, search and modify custom user attributes, assume extra user roles, and obtain IAM credentials at each step to facilitate privilege escalation. Then it tells us that the typical attack requires 4 arguments, a username, password, and user pool client or identity pool. Then for each of the flags available in the usage example, we can see the description associated with what those flags are. So this is how we can get more information for any module within Pacu to understand what it is we're running and what those modules will do. So if your penetration test involves AWS resources or environments, Pacu can be a powerful tool to interact with and perform penetration tests on those environments.
In this video, we're going to look at how we can use Docker Bench to check for best practices and ensure that container best practices are followed. Docker Bench is a security tool, and it's an automated script that we can use to check Docker installations and containers for security best practices. Generally, it does this by using the recommendations from the Center for Internet Security, or CIS, Docker benchmarks, and it will perform a series of checks according to these recommendations to see whether or not the Docker environment is securely configured. So some of the key features of this tool include automated security checks, CIS benchmark compliance, and wide coverage in terms of Docker configurations. Some of the use cases that we would typically use Docker Bench for include performing security audits, maintaining compliance, as well as development and testing of our containers. In order to use Docker Bench, we'll need to be running on a system where Docker is installed or have a publicly available Docker container to target. In this case, we're going to be working on a Windows system with Docker pre-installed. So our first step is going to be downloading and installing the Docker Bench tool. To do that, I'm first going to switch from a PowerShell terminal into a Linux terminal. Then I'm going to clone the Docker Bench security repository with the command git clone, followed by the URL to the repository, which is https://github.com/docker/dockerbenchsecurity.git. Then I'm going to change directory into the cloned repository with the command cd docker bench security. Now we can run the script with the command sudo /dockerbenchsecurity.sh, and we're going to pipe the results to a file using the pipe character t, and we'll call our output file dockerbenchresults.txt. And we hit enter. Now Docker Bench is running its audit, and it has completed, and we can see the results of that audit inside of the file that we output the results to. We can also see the output of the results in the terminal as the tool ran. And if we check out the results of the file, we can see that it contains the same information. If we scroll up to the top, we can go through and see the results of our audit. First, we have section A, which is where the script is actually checking the results. And for each check, we can see what the results were. So when we see a label of info beside a check, this indicates that this is an informational message. The check was performed by the tool, but no immediate action is required because no violation of the rule was found. But if we see a warn icon next to a finding, this means that the tool has found something that doesn't align with the CIS Docker benchmark best practices. So this indicates that we need to look at this rule and consider addressing it to improve the overall security of our Docker container and our Docker environment. So for example, we have a warn icon on 1.1.1 that tells us we need to ensure a separate partition for containers has been created. And in this case, we can see that in our Docker environment, this is not the case. Scrolling down to the results, we can see a few more statuses. For example, on 1.2.1, we have a note status. This means that this is a manual check that's going to require us to verify it because the tool is not able to do it automatically. So it's good to keep track of these specific items because these are not going to be checked by the tool, and if you want a full, complete security audit, you'll need to go through and find all of the checks that have these notes and check them yourself. Then below that, on 1.2.2, we have a pass status. A pass status means that the check has been successfully passed and our Docker environment meets the recommendations set out by the Center for Internet Security. If we scroll down to the bottom, we can see another section, C, which tells us our overall score. This gives us a summary of the overall audit. Beside checks, we have a number, 86, and that indicates the total number of checks that the tool performed during the audit or during the security assessment. Then we have a score. In this case, we have a value of 3. In general, we're trying to get as high of a score as possible. In this case, a score of 3 is relatively low, so this means that we should be looking to remediate a lot of the items that were found by the tool in order to improve this score. So the higher we can make our score, the more secure we're going to be in our Docker environment. Now, if we want to go to the output and get more information about a specific benchmark, for example, this 1.1.1 benchmark that we have a warning on, we can do that by going to a site like Tenable.com, which often hosts information about these audits, and looking for the specific item that we want, in this case 1.1.1. We can see all of the details about this check on the right-hand side under the Item Details header, telling us the audit name that it comes from, the reference, the plugin, and a control ID. Then, in the main window, under the Information header, we have more detailed information about the check and why the check is important. At the bottom, we have a solution which can give us information about how we could go about remediating that check. Alternatively, all of these standards are available directly from the CIS website. So this is how we can use the Docker Bench security tool to audit and improve the security of our Docker environments. In this video, we're going to look at how we can use the kube-hunter open source tool to explore security weaknesses in Kubernetes clusters. kube-hunter is a tool developed by Aqua Security, and it's specifically designed to identify vulnerabilities in Kubernetes clusters. Some of the key features that come along with the tool are Kubernetes-specific vulnerability scanning, with 2 types of scans, one being passive and the other being active. It has multiple modes of operation between network scanning, remote scanning, and in-cluster scanning. It has vulnerability categories in terms of unauthenticated access, kubelet/API server exposures, and insecure configurations, and it can give you good reports and recommendations on all of the findings within the tool. Some of the more common use cases for kube-hunter include performing security audits by Kubernetes administrators to make sure that their Kubernetes environment is secure, performing continuous security monitoring within something like a DevOps pipeline, or performing penetration testing exercises like Red Blue Team to try and attack Kubernetes clusters and simulate their defenses. It's important to note that this tool primarily identifies vulnerabilities within the cluster configuration itself, rather than looking at application-specific issues that might be running in the cluster. So let's look at how we can use this tool to evaluate our Kubernetes clusters. kube-hunter is a Python-based tool, so we'll need to make sure that our system has Python installed before trying to run the tool. So on a system with Python installed, go ahead and open up a terminal of your choice. In this case, we're going to be running on a Windows system inside of an Ubuntu shell, and run the following commands. First, we're going to clone the repository for kube-hunter using the command git clone, followed by the URL to the repository, which is https://github.com/aquasecurity/kube-hunter.git. Once we've cloned the repository, we can change directory into the cloned repo by using the command cd kube-hunter. And then we need to install the requirements for the tool using the command python3-m pip install -r requirements.txt. Once we've installed the requirements, we can install the tool using the command python3 setup.py install. At this point, kube-hunter should be installed on your machine, and you can verify that by running kube-hunter-h. And this will give us the help output for the tool. So we can see that kube-hunter has been installed, and when we look at the help output, we can see a usage example, followed by the various flags that we could pass to the tool, accompanied with a description of what each flag does. We could also run the tool in interactive mode by just typing in kube-hunter and hitting enter. When we do this, we get an interactive prompt telling us to choose one of the options, and our options are remote scanning, interface scanning, or IP range scanning. In this case, let's choose remote scanning. Now we need to specify the remotes that we want to scan for Kubernetes clusters. In this case, I'm going to just scan the local host or my local machine and see what clusters it finds. So I pass it a remote of 127.0.0.1 and hit enter. And we have some output. If I scroll to the top, we can go through and see what kube-hunter did. We have some output about the tool starting its various discovery, and it started by looking for open Kubernetes services, and it found an open service API server at 127.0.0.1 on port 8080. And then we can see below that it found multiple vulnerabilities in this cluster. So we have the vulnerability for K8's version disclosure in this Kubernetes cluster, insecure HTTP access to API, listing namespaces as anonymous user, listing roles as anonymous user, listing cluster roles as anonymous user, and listing pods as anonymous user. So these are all the vulnerabilities that the tool was able to identify in this cluster. If we scroll down, we can get more information about the cluster and more detailed information about the vulnerabilities that were found. So we have some information on the nodes and the services that were found running on the nodes. And then we have the vulnerabilities with detailed information associated to them. So for each vulnerability, we have an ID, a location, a MITRE category, the vulnerability, a description, and the evidence of how the tool found and validated the vulnerability. So with this information in hand, if we are performing a penetration test, then we have vulnerabilities that we could now go and try to exploit in the cluster. On the other hand, if we are a blue team and trying to harden our environment, we now know which vulnerabilities we need to patch and remediate in our environment. If we want more information on all of the various tests and how kube-hunter comes to its conclusions, we can go to the help output and see this -- list flag in the options section that tells us it displays all the tests in kube-hunter, and we can also add the -- active flag to see active tests. So if I use the command kube-hunter -- list, it gives me an output of all of the tests that it's running, along with a brief description about what that test does. So for example, at the bottom we have access secrets, and it tells us that this test is accessing the secrets accessible to the pod. And we can scroll up and see all of the tests and the category in which they are under. So in this case, these are passive hunters. So kube-hunter can be a valuable tool for hardening and attacking Kubernetes clusters. And by using this tool to identify common misconfigurations and vulnerabilities, we can greatly increase our penetration testing capabilities. In this video, we're going to look at how we can use the Prowler tool to conduct cloud security assessments. Prowler is an open source tool, and it's aimed specifically at assessing the security posture of AWS environments. It does this by going through a variety of checks based on best practices, compliance frameworks, and security standards, and gives you back an analysis of your overall AWS security configuration. Some of the key features of the Prowler tool include CIS benchmarks, multi-framework support, AWS security checks, and powerful reporting capabilities. Generally, we would use the Prowler tool when we're performing security audits on an AWS environment, but it can also be helpful when performing compliance audits on AWS environments for things like CIS or GDPR, and we can also use it for monitoring purposes to track changes and configurations in real time to help prevent security breaches. Prowler is a Python-based tool, so you'll need to make sure that your system has Python installed before you're able to run the Prowler tool. So on a system with Python installed, open up a terminal or PowerShell window and clone the Prowler repository. We can do that with the command git clone, followed by the URL to the repository, which is https://github.com/prowler-cloud/prowler.git. Once you've cloned the repository, we can change directory into the cloned repo using the command cd prowler. And now we're ready to start working with the tool. So we could check the version of Prowler that we have by running the command python3 prowler.py -v, and it tells us that we are using Prowler 4.5.0. We could also do python prowler.py -h, and this will give us the help output for the tool. So at the top, we can see a usage example for how we go about using the tool. Then we have the options that we could pass to the tool. Then we have the available cloud providers that the tool supports, in this case AWS, Azure, GCP, and Kubernetes. And here we can see that even though the tool is specifically designed for AWS, it does support other cloud providers for doing assessments. And then we have the dashboard component, and for each of these providers and components, we can get more detailed help about them by running Prowler, followed by the name of the provider or the component, and then -h. So let's see what happens if we do python3 prowler.py AWS-H. And here we have a very long output of all the detailed information about the AWS component in Prowler. So once again, we have a usage example, followed by all the different options and flags that we could pass to the command. If we scroll down, we can see more detailed options, along with descriptions about what those options are for. And we can perform the same action for all of the components and dashboards listed. So let's try running a scan on my AWS environment. To do that, I'm just going to run the tool with no flags. So I type in Python 3 prowler.py. And now the tool is running its checks and scans on my AWS profile. So we'll get an output result telling us the security assessment or my overall security posture in my AWS account. And this scan can take quite a long time. When configuring your parameters for the scan, you will need to run AWS configure in your terminal beforehand using the credentials for the actual environment that you want to scan. In this way, Prowler will automatically pick up the AWS credentials that you put in the AWS configure command and scan using those. So in this case, I've previously put in my credentials using AWS configure, and that's what Prowler is scanning now. And upon completion of the scan, we can see our results in the terminal. We can see at the bottom that there have been detailed compliance results output for us at the following location, and then scrolling up through the output, we can see all of the various statuses and their results. So if we pick one here at the bottom, for example, compliance status of SOC 2_ AWS framework, we can see we have 20.33%, 73 fail, 5.29% or 19 checks pass, and 0 checks are muted. And we can scroll up through the results of all the other compliance checks as well. Then at the top, we have the results of our security scan. And in the overview results, we can see that 193 checks failed, 162 checks passed, and 0 checks were muted. And then we have the detailed scan results in a table for us, telling us the provider that was scanned, the service that was scanned, the status of that service, along with the severity of the scan result. So this is how we can use the Prowler tool to perform security audits and security assessments on our cloud environments. This can be a very useful tool when performing penetration testing on something like an AWS environment. In this video, we're going to look at how we can use Scout Suite to perform AWS security assessments and identify security vulnerabilities. Scout Suite is an open source tool designed specifically for assessing the security posture and performing security assessments on cloud environments like AWS, Google Cloud Platform, Azure, and more. Some of the key features of the tool include agentless operation, meaning it doesn't require installing any agents or making changes to your cloud environment to facilitate usage of the tool. It provides a comprehensive reporting platform to help you generate detailed reports in an easy-to-read HTML format, and it has a focus on best practices, meaning that you can use Scout Suite to check your cloud setup and make sure that you are following best practices and any compliance standards. Some of the use cases that we would commonly use Scout Suite for include performing cloud security auditing, performing compliance checks, and integrating it into our DevSecOps pipelines. So let's get started and see how we can use the Scout Suite tool. Scout Suite is a Python-based tool, so we need to make sure that we have Python installed and ready to use on our system, and we'll also need an AWS environment that we can scan. In this demonstration, I'm going to be using my own AWS account, which I've set up using the command AWS configure in the terminal. This will set up Scout Suite to automatically detect the AWS environment that I want to target. So on a system with Python installed and your AWS account configured, open up a terminal or PowerShell window and clone the Scout Suite repository. To do that, we'll use the command git clone, followed by the URL to the repository, which is https://github.com/nccgroup/scoutsuite.git. Once we've cloned the repository, we can change directory into it using the command cd Scout Suite. And we can examine the contents of the repository using the ls command. Our first step is going to be installing the required packages, and we can do that using the command python3-m pip install -r requirements.txt. Once we have all the requirements installed, we can go ahead and use the tool. To do that, I'm going to use the command python3 scout.py -h. And this gives us the help output for the Scout Suite tool. We can see at the top we have a usage example telling us how we can use the tool. Then we have the options we can pass to the tool. And then below that we have the provider that we want to run the Scout against. And it shows us we have the providers for AWS, Google Cloud Platform, Azure, Alibaba, Oracle, Kubernetes, and DigitalOcean. We can also get additional help on specific providers by running the command scout.py followed by the provider name followed by -h. So let's see a few of these other options now. We can check the version by changing our -h to a -v. And it tells us we're using Scout Suite 5.14.0. And we can get more specific help on the AWS provider, because that's what we're going to be running our scan against today, by modifying our command to python3 scout.py aws-h. And this gives us more detailed help output specifically around the AWS provider. Once again, we have a usage example at the top, and then some options that we could pass. And then below that, we have all the arguments or flags that we could pass to the AWS command with their associated descriptions. So let's run our AWS scan now and see what happens if we just run the command as python3 scout.py aws. And when our scan completes, we can see at the bottom of the output that the tool created a Scout Suite report at the following path, and it opens the HTML report for us. And this is what that report looks like. On the main page of the report, we're given a dashboard with a summary of the scan's results. So within this dashboard table, we can see the service name, the resources, the rules, the findings, and the checks. So for example, if I scroll down to EC2, I can see that there are 34 resources, 29 rules, 85 findings, and 493 checks. I can get more information on that by clicking on the EC2 label. And here we get more detailed information about all the findings on the EC2 system. And these are conveniently color-coded for us, with green being good, yellow being warning, and red meaning danger. If I look at my first row, there's a warning on EBS encryption by default is disabled. I can click on the plus icon at the far right of the tab and see more detailed information about this finding. Here I have a description along with remediation and references for this check. Scrolling down, I could expand a green check, such as default security groups in use. And once again, it gives me a description, remediation, which in this case is not necessary, compliance information, and references. If I want to get back to the main dashboard, I can go to the top tab and click on Scout. And now let's click on CloudTrail, because here we can see a red icon indicating that we have a critical issue. And in this case, our danger issue is that CloudTrail service is not configured. And this means that we're lacking critical logging capabilities that could help us in the event of a security breach. If we look along the top, we can see that all of these items that we see in the main Scout dashboard are also categorized into their own tabs. So in this case, the CloudTrail dashboard is actually found under the Management Specific tab and going to the dashboard here. So if we want to get into specific categories instead of seeing everything all at once, we can navigate through these tabs at the top. As another example, if we go to the Compute tab, here we can see the EC2 dashboard that we looked at earlier. So this is how we can use the Scout Suite tool to perform security assessments and evaluate the security posture of a cloud environment such as AWS. This is a very useful tool in a penetration tester's tool belt to find vulnerabilities in an environment, as well as being a valuable tool for administrators to help secure their environments on their own.
In this video, I'll demonstrate how to use Responder to exploit a Windows user when running in WPAD mode. So Windows Proxy Auto Detection is used for auto configuration. It's a tool set up by Windows sysadmins for simplifying configurations, and Responder takes advantage of this. Responder runs malicious WPAD server to intercept and try to poison network activity and web requests, DNS, DHCP, etc. It intercepts NTLM v2 traffic. It makes it easy to collect hashes from account activity over your network. However, it takes specific Windows configurations and vulnerabilities to be susceptible to this exploit. But it also runs other exploits at the same time over common protocols. Where Responder gets its power in contemporary exploits is the authentication over other protocols, which I will highlight here. So I'll run Responder, sudo Responder, hyphen uppercase I ETH0 hyphen W for WPAT. So sudo responder hyphen I ETH0 hyphen W. So I can look and see how responder is running. It shows me the poisoners and the servers it's running. So anyone trying to get MDNS activity over the network or LLMNR or NBTNS, it's going to try and poison these requests. Responder is running servers for all of these protocols, and it will intercept usernames and passwords for anyone trying to connect inadvertently. Now, one thing it's not doing, which is nice to have or nice to see, is when it forces basic authentication for any of these connections. So you'll see passwords in plain text in that case. So if a user puts in their username and password, you won't just get a hash, you'll get the actual password. So I'm going to restart responder with the same command, but after -W, I'm going to give it uppercase FD. And this will force a downgrade in the authentication. Actually, I want one more poisoning option. I want to force basic auth. So -B, there we go. So if I put in the -B, it gives force basic auth, and we should see requests coming in plain text. I'm also intercepting DHCP requests, so I'm doing DHCP poisoning as well on this request. So the activity will be shown here in the console. So now I'll switch over to my Windows machine, and we can see how responder poisons and intercepts and performs man-in-the-middle attacks on our request. I'll open up a browser window, also open up my Windows File Explorer. Now I'll switch back to Kali Linux. And you can see even opening Windows and loading it and logging in, it's trying to send poisoned answers to our Windows client. So if I go back to Windows, open up the browser, and I'll type 192.168.2.63. This is the IP address of my Kali Linux box. Go back, I'll open up another terminal window and type ifconfig, and you can see in ETH0, 192.168.2.63. So you can run ifconfig or ipaddr to get the IP address to know what to put into your Windows box if you're testing this. So I'll switch back to Windows. Now if I put in a username, inadvertently thinking, okay, I'm connecting to this site, it needs my local user and password, put it in, and then it just gives me a blank site. If I look at the source, there's nothing here. So responder is not actually doing much except intercepting the request saying, hey, you need to log in here, and then giving us nothing. So the inadvertent user might put this information in, and if I go back to Kali Linux, switch over to responder, and it tells me skipping previously captured clear text password for admin. As responder logs this information, it will hold on to that information, and if it gets it again, it will just skip what it already has and log that information. Now I'm going to give it a different username and password so we can see something come up here in Responder's console. I'll start with a fresh browser window. There. And now I'll type in a username Steve and a password. Now if I go back to Kali Linux, it shows me it got this username and password in plain text over HTTP. Now it's not only web requests that it's intercepting and trying to poison many different types of requests. If I go into my File Explorer on the Windows machine, type in /192.168.2.63, it asks me to enter network credentials. So I might be trying to connect to another machine on the network, and I think it's a valid machine. I type in a username, Bob, and a password, whatever Bob's password might be, hit OK, and it asks me to enter it again as if I'd entered it incorrectly and tells me access denied. Going over to Kali Linux, at that point we see access was denied, but there's nothing to access. This is just, could be a honeypot or a malicious server on a network impersonating another device or server, and it's allowing me to put my credentials in. It tells me these credentials were entered, this domain/user when I first connect, and also domain /Bob. So it intercepted the user I'm connected to Windows as and stored the hash value. So this hash value contains information, including a hashed version of the user's password, as well as what I entered for Bob. So I entered password in, and that's encoded in this hash as well. So that gives us some information to use that we can use any number of hash cracking tools like Hashcat or some man-in-the-middle attack tools to leverage this hash to try and compromise that Windows user. Now I'm going to stop Kali Linux. So the information from this session from responder gets stored in a log file. And I can look it up after I finish this session. I've stopped responder. Now I'll type ls/usr/share/responder/logs. And these sessions are stored here. So I'll do ls-la. And I can see, so the current date, this file here, smb-ntlmv2 ssp. So this text file, I can type cat/user share responder logs, paste in the file name, and it contains all of the activity that happened, all of the hashes from those requests. So you can see different users, Bob and user, tried to connect to our server running responder. That concludes exploiting Windows users using responder. In this video, I'll demonstrate how to use the WiFi-Pumpkin tool to perform a captive portal attack. So WiFi-Pumpkin is a framework for rogue access points. Attackers will use it as a rogue access point to man-in-the-middle attack against users who connect to it, and pen testers will use it to test the network and its users to make sure that they have awareness and are not susceptible to the attack, and to make sure that the network is secure. So here in Kali Linux, I'll type sudo wp3 for Wi-Fi-Pumpkin 3, or you can type out the whole thing, Wi-Fi-Pumpkin 3, and it's going to give me an interactive console. First thing to do is to set the interface. So in my case, set interface, I want to specify the wireless network device. In my case, WLAN 0. And then set SSID. So this is the name we're going to give to our captive portal, our rogue access point. So I'm just going to call it Wi-Fi-Pumpkin, so it makes it very obvious what I'm doing on the network. And then set proxy, captive flask. So I'm going to type proxies. There are a few different ones available. Scroll up. So there's no proxy. So it's running the portal without any redirection of traffic, just getting it up and running to make sure it works. And then there's Fishkin 3, so a proxy for running a captive portal for an external phishing attack, Captive Flask, and then a few others. So Captive Flask is a good one to test, to try it out, because it will look like a standard captive portal. And it'll ask you to enter a username and password or to register like you would see on an actual legitimate captive portal. Then if I type AP from this console, it will show me the settings. So it gives me the BSSID, the SSID, Wi-Fi-Pumpkin, the channel it's going to run on, the interface, and whether it's currently running or not. And all there's left to do is to type start. And I'll wait till everything gets up and running. And so it's running this web service using Captive Flask. And I will switch over to another device, to an iPad I have running right beside me. And from its networks, I see a Wi-Fi-Pumpkin. I'll tap that. And as soon as I try and connect, we see some activity in the console. What I see on the iPad right now is the following. So I'm on the network selection, the Wi-Fi selection, and it's connecting to the Wi-Fi-Pumpkin network. And then it prompts me with a sign-in page. So I'll show you the sign-in page, what it looks like. As soon as I connected to the network, it brought up the captive portal with a username and password and an option to sign up now. It's going to accept anything you put in there because it's a rogue access point. It's trying to steal credentials. So whatever you put in, it's going to allow it to go through. So in my case, I'm just going to type hello world and sign in. And then I can see some more activity. So it does the usual stuff. It has some communication with Apple and it tells me login successful. So it appears that it's worked. But here's the thing. In Captive Flask, I see the credentials. So this is what I entered, hello world, and it shows it here in Wi-Fi-Pumpkin. So I select done on my device. It looks like I'm connected to the network. If I load up my web browser, it reloads the Amazon page I had so I can see everything the user is doing. So if I type in a website and hit go, you can see that I just loaded the CBC website, and it's loading all of the web requests that are coming from the Safari web browser to load the CBC website. So everything the user is doing, the DNS is going through the DNS server here. So I see lots of activity. If there's any insecure or unsecured data, if anything going over HTTP, you can see how easy it is to capture it here. And that concludes this demonstration of performing captive portal attack using Wi-Fi-Pumpkin. In this video, I'll demonstrate how to use Aircrack-ng to crack WPA2 Wi-Fi handshakes. Aircrack-ng is a complete set of tools commonly used to assess Wi-Fi network security, perform pen testing, and security hardening on Wi-Fi networks. So we'll start by checking our Wi-Fi devices, so iwconfig. And for this, we need a separate Wi-Fi card or Wi-Fi device. So in my case, it's WLAN 0. And the mode is typically in managed mode. And we can use Aircrack-ng to turn it into monitor mode, which I've done already. The first thing to do in any case is to run sudo airmon-ng check. So this checks to see if there are any processes that might interfere putting it into monitor mode. It'll give you some process IDs. You can run airmonning check kill if they cause any issues. In my case, it doesn't. So I was free to proceed. And to put it into monitor mode, you run sudo airmon-ng start WLAN 0, or you can do stop to remove it, stop WLAN 0 mon. So I'm going to stop my interface, stop it from running in monitor mode. So iwconfig. I've put it back into managed mode, and it's WLAN 0. So when you're done doing this exercise, you can stop the service using airmon. So sudo airmon-ng start WLAN 0. And then we'll put it back into monitor mode. And if I type iwconfig again, you can see the mode is monitor. So it's very important for this exercise that you have a card or a Wi-Fi device or Bluetooth dongle adapter that you can put into monitor mode. So I'll clear the screen. And now I can get started. So sudo aerodump -ng, so arrow dumping WLAN 0 mon. So I specify the device. This is going to run it without any particular settings. It's not saving any data. It's just looking at what's going through the Wi-Fi signals nearby. So in the upper left, it shows the channel that it's monitoring. So I didn't specify a channel. You can specify a single channel to look at. Otherwise, air dumping will hop between channels looking at the various devices. It shows me how much time has elapsed since I've started running it and the current date and time. So if I could see all of the BSS IDs, all of the MAC addresses, the power, so the DBMs, beacons, data, number per second, channel, so it sees what channel everything is running on, what cipher they're using, so everything is WPA2 nearby, and the access point I'm interested in is HAL 2400, that's my own, and I need its BSS ID, so its MAC address is important. So I'm going to quit out of this. I'm going to grab the MAC address and save it, because I'll need that later. So I'll save it off screen, and in my next command, I'm going to need it again. I'm going to cd into a folder, documents, that I've created called airdump for my Aircrack-ng information. There's nothing in there now. Clear the screen. And now I'm going to use arrow dumping. So the same command, arrow dumping, WLAN 0 mon, -c for the channel. So that was running on channel 9, double hyphen BSS ID. And I'll paste in that ID and then -w air dump. So I'm going to call it air dump or maybe arrow dump, more closely associated with the command. So it'll create these output files with this prefix name. Enter. So it's running the same command, gives me the same interface with the channel, but this time it's no longer channel hopping. It's only on channel 9 and it's only looking at this particular BSS ID. I'll switch over to another terminal window. I'm in the same folder. And what I'm going to do is run a command called air replay. So the purpose of this attack is to crack the handshake. So in order to catch a handshake, we need to be monitoring when that handshake happens. And we can force this situation, at least a little bit, use airplaying on WLAN 0mon, --deauth, DEAUTH. I'm only going to target one device, so I give it a parameter of 1, and then -a, and I paste in the MAC address. So it's going to run a deauthentication against this access point. And it's sending deauth code 7 to broadcast BSS ID. So it's forcing a deauth, but we might want to target particular MAC addresses. So I can add a -c, go back to the other screen, you see these station IDs. We can actually attack those individual IDs. So I'm going to grab one of these, something with a stronger signal, this 98.9E. So I'm going to grab this MAC address, and then I'm going to restart command, and I can specify it. So it actually targets that individual device with the deauthentication. Now, if I look in the current folder, you can see that there's the AeroDump01 files. I'll put it in a nicer format. So AeroDump01 and then AeroDump02. So when I disconnected this other process to copy and paste the MAC address of the station, it started it with a new enumeration. So AeroDump02 is the one I'm concerned about. In particular, the cap file. So this is the capture file. And now we can run sudo Aircrack-ng and then the name of the file. So aerodump02.cap. I'll paste that in. And then -w, the word list. So this is the list of passwords that we want to try and use to crack. And I'm going to give it the rocku.txt password word list in Kali Linux and hit enter. And now it's going to go through these passphrases, everything it finds in that file, and tries to crack it using a known password list. And it shows me as it's doing it how many keys tested per second, roughly how long it's going to take. So you can see it's almost half an hour just to try these basic list of passwords from that file. It's actually going to try 14 million different passwords. So WPA2 is hard to crack if it's using a long and complex passphrase. So it's a very good pen test scenario where you can see if the Wi-Fi access point is poorly secured using a simple password. And that concludes this demonstration of cracking Wi-Fi passwords using Aircrack-ng. In this video, I'll demonstrate how to use Wiggle.net to find information about possible target locations. Wiggle is a website with crowdsourced war driving data. So it contains data from open access points, Wi-Fi, Bluetooth, and cell tower locations, anything broadcasting over the radio waves associated with wireless networks. The interface is map-driven. You explore a world map, click zoom, filter, search, etc. You look for nodes that you're interested in. But first you need to create an account and log in. So I've already logged in here. So I've got my account. And the default search location, or the default starting location, is San Francisco, but you can provide your location to the site and the map will center on where you are, or very close to where you are. So I'll click View, and I'll go into Map first, and then I'll go through the interface. I'll go through some options that Wiggle has. So it's asking me to use my current location. I don't know if it's going to pick it up or not. Maybe I need to refresh, but it centers on San Francisco by default, so you can zoom out. I'm just scrolling the mouse wheel, and it has a nice density map of all the locations. Obviously, in the big cities, you have a lot of network activity, a lot of Wi-Fi access points, Bluetooth broadcasting, and obviously cell towers everywhere. But I'm going to scroll out. I'm going to go to a place that I know. I'm going to go to my hometown and scroll right down. Here I'm in Canada, in the province of New Brunswick. You can see it's quite sparse in the middle. There's not much there, a lot of forests and mountains. And then in the cities, there is some density. And I'm going to go down to a small town in the southeast corner called Sackville, New Brunswick. And it might take a little bit to refresh. It's best to go right in and let it do its refreshing when you get right to the lowest point. I'm going to go right to the main town square at this intersection and have a look and see what's going on. There's a few apartments around here. There's some shops and restaurants. So we should pick up something. So as it loads, it'll resolve the little dots. You can go in as close as you can. The closer you go in, when you get zoomed right down, you actually see the names of the access points. Now, there's a lot showing here, but if we look in the search, the date range, it's anything that's been collected from 2001 to 2025. So maybe we want to narrow this down as our first filter. So we've navigated to where we want to be, and now I'm going to move this up, let's say 2015 to 2025. So some of these should disappear when I filter it. So now I've selected one of the icons, and it's going to load the information to do with that data point. And then when you select the node, it loads up some information. It shows the SSID, the BSS ID, so the MAC address, when it was first picked up, and the last time it was picked up, and what channel it's running on, the encryption it's running, the quality of the signal if it has that information, general address of where it is. Now, it's not going to be 100% accurate in terms of address or location because it's picking up the signal as someone drives by, or perhaps someone is running some type of war driving software, Insider or Kismet from their apartment or their location and updating the data. So you can click any access points that are interesting to you. You can click on it, and Weigel will load whatever information was uploaded that has to do with that data point. Now I'm going to switch over, go to View and Advanced Search. And with Advanced Search, you can search based on a number of criteria. So I can specify a region, a city, country, and I can look for particular names. Maybe I want to look for TP-Link. I want to find routers associated with that name, or I can do it a wildcard match. So I can use %TP-Link %, and then hit Query. Now, sometimes the search is a little bit slow. It might take some time for it to find what you're looking for, but it depends on how busy the Weigel servers are at the time. Sometimes it's very quick. Sometimes it takes a minute or two before it gives back some results, or it times out. So I'm not going to stick around the advanced search at the moment. I'm going to go to basic search. And the other thing with Weigel is that there's a limit. When you start up an account, it'll give you a limit of what you can see. And you'll see these watermarks, daily limit. If I click on my account, it will tell me my query limits start low, but increase over time, naturally with good behavior. So as long as you're not spamming the service. So I'm going to go back to basic search. I'm not going to worry about what's here. We are worried about is what we're able to search. So we can specify latitude and longitude. We could specify a range. So if we wanted to look at just a certain area, we can search for MAC addresses or SSID names. And same with cell towers. We could put information about what type of network it is, whether it's CDMA or GSM. So if we want to filter by those. And Bluetooth. We can also look for particular Bluetooth MAC addresses or BSS IDs. If maybe we've seen a particular Bluetooth device, or we had a Bluetooth device, we lost it, we want to see if it's broadcasting somewhere and someone's picked it up. So there are interesting applications for this. So before I hit my daily limit, you got the basics. So there's some information shown about Wi-Fi access points. You can zoom into the map, down really low, really close to it, click the individual nodes, and get data on the individual nodes that you see. If you're performing war driving, if you're collecting data through Insider or Kismet or some other program, you can go to Uploads, and it gives you a list of programs that it supports. So Insider and Kismet are two that we've covered in this course, but there are others that you can use, and you can select Upload a file. It'll give you some information, select the file, and upload it. It even gives you the format, so you can be part of the contributors to Weigel.net if you choose to do so. There's an info section. There's links to the Android app, some facts. The Weigel has community forums, and it's on social media. It's on Mastodon, Blue Sky, and Twitter at the moment. The stats section is kind of interesting. It shows over time the data it has. So if I scroll down here and look at these Wi-Fi networks over time, so it starts back in about 2000, and then all the data it collected, it goes up and up and up until it hits 1.46 billion nodes, so Wi-Fi, Bluetooth, cell towers in the database since 2000. And the increase is staggering. What might be more interesting is the Wi-Fi encryption over time. So back in the early 2000s, the majority, over 60% of Wi-Fi networks were unencrypted, so open access points. I was around at that time, and I remember that time going around being in a location where you didn't have internet access and you needed to get a signal quickly. You might be in your car, you pull over in a busy place, you open up your laptop and look for local networks, and there are lots of unencrypted networks you can connect to. Not a very secure process, not a very good way to do anything that requires a degree of privacy, or you don't want to do banking over this. But if you had to look something up, looking for a local place, then you could do so quickly just by connecting to an unencrypted location. Now, people have wised up to this, had neighbors using their Wi-Fi because it was unencrypted. So people got wise and started adding encryption more and more over the years. And there's an inflection point, probably around 2006, 2007, where the number of encrypted networks surpass the number of unencrypted ones. And then as we go further ahead in time until today, the majority of networks are encrypted with very few unencrypted. By default, if you sign up for an internet account and you get a Wi-Fi box from your ISP, they'll provide you with a password, a default password, and it will be encrypted by default. And that concludes this overview of Weigel.net. In this video, I'll demonstrate how to quickly find rogue access points based off of signal strength using Insider. For the typical use, Insider is used on a laptop with a USB Wi-Fi dongle in monitor mode, and you walk around monitoring the signal strength shown by Insider. I'm recording on a fixed desktop computer, which does also have value with Insider because anything within close proximity will show up with a stronger signal strength. Insider is also good for checking signal strength with a greater degree of accuracy. And it's good for looking for open channels that are less utilized if you're looking for a better signal for your own access points. So I've run Insider. Now, Insider requires an account, a MetaGeek account, the makers of Insider, but the account is free. And once you set it up, configure it, and sign into Insider, it will load up and give you your signal strength. If you don't have a Wi-Fi adapter, a wireless LAN card that you can use to scan with, you can get a cheap USB one. And if it's supported by your computer, then you shouldn't have any trouble. Now I'm running Windows through a virtual machine, so there are some display refresh issues here in Insider, some text fragments that look a bit strange, but I'm looking at the signal strength of these devices. HAL 2400 is running inside of my room, so you can see it has a very strong signal strength compared to the rest. So anything in green is fairly decent. I could connect to if I had access without too much trouble. Anything in the orange, then I'm running into errors and packet loss and things that are farther away. So we can get a sense of how close in physical proximity these access points are just based on the signal strength. Now, there could be situations where a signal is closer, or an access point is closer, but the signal is weaker if it's through a concrete wall or something that's shielded, and the signal can't get through. So this is the main screen where we can see the details. There's a little binocular icon. You can click the binocular icon next to the SSID to show the network details, and it will try and give me some information, such as the device. So this has a MAC address. It's a Buffalo Inc. device, which is correct based on this MAC address, and it gives me some information about what's being used. It gives me the security, WPA2 personal. If it's unsecured or there's no security set, it will show me that as well. I can click over to see devices on my network using the LAN icon on the left. There's also the channel utilization, so I can look and see how much each one of these channels is being used in terms of proximity to where I am. So you can see my device HAL 2400 is on channel 9, and it looks to be the only device there. So the main mode is in this monitor mode, where I can see what's happening on my network. And I can see it looks like in the security column, like every device is secured. It shows the modes that are supported. Most of them are BGN. Looks like there's a printer here, Direct 64 HP Envy 4520 series that only supports GNN protocol. So no B, no AX. So AX is a newer protocol, a newer standard that is a little bit faster. It supports higher rates. So you can see the rates that are supported. So I'm connected to HAL 2400, which is 2.4 gigahertz, and its max rate is 130. There's also another access points. You can see rates up to 573, 487. I can see the channels things are running on. So there's a number on channel 6. There's quite a few running on channel 1. So it seems to be more saturated on channel 1. And then another device on channel 11, channel 2, channel 6, etc. So it's good if you're looking for a free channel, some band that you want to transmit over that has less utilization. Now, if I was living in an apartment building running this and each unit had its own Wi-Fi access point, you'd see a lot more activity than this. An SSID, I can see those as well. And I can go to File and export this summary. So if I want to save it as a PCAP file, standard packet capture file, I can do that as well. And that concludes this demonstration of identifying rogue access points using Insider. In this video, I'll demonstrate how to use Kismet to detect nearby Wi-Fi devices. So Kismet is an open source tool. It's a sniffer or driver for capturing activity over Wi-Fi or Bluetooth and other wireless communications. I'll run it as sudo kismet -c, and then I need to specify a network interface. But actually, before I run it, I'm going to type iwconfig to make sure we have a wireless device that we can connect to and monitor activity over Wi-Fi. I'll type sudo kismet -c WLAN 0. It gives me some information about Kismet launching or loading up, and it tells me to point my browser to a certain location. So localhost :2501. So I'll copy that address and switch over to my web browser. So Kismet runs a web server, an HTTP server that I can access, and have a graphical user interface into the information. I load it up, and immediately it shows me Wi-Fi access points. And I've run it previously, so it gives me some information. It's sorted in order of signal strength, so the closest devices first, and then devices that are further away. So this HAL 2400 is on my local network, and it has the strongest signal because that's the one I'm closest to. So while I'm running Kismet, it's actually logging the information I have here. So all the events, all the information is getting logged to a SQLite database. So after we've explored and let Kismet run for a while and looked at some of its options, we'll actually go into the database and extract some information using SQL. So I can open up the devices, look at all devices, Wi-Fi access points, different types of network types. If I want to look at Bluetooth devices, if my interface card, my wireless card is capable of monitoring Bluetooth, I'll get that information here. In my case, it's not. It's only a Wi-Fi card that I have, a Wi-Fi USB card that I'm using to monitor for Wi-Fi traffic. I don't just have to look at access points either. I can look at all Wi-Fi devices. And it gives me a name. Most often, it's just going to be a MAC address. But I can see if there's any data going to and from those devices. And I can click through and can see all the devices, including Wi-Fi bridges, clients, access points, anything communicating over Wi-Fi within proximity to where I can pick up the signal. There are various alerts that you can set up for Kismet. In my case, it's probably complaining. Yeah, it's complaining that I'm running it as root, which is not ideal. But for the purposes of this demo, it's fine. And SSIDs, so anything with a valid SSID that's being broadcast, I can click through and see the different devices. And I can see things like printers that are host access points. I can see the encryption, whether there's encryption or not. So you can look for any open Wi-Fi devices, things that are sharing networks without any encryption. If you're working in an office building for an organization and you're seeing misconfigured devices, they'll pop up here. Anything without encryption that can get on the network, any rogue access points. Now, one of the things that if you look at the signal strength, I'll go back to Wi-Fi access points. If you have a laptop where you're running Kismet or any type of war driving or wireless monitoring device and you move around with it and it's refreshing as quickly, so there's quite a quick refresh rate, you can move around and actually discover rogue access points by getting close to them. So you might not know exactly where it is, but if you're carrying the laptop around moving, the signal strength is going to change as you get closer and farther away, as you get hotter and colder to the signal. So it's a good way of detecting rogue access points if you can put this in a laptop and move around with it. So I'm going to get out of Kismet. I'll close this down, get back to the command line, Control-C, and I'll look in my folder. I'll do ls-ltr of my current folder, and I'll grab one of these Kismet files. So these Kismet with the date timestamp.kismet are actually SQLite files. So I'll type SQLite 3 with the file name, the Kismet file, and inside of SQLite 3, I can type in .schema, run the command .schema, and I can see all the tables that exist in this database. So all the packets, all the data, all the devices, everything to do, the alerts, messages, whatever was grabbed by Kismet is stored in this file. The devices are the important one. So I can do select, I don't know if I want to select dev mac strongest _ signal type from devices. So I can run a SQL query. It'll give me all the MAC addresses, the strongest signal, and the type of device, whether it's an access point, a client, a bridge, etc. Now, I probably want to, in this case, use a where clause, and where type is equal to Wi-Fi AP. This will give me only the access points. Now, the unfortunate thing is that if I look at .schema again, devices does not have the actual device name. So the name of the device is not in these fields, but it's in this device blob column. So if I do select, change that select that I've run, and I'm going to add to my select query the device. And we're going to get a lot of information. So all of the information I'm looking for is in JSON format. I can pre-print the JSON. So if I go back to my device column and type JSON _ pretty and close the parentheses, run this again, you can see it has a nicer output for the JSON. So it's formatted quite nicely, and it gives me some more information about what I'd like to extract from the JSON. So I'm doing a select devmac, strongest _ signal, type, JSON _ extract, and in parentheses, device, and then in single quotes, I have $. So the syntax to extract the JSON, and then in double quotes, the full name of the JSON name. And now I get what I'd like. I have the MAC address, the strongest signal, Wi-Fi AP, the type, and then the name. So you notice there's a few empty names here. Another way of doing this, there's another field, not just name. I change the name to common name, and it gives me some information of where the name actually came back as empty. And where it can't resolve a name, it just gives me the MAC address. So it might not be broadcasting a name, but the access point is there. And that concludes this demonstration of finding and monitoring Wi-Fi devices using Kismet. In this video, I'll demonstrate the open source penetration testing framework Social Engineering Toolkit, or SET. SET is a tool to help construct social engineering attacks and create payloads typically deployed using social engineering. Now, before we start the SET toolkit or SE toolkit, it's a good idea to get the IP address of the local machine, which we'll be using to create our attack from. So to do that, we can type IPADDR or ifconfig and get the IP address. In this case, 192.168.2.63. So I'll have to remember that for when we're using SE toolkit. So I'll run SE toolkit, but to do so, we need to run it as root. So I'll change this to sudo SE toolkit, and now we're in. So we're at a command prompt inside of SET. So we have SET with the greater than arrow, and then we can type in our commands, which we select from the menu. So it's a non-graphical command line interface that we step through menus. So we have from the main menu, the social engineering attacks, penetration testing, third-party modules, update the social engineer toolkit, update SET configuration, and the last option, help, credits, and about. So I'm going to select number 1, social engineering attacks, and we'll go in and see what's there. So here, there are items to help us with spear phishing, number 1. The second is website attack vectors. The third, infectious media generator. 4, create a payload and listener. 5 is a mass mailer attack. 6, Arduino-based attack vector. 7, wireless access point attack vector. 8, a QR code generator. 9, PowerShell attacks. And 10, third-party modules. Now, I'm not going to go through every section and every module, but the main ones, the first 2, the social engineering attacks and the penetration testing. So I'll go into number 2. And here are some custom ones using the Fast Track penetration testing platform. So these help with attacking or pen testing. Number 1, Microsoft SQL. It's a SQL brute forcer or brooder. Number 2 is the custom exploits. 3 is SCCM attack vector. Number 4, Dell DRAC chassis default checker. Number 5 is user enumeration attack. And 6 is PSExec PowerShell injection. So there are quite a comprehensive list of options that we can use this set toolkit for. So I'm going to go into number 1, the social engineering attacks. And I'm going to select number 4, create a payload and listener for this example. So a payload and listener has 2 parts. There's one, the listener, which we need to run as a service or a server that accepts the callbacks from the victim's machine. So we're going to use this current machine, and this is why I got the IP address at the beginning, because we're going to create an executable to be distributed, a payload, the separate part, distributed via social engineering typically, and put on the victim's computer. And if they run it, then it calls back to the server and it gives us access to it. So in this case, I'm going to select number 2, Windows Reverse TCP Meterpreter. So this will give us a shell back to the victim's machine when they run the executable. So I'll type number 2, and it's going to ask for the IP address for the payload listener. So I'll type in 192.168.2.63 as I determined before I ran the SE toolkit. We can pick a port. I'm just going to pick something high and random, 8181. And it's going to create a payload that has this IP address and port embedded in it to connect back to it. It takes a moment to create the payload, to generate it, and then it exports to the default set directory located under /root/.set/payload. So this .set folder, usually in the current user's directory, since we're running this as root, it puts it in the root folder, and it creates something called payload.exe. Now, usually this payload, this executable, gets renamed to something else so that it's the user, the victim, is unsuspecting of it being malicious. So if they download it via email or from a link, it'll be called something, let's say, update computer firmware or some super important program that looks official, and they'll run the executable and be compromised. So it's asking me, do you want to start the payload and listener now? I'm going to select yes, and I'm going to run it. And so it's starting the console. While it's doing this thing, I'm going to go and copy that payload. So if I go to another terminal window, I can type sudo cp/root.set/payload.exe, and I'll put that in the current folder. And then if I look at it, if I find the payload, it's still as root. So I'm going to change the privileges. I'll do a sudo chown to change the owner to Kali:Kali of payload.exe. And now I can switch over to my other machine, copy the file to my Windows machine, and run it. So as soon as I copied the file, I've copied it here into my downloads, payload, Microsoft Defender Antivirus found threats, get details. So it actually found this file, this payload.exe, and it immediately removed it. So I've copied it again. It'll get flagged, but I'm going to try and run it before Windows Defender can remove it. So it tells me that I probably don't want to run it. It pops up this, I hit run, and it tells me it cannot find it. So it actually deletes it quicker than I can run it. If you're carrying out pen testing, this is a good test to test that your Windows Defender is configured correctly. Obviously, all these signatures from well-known penetration testing programs will be in Defender, and it's going to find it right away. If it doesn't find it, if it does connect back, then obviously there's a misconfiguration. Defender's not correctly configured, or for some reason it's been disabled. And then you have a vulnerability. So for a pen tester, this is very good information either way. It's either gets deleted by Defender as it did here, and things check out, or we're able to run it. And if we go back to Kali Linux, it shows up here, and I'm able to run commands on the remote machine. However, in this case, our target machine was protected, so we don't get a connection back, and we cannot run remote commands. And most of the time, that's to be expected. So just to reiterate, this payload is not going to work if Microsoft Defender is configured correctly and it's running. And that concludes this demonstration of performing a penetration test using the SE Toolkit, or SET. In this video, I'll demonstrate how to use the GoFish open source phishing framework to set up to test for vulnerabilities. So GoFish is a pen testing web-based application to test for phishing vulnerabilities. So it allows you to run email campaigns like you would for actual legitimate email newsletter, sending out to clients. In this case, you're sending out to potential attack victims or phishing victims over email. So phishing campaigns are started from the campaign link. However, first time you run it, you try to create a new campaign, it'll tell you that there are no profiles found. So we need to set up a profile first. So where we really need to start, sending profiles. So we'll create a profile, and this is going to ask us for an SMTP server. So a server for sending mail. So I'll call this my mail server as a name from Bob. And Bob's email is bob@mymailserver.com. And a host SMTP or something like mail.example.com. She doesn't want an IP address, yes. So :25 for the port number. It could be 25 or some other like 465 or 587, some other common SMTP port or mail port. Ignore certificate errors. We could put custom headers in for our emails, and then I'll save the profile. If you want to test it, you can send a test email to make sure your mail server is working. In this case, it's not going to work because these credentials are bogus. So this is just for an example. So I'll save the profile. And then when we create our campaigns, we're going to use this profile to send from. We can set up landing pages next. So this is the page the user sees. So this is test landing page. We can import a site from a URL. So I can type in google.com, and it's going to import the text from Google as the landing page. So that's for the phishing attack. I can capture submitted data or capture passwords and redirect it to another site when the user clicks it. Save the page, and then email template. So this is the content of the email the person sees. So phishing email, who we want it to come from, bob@example.com, or it could be targeted one. So targeted users hostname.com, and the subject could be super important banking information. Please click this link to update your banking information. Typical things you get in a phishing email. So you set up the email here. You can add a tracking image to track to see if the user's opened it or clicked on it. So I want to save that template. So you get a template, and then users and groups. So we want to create a group. So phishing targets. We can bulk import users from CSV files if we've downloaded a list from somewhere, or we can enter the manual, type in some information, alice@example.com, add this user. So we have one user for our phishing attack, for our phishing campaign. So we have a target. Then we go to campaigns, and now we can create a campaign. So a new campaign, I want to call this phishing test 1. I can select an email template out of a list, depending on how many I've created, the landing page, the target, and then the URL. So this is the URL for the GoFish listener. So it should be an external IP address. Could be example.com/landing page.html, something like that. Send email so I can decide when it's going to be sent. And then I can hit launch campaign, and then it will attempt to send it, in this case, immediately, or I can change the time. And let's say I want it to be at, let's say 16th at 11:33 p.m. and then launch campaign, launch. Oh, forgot to select my group, phishing targets, and now launch. The campaign has been scheduled for launch. And then when it gets to the launch date and time, it will start sending out the emails to the phishing targets that I've selected. And it shows me the stats, how many emails were sent, opened, clicked, submitted, and email reported. So there's some information about what was done with the email that GoFish can capture and display for us. And that concludes this demonstration of performing penetration testing using GoFish. In this video, I'll demonstrate how to use Evil-w 2 open source phishing framework to construct a phishing attack. Evil-w 2 helps to construct phishing attacks with what are called fishlets, fake login pages used for man-in-the-middle attacks against known websites, where social engineering is then used to trick victims into entering their credentials. So I'll look inside the fishlets folder I have here, and in this folder, you'll see there are many YAML files for different sites, from Amazon to different banks, AWS, Facebook, eBay, PayPal, etc. So there are lots of different options that we can use to construct these fishlet attacks using Evil-w. Now I'll type Evil-w 2 from my command prompt, -p, and then I specify the fishlets folder. So that's relative to where I am now, so I can do fishlets, or if it's somewhere else, you can always put in the full path. So home, Kali, fishlets, and then -developer to run it in developer mode. So if you're working locally off a local machine and you're testing Evil-w 2, run it in developer mode. Otherwise, if you're running it from an actual server, don't use developer mode, and specify your own certificates and set it up properly with a fully qualified domain name and external IP address. But for the purposes of this video and demonstrating the use of Evil-w 2, we're going to run it locally in developer mode. And then the first thing to do when you first run Evil-w 2 is to set a domain. So in my case, I'm running it locally, so I'll config domain. But here's where you enter your fully qualified domain name. So you'll have something like www.example.com. But in my case, I'm going to use localhost and then config IPv4 external. And this is where you set the external IP address. So in my case, it's just on the local network under 192.168.2.63. And then we want to set the host name of the fishlet we're using. So fishlets is one of the commands. Actually, before I continue, I'll type in help. So you can see the different commands used inside of this Evil-w 2 command prompt. And what we're doing is running the fishlets command. So if you want help on any of these topics, you can type help. Let's say fishlets, what we're going to do now. So we're going to use fishlets hostname to set the hostname for the fishlet. So now we'll type in fishlets, hostname, Yahoo. So this is the fishlet we're going to use for the Yahoo website, and then localhost. And then we can do fishlets again. We'll just run the command to show all the fishlets that are available. And the status of this one is disabled. So we need to enable it. So that's just done by typing fishlets, enable, Yahoo. And now we can create a lure. So lures are actual instances of the site of the fishlet. So you can think of fishlet as kind of the base entity, but we need to create an actual site for it. So we'll do lures, create, Yahoo. And now if we type lures, we have our lure of ID 0, the fishlet is Yahoo, and it has a path. So this is the path we want to use in the URL. But we can use lures get-URL command, then the ID of the lure, in this case 0, to get the URL of where this host is running. Now we'll copy that. So https://login.localhost/ and this random set of characters that gets set. And we could set the path if we like. If we want the path to be something different, we can set it. So let's do help lures to get the syntax for setting the path. So lures edit ID path and then the path. So let's do lures edit 0. That's the ID of the lure path. And let's call the path Yahoo. Run lures again, and we can see the path has changed. And then lures get -URL 0, and it has a more legible URL for us. So I'll copy the URL, switch over to my browser, I'll open Firefox, paste it in. So https://login.localhost/yahoo. Enter. Now, when we're running locally in developer mode, it's going to use a self-signed certificate. So Firefox doesn't have this in its certificate information. So it's going to say, hey, this is not a valid certificate, or we don't recognize it. Do you want to continue? And for the purposes of testing, yes, you want to continue. If you're deploying this for an actual pen test, then you'll want to have an actual certificate associated with it. If I want to look in, before I continue, I'll show you where that resides. So ls.eviljinx is the folder where the configuration information is for Eviljinx. And there's a CRT folder. So ls.eviljinx/CRT. And then the certificate information is in that folder. So if you're running this in practice, you want to put your certificate information or reference valid certificate information from this folder. I'll go back to Firefox. We're going to accept the risk, accept the self-signed certificate, and we have a login page for Firefox. The actual Yahoo login for Yahoo Mail. And this is one of the things that's important in testing. One of the ways this is tested in practice by pen testers is to periodically send test phishing emails to employees of the organization that you're working with self-hosted fishlets on the other end. So you can track how many users click the links in the phishing emails and how many enter the credentials into the fake pages. When employees fail this test, when they fall for it, it can trigger additional training on how to spot and identify phishing emails and fraudulent websites. That's how it typically works in practice. So I'll enter some information here. So let's say example123@yahoo.com. If you have a valid Yahoo email and you don't mind testing it, you can actually put in valid credentials and hit next. And it actually forwards this information to an actual Yahoo login, and it tells Yahoo responds back saying this account has been deactivated due to inactivity. So we just picked a random username, a random email, and it spit back some information saying it's deactivated. So if you did have an actual Yahoo account at this point and the credentials were entered, to see the results, you go back to your Eviljinx 2 terminal, and from that terminal, type in sessions. And it shows some sessions that have been used recently. So you can see there was a Yahoo one used at 9:05, the Amazon one at 9:09, and another one at 9:26 from Yahoo. And if the actual credentials had been used, or it got a valid login session, you may be able to capture the full username and password. And if not, you could actually get the token information for an actual login. So you can reuse the token and bypass the login page. And that's how attackers will often do it. Even if you don't have the username and password, quite often you can use a token to get a valid session into an actual Yahoo account or whatever other account you're testing with. And that concludes this demonstration of using Eviljinx 2 to construct a phishing attack. In this video, I'll demonstrate how to use credential harvesting in SET, the social engineering toolkit, to clone websites for a man-in-the-middle attack. So I'll start by running sudo se toolkit. And from here, inside SET, we'll go into social engineering attacks, so option number 1. Then option number 2, website attack vectors. And then option number 3, credential harvester attack method. So if we read the info up top, the credential harvester method will utilize web cloning of a website that has a username and password field and harvest all the information posted to the website. So basically anything with a form, such as a login form, can be cloned and then used to gather credentials through a phishing attack. So I'll go into credential harvester number 3, and then you can use number 1, web templates, so pre-existing values. So it has a few options here. 1, Java required. 2, Google. 3, Twitter. Now we don't want to use any of the predefined ones, so I'm just going to hit Control D. Go back into Toolkit, Website Attack Vectors, Credential Harvester. And then from here, what I'd like to demonstrate is the site cloner. So the IP address, the first option is the IP address for the postback. If you're doing this in practice, doing it on a public website, you want to have a public IP address. For this demonstration, I'm just using my local network, and the IP address for my local machine on the network, 192.168.2.63, is the one that's shared. So I'll hit enter because I want to set that default. And now a URL of a page that I'd like to clone for this attack. So we go over to the web browser. Example, I'm going to use https://github.com/login. The best way to demonstrate this, or to get the full effectiveness of Credential Harvester in SET, is to have a login that has both the username and password on a single page. There are other types of logins. Let's find one. Let's go sign-in page. So I'm going to search for this in the search engine. So it gives me some sign-ins. So let's go to this one for Google accounts. I'll right-click, open a new tab. There's one here for BMO, the Bank of Montreal. So there's banking website, Outlook, Microsoft accounts, Royal Bank. So there's a bunch of ones that, because I'm in Canada, they're showing me Canada-centric ones, Yahoo. So if I look at some of these, if I look at Google, it just has the email or phone number. So if I type in the email or phone number and hit next, it will bring me to a second page where I enter the password. Now, if you're using Credential Harvester, this is not as effective. You can gather some email addresses or phone numbers, but by the time it redirects, if you clone this website and someone enters the information, you won't be capturing any password information. So it's good to have examples where there's both a username or email or phone number and a password on the same page. For this one, to sign into online banking, this is a potential one as well. It has both the card number and password for banking information. And this Yahoo Mail one, there's no login on this page, but if I go to sign in, it brings me to a sign in page. But again, this only has username, email, or mobile, does not have password on the same page. So it's not the ideal scenario for this example, but a page where there's both the username and password, it gives us a little bit more information, quite a bit more actually. So I'll copy the URL, the github.com/login, tab back to my command line where I'm running the SE toolkit. I'll paste in the URL to clone, and then that's it. So it's running, it tells me Credential Harvester is running on port 80. If I switch back to Firefox, open up a new tab, type in localhost, it has the GitHub sign-in. So this is the Credential Harvester hosted on my local machine with the cloned version of the sign-in to GitHub. If I open up another page and type in github.com/login, and I tab back and forth between the actual GitHub login page and the one that's the cloned one that's running locally, it's almost identical. There's only one small difference. It has a sign-in with passkey option, probably powered by some external JavaScript, but the local cloned one does not. So it's very hard to tell the difference. In this case, a user should be hyper aware of what is going on in the URL. So github.com/login, it's obvious. I click on the lock, gives me some site information. So it has all the detailed information about the certificate, about where it's from, who owns it, etc. Whereas my local one, the URL is obviously not a valid github.com URL. There's no secure information. It's actually just running over plain HTTP, not even HTTPS. If I enter some information here, so if I come up with the username, example user, and then type in a password, I'm going to type in password 123, and then click sign in. And it tells me it's being sent over an insecure connection. I'll hit continue. If you really want to do a good job of this exploit, this type of pen testing, you'll issue a fake certificate so that it thinks it's secure. You'll run it over HTTPS. And the user, unless they're paying attention, will be unaware of what's going on. And then when it does it, it actually redirects it to github.com/login. So it attempts to do a redirect to the actual GitHub page, but not before it's grabbed the credentials. So it's harvested the credentials. Now, if I go back to my terminal window where I have the set running and the credential harvester running, it says possible username field found, login equals example user, and possible password field found, password equals password 123. So I've captured the username and password credentials that I'd entered in. And if I was an unsuspecting user, I could have been compromised. And that's where an attacker will steal the credentials without you knowing. And that concludes this demonstration of performing social engineering attacks using Credential Harvester. In this video, I'll give a basic tour of Maltego and demonstrate how it's used to perform reconnaissance for information gathering, target identification, and social engineering. So on my screen, I have Maltego Community Edition running. It requires an account, so I have that set up, and there are different versions or different products associated with Maltego licenses. Inside of Maltego, I can switch the product type. At the moment, I'm running Maltego CE or Community Edition, and this has some basic features, but it's not full-featured like the Classic, the XL, or the Maltego One. If you're using this in a professional setting or in an enterprise, you should be purchasing Maltego One and activating it with a key to unlock its full features. But you can get started with Maltego CE, explore the software, run some basic transforms, and get a basic understanding of it. So the main Transform Hub, Maltego has a list of Transform Hub partners, which are databases and services that contain information that get queried by Maltego when performing transforms, when building its graph. So I don't have a whole lot here. There's some you can go in. It shows some that require subscriptions. Others require API keys. So if I look at the details, let's say Google Maps geocoding, it has the bring your own key feature, or there's some built in to Maltego that you can use if you have higher level versions like professional or enterprise. Some of these are available with Maltego Community Edition. If I want to install any additional ones that are not installed by default, I can click the install link, click next, and finish, and it will do the install. So if I can click any of these, some of them require licenses. So depending on what you need and what kind of scans or what kind of queries you want to do, you can install transforms as needed. And it's fairly quick to install. To get into the query section, the transform section, we go to new to create a new graph. And then it has an entity palette. So this contains all of the features that I can search through. I'll expand it out. So you have sections recently used, person, domain, domain names, DNS domain name, palettes for cryptocurrency queries, device queries, events, groups, like such as companies, infrastructure. So you can see there's DNS records and other internet infrastructure queries that can be done, locations, malware, penetration testing, personal, if I want to build a graph on a person based on their name or phone number or email address. Now, many of these, if I drag, it's just a drag and drop. There's an email address on here, and I right click, and I can see the transforms that are available. So there's some standard transforms, have I been pwned, different ones that are available. All transforms contains a big list. Now, if I go into this list and I want to use, let's say, email addresses using search engine. So if I click on it, I get a warning here. It says, warning, please input Bing search API key. Many of these lookups require API keys. Some don't, but it also tells me, note that results within machines are restricted to 12 entities in the Community Edition. So there are some limitations. Here it says not listed. I can double click on a node to get more information. Exceeding rate limit of API. I'm going to close this graph and go to another transform. So I'll click new. And this time I'm going to search for domain. Double click, enter the domain name, let's say example.com. And then I can run the machines, the transforms that I'd like to run. Let me expand this so we can see what it availables. And I click the Wikipedia one, click run. So I'll just click through. Let's see if I can make this bigger. I can scroll out. You can see the type of graph that it displays. I'll drag this over on this side as well. And we can have a closer look at what was returned. So it returns some DNS information from ICANN, from the IANA servers. So it's doing lookups on the domains, it's finding IP addresses of devices associated with example.com, who it belongs to, and the list of servers. So you can see the network ranges, the IP ranges, based on the domain name example.com. Now, it's not a very important target. Example.com is just a sample domain provided by ICANN. So it's not going to give us a whole lot. So let's put in an actual domain name. And let's leave in maltego.com and do a footprint L1 scan. So this is a fast scan. Should give us some information fairly quickly. And here it gives some information about the Maltego domain, IP addresses that are owned by it, including IPv6 addresses, and what block these fall under. And we can see that the DNS comes from joemax.net and some basic information about Maltego. I'll do one more query. Let's do another domain name search. I'll replace the domain name with, let's try wikipedia.com. Let's try the company stalker CE run. So if I expand the left side, you can see the company stalker gives us an IP address. So there's an admin@wikipedia.com email address. I can click on that. I can do a search on that email and expand the searches, getting more information if it's available. So I want a little bit more from wikipedia.com. I'm going to actually find Wikipedia edit CE. This should give me a fair bit of information considering it's coming from the domain name itself. So it's getting quite extensive in here. So it operates fairly quickly. If I look at the graph, it's actually quite large. I can zoom out. You can see quite a bit of information has been returned. You can see that it's found subdomains, ns0.wikimedia.org, mail.wikipedia.com, ns2.wikimedia.org, and some others as well. And hostmaster at wikimedia.org, and admin at wikipedia.com. So it gets some information about, probably from the domain registrar, getting some information about what's been registered with the domain, as well as IP addresses associated with those domains and what blocks they fall under. If I scroll down, you can see there's quite an extensive graph here that's forming based just on this domain name. So you can discover quite a bit of information from these graphs, and you're not just limited to domain names, as I've shown here, but if you have API keys for different services, or you're using different libraries, different transform partners inside of Maltego, you can gather quite a bit of information from targets, whether they be domains or people, based on very little information to start with. And that concludes this demonstration of using Maltego to perform reconnaissance on targets. In this video, I'll demonstrate how to perform open source intelligence, OSINT, using Recon-ng or Recon-ng to identify users on a platform. So Recon-ng provides reconnaissance, information gathering, report generation, and exploitation discovery. You can launch it from the command line using recon-ng. So it's Recon-ng or Recon-ng for short. And once I have it loaded, I'll start by running help. So there's a few things. The first time you run it, you won't have any modules loaded. To get modules, you use the marketplace. So I can type marketplace, if I type it correctly, marketplace search. So it gives me quite a long list of available modules separated by category. The easiest thing at this point, when you first load it, marketplace, install, and then I can type a module name, or I can just type all, and it will install all of the modules. Now, as it reaches the end of installing the modules, it will give me some information where you'll see something like Bing Domain API module will likely fail at runtime, C keys add. So many of the services, many of the tools require API keys to work. So these are external services that are queried by Recon-ng. And if we set up APIs for these, then we can have access to those services. But there are many modules that don't require API keys, so we'll stick to those for this demonstration. The next step is to look at the workspaces. So workspaces allow you to work on a particular set of modules or run particular queries and save the results. So you can run multiple queries in different workspaces working on different reconnaissance activities. So if I type workspaces list, you always have a default workspace when you load it up, and we'll put it into this one. If you're working with multiple workspaces, you can type workspaces create and then give it a name. So I'll just type my workspace for this demo and then type workspaces list. And it shows me the workspaces that are available. Now I'd like to load a module. So I'll do modules, load, recon / domains hosts, brute _ hosts. So this is going to query hosts or domains using brute force techniques. So it will query a number of different services. But before I run it, I also need to look at options. So options list will give me a list of options for the loaded module. So this module requires a source. So options, set, source, and I'll give it something generic, google.com. And now I can type run. So this is going to query domain name records, looking for IP addresses and subdomains under the google.com domain. And now I can type show hosts, and it gives me a list of all of the hosts found using brute hosts. So it's brute forcing all this hosts, all the subdomain hosts, like developer.google.com, desktop.google.com, blog.google.com, books.google.com. So all these Google hosts and their subdomains are found. And I have these results. So what do I do with the results? Well, it's quite common that we want to use it in an external program. So I can do modules load reporting /CSV and then run. And it will save the results in a CSV file. So under my home folder in .recon-ng, there's workspaces, my workspace, the workspace I created, and results.csv. So I can go get that CSV file and open it up in an external program. Modules, load, recon, profiles / profiler. Then options list, and it needs a source. So in this case, it needs a username. So options, set, and we can pick I'm going to search, let's say we want to find someone with a username out on the internet, on various social media sites and public forums called ScubaSteve123. So I picked this username at random, and let me just make sure this is set. Actually, I missed the keyword. Option set source ScubaSteve123. So if there's a user out there on the internet with this username, when I run this, it will look for it, and it shows me all the different sites it's looking for this user to exist. And it's not necessarily the same user across all of these sites. It's just showing where this user might exist. And it could be different people with the same username. So it's not a precise search, but you can find out where this exists. And then you have something to work from, some target to look at, where you can try and find this user across different sites if it's the target you're looking for. So you can see it's quite a comprehensive list of sites that it found, 58. And after it finishes, I can type show profiles, and it will show all of the results, every site where it found a user with this ScubaSteve123 username. And if it's a particular ScubaSteve I'm looking for, I can narrow it in and look at each one of these sites individually, see if that user's profile matches the user I'm looking for. And again, I can use the modules load reporting. And if I hit tab twice, I can see different results. Let's say I want to store that in JSON format. I can do that, hit run, and it puts the results in a JSON file under profile test in my workspaces. And that concludes this demonstration of reconning to perform open source intelligence. In this video, I'll demonstrate how to hook and attack web browsers using Beef. So Beef is the browser exploitation framework. It's not installed by default on Kali Linux, So, but it is in the repository. So if you don't have it installed, you can tell by if you run sudo beef-xss and it works, it means you already have it installed. If not, if that doesn't work, you do sudo apt install beef-xss. And here it tells me I'm already running the newest version. And then once it's installed, if you have to install it, run sudo beef-xss. And the first time you run it, it'll ask you to enter a password to replace the default password. And then once it launches, it often automatically opens up Beef in the web browser. So the default installation is on the local host machine. So 127.0.0.1:3000/UI/authentication. Now, if I'm accessing it from another computer on the network or from the wider internet, I'll have to specify a host name, or I could specify the local machine's IP address. So in my case, it's 192.168.2.63, which is more important if I'm accessing it over the network. So for username, I'll put in beef and then put in the password that I entered when I installed it and run it for the first time. And then it brings me into the web interface. So you can see there's a list of hooked browsers, online browsers, ones that I actively have hooked, and offline browsers, ones that I've previously hooked. And there's a record here of me running previously to recording this video. So there is an offline browser. So when a browser is online and hooked, you see it in the active hooked browsers. And then once it disconnects, it goes into this history, this offline browsers. And one thing I want to point out, I'll go back to the terminal window. It gives me the web UI for Beef, but it also gives me a hook script. So it's script source, and then the URL where Beef is running /hook.js. So this is essential to be on the page where we're trying to exploit a browser. So you add it to a hacked website or a malicious website, possibly sent via phishing attack. And on that hooked website, it's going to communicate with the Beef backend and send all sorts of information about what the user is doing on that page. And if the browser is vulnerable, we could use the web interface to manipulate that browser or take it over. So there are features to control the browser remotely. I'll go back to the web interface. Now, when you first get started, instead of trying to build a page for yourself, it's a good idea to get situated in Beef to get a sense of it just by going in and hooking the basic demo page. So it comes with the basic demo page, which there's a link here in the Getting Started, and I'll right-click and open that in a new tab. And when I have it open here and it's loaded, my browser should show up in the online browsers. So it does show this browser here hooked. And I look at the information, it provides all sorts of details about the browser that's connected. The features, the capabilities that it has, what browser it's using, so we can see what plugins it has, cookies, all sorts of information that we get from that communicated by the browser to the server. There are also logs that has information. So if I do any actions, any activity on the page, it will get added to the logs of Beef. So if I go back here, there's a text area here. And if I type in something, let's say, hello world, now I'll go back to Beef control panel, and it should show up in this list. Now, if it doesn't show up right away, that's okay. It'll eventually show up. And I think I can refresh Beef. It should show up right away. Go back to the logs, and you can see what I typed. So it shows that browser windows regained focus. So that's when I tabbed over to this Beef basic demo, and then I typed HELLO. So it's sending it asynchronously, so it doesn't come all at once. So HELLO, comma, world, exclamation mark, mods debug shift, exclamation mark. So it actually shows everything I typed, including the shift key and the exclamation mark. Every time I click somewhere, if I click around the window and type in some more text, go back, it'll show up here. It will eventually refresh. I believe there's an automatic refresh, but I can also just reload it, go back in to get it right away. And you can see all of these actions that I did. If I scroll in, you can see mouse clicks. I was clicking all over what I was clicking on, the body of the page. I was clicking on the image. I was clicking on a div on the page. I clicked on the text area, and then I typed MORE space text. And then it tells me that the next action was a blur, the browser windows lost focus. So I'm getting all sorts of information about how the user, the victim, is interacting with the page, what they're typing in. And this could include usernames and passwords as well. I also have a command section. So this is the key. This is where Beef has its power. So the JavaScript is running on the page, but it lets me interact with the page, with the browser. So I can run functions. I can detect if the user is using any of these features, if they're using, the last password manager. Gives me all sorts of options that I can run and execute. And it shows me the results, not in use or not installed. So there are various things that I can do. Get cookie, I can execute that. Shows me what cookies are. So in this case, the data, the cookie shows the beef hook because it's the beef hook. It's the beef demo page. It's getting all that information. I can try to play sounds. I can check for webcam access, all sorts of permissions, things that I can do to exploit or gather information about the browser or about the user that's using it. So there's a browser section, the Chrome extensions, if they're running Chrome, debugging, exploits, host, IPEC, Metasploit, miscellaneous, network, persistence, phone gap, and social engineering. And that concludes this demonstration of hacking web browsers using Beef.
In this video, I'm going to demonstrate how we can use Scapy to perform packet manipulation and sniffing. Scapy is a Python library that's used specifically for packet crafting, manipulation, and analysis of network traffic. It's a very widely used tool in the cybersecurity world, and it's also used in general day-to-day networking. Some of the key features of Scapy are its packet crafting and manipulation capabilities, as well as its packet sniffing abilities. It has a wide range of protocols that it supports, including Ethernet, IP, TCP, UDP, etc. It has powerful automation capabilities, and it's a highly versatile tool. So to get started, we first need to have Scapy installed on our system. For this demonstration, I'm going to be running on an Ubuntu Linux system, and we'll need to make sure that we have Python 3.10 or higher installed on our system. To install Scapy, I'm going to use the command python 3-m pip install Scapy. Now that Scapy is installed, we can start to see how to use it. Let's start an interactive Python session with the command python 3, and we're going to import the Scapy package, specifically IP, ICMP, and send. To do that, I'm going to use the command from scapy.all, import IP, ICMP, and send. Now, we're ready to create, send, and manipulate packets. Let's send a ping to our local host. To do that, I need to create an ICMP packet with a destination of 127.0.0.1. So I'm going to define a variable called packet and set that equal to IP. And as an argument, we pass it the destination IP address, DST equals, and in this case, we're going to use the local host, /ICMP. We can then see the packet that we've created using the command print and pass it packet.summary. And here we see the packet that we've created is an IP ICMP from 127.0.0.1, our local host, to 127.0.0.1 localhost. And now that our packet has been created, we can send the packet using send and passing packet as our argument. And we have successfully sent one packet. Now in this case, we sent a ping to the local host, but we weren't able to see what was returned to us. So let's return to our import statement and import another function called SR. So now that I've imported SR, we can send the packet and see the response as follows. We're going to define two variables, answered and unanswered, and set them equal to SR. And as an argument to SR, we're going to pass the packet, a timeout of 2, and verbose equals 0. Now let's loop through the answered variable with for sent received in answered, print, and we'll do a string formatting to print out the sent portion. And we'll do another string formatting to print out the received portion. And now we can see what we sent and what we received. So we sent out an echo request to the local host, and we received an echo reply from the local host. So this is how we can craft and manipulate packets in Scapy. In this case, all we did was create a custom destination and an ICMP packet, but you can go much more in depth and modify every field and value of a packet to match your use case. Now, let's look at how we can perform packet sniffing with Scapy. To do that, I'm going to import another package called sniff, and we're going to sniff 5 packets on our loopback interface. So I'm going to define a variable called packets and set it equal to sniff, and I'm going to pass the argument of count equals 5 and iface equals LO. Now we're sniffing packets on the loopback interface until we get 5 packets. And once we have sniffed 5 packets, the function completes. So let's loop through the packets now and see what we received. We'll do that with for packet in packets, print packet.show. And if we scroll up to the top, we can see all of the packets and their contents that were sniffed on that interface. So we have the Ethernet portion of the packet, the IP portion, and the ICMP portion. In this case, it was an echo or ping. And then we can continue going through the packets in that manner. So this is how we can use Scapy to sniff packets on a network to see what's being sent and received. In this video, I'm going to demonstrate how we can use the open source tool TCP Replay to generate network traffic on a Linux system. TCP Replay is a tool that we can use to replay or send network traffic from pre-recorded packet capture or PCAP files onto a network interface. We often use this tool for testing, troubleshooting, and otherwise analyzing network performance or device behavior given specific network conditions. Some of the key features of TCP Replay are its ability to replay, send, and modify traffic from a PCAP file, and we can send it at either the original network speed, a predefined user speed, or the maximum speed possible. We can also loop the traffic to replay the same PCAP over and over again, and it supports both multi-interface scenarios and is cross-platform. To get started, we first need to install TCP Replay on our system. And in this case, I'm going to be working on an Ubuntu Linux system. So the first thing I'm going to do is inside of a terminal, run the command sudo apt update, and then I'm going to run sudo apt install TCP Replay. Now that TCP Replay has been installed, I can verify it by typing in TCP Replay-H. And this gives me an output of the help interface for TCP Replay. We can see a usage example along with all of the various flags and their descriptions underneath of that. We can also check the version of our TCP Replay with TCP Replay-V. And in this case, we're using TCP Replay version 4.3.4. Now that TCP Replay has been installed, we need to have a PCAP file that we can use to replay on our network. We can either generate this traffic ourselves, or we could get a sample packet capture from somewhere like Wireshark. In this case, I'm going to use a sample packet capture, so I'm going to open up an internet browser and navigate to the URL seen at the top of my screen, which is wiki.wireshark.org/sample captures. And then I'll click on general/unsorted, and I'm going to scroll down until I find dhcp.pcap. So I'm going to right click on dhcp.pcap and click copy link, and then I'm going to return to my terminal and use the command wget and paste in that link. And now if I do an ls, I can see dhcp.pcap is present in my directory. Now we can use TCP Replay to send that traffic to a network interface. In this case, I'm going to send it to my localhost or the loopback interface. So I do that with the command sudo TCP Replay --int f1 equals LO followed by dhcp.pcap and hit enter. And then we can see the report of what TCP Replay did. We can see that 4 packets were sent and the number of successful packets was also 4. Now let's play around with a few different options. I'm going to return to our previous command and I'm going to add a flag to it --mbps equals 0. And what this flag does is replay the packet capture at the original speed at which it was captured. So we can see it sent the same 4 packets, but it sent it in a very different time. If I do the original command without the flag again, we can see the time difference. In the one without the flag, it took 0.07 seconds, and with the flag, it took 0.000025 seconds. We could also add a flag of --pps equals 1000, which will tell TCP Replay to perform the replay at a specific packets per second rate, in this case 1000. And again, we can see a different time of 0.003 seconds. Finally, we could perform the replay as fast as possible given our current environment with the flag --top speed. And here we can see it replayed it in 0.000033 seconds. So this is how we can use TCP Replay to generate network traffic on an interface by replaying packet captures. Now it's important to note that there are some risks that come along with TCP replay. Because you are replaying the packet capture on a live interface, if there's malicious traffic inside of the packet capture that you're replaying, then that malicious traffic is being replayed on a live network and it can trigger vulnerabilities in systems and devices and could even reach out to install malware. So it's important to understand what packet captures you're replaying before you replay them live on a network. Even if a packet capture is not malicious, running TCP replay can still have impacts on live networks. You could inadvertently cause network disruptions or trigger alerts by flooding a large amount of traffic via TCP replay into your network. And if you're generating your own PCAP files, it's important to make sure that confidential or sensitive information doesn't inadvertently make its way into the PCAP files as a result of that information flowing across the network while performing your packet capture. In this video, we're going to look at how we can install Wireshark and then configure it to perform network traffic analysis. To get started, we first need to download Wireshark. To do that, open up an internet browser and navigate to the URL seen at the top of my screen, which is https://www.wireshark.org. On this page, click on Download and then select the installer for your particular distribution. In this case, we're going to be working on a Windows system, so I'm going to click on Windows x64 installer. This will download a Wireshark executable, which we can use to install Wireshark. Once the executable has downloaded, I'm going to open up the executable, and this will launch an installation wizard. On the main screen, click Next. Once you read through and agree with the license, click Noted. Then click Next. Leave the defaults for components and click Next. We'll leave the defaults for additional tasks as well and click Next. Leave the default installation location and click Next. If you don't already have npcap installed on your system, then you would check the box to install npcap here and click Next. Similarly, if you don't have USB PCAP installed on your system, you can click Install USB PCAP if you need it. In this case, we don't need it, so I'm going to leave it unchecked and click Install. Now Wireshark is being installed on our system. Once the installation is complete, we can click Next, and then click Finish. Now we're able to launch the Wireshark application, and the landing page will look like this. At this point, we're ready to start capturing and analyzing network traffic. So on this landing page, in the main window, we have a list of network interfaces that we could select to start capturing network traffic on. In this case, let's select Adapter for Loopback Traffic Capture. This is going to look at our loopback address, or local host. So I can double click on this, and it starts taking me to a packet capture. And here we can see all of the network traffic in a live window that's occurring on the local host. So we can see the source and destination addresses that are happening. Once we feel like we've captured enough network traffic to analyze, we can click on the red box up here in the top toolbar, which will stop our packet capture. So now our packet capture has been stopped, and we can start to analyze what we've gotten. We can see that we captured 327 packets, and in the majority of cases, the source and destination were both our local host. This is expected because we're capturing traffic on our loopback interface. However, if we scroll up to something like packet 249, we can see that there's a different source and destination here, but the source is still a private IP address, and the destination is a multicast. Let's scroll back down to the bottom and go deeper into one of these packets. I'm going to select packet number 327 by clicking on it in the top window. Going through column by column, we can see information such as the packet number, the time at which the packet was received on the network, the source IP address, the destination IP address, the protocol type, which is TCP, the length of the packet, and other info about the packet. Then in the bottom right window, we can see the hex representation for the packet, and in the bottom left window, we can start to go more in detail with the packet information. So we can expand these different tabs, such as the frame, to get frame information about the packet. We can expand the interface line, and we can also expand the Internet Protocol version 4 line, which will give us more detailed information about the packet's headers. Then we can expand the Transmission Control Protocol line, which will give us more information about the TCP handshake and flags. And then we have the data header, which gives us the actual contents of the packet. So this is how we can capture and analyze network traffic using Wireshark. If we want to save this capture for later, we can do that by going to File, Save As, and saving our packet capture. We have a variety of different types that we could use when we expand the Save As dropdown. and we can see the different types of packet capture that we could export this as. In this case, I'm going to save it as Wireshark TCP dump format, and I'm going to call this demo. And I'm going to save my packet capture. If I close that capture and return to the landing page, we can see a new section in our window saying open, and it has the path to our packet capture. If I click on that, it opens up the packet capture that we just saved. So this way we can come back later and continue analyzing our packet capture. If I want to then start my capture again, I can click on the blue fin and click Start Capturing Packets, and now it starts a new packet capture on the same interface. And if I need to restart the packet capture, rather than stopping and starting it again, I can click on this green fin, which restarts my capture, and it gives me the option to save before continuing, or continue without saving. In this case, I'll continue without saving, and it restarts my packet capture. This can be useful if you meant to only packet capture during the specified time window that a test was running, and you need to restart because the test didn't work, or for some other reason you didn't want those earlier packets you captured. So Wireshark is a very useful tool when it comes to network analysis and capturing and analyzing network traffic. In this video, we're going to look at how we can use the open source tool MobSF to scan and analyze mobile apps. MobSF stands for Mobile Security Framework, and it's an open source automated mobile application security testing tool that supports both static and dynamic testing for mobile apps, whether they be on Android, iOS, or Windows. And the tool also supports mobile malware analysis. The tool can provide us with security recommendations based on its findings, and it has API integrations as well as cross-platform support. In this demo, I'm going to be running on an Ubuntu Linux system, but MobSF also supports Windows, macOS, and other Linux distributions. First, inside of a terminal, I need to install Docker. To do that, I'm going to run the command sudo apt-get install docker. Now that Docker has been installed, we can install MobSF by pulling down the Docker image using the command docker pull open security /mobile-security-framework-mobsf. And this will pull down a Docker image of MobSF for us onto our system. Once our download has completed, we can now run the MobSF container. To do that, I'm going to use the command docker run -it-p 8000:8000 open security /mobile-security-framework-mobsf, which is the name of our container. And what this command will do is start MobSF on our local host at port 8000. And we can see in the terminal at the bottom, MobSF is now listening at our local host on port 8000. And when I open up a web browser and navigate to localhost :8000, I'm brought to the MobSF login screen. To sign in, we can use the default credentials of MobSF for both username and password. Now we're logged into our MobSF instance and ready to start scanning. So let's go ahead and do a static analysis of an APK file. To do that, I'm going to go to the top bar and click on Static Analyzer. And here I can upload and analyze an APK file. Once I've selected my APK file, it starts uploading to MobSF, and it gives me the results of its static analysis. So let's go through these results and see what MobSF has found via its static analysis. We get a summary in the top left with a security score of 38 out of 100 and 0 trackers detected. We can click on MobSF scorecard to give us a dashboard view of the application. And here we can see that the security score of 38 is relatively low. It's been given a high risk rating, and we have a severity distribution for the findings showing us the classification for each finding. So we have 50 medium findings, 33 high findings, 8 secure findings, and 8 info findings. Scrolling down, we can get more detailed information about all of these findings. So let's take a look at the first high finding, which is that the application is signed with a debug certificate. If I click on that, it opens up a drop-down and shows me that production application must not be shipped with a debug certificate. Scrolling down through the findings, we can do the same for every finding. And at the bottom, we can see 2 critical permissions for this app were also found, which are the read external storage and write external storage. If I return to the overall dashboard from our static analysis, we can see some file information about what was scanned, which includes the file name, size, and some hash sums. Then we get some app information, including app name, package name, main activity, target SDK, minimum SDK, max SDK, Android version name, and Android version code. we can see exported activities from the APK, and clicking View All shows us these exported activities. Underneath of that, we have exported services and providers from the APK. Going back to the top, we have some scan options, as well as the ability to view the decompiled code from the actual APK itself, which can be extremely useful if you're trying to perform code analysis yourself, allowing you to view the source code in a file directory structure. So for example, if I dig down into com, netlite, sec, finstagram, r.java, I can see all of the source code for the application. Now let's move on to do a dynamic analysis. I can either do that by clicking on Start Dynamic Analysis in my scan options, or clicking on Dynamic Analyzer in the top bar. When I click on Dynamic Analyzer, I need to select which environment I'm performing my analysis in. In this case, it's an APK file, so I'm using the Android Dynamic Analyzer. When we click on that button, we can see in this window, under the Apps Available header, that we have our APK file available to us. Going over to the green button, I'm going to click on Start Dynamic Analysis, and now the dynamic analysis is running for our app, which will bring us to this Dynamic Analyzer page. And then on this page, I'm going to scroll down and click on Start Activity. Once I click on Start Activity, I can go up to Show Screen, and then we are actually able to see and interact with the screen on our emulator. If I click on TLS/SSL Security Tester, we can see that this gives us the option to run TLS SSL security tests on the APK. And then we get a description of what the various tests are going to do. And if we scroll down, we can click on the blue Run TLS/SSL Tests. In the gray box in the middle of the screen, we can see the test progress running the 3 different tests, and it tells us that the tests will take about 75 seconds to complete. And when finished, we can see TLS/SSL security tests are completed. Now, let's go back to the main Dynamic Analyzer page and click on Generate Report. And here we can see the report from our activities performing dynamic analysis. We can see the output from the TLS/SSL security tester with the different tests that were performed, and we can see the various log output from our activities while performing analysis. So this is how we can use MobSF to perform static and dynamic analysis on APKs and other mobile applications. In this video, we're going to look at how we can use Frida to hack Android web views. Frida is a toolkit specifically designed to reverse engineer, analyze, and modify the behavior of software during runtime. Frida does this by allowing us to inject custom JavaScript code into native applications, thereby allowing us to test and modify the application's functionality. It's most commonly used for security testing, debugging, and reverse engineering. Some of the key features of Frida include its runtime instrumentation, allowing us to do that injection of JavaScript code into a running process. It's a cross-platform tool, meaning it works on Windows, macOS, Linux, and more. It's relatively non-invasive in that it doesn't require us to recompile or modify the target binary. It has support for multiple languages, so while we inject JavaScript, we can still interface and work with Frida using Python, Node.js, or a variety of other supported languages. It provides us with code hooks, allowing us to intercept function calls, arguments, return values, as well as replacing and modifying those values. We can perform memory analysis with Frida. We can bypass SSL and TLS with Frida, and Frida is an open source tool. So to get started, we first need to install the Python client for Frida. In this demonstration, I'll be using Frida on a Windows system. So I'm going to open up a PowerShell window and run the command python3-m pip install frida-tools. Next, we need to download Frida server for the specific architecture that we're going to be testing. So in this case, we're going to be looking at Android x86_64 as our architecture. To download that server, open up a web browser and navigate to the URL seen at the top of my screen, which is github.com/frida/frida/releases. Here, under Assets, select the appropriate server file for your architecture. Once you've downloaded the Frida server package, extract it to a directory on your computer, and note the location that you extract it to. Now we need to push that Frida server to an Android emulator. There are a variety of different ways to get an Android emulator running and connected on your PC, for example using Android Studio or Genymotion, and in this case we're going to be using Android Studio. So we have an Android emulator running, which we can see if we use the command /adb devices. And ADB is the Android Debugger Bridge executable that we can use to interact with our Android Studio emulators. And here in the output, we can see we have an emulator attached, and that's what we're going to push our server to. To do that, I'm going to use that same ADB command, push the path to my Frida server that I downloaded, followed by the path that I want to push to on my emulator, in this case /data/local/tmp. And now I've pushed the file to my emulator. We then need to set the permissions on that pushed server with the command ./adb shell, and then in quotes, chmod 755 /data/local/tmp / the name of the Frida server file. Now we'll start Frida server on our device using the command ./adb shell, and then in quotes /data/local/tmp / the name of our Frida server, followed by an ampersand. But unfortunately, we get an error telling us we're unable to load SE Linux policy from the kernel. This is because any emulator we run needs to have root access to the device. So we can check to see if our emulator has root access using the command ./adb shell, followed by su, and we can see that root access is not available to us. So it's important to make sure that any emulator we set up is also rooted so that we can have root access to that emulator. So now I've reconfigured my emulator to have root access to the device. I'm going to rerun my command, and now Frida server is started up on my device. If I go to a new terminal and I run the command frida-ps-U, I can verify that Frida is running on my device because I can see a list of the processes currently running on my emulator. And if I scroll to the top, I see process ID 2712 test app. This app is running a web view that I'm going to exploit. To do that, the first thing I'm going to do is attach Frida to that application. I'm going to do that with the command frida-U-n, followed by the name of the app, test app. Now I'm connected to my emulator and attached to the test app process. Here I can start running code to analyze and interact with my application. The first thing I'm going to do is get the name of my web app interface that I want to exploit. And to do that, I've pasted in a function that will enumerate the name of the class for that web app interface. And when I run that function, I can see in the output, found class com.example.testapp.webappinterface. So now that I have that class name, I'm going to paste in another function. And there's a lot going on here in this code, but what this function is essentially doing is intercepting any messages that are being sent to the showToast function by the web app interface. So now I've injected that code into the application. We can wait to see when a user interacts with the application, what actually happens. And here on the screen, I have the running application with the test app, and I'm going to interact by clicking on the button at the top of the screen. And I can see that as soon as I did that, output appeared in my terminal. If I return to my terminal, I can see that we intercepted a message to showToast, hello from WebView. This is how we could exploit the WebView interface to try and extract sensitive data by monitoring the interactions and messages that get sent back and forth as the application is used. So this is how we can use Frida to start to exploit, interface, and analyze running applications by injecting code into them. In this video, we're going to look at how we can run exploits on Android devices using Android Debug Bridge. Android Debug Bridge, or ADB, is a command line tool that lets us communicate between a computer and an Android device commonly running on an emulator. We primarily use this tool for debugging, file transfers, app installations, or system management, but it can also be used as part of a penetration tester's toolkit. Some of the key features of ADB include its ability to perform device management on something like an emulator. It gives us shell access to an Android device, which can then allow us to manage both files and apps on that device. We can also use it to debug and collect logs on a device, as well as manipulate and work with the networking and wireless capabilities of a device. So our first step in using ADB is to obtain the tool. In this demonstration, I'm going to be working on a Windows system. So to obtain the ADB tool, open up a web browser and navigate to the URL seen at the top of my screen, which is developer.android.com/tools/releases/platform-tools. On this page, scroll down to the Downloads header and click on the download for your particular distribution. ADB is supported on Windows, Mac, and Linux. And in this case, because I'm on a Windows system, I'm going to click on Download SDK Platform Tools for Windows. Once your download has finished, extract the downloaded zip file to a folder of your choice, and then open up a terminal in that folder, which is what I've done here in my PowerShell window. If I run an ls command, I can see all of the tools that came with the Platform Tools zip file download, and at the top of the list is adb.exe. This is the ADB tool that we can work with on our command line. Now that we have the tool downloaded, we'll need to set up our own local emulator running an Android device. There are a variety of different tools that you can use to do this, such as Android Studio or Genymotion, and in this case, we're going to be running an emulator on Android Studio. Once you have your Android emulator up and running, you can use ADB to find it with the command /adb devices, and this will give an output of the list of devices that are attached. And in this case, we found our emulator, emulator-5554, and this is the emulator that we're going to be using. The first thing we're going to do is run adb root to run adb as root on the device. Now, we've restarted the ADB tool as root. Next, we're going to enable ADB over Wi-Fi to help get us an insecure setup for the demonstration. We'll do that with the command /adb TCP/IP 5555. This will open up the access port on port 5555, making our device vulnerable. Next, we're going to find the device's IP address using ADB. We'll start with /adb shell IP-f inet adder show WLAN 0. Now in this case, because we're running on an emulator, Android Studio is routing the traffic differently, so we're seeing the default internal IP address of 10.0.2.16. What this means is that in our case, ADB is communicating with the device on our local host using a forwarded port. However, if you were setting up a device with its own IP address, then the next step would be to run /adb connect followed by the IP address :5555, and this would connect to the device. In this case, we're already connected to the device via localhost, so we don't need to run this command. Now, because we have root access to the device via ADB, and the device let us do that because it's a vulnerable image, we can start to perform exploitation of that device using various ADB commands. So the first thing we could do is get device information. We could try running /adb shell get prop, and this will retrieve all of the device properties. We can oftentimes use this output to get information about various things like operating system versions, manufacturers, level of security patches that have been applied, software that has been installed, and all of this can go into our information gathering stage to help us determine how we want to attack a device. Next, we could try to expose any stored Wi-Fi credentials on the device using the command /adb shell cat /data/miss/Wi-Fi /wpa_supplicant.conf. And this will attempt to look for and output any stored credentials on the device. But in this case, there are no stored credentials, so we weren't able to find anything here. Additionally, if we wanted to upload our own malware to the device, we could also do that using ADB. If I run an ls command on my folder once again, I can see that in the output, I have malware.apk. This represents a malicious mobile application, and I can install that on the device using the command /adb install -t malware.apk. And now I've installed the malicious application onto the device. So these are just some of the ways that we can interact with and exploit devices if we have access to them via ADB. This can make it a very useful tool for performing security penetration testing and discovering vulnerabilities in your applications or your device itself. In this video, we're going to look at how we can use Drozer to hack Android application vulnerabilities. Drozer is an open-source Android security assessment framework specifically designed for security researchers and penetration testers. We can use this framework to identify and exploit vulnerabilities in Android applications or devices. Drozer helps us do this by letting us interact with Android applications and their components directly to test for security weaknesses. Some of the key features of Drozer include the Android application testing, automated exploitation and module system, the ability to perform remote code execution on vulnerabilities, and support for writing your custom exploits on the platform. Drozer works by having a Drozer agent running on the Android device and a corresponding Drozer console running on a host machine that connects to that agent running on the device via something like ADB or a network. Using this connected console, we can then execute commands on the target device. So the most common places that we're going to be using Drozer are to identify improperly exposed Android components, looking for insecure storage of something like sensitive data, exploiting misconfigured filters, looking for SQL injection vulnerabilities, or testing for weak permission configurations. In this demonstration, I'm going to be working on a Windows system with Docker installed and an Android emulator running. So to get started, open up a PowerShell terminal and pull down the Droser Docker image. We can do that with the command docker pull with secure labs/droser. This will pull down the Docker image of Droser that we can work with. Next, I've installed a deliberately vulnerable application on my emulator device using the command ./adb.exe install -t followed by the name of my APK file. This will set up a vulnerable application on my emulator. There are a variety of different tools you can use to run emulators for your Android devices, including Android Studio or Genymotion, and in this case, I'm running an emulator on Android Studio. So now that we have the Docker image for Droser and an emulator running with a vulnerable application, we need to put the Droser agent onto our device. To download the Droser agent, open up a web browser and navigate to the URL seen at the top of my screen, which is github.com/with-secure-labs/droser-agent/releases/tag/3.1.0. On this page, scroll down to the assets header and download droser-agent.apk. Once you have the APK downloaded, you'll need to install it on your device in the same way that I installed the previous application. So I'm going to use the command ./adb install-t droser-agent.apk. And now my Droser agent is installed on the device. Now that the Droser agent is installed on your device, you'll need to start the actual application. So in your emulator, if you go to your list of applications, you should see a Droser agent application there. Opening the application, we can go down to the bottom and click the off button to change it to on. And now our Droser agent is running on an embedded server at TCP port 31415. So now our device is ready, and this sets up our device to be connected to via the Droser console. Next, we need to set up the device to forward our connection using the command ./adb forward TCP:31415 TCP:31415. And now our device is set up to forward that port connection. Now, let's obtain a shell into our Droser container. We'll do that with the command docker run --net host -it --entry point sh with secure labs/droser. Now we have an interactive shell in our container for Droser. Here, we can start to run commands. If I just type in Droser, we can see a help output showing us the commands that can follow Droser. In this case, to connect to an emulator running on our local host, I'm going to use the command droser console connect --server host.docker.internal. And here we can see that we've connected a Droser console successfully to our emulator device. So now we can start to use Droser to perform exploits and information gathering. Let's start by finding some installed applications. We'll run app.package.list, and this will enumerate all of the installed applications on our device. If I look through the list, I can see the vulnerable application I've installed on our device here where it says infosecadventures.allsafe. If I want to examine that app specifically, I can use the command run app.package.info -a followed by the application name, infosecadventures.allsafe. And here we get some specific information about the application. This can be extremely helpful for your information gathering, as we can see some very useful information like all of the permissions that this application uses on the device. We can also see the version number, the process name, the APK path, and any shared libraries or user IDs. Now let's continue our information gathering to see if there are any exported activities from this application, which would be activities that could be launched by external applications. We'll do that with run app.activity.info -a followed by the application name again. And this gave us a list of the activities in the app, but not necessarily whether or not they are exported. To get more detailed information, I can use the same command followed by -i. And we can see a similar output, but with much more detailed information. And in this case, we don't see any exported activities because exported true is not present under any of these activities. But under InfoSec AllSafe Challenges Deep Link task, we can start to see there might be something going on here, specifically with this congrats data, and looking at information like this can help focus our penetration testing activities. Next, let's test if this application is vulnerable to SQL injection. To do that, I'm going to use the command run app.provider.info -a followed by the name of the application. And here we can see that there are null permissions, so let's try and dump the database contents. We can do that with run app.provider.query, content : / and we'll paste in this content provider string. But we were not successful. We couldn't get a content provider client for the data provider. And there's a variety of reasons for this. It might not be vulnerable for SQL injection, the content provider itself may not be exported or may require permissions that we don't see here, or the app might be using content provider protection mechanisms. But this is how we can start to try to exploit the applications. We could also check to see if there are any insecure broadcast receivers with the command run app.broadcast.info -a, followed by the name of the application. And we do have a receiver, but once again it's not exported, so we likely can't inject directly into that. Let's continue our information gathering using the command run app.package.manifest infosec-adventures.allsafe, which will show us the manifest file for the application, which once again can be used to get information about vulnerabilities or potential issues that could be exploited in the application. And let's try to identify the attack surface of our application. To do that, I'm going to use the command run app.package.attacksurface, followed by the name of the application. And here we actually get some new information. This attack surface has found that 3 activities are exported, 1 broadcaster receiver is exported, 1 content provider is exported, and 1 service is exported, where previously we thought that these particular items were not exported. This goes to show that when you're performing penetration testing with Drozer or any other tool, just because one path leads you to a dead end doesn't mean that you should stop looking for other ways to get that information. Now let's see what we can do with the scanner modules. I'm going to try to look for the various URIs that we could query for the content providers in the application. To do that, I'm going to use the command run scanner.provider.findURIs -a, followed by the name of the application. And then Drozer scans the URIs, and we can see we get no response from some of the content URIs, but we do get responses from the content URIs for the data provider. And we could try to query these URIs with the app.provider.query command. And if we want to see what arguments we pass to this command, we can pass in the -h flag after it, which tells us how to use this command, and we can use that -h flag for any command we want to get more information about. So let's try the command with the content provider that got a response. And now we have successfully performed an exploit on the application. We were able to extract information from the database via that URI. We can see in the output the columns of ID, user, and notes, and some of the information associated with it. So for example, on the admin column, we can see a note saying, "I cannot believe that Jill is still using 123456 as her password." So this shows how we can go about information gathering and exploiting applications using the Drozer tool. In this video, we're going to look at how we can use PowerShell Empire to perform penetration tests and automate penetration testing tasks. PowerShell Empire, or just Empire, is a post-exploitation framework that's specifically designed for use in red team, blue team exercises, penetration testing, and adversary simulation. It works by giving you an interactive command and control environment, allowing you to do things like execute malicious payloads, pivot and move laterally within a network, and maintain persistence on a compromised system. Some of the key features of Empire include its agent-based communication, its ability to perform fileless execution using in-memory execution to avoid disk-based payloads and help evade antivirus solutions. It comes with a variety of built-in post-exploitation modules. It has cross-platform support. It can use multiple communication channels with flexible stagers, and it helps perform obfuscation and evasion tactics. In this demonstration, I'm going to be using a Kali Linux system as my command and control computer, and I'm going to be using a Windows VM as my target computer. To get started, on my Kali Linux system, I'm going to open up a terminal and use the command sudo PowerShell-Empire. This will give me a usage example telling me how I can use the PowerShell Empire tool, which comes pre-installed on Kali Linux. So we can see the usage is empire.py-h followed by a server client. And then these positional arguments are expanded upon, showing us that we can use server if we want to launch the Empire server, and client if we want to launch Empire CLI. In this case, on my Kali Linux machine, because I'm using it as the command and control center, I want to launch Empire server. So I'm going to use the command sudo PowerShell-Empire server. Once our server has started up, we can launch a new terminal and run sudo PowerShell-Empire client. Now we have an Empire console that we can work in. Let's start by setting up a listener. If I run the command listeners, we can then create a listener using the command useListener HTTP. This then shows us a table of all the configurations that are set up for that listener. We can see the host is correctly set up to our internal IP address, the name is HTTP, and so we can use the default settings here. If you needed to customize any of these values, you could use the command set, followed by the name of the value you want to customize, and then the value you want to set it to. Since we're leaving the defaults, we can just use the command execute. So now our listener has successfully started, and our command and control center is ready to be connected back to. Now, let's generate a PowerShell stager to run on our target machine. To do that, I'm going to use the command useStager Windows_reverse shell. And we can see that for this one, we'll need to set a few different values. We'll have to set our listener to HTTP, and we'll have to set the local host to the IP address of our local machine, which is 192.168.56.102. And then we can generate that payload with the command generate. This will create a malicious executable that we could run on a target machine, which when run on a victim machine would connect back to our local host. So now I've switched over to the Windows VM, which is our target machine, and we can see I've put the launcher application that we generated onto the desktop. I'm going to double click to execute the application, which briefly opens a PowerShell window and then disappears. And then when I return to my Empire console, I will see a new agent has checked in. This means that our target computer has connected back to our command and control computer, and we're ready to start performing post-exploitation attacks. For our first automation task, we're going to set up a persistence module so that Empire will rerun anytime the machine is rebooted. This will allow us to maintain control of the computer even if it restarts. I'm first going to interact with the agent by using the command interact, followed by the agent ID. Now that I'm inside the agent session, I can start to use the modules for post-exploitation. And I'll do that using the command useModule PowerShell persistence userland sch tasks. I can see in the table I'll need to set a listener, and I'm going to set it to HTTP, and then execute this module. And we can see the scheduled task updater has successfully been created. This means the task will automatically execute Empire payloads whenever the user logs in. Now that we've established persistence, let's see if we can harvest any credentials from the machine. And to do that, we're going to use the command useModule PowerShell credentials mimikatz logon passwords. We can see there are no options that we need to set, so we can just go ahead and execute this module. And when the agent completes, we can see the results. And if we scroll down, we can find one particularly interesting user with the username of administrator, and we can find the SHA sum for that user's password. Now in this case, we weren't able to get it out in plain text, but this is still valuable information. Next, let's try to enable some keylogging. To do that, I'm going to use the command useModule PowerShell collection keylogger, and then execute. If I then navigate to the directory indicated to me in the description of the module, I can see a keystrokes.txt file. If I open that, I can see administrator password 1 ! So it looks like the administrator on their machine has typed in their username and password, with the username being administrator and the password being password 1. So this is how we can use PowerShell Empire to perform and automate penetration testing tasks. In this video, we're going to look at how we can use Kaboom to perform and automate penetration testing tasks. Kaboom is an automated cybersecurity tool, and it uses the Bash scripting language. Kaboom is generally used for the information gathering stage of a penetration test and can perform activities for us such as vulnerability assessment. One of the advantages of Kaboom is its ability to support simultaneous multi-scanning. For this demonstration, I'm going to be working on a Kali Linux virtual machine. So to get started, open up a terminal and clone the Kaboom repository. To do that, I'm going to use the command git clone, followed by the URL to the repository, which is https://github.com/leviathan36/kaboom.git. Now that we've cloned the repository, let's change directory into it using the command cd kaboom/kaboom. And let's see what we have inside the repository with the command ls. We can see kaboom.sh, which is the shell script that we're going to use. I want to set up the permissions of Kaboom, and in this case, I'm going to set up the permissions as 777 to make the file wide open. I'll use the command sudo chmod 777 kaboom.sh. Now we should be able to run Kaboom. Let's verify that by using the command sudo./kaboom.sh. And we have an interactive terminal session telling us to insert hosts. So let's provide it with some hosts to scan. let's give it a range of 192.168.56.1-200, which will scan the hosts from .1 up to .200. We need to specify a destination where we want to save the results. In this case, let's use /home/Kali/kaboom. And we'll perform every phase. So we type in IG, VA, D, and we don't want to shut down the PC at the end of our script, so we type in no. And now Kaboom has performed its scanning. If we then navigate to the directory that we specified, in this case, which was /home/Kali/kaboom, we can see a separate folder created for every IP address scanned in the range. If we click on one, we can go in and see if anything was found. And in this case, it's empty. But we would repeat that for every one of the IPs that we scanned to see if we found any information. Now let's go back and try a different approach. In this case, let's scan just one single IP address. So once again, I'm going to use the command sudo./kaboom, and I'm going to scan just one IP address of 192.168.56.103. We'll write out to the same location, and we're going to specify some different options. In this case, I'm going to put lowercase IVD. And once again, we won't shut down the PC at the end of our scan. And then we can see what our scan is performing. So the first phase is starting the information gathering phase, where it runs an Nmap scan, and then it starts a vulnerability assessment phase, where it performs subsequent scans. If we then look at the IP address in our output directory, we can see we have an information gathering folder, where we have metasploitscan.txt, which shows us the details of the Metasploit scan. We have an Nmap folder showing us the Nmap report, and we have a vulnerability assessment folder where we can see some reports from Nikto. And this gives us some vulnerability reports from the Nikto scanner. So this is how we can use the Kaboom tool to perform and automate penetration testing tasks. This is a fairly lightweight tool and can be very valuable in any penetration tester's toolkit. The tool itself is also customizable. If we return back to the Kaboom folder, we can see a user word list short, which is the word list that gets used when performing its dictionary or D phase. If I cat the contents of that file, we can see it just has a very bare bones dictionary of usernames with root, admin, administrator, guest, and FTP user. We could modify this to include more usernames and make this more robust. Similarly, with custom URL wordlist.txt, we can see a fairly comprehensive word list here, but we can still modify it where necessary. If we look at the Metasploit scan script, we can modify this as we wish to pull out or add in modules that are being used by Metasploit. So we can see the default modules that get used, such as SSH version scanner and MySQL version scanner. And if we want to add more, we can do that by adding in more modules in the same format. This customizability makes the tool very flexible, and you can easily set it up for your particular use case. In this video, we're going to look at how we can use Python scripts to automate penetration testing activities. For my environment, I'm going to be setting up my penetration testing tasks on a Kali Linux virtual machine, and I also have a Windows virtual machine running as my target. Python is a scripting language, and it's particularly useful when it comes to things like automation. This makes it a good choice when performing automation for penetration testing. Because of its versatility and vast support with a large amount of libraries, it's a very useful tool to have in your environment. The added features of an interactive console also make it easy for rapid prototyping to very quickly get your idea and proof of concept up off the ground. So to get started, I'm going to open up a terminal on my Kali Linux machine and install a Python library that we're going to need. The library is python3-nmap, and to install it, I'm going to use the command sudo apt install python3-nmap. So now, with that library installed, let's start taking a look at how we can use Python to perform penetration testing attacks. I'm going to start an interactive session with the command python, and now we can start writing our script. The first thing I'm going to do is import nmap, and then initialize the port scanner as nm equals nmap.portscanner. Now we need to define a target IP address that we want to scan. In this case, I have the Windows machine running on 192.168.56.103, and that's going to be our target. And then we can launch our scan with the command nm.scan and pass it our target. Now that our scan has completed, we can examine what is in our object with nm.all_hosts, and we can see the hosts that we scanned, and we can loop through this with for host in nm.allhosts. We'll print the state of the host, and then we'll loop through the protocols of that host with for proto in nm@host.allprotocols, we'll print the proto. Then we'll get the local port with lport equals nm at host at proto.keys. And we'll loop through each port with forPort in lport. We'll print the port. And going through the output, we can see the state of our host is up. We have a TCP protocol with the port 135, 139, 445, 3389, and 5985 all open. So now we've written a Python script that can perform Nmap scans automatically for us. Now let's try automating another penetration testing task. In this one, let's attempt a brute force. We'll import the library requests, and I have a local web server running on the Kali machine at port 5000, so we'll define that as our target URL. Then we need to set up an array of username password objects that we want to pass to this URL. And we've set that up as credentials with two username password combinations, one admin password 123 and the other admin and admin. And now we'll try our brute force attempt by looping through these credentials. So for cred in credentials, we'll make a response object and post a request to our URL, and we'll print response.txt. And we can see the results from both of our credentials. The first one says welcome admin. This indicates to us that our login was successful, and the second one says login failed. So we can see that the first set of credentials was correct and the second set of credentials was wrong. So this is how we can set up an automated task like a brute force attack as part of our penetration test. Once we have these scripts built up, we can start to integrate these automated scripts into our workflow and make them more robust to run on something like an interval and as part of a unified workflow. So this is how we can use Python to help automate our penetration testing tasks. As you explore more in Python, you'll also find that there are a huge number of tools that we can expand into when performing these penetration testing automation tasks. We can use Paramiko, which helps us with SSH-based attacks. We can use Scapy for network scanning and packet crafting. We can use Socket for network-related activities, and many more. All of this means that you can get very in-depth and build up very robust penetration tests using Python as the basis for your entire testing suite.
In this demonstration, you'll learn how to create a service in Windows from the command prompt and from PowerShell. Let's start with the command prompt. So I'm going to click on the Start button, and I'm going to go into the command prompt. And what I will do is I'll right-click on the command prompt, and I'll run it as an administrator. That way the prompt runs with elevated privileges, and I don't hit any permission problems. So to create a service in Windows, you can use the service controller command, the SC command. And if you hit enter, it'll display help on the command and give you the different parameters or options that are available with the SC command, right? So down below here, I can see there's an SC start option. There's a pause option to pause a service if we wanted to. There's a stop option to stop a service. What we want to do is we want to go and create a service. So there is a create and a delete option to create a service and delete a service. So those are some of the commands that we're going to use. But again, notice that you can view the help by just typing in the SC command. So I'm going to do an SC space, and we're going to use the create command as our first command. I'm going to create a service, and this service is going to be called Core 16 malware. Then what you're going to do is specify the option of the binary path, or what we call the bin path. So bin path equals. Now the hook here is when you're using the SC command, you have to put a space after the equal sign, which is kind of strange. Most Windows command prompt commands don't get you to do that. But with this command, we are required to put a space after every one of the equal signs. And then in quotes, you specify the path to the program that you want to run as the service. Now, in my case, the program is malware that I created, and I want to run that in a command prompt session continuously. So it's cmd.exe /k C, and then the path to the program, which is c:\lab files / and I've got the program called core16 _malware.exe. So that's the binary path, which is the reference to the executable that you want to execute as a service. Then we can specify our startup options. So I'm going to do start equals, and in quotes,
I'm going to put auto. Now notice again, after the equals, I did put a space in. And then finally, we're going to do obj equals and then space, and in quotes, we're going to put local system. And this is the user account that we want to run that service as. So it'll run as the local system account. So I've got all my options set. So I'm going to hit enter, and it comes back and it says that it created the service successfully. So now this service is created, it's not started. So if I want to start the service, I can use the scstart command. And then you specify the name of the service. In this case, I called the service Course 16 malware. Now I'm going to hit enter here, but in this example, the service won't start. And the reason being is this malware is designed to remotely connect or make a reverse connection to a listener on my hacker system. And I haven't started that listener. I'm going to take that step in the next demonstration. In this demonstration, I just want to show you the commands to create a service so that when you're going and performing your pen test, when it comes time to maintain persistence, you know how to go and create a service, right? Again, that'll be in our next demo, but this demo, I just want to make sure that you see the commands to create a service. My point is, I am going to hit enter here, but it will time out. It'll give me an error because what's happening is that malware is trying to make a reverse TCP connection over to my pen test system where I would normally have a listener set up, but I don't have that listener set up because my focus here is the creation of the service. Right? So the service was created. We saw that. That was successful. And I do want you to see how to start a service. But again, I haven't prepped up my other system to receive that connection, so it did time out. Perfect. So we have the service created through the command prompt. Now, the other thing I want to do is I want to show you how to create a service through PowerShell. It's actually a little easier through PowerShell. So if I go to the Start button and I type in PowerShell, here's our Windows PowerShell. Same thing. I'm going to right-click on that and run it as an administrator so it runs with elevated privileges. And here's our PowerShell prompt. I'm just going to size that out a bit. And I think what I'll do is that, just to give myself some space on the screen. Perfect. So I'm in my PowerShell prompt. Now, if you want to create a service from PowerShell, we use the new -service commandlet. And when you use this commandlet to create a new service, you specify the name of the service, so -name, and in quotes, I'm going to specify Course 16 malware, and I'm going to put a number 2 at the end because I've already created a service called Course 16 malware. So I'll put a 2 there, and then we'll specify the binary path, so same idea. But in this case, the binary path will be :/lab files /course16 _malware.exe. So there's our binary. We do have options as well. There's more parameters here, but we can set a description, right? So for our description, I'll put Glenn's malware. And then you can specify the startup type if you wanted to. So I want this to set start up automatically. So anytime the system reboots, the service would start. So in the case of persistence, during a reboot, I want my malware to make a remote connection to me so that I always have access to the target. Again, that's something that we'll kind of see in our next demonstration. For this example, we just want to create the service. So this should create a new service called Course 16 malware 2. So you can see it came back with the results, a little bit better feedback than what we saw in the command prompt. So PowerShell's come back saying, hey, we created this service called Course 16 malware 2, and that service is stopped. So if I wanted to start the service from PowerShell, we could use the start-service commandlet, and then you specify the name of the service, so Course 16 malware 2. Again, when I hit enter here, it'll give an error, because I haven't done my pen test system. But just to kind of see if it does try to start it, and again, it is trying to start it, but it's not able to complete the start because it can't make the connection, which is fine at this point. But I did want to make sure that you saw how to create the service and also start the service. Now from PowerShell, we can also do a number of other commands. I'm going to clear the screen here with a CLS. You can use the get service command to get a list of services. So for instance, I'm going to say, give me a list of services that have the name that starts with course 16 and then an asterisk, which means any group of characters afterwards. And notice that I do see my two services there. The first one that I created from the command prompt, which is called course 16 malware. And then the second one is called course 16 malware 2. And notice that they're both stop services. So in this demonstration, you saw how to create a service from the Windows command prompt and from PowerShell. In this demonstration, you'll learn how to create a service on a target Windows system that can be used to maintain persistence. So our first step is we want to go and plant the malware on the target system. So I'm going to go into a terminal session here. And the first thing that I want to do is use Metasploit to get a Meterpreter session so I can go and upload a file to the victim system. So to launch Metasploit, we're going to type in MSF console. Once MSF console or Metasploit loads, then what we're going to do is specify the exploit that we want to use. Now we know what exploit we want to use because we've already done a vulnerability assessment of the target system. So I know that this target is vulnerable to the Eternal Blue exploit. So I'm going to do use exploit /Windows/SMB/MS17_010_Eternal Blue. I can see that it's loaded, or I'm using this exploit because in red there within my prompt, it shows the exploit that's being used. Now what you want to do is use the show options command to take a look at what settings need to be configured before you run the exploit. And right off the bat, when I take a look at this, I'll see here we have an rhost setting that has no current value, and it does require a value. And in this case, rhost is the IP address of the target system that we want to attack. So down below here, I'm going to set that rhost setting with the set command. So set rhost to 10.0.0.100, which is the target IP address, or the IP address of our target system. And now I'm going to run the exploit. So if the exploit is successful, it'll come back with a banner of win. And you can see here at the bottom of my output, I do have a interpreter session that's been opened to the target system of 10.0.0.1, and you can see the banner win there at the bottom. So, and my prompt has changed. My prompt is now the Meterpreter prompt. And with the Meterpreter connection, we can go and run a whole bunch of post-exploitation tasks, right? Now within Meterpreter, if you want to see a list of commands, there is a help that you can use. And there's a big list of commands here with descriptions of those commands. So if I scroll up to the top here with our file system commands, the first command that I want to use, the upload command, to upload malware from my Kali Linux system to the target, which I'm currently connected to. So what I'm going to do is I'm going to use the upload command, upload malware from my pen testing system up to the victim system that I'm currently connected to. So I use the upload command. I specify the path to the malware. So it's in my home student, and it's called course16_malware.exe. And I hit enter. It says that it's uploading the malware to the course16malware.exe file on the target system, and the upload was successful. Now, if I'm wondering, okay, where did it upload on the target system? There's a couple commands that we can use in Meterpreter, like for instance, the pwd to print your working directory. So I am currently connected to C:\Windows\system32 of the victim's Windows system. So what it did is it uploaded the malware to that folder. So what I'm going to do is I'm now going to jump into a command prompt on the victim system, what we call a shell, and I'm going to go and create a service that basically starts or runs that executable every time the system restarts. And that's how I'm going to maintain persistence with my malware. So first thing I want to do is I'm going to use the shell command to jump in to a command prompt of the target system. And the shell command is another command of Meterpreter. It's a quick way to bounce out of Meterpreter and come into the command prompt of the target. And if I just want to verify things here, I'm going to use Windows commands now because I'm essentially in the command prompt of the target system. So I'm going to use who am I to verify my credentials. And notice that it looks like I've been authenticated as the system account. And that's good news because if I'm authenticated as the system account, it means I have full admin capabilities, which means I'll have no problems from a permission point of view creating a service on the target system. The other thing that I want to do is check the host name of the system, and it looks like it's a system called Win7a. Perfect. Now, if I want to create a service, I can use the SC command for the service controller, and I want to create a service called Core16 Malware, will be the name of the service, and then we specify the binary path to the service, and the binary path will equals, and it's a command that will get run in a command prompt. So I'm going to reference the cmd.exe command and then pass in as a parameter to that the path to the executable. So c:\windows /system32 /core16_malware.exe. Then we specify, we have other options that we can specify with this service that gets created. The next setting is what's its startup. So I'm going to put start equals, and notice that I'm putting a space after the equals. I did that with the binary path as well, and that's kind of a requirement of this command, a little bit different than most other Windows commands. So I'm going to set the startup to automatic, and then the count that it runs as is going to be the local system account. So I'm going to hit enter, and notice that it says that it was able to create this service successfully. So the next thing that you're ready to do is start the service. Now, if I wanted to start the service, I would use the service controller, so SC space start to start the service, space, and then the name of the service, in this case, which is Core16 Malware. So that'll start the service. Now, I'm not going to start the service just yet because in this case, the malware makes a reverse connection to the hacker's machine. So what I should do is set up the listener on the hacker's machine so that when the service starts and runs the malware makes the connection, and the hacker can go and gain access. Now, keep in mind, I don't really need this connection at this point because I'm already connected to the system, but it's about persistence, right? Maintaining persistence. So I'm going to start another terminal session. And in this terminal session, what I want to do is I want to set up a listener that waits for the target to connect to it. And again, it'll be an interpreter session, right? So the malware is going to connect to this. So I want to launch this. So I'm going to go into MSF console. I'm going to use exploit multi-handler. And I'm going to set the payload to Windows Meterpreter reverse TCP. Make sure I get everything spelled correctly. So the payload has been set. I'm going to set the localhost IP address to the IP address of my Kali Linux system, which is 10.0.0.101. And then I hit enter, and then I'm going to do exploit. And it's starting a reverse TCP handler on port 4444. Sorry, I don't want that. I'm going to Control-C that. And I'm going to set the local port to port 5555. So that was a bit of a mistake on my part, because this is connected on port 4444. So I should have paid attention to that, but let's go and change the port. So within the options, inside of our, if I do a show options, there's the local port setting. It's set to 4444. So what I'm going to do is I'm going to set L port to 1234. And the reason why that's important is when I created the malware program with MSFvenom, which I did in a previous demonstration, when I created the malware, I created the malware to connect to port 5555 on a listening system. So this is going to be the listening system, which is, I got to make sure I set that port number to the value that the other software, the malware, is going to try and connect to. So that's set. Now let's go and do our exploit. Perfect. So it's listening on port 5555. So I'm going to leave that window there. And remember, I'm on the Windows system here. If I hit enter here, when that service starts, it should run the malware, which then I can see it happening in the background. Look at that. So a connection was made from the malware on the Windows client machine to the system when the service started up automatically, and I have an interpreter session ready to go. So what that means is that I can go and close this other prompt down now, this one right here if I wanted to. And what that means is anytime the target system reboots, as long as I have this listener set up waiting, every time it reboots, it'll connect to this target system and I'll have a interpreter session. And from this interpreter session, I can do sysinfo. I can use all the interpreter commands. So again, you can use your help to find out what those commands are. So I can see that this is a Windows 7A system. I can use all the commands to browse the file system if I wanted to, all kinds of stuff. Again, that's in your help command. So the next thing I want to do is I want to reboot the client machine and see if it reconnects automatically to the hacker's system. What we'll have to do though is set up the listener again before we do the reboot. So let me first exit out of this interpreter session. Notice that I'm out of the interpreter session. And then I'm going to go and do the exploit again. And it should set up the listener because the port value and the IP address is still set. So notice that it's sitting there listening, waiting for the connection. So now what I'm going to do is I'm going to go and reboot that client system. So the client system is rebooting. And let's see if it makes a reverse connection on boot up back to the system. Again, what I'm watching for here is notice that I do have a cursor, but I don't have a Metasploit prompt right now at the bottom of the screen there. And there it is. The client machine has rebooted. It made a connection to my hacker's system. And now I have a interpreter session open. And with this interpreter session open, we can then execute any of the interpreter commands, those post-exploitation commands. And again, you can use the help command to view the help of all the different interpreter commands. In this demonstration, you saw how to exploit a system, upload malware to that system, and then create a service to act as a method of maintaining persistence. In this demonstration, you'll see how to use a bind shell to take control of a target system. A shell is a command line interface that allows you to interact with an operating system. As a pen tester, if you can bind or attach to a target system with shell access, you can use the commands of that system to manipulate that system. The Pentest Plus exam objectives call this LOLBINs for living off-LAN binaries. A binary being an executable file, and living off the LAN meaning what's available on the victim system. Let's take a look at how to obtain a bind shell. First thing I'm going to do is go into a terminal session on my Kali Linux system. Now in this example, what I'm going to do is I'm going to use Metasploit to obtain a bind shell. So I'm going to do an MSF console and hit enter. And that'll load Metasploit, where I can exploit the system and obtain a bind shell for access to that system. Now, once Metasploit has been loaded, your next step is to select the exploit. Now, because I've already done my vulnerability assessment of the target system, I know that the system is vulnerable to the Eternal Blue exploit. So I'm going to use exploit Windows SMB MS17_010_Eternal Blue. Now I could have also used the search command and search for Eternal Blue as keyword. So I select that exploit. You can see in red that the exploit has been selected. Now the next thing I want to do is change my payload. And you can see here that it said that no payload is configured. It's defaulting to Windows x64 Meterpreter reverse TCP. If I run this exploit, it's going to go and obtain a Meterpreter session, which I love, but with a Meterpreter session, you use Meterpreter commands. And most of those commands are post-exploitation commands, which are awesome commands. And a lot of times when I am exploiting a system, I like to get a Meterpreter session because there's a bunch of commands there for uploading and downloading files, capturing screenshots or starting webcams and microphones, all kinds of really cool things. Now in this demonstration, I want to show you how to obtain a bind shell. So that payload, the payload is what executes after the exploit runs. So in this case, it's going to default to a Meterpreter session, but I don't want that. I want to obtain a bind shell. So what I can do here is I can use the command show payloads, which means show me what other payloads are available. And there's a big list of payloads, and a lot of these payloads can be used to run executables, to obtain a bind shell or a reverse shell. The difference between a bind shell and a reverse shell is a bind shell means that the attacker is going to connect to the victim system and obtain shell access. A reverse shell means you're going to have from the victim system, you're going to connect out to your attacker system. And the benefit of that is if there's firewalls or NAT devices that the victim system is sitting behind, you'll want to do a reverse shell because there's nothing blocking typically outbound communication. So in this example, I can see here that payload number 1 is payload generic shell bind TCP. Right? And notice that there is a reverse shell as well. So we're going to go and select payload number 1. Now you can either select that by typing the number of the payload in there. So number 1, each payload has an index number assigned to it. And then, or you can select it by its name. So you could type in payload /generic /shell _bind _TCP. I'm going to use the number just because it's quicker to type. So if I just hit enter there, it'll kind of bring me down to the bottom where my prompt is. And what I'm going to do here is I'm going to go and set payload to 1 and hit enter. And it should come back and confirm to me that, okay, the payload has been set to a bind shell or shell _bind _TCP. Awesome. Now, the other thing that you want to do before you go and run this exploit is you want to see if there's any other options that need to be set. So I can do a show options command, and what it'll do is it'll show me all of the settings that could be set here. So our host is kind of the setting I had in the back of my mind here, which stands for the remote host. So what is the host that you want to connect to or exploit? And notice that there is no value there, and it is a required setting, and it represents the target IP address of the system. So I do need to set that setting before I run the exploit. If I try to run the exploit without setting that, I'll get an error message. But notice that there's other settings here, like you can specify a username and password, but those settings are not required. So I'm not going to go and set those, okay? So the only setting that I have to set here is the our host option. So I set our host to 10.0.0.100. Just want to make sure it's plural. Yes, it is. Perfect. And then I'm going to hit enter. Says great. Okay, we set the our host to 10.0.0.100. That is the IP address of my victim system. Now I'm ready to run the exploit. So if I type in exploit, or you could use the run command, it'll go and run the exploit. If it's successful, it'll show win, but if not, it'll show fail. And there's the win. Perfect. And you can see I've got a cursor sitting there. A lot of times you'll end up in a prompt, but notice that I don't have a prompt, so I do have a cursor. A lot of times I give it another second or two, but in this case, I do know that that is a prompt waiting for me to type. So I do have shell access to the target system. So if I do a dir and hit enter, notice that it's showing me a list of files that exist on that system. And now I have a prompt there. So it's /Windows /system32. So I'm on the target system in a shell environment. And I can do it, and basically I can use any of the Windows commands. So for instance, a lot of times I like to see who I am. I will show who I'm logged in as. And with who am I can see here that I'm authenticated as the system account, which means I have full system access. So I can make any changes to the system, which is important from a pen tester's point of view. Now, just as proof of that, what I'm going to do is I'm going to navigate to the root of the file system. And in the root of the file system, I do have a lav files folder. So again, I'm navigating through the file system of the target. I'm looking for information or data available, a value. And I can see here that it looks like in this lav files folder, there's a customer list.txt file, right? So I can display that if I wanted to, type customer list.txt. Now, again, the type command is a command available in Windows. So this is me using the lol bins, right? So the living off land binaries, which again is a Pentest Plus exam objective, is know that once you get a bind shell, use the commands of that system to basically navigate around and discover other information. So I can see here the customer list information. What's also important, again, if I do a dir, I can see the file is there. It's 98 bytes. I can delete that file if I wanted to. So if I do want to cause damage to the system, so I've deleted the customer list.txt file because I set that up for this demo and it's relatively safe to delete that file. But bottom line is you could go and delete any files you wanted to because I do have full system access. Once you're all done, you can use a Control-C to break out of your session. It says, hey, do you want to abort the session? So I choose yes and hit enter. Notice that I'm back in my Kali Linux system and I've got the exploit there, and I could continue to modify the payload and run a different exploit if I wanted to. So in this demonstration, you saw how to get bind shell access of a target system as a method of controlling that system. In this demonstration, you'll learn how to compromise machine accounts as a method of maintaining persistence within an Active Directory environment. If you can exploit a domain controller and gain privilege level access to that domain controller, you can create a computer account within Active Directory and then configure that account as a domain controller so that it could receive sync copies of the Active Directory database. You could also make the account a member of the domain admins group so it has full access to all systems within the domain, and then use that account with a tool such as Impacket to retrieve password hashes from systems. So let's take a look at how to create an account within Active Directory. The first thing I'm going to do is I'm going to create a variable called secure string, which will contain a secure version of our plain text password. So I'm going to use the convert to secure string commandlet, and I'm going to convert our password that I'm supplying as plain text to a secure string. Perfect. Now I can go and create the Active Directory account. So in PowerShell, we have a new AD computer commandlet that we can use to create a new computer account within Active Directory. And if you wanted to create a user account in Active Directory, you could use the new -AD user. Now in this case, I'm going to create an Active Directory account called Pentest System A. And the account password is going to be our secure string. We want to enable this computer account, and then we can set other parameters if we want as well, like what the operating system is. I'll set it to Windows 10 Enterprise, and we can set the operating system version as well. And I'll set the operating system version to 10.0, and I'll set the DNS host name for the system to pentest system A dot quick 24/7.loc. So we hit enter. After I hit enter, notice that there's no error messages that appear on the screen. So with PowerShell, if you don't get any error messages, you can assume that it was successful. If I want to take a look at that system, I'm going to use the getAdComputer commandlet to retrieve a list of computer accounts from Active Directory. So if I just use that commandlet by itself, it wants to know if we want to filter it out. I don't want to, so I'll put an asterisk. And you can see we have a few different computer accounts here. We have a server A, looks like there's a Skillsoft Win10A, and then there's their Pentest System A. And if I just want to see that name, I don't want all the other properties there, then what I'm going to do is I'm going to do a CLS to clear the screen, and I'm going to use the getAdComputer
and I'm going to pipe that to the select name. And that way it just goes and shows the name property only. So you can see I've got 3 computers, Server A, Skillsoft Win10A, and Pentest System A, which is the new account that I created. Now the other thing that I want to do here is I want to show you the get AD computer commandlet. I can retrieve just information about that one system if I wanted to. So Pentest System A. And you can see the DNS host name is there. It's set. You can see that it's enabled. You can see the name of the account. You can see its class, which is the type of account. So it's not a user account. It's a computer account. So, which is perfect. That's awesome. Now, the other thing that I want to show you here, I'm going to clear the screen one more time. So after creating the machine account, the next thing I want to do is I want to alter what's known as the user account control property. And what we want to do is we want to set that to a value of 8192. By setting the user account control property to 8192, the system is flagged as a domain controller within Active Directory, which means that it's possible that it could receive sync copies of the Active Directory accounts or the Active Directory database. So to modify the properties of the Active Directory account, instead of using a new -AD computer, we use a set AD computer. You specify the name of the system that you want to alter. In our case, it's going to be Pentest System A. And then we're going to use the replace parameter. And we're going to change the property called user account control. And we're going to set its value to 8192. And then close my curly bracket and then hit enter. So that's gone and changed the user account control property to 8192, again, which kind of simulates that this is a domain controller, which makes it possible for us to get directory synchronization later on down the road with this account. The other thing that we can do as well is we can go and add this computer account to the domain admins group, which has full access to the entire domain and all computers within the domain. So to add this account to the domain admins group, I can use the net group command, specify the group that we're modifying, which is domain admins, and then specify the account that you want to add to the domain admins group. So Pentest System A, and we reference that computer name with a $/add/domain. So add it to the domain. Command completed successfully. One of the benefits of adding the account to the domain admins group is you could then use the account to execute the secrets dump Python script that comes with in packet, which allows you to obtain all the Active Directory password hashes for different accounts. In this demo, you learned how to compromise machine accounts as a method of maintaining persistence within an Active Directory environment.
In this video, I'll demonstrate how to mount a virtual drive and extract data from it in a macOS environment. I'll walk through the steps an attacker might take to create a virtual drive, stage sensitive data within it, and prepare it for exfiltration. Remember, this is for educational purposes only, and it's crucial to have authorization before performing such activities. Let's begin by creating a disk image, which acts as our virtual drive. Firstly, we'll open disk utility, and then we'll go to create a new image. We can do this by using Command N. We are going to name our disk image to be sensitive data.dmg, and we'll save it on our desktop. We're going to give it the title of confidential. We're going to leave it at 100 megabytes, which should be sufficient for our demonstration. We'll change the format to Mac OS Extended Journaled. And then for encryption, we'll set it to 128-bit AES encryption. We'll type a password, and we'll click choose, and then we'll click save. That is going to create a disk image on our desktop called sensitivedata.dmg. It has also mounted this disk as confidential drive. We can see this in action if I right-click on confidential and eject confidential, and then I can double-click on sensitive data, again, .dmg, put in the password, and it will open up our confidential volume. Let's simulate copying sensitive data into this drive. I'll create a sample file with some dummy data, and then I'll save that on my desktop. So let's open text edit. We can type in, this is confidential information, and I can save this file, call it secrets.txt, save it on my desktop. Now, once that file has been saved on my desktop, I can drag that file and drop it on my confidential volume. You can repeat this process with any files or folders that you could consider sensitive. Now, once we have staged all the data, we can unmount the drive. We can do that by right-clicking on confidential and eject confidential. Now, all of our sensitive data is packaged with the sensitive data.dmg file on the desktop. At this point, an attacker might attempt to exfiltrate this file. They could open a web browser, navigate to cloud storage site, and then upload that file to that cloud storage site. So let's discuss why virtual drive mounting is significant in the context of post-exploitation. If I open this sensitive data.dmg one more time, put in the password, we can open up our confidential volume and see that our secrets.txt file is in there. So by bundling files into a disk image, an attacker can consolidate multiple files into one container, simplifying the exfiltration process. They can use encryption to prevent detection during transit or scanning by security tools. They can potentially evade file type filters that might block standard file formats. To mitigate such risks, organizations should consider implementing data loss prevention solutions to monitor and block unauthorized transfers, restricting the ability to create or mount disk images on sensitive systems, employing security tools capable of inspecting encrypted containers for unauthorized data. And before we wrap up, let's clean up our demonstration. We'll close our volume, we'll eject our volume, and we'll drag or send our files, our secret.txt, and our sensitive data to the trash. And we will finally empty our trash to ensure that everything has been tidied up.